request, the market needs. Yeah.
That's a true point, Wolfgang's mate. Where is new here and hasn't had much of a chat, but I'm an old hand. That's really cool. I really like that idea. The White's word in Geo's server is talking about another test that's also physical. I think both of them are really cool ideas. I think your one's actually more solid. I think his absolutely riddled. Talked to him about this many times. I'm not trashing him behind his back. His has a logistical issue, whereas this to me seems like it'd just work.
Yeah. Yeah.
Anyway, you talked to where.
I appreciate that.
That's a great idea. I think that's one of the things I love about the community that I've always said. It's like these ingenious ways of of empirically testing something for yourself. I think it's just, it's really cool. Also because it's different from so many others. Yeah.
In Gem Panda, they made fun and they were laughing, but I know they didn't understand.
Yeah, I mean, I think it'd just be Gem Panda. That's how they be over there.
Welcome, Science Gustav.
Say again?
Sorry, I was at the shop.
All right.
Yeah.
Anyway, what's your main reason for thinking you live on a globe?
My main reason?
No, where's a guy in here called Where? I was going to for a conversation.
There is a guy named Where here. I'm actually quite a young fellow, and I've been, as I was talking to Wolfgang earlier today, because I'm in Australia, I was just telling him, I was very much what you'd call a sheep, and so I was just like, I wanted to branch out, you know what I mean? I wanted to branch out my knowledge and see, there's so much stuff on it. I wanted to know, where does it all come from? What's the actual? It's very open to learning.
Seemed get disconnected.
He's legged it.
I think he's probably his phone's cut out. I don't think he'd.
He said he was in the supermarket.
Yeah,
but no, I was just. I just found the server. I was.
Back off! You're open though. You like. Oh, Professor Warden sextants can only be used. Nobody's open to it. Like you flip. This is one of those topics that you just go snap over to the other side, one to the other.
I've always been very open to like listening, and I like knowledge. I like just reading stuff and hearing about what other people think. And so I just like listening. I just like listening to what people think and how their brain works. So, yeah. And some things people say on this server, I completely disagree with, right? Some of them are just, they make me laugh. But some of them, they make me, they make me think and they make me go, oh, no, hold on, this makes sense, this is a really fair point. And then I'll go deeper into it and I'll tend to start agreeing. But yeah, no, I'm very much an open, I don't know what you're going to call it, a very open person when it comes to knowledge. Like, I'll read everything and anything if I can get my hands on it.
Oh, somebody can step up and flat smack you. I'll only be good for shilling for the globe over here. If you want to hear people think they'll have to speak up.
I think I've joined because I know, I've only known globe, and so I'm very much inclined to hear the other side of it. If that makes sense, if you know what I mean, because I'm quite a young fellow, so I've heard one side because I've just been taught all this stuff while growing up, but I've learnt all this stuff out of the blue. I'm actually quite interested, so I'm hooked now.
Good morning. Is anybody hiding around here?
Hello, my friend.
Hey, good morning. How are you doing?
Oh, good morning. Oh, I'm in Australia, so it's
Ah,
quite late.
I was gonna say it's not morning there.
No, it's 11 p.m. as we speak.
Well, so it's almost morning then.
Oh, yeah, I mean technically, yeah, it is.
Yeah,
Or
so
could you call it like a twilight zone? I don't know.
there you go. That sounds about right. What part of Australia are you in?
I'm in Victoria, so like the more south part of it all, like the right
Oh,
but south, below New South Wales.
yeah. So what, over towards Harrietville?
I have no idea what Harrietville is, if I'm being completely honest.
Ah.
Melbourne. Do you know Melbourne?
Oh yeah, you in Melbourne?
Yeah, like city centre almost.
Oh, okay. Gotcha. Yeah. When you said just south of New South Wales, I thought maybe you meant you were.
Oh no, I meant like state-wise. I'm south of
Yeah.
it, like as a whole, like puzzle piece type looking thing.
Oh yeah, for sure. Yeah, I know a little bit about Victoria. Not been there, but I know a little bit about it.
It's got. I think it's got. I think it was one of the most effective transport systems in the southern hemisphere. Of
Oh,
the
no doubt about it. Uh,
Yeah, no, okay, now I know what you just heard me say, right?
yeah.
All right, but I am very new here, and I'm very open to. I was talking to Wolf before, and I was talking in here, and I was just explaining that I've just kind of discovered all this stuff. You know what I mean? Like I'm very much learning, and I'm very open to listening, and I love knowledge, and I love just kind of all that stuff. You know what I mean?
Sure.
Like I've just been sitting here for the past hour or two, just listening to the things, and I've been reading all the things that they've been posting, and it's some of the things, I'll be honest, I've gone, yeah, okay, and I've laughed at, but some of the things they've really caught my attention, and I'll be honestly, it's I've actually really enjoyed, learning this stuff, and it's
What have you laughed at?
I don't know, just the way some people are. I mean, I don't know in particular because it's nighttime. I'm kind of just browsing, if that makes sense, but I've just kind of I know there's been one or two comments that have kind of like they've contradicted themselves, but I don't want to get into that because I don't want to, I don't want to start anything. But no, I'm very as I said to Wolf earlier, I said I've just been a sheep for most of my life, and as he put it, he's like, you want to know why you're a sheep, and why you've put on the, why you're with the sheep. You want to stand back and you want to be your own sheep, which was nice. But I'm yeah, I'm just kind of it's kind of a strange topic, but I'm just kind of sitting here. I'm trying to just, expand my knowledge of everything that kind of I can get my hands on, if that makes sense. And I'd be more than happy to, listen and ask questions to you guys because the flat Earth is a very much new topic to me, so I don't know much on it, and so I'd be more than inclined to talk to you guys and ask questions, and
Okay,
that's
so what I was asking you was what was funny so we can talk about it.
oh man, I don't remember. It was a while ago. It was just like I think it was. I can't remember the dude's name, but he was in here before. I mean, I was laughing at Egg a bit, Eggshells, because he's a bit of an odd one. I don't want to, you know. And he was saying some stuff, and I was laughing at it. And then the other guy that was getting a bit heated was, I don't know. It's just I'm not laughing at the facts of what they're saying. I'm more laughing at how they interact. If that makes sense.
Yes.
It's just a bit funny to me, that's all.
Yeah, that's understandable.
Like, yeah, no, it's just like, so the way people interact is amusing. That's what I should have said. The way they're interacting is more amusing than the actual topic themselves.
So, do you believe you live on a spinning wet ball?
Honestly, at this point in time, I just kind of think I'm here, you know what I mean? Because I actually haven't had much proof either at the moment.
Uh, Can I take you to the 3 points question quick? This is not a IQ test.
No, you're right.
Something we ask all the people who are new in the server.
No, go for gold. No, of course, of course.
Okay, cool. Let's go. Now, first question is: do you know which man in human history uh, proved, discovered that the Earth is a ball, and by which method?
I don't know the name of the dude, but
Yeah.
I think it was. See, like, it was a while ago I learned all this stuff. That's why I'm delving into it now. But I will answer your question. I remember there was, wasn't it the guy that like mapped it out via like a boat and he like sailed around or something?
No.
No. Oh, then I have no
No.
idea.
You can have a in your neighborhood. You can travel in circle, and then you will say your neighborhood is a ball,
That's
right?
fair enough. That's a good
Okay,
point.
good. Second question. Do you know who discovered and proved that the Earth is spinning around its axis, and by which method?
Oh, the spinning. I don't know. I think it was I'm being completely honest off the top of my head. It was some like it was like Leon something. I'm not too sure, but like I said, I'm not very
Yeah, that's not the answer. But anyway, yeah. So you don't know
obviously.
either.
So no, I don't.
Okay. That it's no problem. It's the best thing you can say when you don't know. Yeah, it's the most honest. That's
Yeah, I just,
important.
that's all. I
And
don't know. As simple
yeah,
as that.
yeah, good. So the third question is: can you have gas pressure without a container?
Can you have gas pressure? I want to say, yeah, you can.
Really?
I mean, if you contained it in a liquid, like, yeah, you could.
In a liquid?
If you contained a heavy gas underneath the ocean that was less dense than the ocean, I believe that you could. Sorry, more dense than the ocean. I believe that you could.
Well, what happens with the gas which
The water
escapes
will be
from the ground? You know, the in the ocean we have this underwater um places where we see gas rising from the ground. What happens with that gas when it enters the medium of the water?
I guess it doesn't mix, just kind of rises, doesn't it? But
It does rise, yeah.
yeah, but I'm just trying to, like, if there was a gas that was more dense than water, then technically it could be contained, could it not?
Oh, yeah, that will be interesting to show me a gas more dense than the water.
I don't know a gas more dense, but it just kind of entered my head then. It was like
Yeah.
that's what I
Okay.
mean.
Then,
Yeah, well,
yeah.
what you're saying there is
Uh,
that the water would be the container. That would be the container in that case.
Yeah,
yeah.
then what is a container? If that, like, are we contained by what we are surrounded by then?
Yes, according to the law of gas pressure and the second law of thermodynamics,
So everything.
we are contained. We live in a closed system because we have gas pressure. That is what we experience. And you cannot show me that you can have gas pressure around your car wheel without a tire.
That is a fair point. I think you can
Yeah.
hold gas with
Or
gas.
yeah, or to hold the gas pressure, 3 bar or whatever, um, around your tire, bicycle tire, around your bicycle wheel, and without a tire, you need that rubber to hold it. It's a closed system. Yeah, it's a closed container.
Gas itself, I don't think so. No, a gas itself cannot hold gas. No.
Correct. Correct. That's very correct. So yeah, if you can't prove this, it means also that there is no way to demonstrate gas pressure adjacent to a vacuum, next to a vacuum. So that medium of space, which NASA is telling us, is a direct violation of the laws of gas pressure and the second law of thermodynamics.
But like, I understand that. So what you're trying to prove
Yeah,
here is that space doesn't exist. Is that the going right now?
exactly. Yeah.
Okay, that's fair enough. I've kind of wondered
So,
about that. You know what I
mm,
mean? Space is a kind of odd subject. Sure, it's a
yeah,
nice thing to delve into. It's a nice little thought. It's
yeah. It's the
interesting.
place where the stars, where the celestial bodies are. But to claim that we know this and that about them, that they are that far away, no man has ever been. No man has ever walked
Unless you can show me a
that
star in
distance.
person and I can hold it, I will not.
Exactly. Well, I can show you on the sky. Yeah, and I can show you the sun also or the moon. But
Yeah, but
anything other than that, mm,
stars
other
are
than pointing you to a tiny source of light in the sky,
I have to ask. This is
it's just a
completely off.
fancy story.
Yeah, it is. I was reading before because I got caught up in the tides and waves things before.
Mhm.
And how I was trying to explain it, and I was watching a video, and like in
Yeah.
the server, and they were trying to explain how tides exist from um this thing called like something moves below us, and like the tides just kind of happen.
Mm,
Like how do tides come to be? That's what I'm most interested about at the moment, to be honest.
Well, to be honest, I do not know what
We
causes
don't know,
them. I can speculate about that, but
but we do not know.
that's not science.
Yeah,
Yeah.
fair enough. Fair enough. Because
And
what I was watching this
yeah, what we like to do in this server is to stick to scientifically known facts. And everything that is a wild story, a fortune telling, a palm reading, we don't like that, you know?
Yeah, that's fair enough. That's fair enough.
Yeah. I mean, we like to speculate with people, but we want those people to actually acknowledge that, hey, this is speculation what we are doing now, and this is not something that we positively affirm, because every positive claim carries the burden of proof, so yeah.
That's a good point.
Yeah.
That's what I mean. Like, this
But
is what I
we know for a fact that the moon does not causes the tides, and
yeah. That's a
this
bit
is
of.
how we learn all in school by default.
I mean, yeah. There's the
Yeah.
like there's the centrifugal force and whatnot, but like that's a bit odd. And you can prove that on a tennis ball when you spin it, and you can like stick stuff to
Mm,
it, like at those rides in the
mm.
thing at the Ferris wheel when they spin so fast, you stick to stuff. But that's more on the outside than the on the more on the inside than the outside. But there's the base
Yeah,
idea.
but you see, the globe does not increase in
No, it doesn't.
its rotation or decreases in
Yeah,
its
just
RPM, I mean, it has one revolution per day.
it's
For
always like that, huh? That's just kind of
Yeah,
odd.
and because it's a spin, it's actually a constant acceleration. Wherever you are on this spinning ball, it means that you are constantly accelerating.
Mm.
And it's an acceleration which is impossible to measure.
Yeah, it is. It's quite impossible to.
Yeah, but it's funny because you are using a mobile phone, a smartphone, yeah, and it has a comagnetometer inside it, probably one rubidium atom inertially suspended on 6 axes, and that's a device for detecting acceleration. It's very, very small device. It's inside your phone's microchip, you know.
Yeah, I'm aware how it works. It's like it rolls, and then when it turns a certain way, it triggers a.
Yeah,
Yeah, it's
and
'cause it's a 3D.
when you get in your car and you're moving with 100 miles an hour, your phone shows you that you are moving approximately 100 miles an hour, that you are traveling. When you come to a stop and you get out of your car and sit on a bench, yeah, somewhere, it will show you that you're not moving now.
Yeah, it's because it's going to sound quite silly, but
Uh,
I've actually I've done a little test on that. It's like the scales that you can set a weight to, and then
mm,
when you put like if I put just say I put a bowl on there, and it'll come up as like 200 grams or something, right? And then I can
yeah,
set it back to 0 with the bowl on it, and then I can put something else on it, and then it'll tell me how much is in that bowl.
yeah,
You can do that with a phone. You can have it set to a certain you can have it set to a certain speed. If you were
yeah,
to look at it, you can set it to a certain because it's set to whatever technical term they want to use. It's set to Earth spinning speed. Whatever whatever that is. Right?
Well, in the phone, you do have also pressure sensors, like when you press your screen, it's very much like a scale. Um, I'm not sure if it's a piezoelectric sensor or a different kind.
It's done by momentum.
Yeah,
The constant
when you
force.
apply pressure on that glass, there is a warping in the glass. It's very small, like
Mm,
nanometers. Yeah,
that's a really good. It's a really good way to put it.
yeah, yeah. And if you have that device inside your phone, then yeah, of course you can access it. Just take root, and then you can tap into all these sensors, and yeah, you can use them as a scale also, Yeah, the newer phones definitely they can measure like
I'm actually
jewelry and stuff like this
science.
on the screen.
Hmm.
Yeah. But yeah, we went to the 3 points, and yeah, the purpose of these 3 points was to establish that you don't know the globe model. For
No,
you,
no,
it's only a belief system. It's not knowledge. It's
no,
not
no, I don't
something
know.
that you know. That was the only purpose of those 3 questions. So yeah, I
Okay.
just wrapped it up to explain the purpose, and yeah,
Yeah,
from
I'm just
here you can ask questions to us like, hey, I want to know
how
what do
does
you
blood
guys think?
work?
What do you guys know about this and that? Yeah. So
It's been a quite a it's going to been a quite a I don't want to say aggressive community, but there's been a few people that
mm,
have DM'd me personally and been like, then I'm not very happy
yeah,
about.
um, take your time. Don't put everything to your heart.
No, no, no. I've just kind of
Science doesn't have feelings.
yeah,
It
exactly.
doesn't work with feelings. So yeah, it will take it a little bit of time for you
It
to
will,
get used here in this community and
especially when I'm
to
so
get
new to.
known. You know.
They'll kind of come
Sorry.
aware of how I talk and what I mean
Yeah.
when I say certain things, and it'll be like, oh, he actually is trying to listen. And he's not trying to be spiteful or something.
No, you sound very intellectually honest person, and I appreciate a lot. I appreciate that a lot.
If I don't agree or something, I'll
Yeah.
tell you I don't agree, and I'll try to
Yeah.
explain. And if you give me a genuine point and can prove me wrong, then I'll listen to you. You know what I mean? It's
Yeah.
I
You
think what I
see,
think until proven wrong.
so have you seen the Black Swan argument?
Um, I've seen a lot of the word black swan, and like, isn't it the things on the horizon, like the oil thing?
Yeah, the oil rigs photographed in California beach. Um, it's two oil rigs, one at 6 miles away and one of them 9 miles, and the horizon, you can see it behind them. Indeed, the horizon is blurry, but you can definitely see that the horizon is actually behind the oil rigs.
Yeah, yeah. I'm
I
looking at them.
mean, yeah, you have to be an honest person. So only if you're not honest and you will say that the horizon is not behind those oil rigs. I know the image is not very, crystal clear, has super high definition because it's the high zoom of that camera, and
The camera's
it's
not very good.
maximum zoom, and it's the furthest that camera can see in that day.
Mm. But
So yeah.
I can see the horizon quite
Mhm.
easily, from
Yeah, yeah,
this picture alone. But it
yeah.
is a
But
very
we had such kind of people, dishonest people, who said that no, the horizon is not behind them. And
I mean, yeah, it's I don't know how, in that picture there, the horizon is behind it, but could be
yeah,
another picture where they've actually changed it, or we've changed it, or
it also looks blurry.
it is. Yeah, it is a
Yeah,
very.
yeah,
If I'm being honest, it's a really
yeah,
shit photo. Like this,
yeah.
it's got so much
It's not
stuff
a
going
shitty
on top of it.
photo. I mean, hey, that's actually a very high definition. It's a very long distance
This is a
observation.
long distance
Yeah.
photo. It's just like
Yeah, that's
6
a
miles away, I guess. Yeah.
that picture. Listen, that picture is a still shot from a video taken with a P900 Nikon P900 camera.
I know
Is
what.
one of the most advanced, technologically advanced commercial cameras. So it's not just a shitty camera, you know.
Yeah, I know. I'm not saying the camera's
Yeah,
bad. It's just when I look at this photo
yeah,
alone, it's just like,
yeah.
without knowing that stuff. You see what I mean? Like, if I don't know the background, which I didn't, now I do. It's much more impressive.
Well, I
But
tell you, if you go outside and look with your naked eyes,
I will not see what I see in the photo.
exactly. I mean, to see that far away with your naked eye and at that quality, you should be Superman, you know.
I know. If I could see what I'm
Yeah,
seeing here.
yeah. So anyway, according to the Ball Earth radius, 3,959 miles, um, that you're describing an arc curvature of 8 inches per mile square drop. So with distance, every time you double the distance, the drop increases exponentially. It's an exponential drop. This is not our claim or stuff like that. This is basic geometry, the geometry of sphere and circles, and um, in this case, when the Earth radius was almost 4,000 miles, that means that the horizon line, yeah, that place where things start to disappear from the bottom up, is going to be happening at 1.225 miles away, because that camera on the beach is 1 foot from the sea level. So that's like when you go to the beach and you lay down on your belly to get a tan, yeah, you raise your head up and you look at the horizon on the sea. And that's a 1 foot observer height, like 30 centimeters, something like that. So the horizon for you from that observer height uh, is supposed to be at 1.225 miles far away. But we see further than 9 miles. We see that the horizon is behind the second oil rig, which is 9 miles away. So that means the horizon is at least 10 miles far away. That means the horizon is 10 times further than it should be. You get me? There is a Earth curve calculator. You can find a lot of them, even on GitHub, even on NASA website, and you can use that, and you will see that none of these calculators will ever match what you actually see in reality. When you try to find that curvature, it's not there.
So he's split then?
Yeah, that's a bye-bye ball.
You killed him with that, and he left.
Oh, he left. Well, pity. I hope he returns, because he didn't sound like a troll or clown.
Was it concern trolling?
No, I wouldn't say that about
Well, maybe you
him.
just lost internet service for a little bit or something.
Sometimes I will say that real life intervenes, so people have to drop off, they dip out without saying anything. So yeah, it's a common practice.
It
Yeah,
always happens on Discord. They seem to just go away and they never come back because they
yeah,
can't log back in because of the internet, especially with professors.
oh yeah, yeah. I know when that professor had the
I think it's two
there was
times.
that
I think it's two
Dawkins
times
guy.
now. I think it's two times now. Professors they couldn't get back on Discord and their internet sucked because I guess they can't afford internet. That's my guess.
Yeah, with QE, he had this argument. They had a show and it lasted 5 minutes.
Right after the first question, his internet broke.
Yeah, yeah.
QE broke the guy's internet with one question.
Yeah. And it was about science, the scientific method. He got there. Like, that's what they started with, discussing the science and scientific method to establish the common ground. And once he did that, like, that professor was like immediately dipped out. Yeah.
Yeah, he knew he had lost.
Yeah. See ya. I mean, my Discord. I can't understand. Gotta
Yeah.
go.
Yeah. Well, I gotta go back. I gotta go to work actually. Catch you later, guys. It was nice to hear you.
Yeah, have a good day. That's one of the things I notice on Fascist Book is these trolls will they will act like they are smarter than you, etc., etc., etc.
Mm.
And then the very moment you ask them a question they can't answer, block, or they just disappear, or and then when they reappear, they're back saying the same stuff again. And then you say, "Hey, I asked you this question the other day, you never answered," and then they disappear again.
Mm. Well, they show me those um, two arms spiraling galaxies, you know. They are very nice images, yeah, I can give you that. But why does a droplet of dichloromethane, when you drop it on water, um, it starts spiraling just like that galaxy, you know, and the the moment it will start spinning, you know, and you can see like two arms, like a shooting jet, yeah, and it evaporates into nothing, you know, it completely vanishes, it evaporates. So the moment it starts spinning, we see it accelerating, and it reaches a certain quite fast spin. But the faster it spins, we see that the faster it's evaporating, and yeah, we don't observe why are galaxies so stable, you know. I mean, obviously we see these liquid droplets that when they are spinning, they are not stable anymore. Like they evaporate much faster. The evaporation process actually accelerates. And yeah, the funny thing is that it's a huge mystery why that droplet is actually spinning. It's not scientifically explained yet. Nobody knows the cause. There is a guess which says that evaporation causes that spin, but it's not proven yet. So yeah.
I posted my question that I used in Cogdis yesterday, which caused a 4 to 5 hour disturbance. They couldn't answer a yes or no to the question. Look at what I put in there. I drop an egg in water and it sinks. Is this considered gravity?
It's so funny you say that in response to it, because this comes off the tail of a discussion where I was asking for a simple yes or no about what is the black swan. And I find the same. I find that both sides do it.
So what is
and that is refuse to answer a yes or no question.
Black Swan says you can see too far.
Sure, yeah. I was asking a yes or no question about it. How is the wording I put for it? Are we taking measurement from the eye of the observer to a horizon, an angular measurement that is based on an assumption of a straight line?
It's an observation, and the straight line, it's from your eye to that oil rig, yeah.
Sure, from your eye to that oil rig and to the horizon beyond, correct? The oil rig is pointless without the
line
horizon.
Of sight is straight, but you see, in water, where you have a higher refraction index, there's a strange thing, like if you are far enough from the light source, you see that light source, but it doesn't mean it's actually in that exact position where you see it, because the light comes to your eye in a curved path.
Sure.
Yeah.
So, I like that. It's a good description too. Yeah. Like not the light curves, but it comes in a curved path.
Yeah.
I think is a good description.
And it reduces your visibility. I mean, when you dive in the ocean, you can barely see 2 or 3 meters, 4 meters away from you.
Is that refraction? That to me is something a different effect. When I'm in the water, for example, it doesn't bend, it doesn't sort of wibble. It just gets cloudy, and cloudiness and wibbliness I would put as two different things.
Yeah. Well, it's not transparent. I mean, it's a transparent medium, but not perfect. So
it's got some opacity to it. A bit opaque.
Translucency, or not opacity. But it's not a perfect transparent. So you don't see unlimited distance, Yeah.
Sure. Yeah. So my question about that was just about the black swan, which is like, we're taking a measurement from our eye. It presupposes a ball, right? It says if the Earth is a sphere of radius 3959, which is P, then every horizon distance measurement must be no more than 1.225 square root height, blah, 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 Q.
I can show you a very good example, like try to do a scuba diving in Australia, because you're in Australia, probably beautiful. You are close to the ocean.
All of us, yep.
So, do a scuba diving in the evening, and have a guy, a friend of yours, like 100 meters far away, each of you dive underwater and shine a flashlight towards each other and see if you can see each other's light. you will not see it from a 100 meters distance underwater. But if you
Is that
stand up
is that
from the
diffraction
water
or
and you
is that?
shine the flashlight towards
Yeah.
each other, you will see the light.
Yes, I definitely agree with that. Yeah,
Yeah,
definitely agree
yeah,
with that.
yeah. And you can also, come towards each other and see what's the distance where you can start see the flashlight from himself underwater, and you will find that, hey, it's just a couple of meters. you know so
Yeah, I think
well,
yeah.
gotta
Yeah,
go
I'm on
back
board
to
with that.
work. I
All
have
right,
to
mate.
go to work.
Have a good
Thank
one.
you,
Work
Rick
well.
Charles. You too.
See you, mate.
You
Good
too.
talking.
See ya.
Good to talk to you again.
I'm at work cheating on Discord at the same time.
Geez, what do you do? What's this Discord-enabled job?
Oh, it's not. I'm an administrator, so I can run whatever apps I want.
Ah.
Privileges.
Yeah, so only the point about the Black Swan I was making was, it appears to me that the Black Swan is presupposing a ball and then saying what one could do with the measurement of a ball is draw a straight line between the eye and the horizon and know that exact distance from me, which is quite cool. So what the fuck's a curved adjacent about? How can you suddenly go from, hey, given ball, I can test straight lines, to, well, you can't test that without a curved adjacent? Like, the two arguments are incompatible. In my book, you need to pick one. Exactly. It does relate. It relates to the sextant. If we say you cannot have a curved adjacent, what we're saying is the angle measured is your toe and your line of sight is curved across the surface, which is not possible. Therefore, Black Swan isn't possible. Or the angle is from your eye and one can take a measurement of the horizon.
I think we need a debate with you and QE on this.
Oh, he mutes me pretty quickly, which is a good sign of the people I've heard debate him lately, because obviously there's this McToon bet and I was invited in because I had a sextant, so I've been on the inside chat with that. People who understand the argument get muted pretty quickly with QE. Because he needs it to stop at curved adjacent. He needs the argument to stay at curved adjacent, which is totally incompatible with Black Swan. But he needs it to stay there because if you look at sextants, every single step after that is so clearly only possible on a globe. He needs you to not look at the other steps.
Really? Okay.
Yeah, like if you grant for a second that you just go, right, I'll put the curved adjacent aside. I'll grant that maybe you can get an angle from the horizon like in the Black Swan. What does it say next? And the very next thing it says after subtract that angle from 90 is times that by 60 to get your nautical miles from the location. So if that celestial body is at 40 degrees, you go 40 times 60 nautical miles is how far I am from the GP of that star, right? You make a nautical mile, arc minute per nautical mile linear measurement, correct or incorrect? So the two choices to me are either you cannot take an angular measurement from the eye and there is no Black Swan, or you can take an angular measurement from the eye and there is a Black Swan and there's no curved adjacent. There's a good chance I'm missing something. Crypto might help me out with it. Should we go live, Crypto? We've got percentage on too. Ah, you motherfuckers. Another night.
8 o'clock in the morning where I'm at. I'm at work, like I said, so I can pop
Yeah,
in.
no, I understand. So, because it seems like a fairly simple point, he gives you the height of the observer. And the height of the observer is relevant, right? In the Black Swan, if the height of the observer was 0, what would the measurement be? 0, right? It's got to be times the observer's height in feet. So if you anywhere along a chain of times tables, you put a 0 in, the whole answer is always going to be 0, right? That's just how times 0 works. So if the observer's height's 0, then you cannot do that measurement. So the observer's height cannot be 0 to do the Black Swan. It must be 1 foot or 6 foot or 12 foot or something, so you can times it by something. So what we're saying is the eyeball is not on the ground, which, is reasonable.
Eyeball's not on the ground, therefore globe.
Yeah. So the eyeball's not on the ground. So what you're taking is a measurement from, let's say, 6 foot off the ground to the horizon. Where's the curved adjacent in that picture? That's all you're doing with a sextant, isn't it? Eyeball to horizon. But for some reason, you can do it in the Black Swan. But then you get to the sextant, you're like, nah, not allowed to do that anymore. Not only are you not allowed to do that, but you're not allowed to hear any of the other steps.
There are no more steps.
Okay, tell me the steps in triangulating or trilaterating, I beg your pardon, your position on Earth with a sextant. Go for it.
I don't have my sextant. I haven't done it yet.
Cool. So,
I have my book.
but you know the steps, right?
You cannot get an elevation angle. You cannot get an elevation angle unless you know that the horizontal baseline to which you're measuring your elevation angle is a straight line. It's the one necessary requirement for any elevation angle.
Sure, cool. Thank you, Solar. What's the straight line you're talking about?
The horizon, the flat baseline that we call affectionately sea level.
Okay, so where does the angle? You're right. You're talking about the curved baseline, right? Which is a curved line that joins an angle.
No, incorrect. There is no curved baseline. Okay. There is a flat horizontal baseline.
No. I'm inviting
known as the level to which all the elevation angles are taken.
Okay,
that's
so
not negotiable.
Can you please label the angle for me?
Did you miss the point?
Just give it a label. The
baseline is a flat horizontal line. You keep talking about a curved adjacent. You cannot get an angle from a curved adjacent.
That's what I wanted you to say. Yes, thank you. So could you describe angle A? Do you want to call it A? Do you want to call it my eyeball? Do you want to call it my toe? What do you want to name the angle so we can go through this maths together? What's the name of the angle that has the flat baseline or the curved adjacent?
The point of observation, it's irrelevant what we call the angle. The fact that the baseline is
but I'm inviting you to call it something. I'm just inviting you to call it something. I'm going to call it something.
When it's irrelevant.
Can I give it a name?
It does not need discussing. The fact that you have an angle means you have a flat baseline, and then you have a flat line that you're going up to the elevation angle point of the observation.
Yeah, I'm aware of it. I've been around the argument for months. Let's not take that long with it. Let's call the angle Dave.
Keep asserting you can get an angle from a curved adjacent.
Yes, I am. So call it Dave.
If you've been around the argument for a few months, you would know that that's impossible.
So call the angle Dave, which is Crypto's suggestion. I think it's a cracking suggestion, Crypto. Call the angle Dave. Where is Dave? Is Dave in my eye or in my toe? Where is Dave? Where's the location of that angle that is the problem that has a curve next to it?
And is Dave standing on a flat horizontal baseline to take this measurement?
Where exactly?
Or an imaginary curved baseline like you're asserting?
Exactly. That's what we're trying to test. You're on it. You're on what we're trying to test. You're just not trying to test it. The test is where exactly is Dave? Dave is a point in space. Is that point in space somewhere right next to my eyeball, or is it somewhere next to my toe? Which one is it?
Once again, it's irrelevant.
Come on, it's irrelevant where the point is. We're talking about taking an angle, and we've got a problem with the angle, and it's irrelevant where the angle is? Come on, man. You can do better than that. It's irrelevant where the angle is?
Baseline that's required for any angle measurement.
The baseline for what angle? Label the angle.
It matters
Where's
not where
the
you
angle?
place Dave along the straight flat line to which you
Along the
measure your
straight flat
elevation
line.
from.
Okay.
It matters
Where do I hold
not
the
where you
sextant
place
in the
Dave.
world? In the world, when I hold the sextant, do I hold it next to my foot, Solar, or do I hold it next to my eyeball? Where do I hold the sextant, Solar? Come on, man. You're a really smart man. We've had lots of chats. They've just hoodwinked you with this sextant bullshit. It's you hold it at your eye and it does matter. Come on, you know that. You might not understand the rest of the argument and you feel on unsteady territory, but come on, you recognize that you hold the sextant at your fucking eye, man. Come on.
And that's relevant to the flat baseline how?
Because what is straight in the black swan? Is it a line between your eyeball and the horizon? Or is it a line from your toe round the curve? What is relevant to it is the same motherfucker that told you the story about the black swan is telling you a completely incompatible story about the sextant and you aren't fucking questioning it. It's one dude saying this shit, right? Maybe two. And you all just parrot it without going, these two things aren't compatible. You could still live on a flat earth, but he's definitely having you on if he says these two obviously incompatible things. He knows he's full of shit and he sells you this shit anyway. I'd be angry, man.
What's truly amazing is everything you said there was fallacious.
Which bit?
Being in a group like this, we all test everybody's assertion.
So test this assertion with me. Does it matter?
Is by taking someone's opinion and then doing your own research to either support or disprove their opinion.
Okay, so you need to challenge it, correct? So challenge it with me now. Does it matter where the angle is?
All right.
Is the angle in your eye?
Do you not understand what dip correction and changing the height of the observer correction? That you place the sextant against your eyeball, yes, and then you factor in your height above the sea level, which is what I was talking about, the level line to which you measure any angle. The height of the observer is taken into consideration and therefore removed from the discussion or the equation going forward, so that it is as if the eyeball is on the flat baseline where the toe of the person is placed.
Yes, correct. So really good description. Wow, that's a good description, man.
Your limited understanding that an observer height correction takes the eyeball down to Dave's toe, and you were trying to make a distinction between Dave's eye.
No, I can still make that distinction. I can still make that distinction. That's a great description.
Correction is putting Dave's eyeball at Dave's toe on the flat horizontal baseline, not a curved baseline. Correct. On the flat baseline, let me sea level, to which any elevation angle must be taken according to the flat baseline, which we know is which we even affectionately call sea level.
I agree with you.
Level.
No, I agree with you. I agree with all of the things you said. I just want to add one thing. I just want to add one thing on in the form of a question.
Do you agree that you cannot see the level?
Let me finish the question, because I'm going to accept all of the things you've said, and I think you've said them really well. Which is that what we are doing by the.
With me. Do you understand that? If I've just rebutted your point, you cannot say I completely agree.
Because I'm about to rebut your point. I'm about to rebut your point, but I'm going to agree with.
I completely agree.
Well, I don't completely. I don't. No. Okay, I disagree with your conclusion.
No, you're wrong. There is a curved baseline, and we know it's curved by measuring where. Where can we measure this curve?
Sure.
That you keep asserting there's a curved baseline.
Sure.
To which angles
where do we measure it is the question. Where do we measure it is the question. And the question is, where do we measure it from, not what do we equate it to? So we measure it with our eyeball 6 foot, 12 foot, 20 foot off the ground. Why? Because we cannot measure it at zero. We are not able to measure a curve at 0 for exactly the point you stated. It would be 0. The observer's height would be 0, so the distance to the horizon would be 0. You're not going to get anything meaningful out of that. So you have to raise it up and get a wrong result that you can correct back to as if it was 0, because you can take a straight measurement to the edge of a curve as easily as I can take a photo of a basketball. Is a photo of a basketball not the same thing?
Correction when they place the eyeball at ground level so that the observer height is 0.
No, it doesn't work. Nobody does that. Nobody does that. Why do they do that exactly?
The Navy does it.
Exactly. Why do they do that? Why do they correct it down to 0? Why don't they measure it at 0? If they can't measure it at 0, why do they correct it down to 0? Ask yourself that question.
Not a distance to an imaginary curve, which you keep mixing two. You're mixing two pieces of mathematics. One is a fiction idea of curvature at some random distance based on an observer height. The other, what we're actually discussing, is taking an angle measurement with the observer height at sea level, as in at 0 observer height, so that you can measure the angle accurately. Those are two different things. I'm not sure if you're aware of that. The one measuring an imaginary curve based on some observer's height, and then the sextant being used to measure an angle. Those are two different pieces of mathematics. But you've now merged them into one, claiming that no observer height is ever corrected for, no dip angle correction is ever done to a sextant to place the observer's eye at sea level so that the elevation angle can be calculated from the flat.
To clarify, I agree with you that a dip angle correction is done.
Two pieces of mathematics.
Yes, I've mixed two pieces of mathematics. Absolutely, you're right. I'm not claiming they're the same bit of mathematics. What I'm saying is they're measuring the same thing. Just the same as you might measure my weight and do that maths for two different things. My weight will be a constant you might use in different models. What I'm saying is both of these. Let me finish, Solar. Come on, Solar. Let me just finish a thought. Let me just finish the thought.
The one is
you're not going to let me finish a thought? Come on, man. You had a long go, didn't you?
The other one is measuring the distance to the horizon. Do you think that those are the same thing? You just said now the mathematics is basically used to measure the same thing. The one is an elevation angle above horizontal. The other is distance to an imaginary horizon. Those are not the same thing. Are you following along?
Well, why are they not the same thing? How do you measure the angle of elevation when you take a sextant measurement? What do you take it off? What's the name of the thing you take it off? You've got a mirror that sights a star or celestial body, and then you have a bit of half-silvered glass. What do you call that mirror? What's the name of the mirror? Come on, Solar. The horizon glass. What is a measurement? What is the word that continually comes up in the Black Swan?
Flat and horizontal.
Horizon, right? So are you saying they're not the same thing when both of them are saying I can take a straight line between my eye and the horizon, that they aren't talking about the same thing, that one of them has a curved baseline from which such a measurement is impossible, and the other one is totally okay because it disproves the shape of the Earth? Do you not see that as a double standard?
Once again, you're conflating 2 points. If I'm standing looking at 10 degrees above horizontal...
How do I determine horizontal?
Elevation angle.
How do I determine horizontal?
The sextant is used to calculate the angle of the elevation point above a horizon. Your other mathematics is asserting the horizon is the edge of your geometric sphere and only calculating the horizontal to that point. One is elevation angle above the point. The other is a supposed angle horizontal to that tangent. The tangent and the 10 degrees above the tangent are different. You're trying to say, no, they're the same.
No, I'm not trying to say they're the same. I'm trying to say here's how the same they look to me. I am saying they're the same. I actually am saying they're the same. I'm saying they're doing the same thing. I'll make this little image and I'll send it. No, I'm not double speaking. I'm saying you're taking both of the Horizon. You use Horizon in both of them is what I'm saying. And here is an image I can line up that will make it irrefutable. I'm just making this right now. So just stick with me for a moment.
Okay.
This is immediately taken off a website. Oh my God, somebody just used it above.
For two things. Therefore, it's exactly proof that they're identical because my eyes were used in both observations. So therefore, both observations are identical because my eyeballs were used. You're saying both of these are identical.
So pay attention, Solar. Can you see the chat? Can you see the chat? I've made an image in the chat. I'd like you to talk about that image. Could I cite
on the Black Swan?
Could I? The question I have for all of the room is this: could I, if I wanted to, use my sextant and take my reading of the horizon from between the two oil rigs? And if not, why not?
No.
And if not,
because
why
your
not?
Sextant, this is exactly the point which you're misunderstanding. The sextant is used to calculate the elevation angle above the flat baseline.
Right.
You're never using a sextant to measure the distance to the horizon.
Correct.
You're never using the sextant for that. You use the horizon mirror in the sextant to line up your sextant so it's level. And then you're measuring an angle above the level, which means your head is pointing upwards.
So describe to me the problem with the curved baseline. So now, yes, you're right. Where's the curved baseline?
Where the sextant is not used in the Black Swan. Not at all.
The question was, can I direct you to the question?
To do with the sextant.
Could I direct you to the question, please?
By putting both of them together is fallacious because you're not ever going to use a sextant to measure the distance to a horizon. Do you not understand that?
Can I direct you to please answer the question? I will restate the question. Could you take a sextant measurement of an elevation of a celestial body from between the Black Swan derricks? And if not, why not? That's the question I want you to answer. If I cannot take a sextant reading from that point, why not?
So exactly the point I was talking about. Yes, you can take an elevation angle off of the flat baseline, to which we know is horizontal.
Where's the baseline?
Which we term sea level. It's the level line.
It's from zero. So it's from 0 foot.
Where that horizon appears 10 times further than it should at a 1 foot observer height. Yes, that
at 1 foot. At 1 foot. Okay,
that's
not at 0 feet.
You can use that as your baseline to measure the elevation angle of something existing above the horizon. Now tell me, what part of the Black Swan includes something above the horizon? Or is it simply pointing out that the horizon exists 10 times further than it should, based on your geometric curve, which should have been evident at 1.2 miles?
Simple question is this. Go back to the description of the sextant and tell me what the curve baseline is.
What is above the Black Swan image that you're trying to measure the elevation angle to in the Black Swan?
You chose the height.
Trying to measure above?
Sure.
What are you trying to measure the elevation angle to above the horizon in the Black Swan?
Above the horizon, yes. So if the horizon is 1.22, so I'll explain it. The maths. Yeah, the maths.
What are you measuring?
Okay.
Above the horizon in the Black Swan?
Yeah. So the measurement is the 1.225 is how you get to 2 arc minutes. In fact, it's
maybe you didn't hear the question. Maybe you didn't hear the question.
I'm telling you.
What is above the horizon that you're measuring an elevation angle to in the Black Swan?
Sure. So
not horizon.
I'm measuring horizon.
Something above horizon. Remember?
I'm measuring the horizon and subtracting them from that.
Angle means above horizon.
Solar, I am trying to let you speak. Can you sometimes let me speak? Is that cool, man? Because we do get on. We're just having a fiery debate. But I just don't feel like I'm being allowed to speak.
Over him, so expect the same behavior to you. You need to take some breaths and calm down and slow down. You need to when he answers your question, count to 10 before you start talking again. I mean, come on, man.
What you're demonstrating here is your misunderstanding of this topic. What I'm simply trying to elucidate, which is obviously falling on deaf ears, is that nowhere in the Black Swan did anyone describe anything above a horizon. The only point of the Black Swan is, look, we have some rigs which are distance markers, and look where the horizon appears to be.
Nobody talked about being above the horizon.
Location. When you bring up a sextant, you are talking about elevation angles of an object above the horizon. And what is the angle?
But I'm asking where the angle is, and you said it's on the surface, and there's nothing about it being above the surface, but it's got a description of the height above the surface and how it's relevant to the measurement. So is the height above the
again? You're conflating the maths.
This is QE.
Explain this to you.
This is QE. This is the Black Swan I'm presenting. You're arguing now with the Black Swan.
This is called Flat Earth Solar speaking. And like I started our discussion, I said, no one in here just hears something and repeats it the way that you're doing. Everyone in here goes and actually researches themselves.
Okay.
And this is
Let me show you the research about the height above the surface. Let me show you the research.
Distance to a curve, or are we measuring elevation angle above horizon, which are two different points?
Okay.
Nowhere
here's the point above the I've highlighted it for you.
Horizon
I've highlighted it for you. I've highlighted it for you. It's in the chat there. 1.225 times the square root of the observer's height is definitionally the opposite of what you're saying right now. You're saying it's not on the surface, nothing above the surface is mentioned, and it is specifically in a 3-line thing, takes up like half a line.
Okay. And the Black Swan is measuring a distance to the horizon. Sextants are used to measure elevation angles of objects above the horizon.
Well done.
Above the horizon is the same in your mind as distance to the horizon.
Okay. So which
part of those?
Let me try and make sure I've understood you.
Those are the same.
So let me try and understand you. A Black Swan, because it's a measurement across the flatness of the surface to the horizon, because it's from sort of my feet upwards, essentially, to the point of the horizon, and that's the point at which it terminates. That's different from taking a measurement from the top of the horizon up from there. Correct? Is that the gist?
Correct.
Okay.
That's the most logical thing you've said in the last 20 minutes.
Right. Okay. So, so I haven't misunderstood you.
Are those fundamentally different?
I think, they are definitely different. I get you now.
Horizon.
Yeah. Could you describe to me in what way that difference makes a difference with regards to the curved baseline? Because it sounds to me like the curved baseline is saying it matters where angle A is. Is it against the curve?
You don't have a curved baseline. You don't have a curved baseline. You, even in the mathematics of height of the observer times 1.22, you are still drawing a tangent, which is a flat line. And you are apparently drawing that flat line to a tangent point. There's no curved baselines ever. There is only either the flat tangent meeting the geometric edge, or there is the flat horizontal horizon to which we're measuring angles above. There's never a curved baseline.
Right. Where do we take the angle from, though? Do we take the angle? We take the angle as we've accepted. I don't want to go back to this. We take the angle through our eye. Where is the curve of the light that comes out of our eye that hits the horizon like it does in the Black Swan? That's all we need to know, right? We just need to be able to see in a straight line to the horizon. Whether we're measuring below it or above it doesn't really have any real bearing, don't you think?
Then you're not looking at the horizon, because the horizon would be the middle point. You wouldn't be above the horizon
middle
or
point.
below the horizon and still be
what you've got to do
the horizon.
Is try to figure out where that line is. In both of them, you're trying to figure out where that line is so you can go how much above it or how much below it. But the line's there. If it's there, and I can use my eyeball to need to see the horizon in order to do the Black Swan, then I must be able to use it for a sextant without there being a curved baseline bullshit. Because if it's just a line between my eye and where this supposed geometric Earth curve horizon is that's no more than 1.225 the observer's height in feet, a square root.
It cannot be. It can be no further than. And that black swan picture shows you it's 10 times further than. So
and it must rely.
It cannot be further than 1.2 based on the numbers that your side has already given us in terms of the radius dimension and the diameter of this presupposed imaginary spherical ball. In real life,
all of it. Happy to grant all of that.
It is not where it should be if the Earth were a ball based on the known measurements that they claim. The point that you're not understanding here is that my floor is not also my walls. Okay, so if I'm measuring something that's elevated on my wall, I'm not talking about my floor any longer. The fact that I use the floor...
I'm not following you on this. Tell me.
All right, well, then rather don't interrupt and let me make the point.
Right,
if I want to measure how high is something on my wall, you're claiming we're still talking about the floor, the flat horizontal baseline. We're not talking about the flat horizontal baseline when trying to measure the angle of something on my wall, because the thing on my wall is not the floor. You're claiming because a sextant measures an elevation angle of something above the horizon, we're still talking about the horizon. We're not. We're using the horizon as the flat baseline to measure an elevation angle. In the Black Swan, you're trying to measure the distance to the horizon. Black Swan, you're measuring the distance to the other side of your floor. In the sextant example, you're trying to measure the elevation angle of something on your wall. And you've spent the last 20 minutes trying to say that the angle measured on my wall is the same as measuring my floor. Makes sense here?
Yes, yeah, I'm with you. Like, I've drawn a diagram of it while you're speaking. The floor is in blue. And what you're saying is the measurement CAB, which is horizon, eyeball, floor, is not the same as measurement CAD, which is horizon, eyeball, star, right? They still rely on line CA to exist. That is my point. If line CA is curved, then the measurement to AB doesn't work. If the line AC is curved, so is there anything wrong with that diagram? That's what I want you to sort of focus on for this bit, because otherwise I feel we might get into semantics about things, whereas I think that's a fairly simple point I'm making, which is the line we're using for horizon is the same in both, which is CA.
I don't know how more simply I can put this. The Black Swan is measuring the length of line AC in your diagram. Black Swan.
How's it measuring it?
The length of the line AC, whereas a sextant is measuring the angle of DAC, meaning the angle at A between the lines of DC. So the one is measuring the distance along the line AC, Black Swan. A sextant measures the angle between DAC, only talking about the angle at A between DAC.
So is CA? So I'm with you now. So is the line? Yeah, I'm with you.
Things.
Yeah, you're measuring two different things.
And the elevation above the flat line are two different points.
How do you determine the length of line CA? Geometrically,
on a sphere with a radius of 3959, the geometric edge to which you would draw your tangent can be no further than 1.22 miles times the height of the observer squared.
So if it could be no more than 1.22 miles, could that line be curved? Or is it impossible for that line to be curved because it is no shorter than? There is no shorter distance than a straight line. So is it not saying that C and A are a straight line?
No, it's saying that the tangent...
Say it again.
It's the tangent that you would be drawing to your geometric physical edge. You're measuring the straight line distance. So
it's saying CA is straight.
You don't even have a curved baseline in the Black Swan because you're measuring the tangent, the straight line distance to the supposed sphere edge. So you're not even measuring according to the edge of a sphere or a curved baseline. In the Black Swan, you're using a flat tangent. In the sextant, you're using the flat horizontal baseline called sea level. Both of those describe the flat baseline. So if you're drawing a tangent to a presupposed curve, and that presupposed curve should be physical, that it does not expand and inflate and contract at will. Okay. Therefore, the geometric edge should always be where the geometric edge is. And thusly,
so can somebody give me...
we say can be no further than 1.22, because that is where your geometric edge should begin and doesn't.
Okay, so here's the other drawing I have for you. Is this...
Do you understand the point?
You just skate right past that. I absolutely understand. Sure, I understand the point. I understand the point. Would you like me to repeat it to you to demonstrate it to you? The geometric
skate right past the evidence, man. Why do you just skate right past it like he didn't even say anything?
I'm happy to repeat it. I'll steelman it now.
You just completely ignore it.
For lying about the
you completely ignore it and then move on to horse shit.
So no, hold on. I'm not even giving this dude a chance. Look, I just listened to the shit you said about FE Core. You're a fucking liar.
Is it not true? Have they released the footage?
Yeah. It's in the fucking document Roger posted. Listen, go down.
The document Roger posted is the one I was challenging its validity.
Let me finish my sentence. You just asked for something, and I'm going to tell you exactly where it is. It's in that document. So each test is listed. Experiments 1, 2, 1 and 2. Those are done at Balaton. 3, 4, 5, 6, and 7. Those are all done at Lake Issel. 2 of them were done in April. I think it's the 21st, or no, 14th. And then 3 more were done, like the 24th. So they were done 2 weeks apart. At the end, they have an image of the laser in the document. How did you not see that? In each individual measurement, they have images of it in the document. How did you not see that? You called him a fraud, right? You called him a fraud, right? If you watch their live stream,
if it's the one I'm thinking,
the live stream they gave out when they did the measurement where they put the green laser on the screen, it's well known that was a test shot. Okay? They did a live stream of this, and you're saying they're misrepresenting it. That's a lie.
So what's the bit that I said specifically that was wrong? What's the thing that I said that didn't exist? I'll
tell you the blatant lie. The salad didn't work, so they stopped using it. That's a lie.
They still did use it. Okay, maybe I got that wrong.
Listen. Dude, you have no idea what the fuck you're talking about.
I'm not sure about that.
And this is just claims, which in my opinion is slander. And
we're both just stacking claims up against claims here, and I don't know.
Look, no.
Fair enough. I can see you're upset about it.
Now you're backpedaling on your bullshit. You're just a fucking liar.
I'm still sticking by it. Show me that I got it wrong. I'll show you the Slice Barcane.
I've watched it. I watched it live when it was happening.
Discord call with him where I think, unless there's maybe details I got wrong.
When it was happening. Why?
There's maybe details I got wrong.
Dude, I saw it a long time ago.
Have you watched it recently? Is there a chance you've misremembered some in the meantime? Because it was painful. I would imagine you wouldn't watch it again.
Is an idiot because he's stupid. Slice Arcane is fucking stupid. He doesn't.
So that's a genetic fallacy, isn't it? Why the fuck do we care about Slice Arcane? The questions about whether the FE core guys lied. Why are you talking about Slice Arcane? That's just clearly a genetic fallacy. Talk about the people in the salad. Tell me about it, man.
Okay, and I'm going to tell you why Slice Arcane is stupid. I'll just tell you why he's stupid.
I don't really give a shit.
Because he says things like they didn't level the laser in the document. That FE core document. There's literally a picture of the laser level sitting on top of the salad. Right? And there's images of the ruler they used to measure the height of the salad with the laser level laser and the laser from the salad pointing at the same fucking tape measure.
Okay, so let me just check this. This is in the whole
fucking document.
And I've seen those photos.
This is simple shit. Shut the fuck up.
I've seen these photos.
I'm just going to mute you. Shut the fuck up. You're not going to come in here and accuse people of fucking fraud, dude. Like, seriously. You're not going to do it. You're here all the time. I don't tolerate liars. There's no point in having a discussion with the liar. There's no point. It's like, why are you here then? You're just here to lie. What's the point? You're just rooting for your team. And your bias has clouded your judgment. You didn't actually analyze the document. You're just parroting some stupid shit from another ignoramus. that doesn't understand simple things, right? The point is that, so I'm going to just say, one thing you said was the salad didn't work and they stopped using it. Actually, the salad didn't work because they were trying to hand aim it. So what they ended up doing was they added electronic control and a stepper motor so they didn't have to hand aim it. So they actually modified it to make it work better. And when they made it work better, because when you're shooting over a long distance, a small change in the angle makes the other end of the laser move hundreds of yards. So in order to increase precision, all that shit's in the document too. If you go all the way down to the bottom, it says stepper motor, 0.000024 degrees of precision. They added that. The other thing you said is they got rid of the collimator. No, the collimator wouldn't work, so they didn't use it anymore. The collimator was fitted for the green laser. It wasn't, which had a different housing than the blue laser, so they couldn't use the collimator on the blue laser, obviously, because it doesn't fit. Okay, so you sit there and say it didn't work, so they got rid of it. Those are just lies. They're just lies, dude. So don't come on the server and lie, or I'm going to just kick you off, and you won't be here anymore. You can get your own platform to tell your lies.
And as Indio so succinctly demonstrated here, is that he's not just simply repeating something that someone told him. He went to the actual documentation, down to the date that those observations were taken.
Yeah, but it's all in the documentation. If you read it, right, and actually try to comprehend it, and not just look for things that are going to try and, like, I don't know, pick apart or whatever, however you analyze information, I have no idea where you even got this idea from. You guys don't understand, like, simple things. So I'll give you an example. Slicer Arcane does this demonstration where he takes a laser and points it at the wall and said, this is some point-to-point thing. Well, they did a horizontal pan of the laser from target to target, right? So the thing is, and this is his contention about it not being level. The thing is, if you take a laser and you shine it like on a wall or something, right? And if it's not perfectly level and you rotate it, it's not going to trace an arc it's not going to trace a straight line on that wall. It's going to trace an arc because it's not level, right? Because it's a light being projected on a wall. And if it's tilted, that light will trace an arc across that wall. But when they pan the laser, they had the same elevation across all these distances. There was no arc. And this is another thing that Slicer Arcane demonstrates in this thing. It means he just doesn't understand things. He's too stupid to really just understand how this stuff works. Like, it's a total geometry fail. Anyway, I'm going to unmute you. You better have a pretty good goddamn excuse for why you told a bunch of lies, or I'm kicking you out of here.
Right. Oh. G'day, mate. Sorry I upset you.
Listen, I don't like liars, dude.
I don't think I don't. So I certainly didn't intentionally lie. That's the first thing I want to say. I certainly didn't intentionally lie. All the things I thought
go throwing around the word fraud.
So yeah, and I probably went a bit far at that point. That's actually fair enough. To me, the fundamentals for me about what I was claiming was that they, in their design, in what they said they were going to do beforehand, they said a salad and a collimator is important. And for whatever reason, I can remain agnostic to the reason. I've got no idea if it broke or didn't work or they found they didn't need it or whatever. They didn't use two of those crucial bits of kit. And it seems that you agree on both of those things. You're saying there was a reason that they didn't use it. That's fine. I'm happy for there to be any reason in the world. Then they came back with a result. But to me, my only point about them is I'll go back to this point rather than calling them frauds because I think you're right about that. I don't know what happened, but it sounds to me like we agree that they didn't use the salad, they didn't use the collimator. They said that was important, and they still counted their results.
They did use the salad. They modified the salad so that it was no longer controlled by hand, and they added electronics to it to control where it was aimed. Right.
Well, my understanding is that is the case.
When you punch in the coordinates and but the salad automatically pans itself and aims at the location where you say the target is.
Yeah,
because they were trying to do that by hand, and the precision is too much for the human hand. Because think about it for a second.
No, that makes sense.
Well, think about it. at 25 miles away, a deviation of what they said the collimator was, so 0.008 millirad, a deviation that small is 2 meters at the other side. Dude, that's like the width of a human hair.
Sure. Did they, for the final, their results, their positive results where there was a laser on the horizon, was that using the salad though? Because it looked very inexact. It looked like it was bouncing all over. What do you mean? It looked like it was being held by hand.
What are you talking about?
So the final images, let me show you some of them. So this one is the one that is often passed around, but hopefully most people know this is not real because they even admit that, is my understanding. They weren't showing this even, by their words, they weren't showing that as a positive result. They were showing that as a sighting shot. They were just citing it in. But in these shots...
I go off what I saw in the live stream, right? So they live streamed all them doing all this stuff. None of this stuff was secret, right?
Yeah, no, I'm not saying they did it secretly at the time.
Goldbusters live streamed on their channel. Jaronism live streamed it on his channel, and Karen B live streamed on her channel, all from their individual unique viewpoints, right?
Sure.
So like none of this stuff was like hidden. It was all done out in the open. If people draw conclusions that this is somehow this is what they're putting out, right? First of all, they're not thinking, because obviously the laser can't be like, this would be 12 kilometers. There's no way it's going to have that tightness of a beam at 12 kilometers away.
Yeah.
It doesn't matter like what, you're not thinking, you're not a thinking person, like if you're doing that.
Sure.
If you draw a conclusion that you think they're passing that off. No one tried to pass that off as an observation.
Typically, that's why I was careful about why I was careful about my wording. I don't think, and that's why I said it this way. And you heard
that isn't even their target. That was like a test shot. That wasn't even done at Balaton.
I'm not saying
that was done before they ever went to Balaton. Because, like, obviously, you have to set up what you're gonna. Right? They came up with a plan to do something. They tested all the equipment before that. Right? You just don't go somewhere and just start doing things. You have to like test all this stuff. Right? So we're gonna like. Okay, we're going to do this test distance. This wasn't even done at Balaton, I don't think, if this is the image I'm thinking about. Because I know they did test shots.
So would you agree that they don't
like
make it...
the fourth time they did this.
Would you agree that they don't make it super clear on their website such that I have seen flat earthers passing this top image off as the final result of them hitting a laser over too long a distance?
I don't know who's passing that off. I can't speak for other people.
Jin for one, but I don't know. Like he regularly does it, but he also admits that he posts things that he thinks are going to be impactful, not necessarily.
Well, I mean,
it sounds like you're a headline reader, and that you expect that every piece of information that's valid or going to be repeated should have been in the headline. Because like India just explained to you, there's multiple PDF documents indicating every little thing which you've just been proven wrong on. But
did they hit the target? The question remains. Did they hit the target?
And one or two other really worse than uncredible references. And they're making up lies which can be easily disproven in 3.5 seconds of actually reading the document yourself.
So I've read the document. I'm not going to take the document's word for it.
Listen,
everyone here is curious.
Even hitting the target at the Balaton, it wasn't their goal was to shoot 30 kilometers, but the weather conditions didn't allow it. A lot of people came from all over the world to go there. It's like it's not cheap to just go to Hungary and post up. So because of the weather conditions, they couldn't do the distance they wanted. This distance isn't even this. They can make this shot on a globe. The Balaton measurement, I mean, it's like within the margin of error of the measurement. I think at 12 kilometers, like it's supposed to be, like maybe 3 feet under the horizon or something. I haven't done.
So you're saying even if
this is Balaton, all this blue stuff, these blue, this target, all that stuff, all this is Balaton, Lake Balaton.
Hang on. So Balaton was a bust in your view. It would have been possible on a globe, you were saying?
Yeah, Lake Balaton, yeah. It should have been possible on a globe. It's within the margin of error of the experiment.
Do they make that clear on their website? Because I'm on their website and they say we went out and did 2 experiments. They do not ever say when we tested at Lake Balaton, we only got up to the point that we observed.
This is, in my opinion.
And beyond that, it was weather.
I'm going off of memory. All I know is I don't ever talk about the Lake Balaton one because it just isn't enough for me. For me personally, it's within the margin of error. It's within the margin of error. Like,
yeah, that's
like,
good
listen,
on you.
When you're talking about a foot here or there, I'm not, that's not good enough for me. The thing is, Lake Issel, this is two orders of magnitude different than the globe prediction. It's not a small error. You can't say, well, there's maybe a little bit of refraction. You need to refract around a 44-story building, and that ain't happening. That's the difference, right? So the globe prediction at Lake Issel, where they actually did more measurements, they did them further apart and took meteorological data and all that stuff, right? So that test, the globe prediction is that the laser is 127 meters in the air, but they measured the laser height at 1.5 meters. So this is two orders of magnitude. Right? 0, 0.
Yeah, I think I've found what you're talking about. The first one's over 12 kilometers, so it's really short. I agree with that, yeah.
So, and what they did was, so there's one target. We're going to punch in the coordinates, aim at it. Okay, what's the next target? Punch in coordinates. The laser horizontally pans. This is a control, right? So horizontally pans and it picks up the next target. Now, if you have successively, one target is supposed to be lower than the next target if it's close or if it's further away, and then the next target's supposed to be even further away, and that's supposed to be even lower. So how can a horizontal pan intersect all those targets?
I don't know, man. I don't know.
Exactly. I don't know, man. And unless they completely lied, I mean, it would have to be an epic, just a complete and utter lie. Which I doubt, because they do have lots of pictures. Because they have pictures.
I don't think they lied.
And all that stuff.
Here's what I think about it. It's what you would think about me.
What me to say? The people that did these tests aren't slouches. They all have university degrees. Mike Cavanaugh has 3 degrees. Yeah, so he has 3 engineering degrees.
So let me just jump in here. Do you think that globers who are deluded about the shape of the Earth, whether they have degrees, helps them with that? Or do you think people can be deluded about the shape of the Earth, still work in physics or engineering or something like that, even though they've got degrees?
Look, listen, this isn't a point of what I'm saying is,
does a theology degree?
It isn't about their credentials. It's about when you have certain types of degrees, right? If you have an engineering degree, that means you have the experience necessary to make a device like this, right? So it's not.
I agree. I'm not saying there's something wrong with making the device. Let me talk now a little bit.
Let me just finish. A normal person can't go out and replicate this easily. It would take effort because.
All I'm pointing out
required to actually do it because you're dealing with very fine tolerances. Now they could do it. Theoretically, they could do it after a lot of tries, a lot of failures.
Am I muted?
Well, listen, no, I hear you, but I want to finish my statement and don't.
But it's just being I'm not allowed to talk anymore.
Look, the point. Hold on, I'm getting a phone call.
No, Indio, I got this. Look, Eggs, you are not allowed to talk over people anymore. Okay, don't get butthurt about that.
I'm not trying. I try not to talk over people. I just thought it was I might get a go.
Listen, I am. Listen, I'm trying to Sorry, I have complex thoughts and I don't have sound bites.
No, that's fair enough.
A normal person can't just go out and do this. They could, but they're going to fail a lot. So if they have a big budget, they're going to go out there and try it 50 times before they learn how to hey, this is what I have to do to actually make it work. This was their 4th attempt. They've been doing this for over a period of 4 years, and every time they did you globe earthers would go, oh, no, that wasn't good enough, or this wasn't good enough, or that wasn't.
Yes.
So they go out and they take everything in consideration that everybody said was a complaint, and then they get the result, and then you guys the Hail Mary, it's a fraud. That's the only thing you can say now. It's a fraud. You had people that went to where they're incorporated and took pictures of the building and they're not even really a fucking a nonprofit no you guys
So
it's silly shit like that.
It seems that it matters. It seems that it matters that they are experienced engineers if they are in FE core, but if you're an experienced engineer who claims that it's a globe, it's not valid. That's the first thing I would say about it.
If you're an experienced engineer,
if we're going to appeal to expertise, which is fine, I think it's good to appeal to expertise. But if we're going to appeal to expertise, I'm not sure you're going to win that.
Why don't you list the engineers that have tested the shape of the Earth?
Secondly, regarding the fraud, whether it's a fraud. I don't know them. I'm not going to be good. I'm not going to be good at playing that game. But on the issue of whether it's a fraud, it sounds like you agree that one of the measurements is unimpressive. If you look at the FE Core website, do you think they make it clear that measurement was a bust because of the reasons you stated? Do you think they make it very clear that they went, we didn't get a result here?
Look, they make a document. They released all the information. You were trying to say that they were hiding shit.
My question is,
they released all the information. It's on you to go through it and decipher it. What are they supposed to hold your fucking hand?
Well, my question is, in it, do they, in that document, in that 15-page or 32-page document, do they make it clear that the Balaton was a bust, as you said it was in your opinion?
Yeah, make that
clear? Okay,
the numbers.
Please tell me which bit.
Read the numbers. Read the fucking numbers that they posted.
I mean,
do they have it clear?
Okay, well, show me. Okay, where
they post the numbers? They post the distance, right? They post what the laser is. They post their elevation. You can just read the numbers. They posted the numbers, right? How is that ambiguous? Do they need to put their conclusion? Hey, this is a bust.
Yes, absolutely they do. What do you mean?
It's a report.
Why do they need to report that their experiment failed?
Because they don't need to draw. They don't need to have an opinion about it.
They don't need to have an opinion that they went to test A or B and failed to find A, and it's not worth measuring that in your 32-page document.
No, but it's not a failure.
No, dude, because it's a report on a measurement.
Come on.
Have you ever read a report on like a data report? You just get a data report. You just read it. No, the engineers don't write on it, hey, I don't like this measurement because of XYZ. They don't write their conclusion. You just get the numbers. The numbers say what they say.
You don't write a conclusion at the end of a report. What fucking reports are you writing, man? All of them have a conclusion. It's the bit that everybody skips to.
This is a measurement report. In
summary, we should or should not build on this ground. In summary, this is a perfect location for a dam. Like, that's the conclusion bit, right?
But they're not doing it for that purpose. They're just making a measurement. That's all they're doing. They're just making a measurement.
They didn't report that it was a bust.
And you think it's irrelevant.
It's irrelevant.
Did report it. You're saying that you're trying to say you must draw a conclusion and draw a conclusion to tell us what your conclusion is on whether this is. They put the numbers. They're not saying, hey, these numbers mean this or these numbers mean that. It's within the margin of error. So you just draw your own conclusion. Here are the numbers. You're trying to imply they're hiding it or misleading it. No, they're not. They're putting for Balaton. They just put the numbers out there. You scroll down, but you're completely ignoring the vast majority where they put the numbers. They also don't draw a conclusion. You're not complaining about that.
Are you claiming that they are open?
Consistent with the geode model. That's what they say. There's a WGS84 model. This is what it is. The only conclusion they draw is this is not consistent with that.
In your opinion, do they make it clear that Balaton was a bust? Do many other flat earthers here know that Balaton was a bust?
Why are you characterizing it as a bust? Why are you characterizing it as a bust?
You used the word bust first. I'm just copying your word.
I never said it was a bust. Listen,
you said it was within the tolerances of the.
I said it wasn't good enough for me. Don't try and put words into my mouth.
Right, but
listen, you're a propagandist, dude. This is obvious that you're trying to characterize things as a bust. You're making the assumption that they were trying to prove something one way or another. They were testing a model. They're testing.
I just don't think they make it clear. I just don't think they make it clear. I don't think in this image, when they release this on this website, I don't think they make it very clear that is a sighting shot.
Obviously, you've never done any actual flat earthers in your phony. Because when you test
real
the
science
model,
writes conclusions, doesn't it?
Well, dude,
it has conclusions.
Listen, you test a model, right? The model has certain measurement results.
Yes.
You make a measurement, and then the measurement says, here's the predicted, here's the actual value. You compare the two. Then you go, okay, what's the margin of error? What's the precision? What's the inaccuracy? Maybe they should have done that, but I don't know why they didn't. because that's kind of hard to like quantify, and it's actually not necessary because the margin of error. There's no way you have a fucking 2 order of magnitude margin of error. You're not going to go, oops, I didn't read the tape measure right, and I read 4 meters instead of 440 meters. Like, that's not like I didn't read the tape measure right thing.
And the experiment wasn't bust, so that's a misinterpretation. What India was saying to you, it wasn't definitive. It wasn't definitively towards one or the other. So it's not to say that one is fallaciously propped up with fake information.
Yeah,
what India was eloquently explaining to you in a lot of detail.
It set out to measure something and failed. That's what it did, right?
No, the measurements
they did not fail.
Okay, what did they measure? Tell me what they measured.
You globers wouldn't see it as definitive. So they went for longer measurements to make it more definitive. The measurement was concluded.
It was concluded.
This is the entire point.
Was it a meaningful measurement?
Have you seen the results? Have you looked for this information?
Yeah, I've looked.
No, you haven't. As Indio just schooled you about 20 minutes ago, pretty much everything you thought you knew was wrong. And as he went into thorough detail on every point with you.
Kind of silly, so I didn't remember it very well. It's entirely possible I've forgotten parts.
You have too many feelings about this. That's your problem.
Well, I feel you guys have been conned, yeah.
Yeah, well, you have no evidence for that.
Well, I do. I think I've got good evidence for that. The evidence I've provided thus far is that they don't make it clear. Is that they don't make it clear that these are just sighting shots. That they don't make it clear in their results that the first experiment was a bust. That many people share these images, claiming them to be hits.
The word bust. Quit using the word bust.
What do you mean a bust?
Quit using the word bust.
It's set out to measure something and failed to measure that thing. That's a bust.
It didn't fail anything.
What are you talking about?
Never failed.
Did it succeed? Did it succeed?
What are you talking about?
It succeeded in what it was trying to do there, yes.
Which was measure something or not?
It's just that the distance of it isn't large enough to say definitively whether...
Okay, give me an example of a non-bust. Give me an example of a non-bust. What would have been a non-bust?
You hit the target, you measure the distance. How fucking clear can it be? You set a target and you want to know what a hit is. Come on, man. You don't need to do any mental backflips.
They did do that. They did do that. What are you talking about?
Well.
And they didn't release any... And they don't release any images or footage of that. So they did hit the target at Peloton. Okay, so we've changed the story again. We're disagreeing now with Indio.
Listen, they live streamed it. What are you talking about?
Hitting the target. Awesome. Show me the image of it hitting the target. That's my claim, that there is no image of it hitting the target in any of the experiments except this sighting shot.
Eggshells has been a part of the server for quite some time, right? If I'm not mistaken. Yeah. He's been in here. I've seen you in here, Eggshells. That's why I was asking.
Hey,
but
listen,
what's going on, dude? Like, it sounds like you and I'm sorry to interrupt you. I'm just coming in here because I hear Eggshells with the laser test. It sounds to him like it's very unconvincing, which I know he's been in here kind of debating this kind of idea of where he feels he stands with the globe. But Eggshells, like you're very adamant about coming in here and seeing if everything that Flat Earth is doing to provide enough or substantial evidence for the case is good enough, right? So you're basically just challenging the case and putting up your points as you see from, I guess, your perspective, and then saying, okay, making a ruling and saying, this is not good enough, right? I mean, basically, what you're telling Flat Earth individuals in here right now. Did I just summarize what you're...
Actually, ridiculous red herrings at that.
The vast majority of it was absolutely correct. I don't. Okay. I like debating with people and arguing with people. I don't want to make. I agree. Like to be like I'm better than you. I don't like that idea. No, that doesn't gel with me. Maybe it's a bit on a dark bit, but no, possibly. I don't like the idea of.
Can I say something real quick? Why don't you post in the live stream a peer-reviewed research paper where they took pictures of the result you want? Go ahead, post that. Post a good for you, a good enough peer-reviewed paper. Post it in the live stream. Go ahead.
I'm not even sure what you might be talking about.
Exactly, because you've never actually read any papers, right? Okay. So you've never actually read any papers, right? Have you ever read a peer-reviewed research paper ever in your life?
Yeah.
Okay.
Yeah,
Tell me which one have you read? What was it about?
It was mostly psychology ones, so about the Milgram experiment, about the Stanford prison experiment.
Did they take pictures of the people?
At the Stanford prison experiment, I'm pretty sure they did. Whether they were live pictures or recreated ones, I'm not sure. The Milgram experiment, I don't think they've got any. I'll try and find some. It's a new.
I'm going to just say these people don't even exist.
So should we discard the Milgram?
Because there aren't pictures of the people. In fact, the scientists don't even exist unless there's pictures of them. And the universities don't exist if there's not a picture of the university. This is how fucking dumb your argument is.
Yeah, so basically, India.
So excuse me. That's a ridiculous straw man. I'm saying
no, it isn't a ridiculous straw man.
Let me say it. Come on, let me speak. Let me speak.
Pictures of bullshit, dude. They usually just give you the numbers. Usually, in the papers I read, they just give you numbers. They don't give you pictures of everything.
So
right. So I'll give you an example of a laser test where they don't give you pictures. You're just wrong, dude. I'm not going to let you.
If their experiment is to take a photo of it and their result didn't include a photo of it, yeah. Just because I can't think of a psychology experiment that happens to have that, I can find you a million experiments that have a photo in the results. I've posted one.
Where did Effie Core say that they needed a photo? Where did Effie Core say that they needed a photo and that their measurements were invalid unless there was a photo?
There was also no requirement in this study for them to photograph the flying frog, but photograph it they did. Are you telling me people stood there in front of a target? Hang on. No. I've got an easier way to settle this. We can settle this.
The Milgram experiment had no photos and therefore it should be discarded. You agree?
No, this is a ridiculous straw man of my position that I think that every experiment must have photos, otherwise it is false. It's a ridiculous straw man of it.
That's your only point. That's your only point that you've been bringing up. Where's the photo of them hitting their target?
So that I can't make the point. The point is there were like 20 people there with cameras and none of them have a photo of it. And this study, quote unquote, releasing, proving the globe to all of us, didn't include photos.
Yeah, that's a lie.
Suspicious about that?
There's a lie that's not in the listen, there is not photos in the report. What is the photo I just posted? What's that? Is that not a photo?
Let me find it.
I just posted a photo.
Yeah.
Is that not a photo of the laser?
Drive.
Right window. Yeah, is that a photo of it hitting the target? Where's the target?
Listen.
And that Google Drives are full of photos.
Was live streamed.
Sure. Where's the target in that photo?
It's not in that photo, but they do show in the live stream that was watched by, I'm sure, some Globers, and I'm sure Globers saw it. I'm sure you do, right?
Well, I'm
just
sure
pulling bullshit.
We would have images of it. That's what I'm sure. If it was live streamed and there were multiple people there with cameras,
I have an idea. I have an idea. I have an idea. The people that were involved in this are all listed. Why don't you email them and ask them for a photo?
Sure. Why don't you email and ask?
You'll never do that.
Why don't you email the people from NASA and ask them why they lost their footage? Isn't it such that NASA lost?
Because they issued a report on why they lost their footage. They say that they taped over it. I don't need to ask them shit.
Okay, so isn't it weird that these guys also lost their footage? Isn't it a bit NASA-like?
Who said they lost it? No, who said they lost it?
I haven't seen it. I haven't. Have you?
So if you haven't seen it, they've lost it.
Well, they haven't shown us, so they certainly.
But that's your logic. You haven't seen it, so it's lost. That's the next logical conclusion.
No, I think they're hiding. I don't think
maybe you're just not important enough to give a fuck about.
Hey, Excel, let me ask you, bro.
Why would you hide it? Why would you take
now see the characterization that's hiding it? Who said they're hiding it?
Excels.
You're so fucking important, right? If they don't show it to you, they're hiding it, or they lost it, or fucking goddamn, there's a great criminal conspiracy because they didn't show it to writing with fucking eggshells. The most important person on the goddamn internet. Maybe I don't give a fuck about you.
You're a
retard, dude. Like, seriously, your fucking sophistry is beyond all hell, dude.
All of you in here, you all should have seen those images. It's not about showing it to who irritates you. It's about showing to you guys to prove that you're right. You do live on a flat earth. They've got the evidence they could show you, but they're not. For some reason, did they lose it? Maybe. Are they not showing you for a different reason? Maybe.
Maybe it's irrelevant.
It's irrelevant whether you live on a flat earth.
No, it's irrelevant. That particular image is irrelevant. You see the image I just posted? Right?
Is it hitting a target? Oh, no,
what does it matter? Yeah, it's hitting a target. The fucking camera.
Hit a target. What do you mean? What does it matter? The goal was, can we hit a target? They made a giant deal about getting a super accurate laser aiming device to hit a target. It doesn't matter. If you're just going to wave a light in the sky, do you need a super accurate laser aiming device?
There's something called a beam centroid. You don't see. You're another ignorant fuck that doesn't know how lasers work. There's something called a beam centroid, right? It follows a Gaussian. Do you know what a Gaussian is?
No.
So a Gaussian is a bell curve. That means the intensity of the beam is going to be more towards the center. If you are not in the beam centroid, you will not see a bright center and a degradation of the light as it goes off to the sides. That's how you know you're seeing the beam centroid. This is an image of both
how do you know
centroids. Because that's how it works. Pardon me?
What does it look like from the side that you can tell that you're in the centroid?
You won't be in the centroid if you're aside. There won't be a bright center to the light.
So you mean all of those lasers that they've taken images of are shooting straight towards them?
That's right. They're in the beam centroid.
Not look at the photos, man. They're shooting like off to their head and over to the right.
Hey, Indio, he's just going to keep picking apart.
You see, like,
yeah, because it's broken. It's bad. I did hit a target and they waved the light in the sky, and you saw lights in the sky and concluded what was under your feet.
Wrong. You're wrong. You're just lying now.
Hit a target. Did they hit the target? Yes or no?
You didn't justify your lies before. You're lying now. No one just waved the light in the sky and said, "Look, we see the laser."
Did they hit the target?
Yeah, dude. Listen.
Okay.
Did
they show us that they hit the target?
Answer this one question. Did light from the laser arrive at the sensor of the camera where they took this image?
I don't know where the camera is. I'm waiting for it to hit a target that they made.
You don't know where the camera is.
They brought a 10-foot.
So they took a picture of the laser that the light from the laser didn't reach. That's what you're telling us. Like, really, that's your argument. So they saw a laser, but none of that light reached the camera. How did that fucking happen?
It wasn't what they were testing, Indio. I don't know how many other times to say this. They set out saying we need a super accurate laser aiming device because we have to hit a target. It needs to be down to the micron. But if the result included waving it in the sky, it doesn't matter if they use a super accurate laser aiming device. They can wave it in that direction all afternoon.
They're trying to characterize this shit with emotional terms, dude, instead of just analyzing it unemotionally.
Did they hit the target, Indio?
Yeah.
Why didn't they show us that? Why is there no footage?
What do you think this picture is? Where was this picture taken from?
I don't know. No, it doesn't show it hitting the target, does it?
In front of the target when they took this picture.
I want to see it hitting the target, and I just have to take your word for where the camera.
Yeah, he's not going to believe you, Indio. He's not going to do it.
Listen, it wouldn't matter anyway, right?
Why wouldn't you show the target being hit? Why would you take so much photo and video of a light on the horizon and not take an image of the target being hit when your whole reason out there that weekend was to take a photo of a target being hit? Come on.
You're really arguing.
It doesn't matter if you did. The point is, even if they took a picture of the target, you would make an excuse about that.
Yeah, that's what I was saying. That's exactly what I'm telling you, India.
A direct image of a laser. Listen, shut the fuck up. The direct image of the laser, which is in this photo that I just showed you, is more conclusive than a picture of a target because you can clearly make out the intensity of the light is in the center. That means you are in the beam centroid. That means it is aimed right at you. If they were off to the side, say 25 meters, they wouldn't see an image like this. They would just see a little blue halo off in the distance. Okay, this is how lasers work. This isn't my opinion. You can go look at it on the internet anywhere. Type in laser centroid. It's how they calculate divergence. It's how they calculate
eggshells. You know it's hitting the optic. Eggshells.
Isn't this why they had a collimator?
You can actually measure this with a photometer. You can take a photometer and a laser and fucking move the photometer up and down and watch the readings go up and down as you move it along the laser.
That's common knowledge. You know this. Come on.
The very function of a camera sensor is it works by photo intensity.
Now, just agree on that point. Just agree on that point at least.
Yeah, absolutely. I agree. The light hit the camera. If you're seeing a green light, that green light has definitely come from that laser. I'm not absolutely going to argue with you on that.
Okay. Well, that's what he's saying.
Yeah, I agree. It's clearly light has left the laser from the other side of the lake and traveled over.
And you're standing in front of the target. that there's no way that laser could have also hit the target. No way. So they got it. So this is what they did, right? They took a photograph. They took a photograph, but then like the target, we're just gonna pretend that like because the target that's hard to do, but the fucking camera's easy to do. So they went and faked the harder thing and hid the easy thing, right? That's what they did.
What did they fake and what did they hide?
Listen, think about it for a second, right? They show images of the camera in the beam centroid, which is harder to do than actually hit a big, huge fucking square.
Right, okay.
So they hid that, right?
What?
So they hid that. They hid that.
That's
something less conclusive they're deciding to hide. And they decided, we're going to, the shit that's more conclusive, we're going to show you. But we're going to hide that stuff that is not conclusive.
I mean, I don't really understand the point.
Because
if it's harder to be in the centroid,
accuracy and precision, right?
If it's harder to be in the centroid, wouldn't they have just used the collimator? If they wanted to know exactly where the
precision, dude, do you understand?
So how can you tell
right over a target is not as accurate as taking a camera and pointing it at a laser and capturing the beam centroid. One is harder to do than the other. One is a less precise measurement than the other. You're saying they hid the less precise measurement and showed everybody the more precise measurement, and you have a problem with that.
No, that's a bit of a straw man of what I'm saying. What I'm saying is they set out
complaining about the target that they don't show it as if there's something, and you're trying to characterize it as a fraud and they're hiding it or something. Yeah, but they do show you the more precise measurement. But you're going to ignore that for your straw man, for your red herring bullshit.
I think it's more precise, Lou. I have nothing to base that on except your say so. That you sorry, I beg your pardon, Miggy. No, Miggy, that's not Miggy talking.
Indio, thank you.
That's not me.
Sorry, man. Sorry, Indio. We've got nothing to base that off except your say so, right? So that's an untested.
My say so. You can Google it, dude.
This thing about the centroid, I would want to know. I want to know what bandwidth I'd be seeing it out of, and I guarantee you that if I Googled it, I would find a function that mattered about the collimator and beam divergence and strength of the laser. I couldn't just tell it by looking at it across the lake. It would be a complex. It would be a complex. If what you're saying is right, I imagine it would be a complex formula.
You can measure the intensity from the photograph. You know they have histograms like in Paint and Photoshop and all those things, right? You know these things exist.
You've done that?
Dude, like literally, you don't even need to do it. You can just look at it. But if you actually want to if you want me to cut this out, right, and put it in a histogram and measure the intensity, the pixel intensity across the image, it's fucking trivial to do.
Yeah, it's trivial to do. I just don't know what number would say this is definitely the centroid, and here's how wide the centroid is of a distance of that. Does it include refraction?
You're going to get a Gaussian curve, dude.
It sounds just complex and nonsensical to me.
Because what makes sense to me? What do you want me to say? What do you want me to say? If that sounds complex, a Gaussian is a very primitive, I don't know, first or second year university concept. It's not complicated.
Okay, so can you correct me then? If I go quickly through my claims about FE core, can you tell me which ones are false? Did they set out originally?
Every single one, just about.
Did they set out originally to hit a target with a laser using a super accurate laser aiming device?
And WGS-84. No, they set out to test the WGS-84 ellipsoid.
Did they bring with them a laser and a super accurate laser aiming device and a collimator and a target?
Yes.
Did they, in their design, claim that they wanted to hit that target with that laser using that super accurate laser aiming device and the collimator?
Oh, yeah.
Did they succeed at that at a meaningful distance?
No.
Did they make that clear to everybody?
Did they make it clear to everybody? No. I mean, no.
No further questions.
Okay. So, but what does all that mean?
I don't think it means, like, when I used the word scam before, I was probably being a bit inflammatory or provocative, but I think the same thing about them that you think about geodetic surveyors.
But the thing, that was a pretty slick maneuver you just did there, because you switched their purpose.
I don't know their purpose. I've got no idea their purpose. I don't think it's meaningful to me.
The WGS-84 model, they had a particular way of doing that, and you say, did they do that? Yeah, they tested the model. Did they test it to the extent they wanted to test it? No, but that wasn't because of the Earth's a ball. It was because of.
I'm not saying that. No, I'm not even arguing.
And there was weather. So they couldn't do the third measurement that they want to do. They couldn't perform it. Okay? Was what they did, the measurements result they had a test of the WGS-84 ellipsoid? Yes. Is it conclusive enough to falsify the WGS-84 ellipsoid? No.
Hey, Eggshells, are you saying that it's too complicated?
It's a fucking maneuver.
Is it too complicated for the layman?
At this shit. Okay?
Is that what you're saying?
Maybe you should go back to law school.
Yeah,
that's right. Go back to law school.
I wouldn't get into law school.
So, Eggshells, are you saying that it's
a pretty slick maneuver, dude? I'll give you credit because that was some pretty selfish propaganda bullshit you just tried to pull.
Yeah. Hey, Indio, is he saying that it's too complicated?
To make it look like something it's not, but switching the purpose from one thing to another in the middle of it. That was pretty slick. I'll give you credit for that.
I'm
right.
You guys hear me?
Go back and listen to the live stream. If you write that down in text, dude, and read it, dude, pretty slick. I'll give you credit for that.
Hey, let me ask him a question, Indio. Like, was he saying that it's too complicated for like a layman to understand? Therefore, he's saying like it's not easily digestible for anybody just to look upon and say that they can make a conclusion from looking at this that the Earth is flat because of this test. Eggshells, I need your opinion or your voice on this. Like, is that what you're telling? Because you were giving him a line of questions, which I was listening to, but towards the end of that, it kind of sounded like, is it something? And I'm rephrasing it kind of in a way that I'm thinking what you were trying to say. Is it easily digestible for a layman to understand? Is that what you were basically saying to him? That it's too overcomplicated for anybody?
No, so it wasn't. Okay. No, it wasn't really about how easy it is to understand. It was just did they set out to hit a target? And then the second question is, did they hit the target? And the last question is, did they make it clear? What I mean is not like, was it beyond a layman's ability to get it? But I mean, when they came back, they had lots of backers, lots of people following them on Twitch and stuff, people really excited about this measurement. When they came back, did they loudly say to everybody, this was a failure? So
because it wasn't a failure, dude. That is a mischaracterization.
That's
a mischaracterization.
Sure. I'll own that. I'll own that characterization. I would say if I tried to hit a target, like I just got my gun license, and so I've been playing with guns a bit. If I miss a target, I'd call that a failure. Let's just say
listen. You're trying to simplify everything into fucking like 80 level IQ shit. Things are complicated. Experiments are complex. They can't be boiled down to one phrase of a bust. Okay?
Did they hit the target?
That's for low IQ people, dude. Like, seriously, no, that's for low IQ people.
It's just to me.
Yeah, say it. Say you, like I said, low IQ people.
No, it's free thinking people.
No, you're a low IQ person. No, you're just a low IQ person. Everything needs to be boiled down to a 3-second soundbite. Or fucking, like, it's not worth looking at. If this isn't like I gotta be able to characterize this bust, not bust. Thumbs up, thumbs down. What is this, fucking Rome? Is this the Colosseum? Thumbs up, thumbs down? Is that how the world is?
Do you give a thumbs up or a thumbs down to Foucault's pendulum?
Thumbs down.
Foucault's pendulum? What is
down, dude?
So it's okay to give thumbs downs to things. I've given you my reason for giving a thumbs down to this.
And because it gets spurious results.
All right.
It gives results that are unexplained.
So
you never actually looked at anything. Tell me about Foucault's pendulum. When they did Foucault's pendulum and where you think is the South Pole, what result did they get?
I don't know.
You don't know. You don't know anything about it. You're just talking out your ass.
I don't know. I think it's acceptable that you give it a thumbs down for your reasons and you share them with me. I give this a thumbs down, and I've given it
exactly because I have reasoned reasons. You have your feelings.
Actually, I did want to ask you though. Go ahead, Lou. You go ahead.
You asked Indio thumbs up or thumbs down. You gave him two choices. He gave you one out of the choices. Okay, and now you're going to say like, "Oh, I thought we don't do thumbs up, thumbs down." Again, this is how dishonest you are.
He just Excuse me. That just came off the back. He said, you gave a thumbs down to my experiment. What are we, Caesar now? And I just interjected, if he's brought up the idea of thumbs down, do you accept that you do thumbs down to Foucault's pendulum? Straight up, he goes, yes, I do thumbs down to Foucault's pendulum. So ergo, there's nothing wrong with it.
All right. So you read it off.
I also gave like 5 reasons why.
Yeah,
so
you read it.
Reasons again, if you want.
I gave 5 reasons why. You're like, oh, they didn't show this image of a fucking target, but they showed other things which are better than that. But I'm going to ignore those.
So he wrote it off already. It's written. It's written off. It's a thumbs down for him. It's a written off. He doesn't.
Yeah, it's not like someone brought out something better than Foucault's pendulum.
So,
right?
but, yeah.
So there's Foucault's pendulum, right? And I go, well, they didn't show a picture of Foucault's pendulum, but they did something better that they did take a picture of, and I'm going to ignore that.
What's better?
I'm going to red herring on this fucking other bullshit over here.
What's better than showing the result?
The photograph. The photograph of the laser. Look in the live stream. This is a Gaussian. I posted it. It's right there. It's right there, right above the laser. See that? That's a Gaussian. That's what a laser looks like when you're in the center of the beam. Oh, look at that blue one. Oh, my God. What is that in the center?
Okay.
What is that in the center, dude? Do I need to fucking actually do a fucking histogram of this? You can see this with the naked eye.
Okay.
Now, this one over on the right, it's a little more clear, but if you zoom in on it, you can actually see that it's faded around the edges. Right?
I'll zoom in
so
a bit.
Maybe this one.
The screen, and I'll show you, and we can zoom in on it. You can take my perms away in a moment if you want.
What are you talking about?
Like,
no, we're not talking about stuff. We're not going to let you red herring to something else. Address this shit.
We're staying on this.
Address this shit right here.
Yeah. We're staying exactly on this amplitude of this centrum you're talking about, right? I just want to know the distance.
Of the laser.
Yeah, I want to know the distance when we're talking about that wave. How do I calculate? Let me put it back in the chat.
How do you calculate that? You take the half angle, the center of the beam, for whatever the beam divergence is of the laser.
How do you know the beam divergence of this laser?
Well, the green one had a collimator of 0.008 millirads. So the beam divergence from this distance is probably, well, what was that? So I don't know what they use the green laser for. 6 meters? It doesn't matter. I don't even want to talk about Balaton. Listen, Balaton is pointless to talk about. It's not a definitive frickin' test. It's wasting my time.
The question is, did they make that clear? And time and again,
it is with the numbers.
You and other people in this chat accepted that they didn't make it clear that this was
They made it clear enough. They made it clear enough to thinking people, the people that know what they're doing. Okay, they made it clear enough to those people. Maybe they didn't make it clear enough to you. Maybe they didn't make a children's book that they explained Balaton like I'm 5. Okay, maybe they didn't make that. Maybe they need to make that version of a PDF, and I'll send it to you. Maybe I'll just make it myself, and I'll send it to you. Explain it like I'm 5 because I'm fucking dumb. I'll fucking make that just for you. Like, seriously, this is just level of I'm treating you like this because you know exactly what you're doing. You're a sophistic liar. You know exactly. You're not this dumb. I can't buy that you're this dumb after using that slick maneuver you fucking just made. I can't buy you're this dumb. I just can't buy it. You know what's going on.
I guess I just don't understand.
You're a liar.
It sounds like what you're saying is we went out to do an observation or a test or a measurement or something, or maybe even an experiment, and we didn't make it clear what our results were.
No, they did make it clear. They did make it clear. You see this picture? In that report, there are numbers. The numbers describing everything.
Show me the numbers that make it clear.
Because science doesn't go... Listen, when you read a scientific paper, they have an abstract, then they have the experiment, and then they have their conclusions. You can ignore the fucking top and the bottom and just look at the experiment, because guess what? Only the experiment is the science. The other shit is people's opinions. And people's opinions don't fucking matter in science.
Right, so the conclusion...
They don't matter.
Would you say normally an experiment or measurement or surveying report or anything like that, even Indiegogo, that kind of thing, typically people would expect a conclusion. It's like a normal thing.
Depends on it depends on the level you are in the hierarchy of whatever that project is.
Yeah, I'm not in the hierarchy. I'm like, if the government released a report saying, you need to...
Depends on where you are in the hierarchy.
Windows, and I go, can I see you working on that?
Okay, so it depends on where you are in the hierarchy. So say we had a bridge project, right? So there's going to be people that go out and actually do the surveying. And they're going to write down numbers. and they're going to put that in a report, and they're going to send it to their supervisor, and he's just going to have a bunch of raw data, right? And he might send it to his boss that summarizes exactly where it was taken and when the conditions are. So he'll add a little information, the background information. So this is the raw data. This was taken at, the east side of the Mississippi River on June 4th, blah, 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 blah. And goes to the project number, then he'll send it up to his guy. So there's levels of where the data goes. And each person, because usually when you go up management, the less fucking educated they are. So you have to dumb it down as it goes up. So you're perfect for upper management. You should just apply to a CEO of a company at this point.
What kind of measurements would he have to take to do that?
What do you mean?
To do that work of giving, if let's saying a bridge is going to go in, what kind of things are going in his report?
It depends on what level you're at. It depends on what your job is, right? So people have different jobs. We have we compartmentalize stuff. So someone has a particular assignment. So maybe one guy, his job, he has to see something, but the information he needs, right, is for the insurance, right? The information somebody else needs is for the government. So he makes another type of report, and they have their requirements. And then someone has to take the data and give it to somebody else that has their needs, right? This is why we have people doing jobs that don't matter, because everybody needs their little slice of information shaped in a different way. Apparently for you, it has to be dumbed down to such a level that the numbers aren't good enough, and that you need crayon level coloring book shit where you need a picture of the goddamn laser hitting a target when in place of the target, they've taken pictures of it, right? Images, which are actually measurable, which actually have measurable data in them, which is far more definitive, because from this distance, you're not going to actually be able to distinguish the beam centroid on a target. That would be nearly impossible unless you're doing it in vacuum in a completely dark chamber, because of ambient light is always going to ambient light is going to wash out the target. Plus, the target's going to absorb some of the shit. Blah 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 blah. They do these tests, not just like us, right? So the Air Force does laser tests.
Sure.
So
what kind of things do they test
between the Hawaiian Islands?
Yeah, right.
Right. So what did they use? What did they use?
I hear you switching it.
What did they use? You know what they didn't do? They didn't take pictures. You didn't take pictures. So obviously the fucking Air Force got defrauded. I think I'm going to file a claim under the Federal False Claims Act and get a little bit of money, because obviously if they don't have a picture, then it didn't happen.
It makes me doubt it, certainly, as it makes you doubt the 9/11 missions, because they don't have the original footage. It does cast doubt. Does it not? Sorry, the moon missions. The moon missions.
You don't know why I doubt the moon. I doubt the moon missions because they're just full of shit.
You don't. Okay. And so something that contributes,
because I know how physics work.
And something that contributes to that, is it or is it not that they are missing important data? And you're like, well, they lost the tapes, which I think is a good question. They just lost the tapes.
The telemetry tapes are gone, but that doesn't do it for me. Listen, there's images taken where the crosshairs are behind shit, dude.
So do you think
it's called a Rousseau plate. There's a Rousseau plate that's inside the camera. But I'm going to tell you why. Just personally, there's a Rousseau plate that's inside a camera, right? And there's these little crosshairs. And the purpose of the crosshairs is that so you can measure shit in the image. Some of these crosshairs are behind objects. Now, if it's behind an object and the plate is inside the camera, that's impossible. That means it's a composite. Okay? And if I see one fake thing, I'm not going to say, well, they only fake this, and then the rest is okay. The fact that image exists, several of them, where the crosshair is behind an object, that's enough. It's over right there. Then there's the other stuff. I mean, and then you can,
So just to jump in.
There's so much other stuff, I'm not even going to get into it.
Do you find that these, what do you think about the lack of available telemetry data and original tapes?
Irrelevant to me.
Irrelevant. It doesn't
irrelevant because the shit they've put out that they actually said is the real stuff is so bad That alone is enough. It's
Sure,
not their lack of information.
I'm not
it's
saying
the information that they do put out that tells you that they didn't do it. It's not. It's
Right.
like what they did put out.
So it sounds like you're saying I'm very convinced for another reason. So this one doesn't factor into why I'm convinced. That's fine. But what I'm asking you is, do you think that people not having footage of something quite important, an important piece of data, is a bit sus? If you don't want to talk about the moon missions, that's fine.
It is suspect, but that's like the easiest thing to fake.
Sure, and because it's not just the moon missions, is it? It's like, where's the videos of like lots of? I mean, flat earthers would say, "Where's my videos of lots of different things?" Right. So the requirement.
What flat earthers say that?
Loads. I mean, I don't know. Is percentage still in here? Percentage like saying it. Lots of people say it. I want more evidence of it. Do you not want more evidence?
No, dude. Like you've been in here before. Like I said, I'm mentioning it because every time that you come in here, you put flat Earth on the trial, right? You're testing everything out. You're asking the questions, but you've never really stopped to think all the information that you've gathered, even being in this server. You've never challenged it, bro. Like, really, you're on about this whole idea that you just honestly believe in your heart, like with all your might, that the Earth is a globe and that everything that has been given to you, secondhand information, is absolutely correct. So everybody that's in here, including Indio and everyone that's giving you the information, on the contrary, is really just challenging your worldview, and it's frightening for you because you don't want to.
That's pretty true.
I have a question.
Well, I'm just saying, man. I'm stating the obvious because you've been in here before. I mean, I don't see why at this point you would be challenging India on these things because you've heard about the laser test. You've been here many times, and the thing is, you want there to be enough evidence for your own satisfaction that will never happen because it seems like with everything that is given to you. That's substantial. It sounds like to me, from what I'm listening to you having a conversation with Indio, it sounds like you're going to pick everything apart. And then on top of picking that apart, I hear you switching topics. And you're not slick, dude. I've been doing this a while, so I know that every time you ask him that you go off to another thing and you tag another thing, it's an endless line of questioning. That's to you, I guess you love it because you just admitted you like arguing, but you just keep going to the next.
We all do, don't we?
Well, we do, but like, listen. At some point, you and me, as individuals, we have to come to a conclusion. Either you are going to continue to believe that the Earth is a spinning ball in the outer space or whatnot, or you're going to say, "Hey, wait a minute. You've used this term before, and I don't think you really understand what it means." But a free-thinking individual is not somebody who just takes information secondhand and then just says, "Okay, I'm making a conclusion that I was taught this, and I'm going to believe that it is what it is because maybe hundreds of people came together and said so. I will challenge it by then doing something myself to verify that information." I don't think you've gotten to that point. I think you're at the point where you're asking us. You're telling the panel here, why would they lie? And you're on about giving us a hard time about us trying to explain to you why they would lie in so many different lines of questionings that you've given us. I'm summarizing.
I've dropped the why would they lie. I don't think I've asked.
Do you think you've made an honest inquiry into this topic?
That's
I
what
think I have. Yeah,
I know that's what you're getting at, Miggy, but I was just putting it like in a.
No,
I think I have. I think you could test me on it and see whether I have. Whether I've.
Have you put the level of scrutiny that you put into the FE core document into any globe evidence?
Yeah.
Anything. The Coriolis effect, the fucking Foucault's pendulum, the Cavendish, any of the globe so-called proofs. Yeah,
we're not examining like the globe evidence right now, eggshells. But what I am saying is that being honest with you and me, I don't really honestly think that you've done that much investigation into the globe because you, in your mind, you're satisfied with the whole world knowing that it's a globe. Like to you, that's good enough. Like you're like, well,
yeah, that I would agree.
I mean,
right? Do you have doubt? You're evaluating a laser test, which blows me away.
How much doubt do you have,
how
Miggy?
the device works before you evaluate it.
Yeah, what'd you say? Actually?
How much doubt do you have, Miggy?
Doubt on the globe or doubt on flat? What do you?
Doubt about flat Earth.
Doubt? No, I don't think there's
Now,
doubt.
see, I tried to flip it. Now you're the religious one. Now,
No.
what about your
This is
beliefs, Mickey?
I think this is fair parity, because I think what you're saying about me is absolutely right, Miggy, which is that I'm coming in here with a very strong globe bias. Like, yes, I would go further. I would say my globe bias is now stronger than it was like a year ago when we were first talking. Absolutely, I'd agree with that. And it sounds like what you're saying is because I'm like 100 and more than 100% on the side of the globe, I'm not able to come at it in an honest way.
Well, not only that, but
why wouldn't that also be true of you? Wouldn't that be true of all of us in this room?
No, Eggshells, here's the thing, because I'm going to say that you use the term free thinker, and I really wanted for you to understand a free thinker isn't somebody that just takes second-hand information like to what you just described and completely would 100 or more than 100%, as your point said right now, is just going to just believe it. Like, that's not a free thinker, brother. That's really somebody who's just taking information because the consensus had said so and just saying, hey, well, I got the majority of people on my side that say that the Earth is the opposite
of. That's the opposite of what I meant by free thinkers. I mean, you guys are free thinkers. To me, free thinkers are exactly what I think you would say, which is people who aren't ruled by consensus, people who are able to weigh any idea regardless of how ridiculous it might initially seem, so that they can properly explore it, rather than most people who sort of follow the hegemony. No, I don't mean free thinkers as people who follow the mainstream. That to me would be the opposite.
Well, but I'm trying to get at and the whole reason why you're here is you're hearing information that's coming at you all the time in the server, and people in here, and you've asked me the question. I kind of wanted to get back to that. Like, you're asking me, well, what do you think about flat Earth and all of that? And I would say, ever since I began my journey back in 2015, was that it's been startling for me to actually have the conversations with people, and I hate to use this word, but evolved into a different model of mind. From the time that I started. And I could tell you many, many things where flat earthers came out and said something that right now in the back in 2015 was incorrect. And now it's shaped up to the argument has shifted to a more refined understanding. Because we started with the idea that we had to give evidence on our side, that we got to give them something because the globe Earth is coming in here and they're demanding evidence. So we have to hand them something every single time they come in here. So because of that, there has been some misconstrued arguments from the flat Earth side. And I'm going to admittedly say that I was part of that because I was announcing certain things that now, looking back, I'm like, I should have said that, right? But now it's easy to see that I don't have to do that any longer. I let go of all of that. At this point, Eggshells, I don't have a dog in the fight, man. If you come in here, you're like, dude, the Earth is a globe. Show me the evidence. And they were like, okay, here's the evidence. And then you're like, well, that's not good enough. Okay, well, that's fine. You just made a point that now you think the Earth is a globe. What's even more disturbing is when one of us say, okay, man, have a nice day. Think about the Earth being a globe and dream about space. Because that, to me, to you, is the worst thing that can happen. Subconsciously, and I don't know if you were talking about it psychologically, but subconsciously, I think you want us to challenge you. You're like, dude, I'm going to argue, because the psychology behind all of this, I've been around these conversations, so I know. People that come in here, they come in with a purpose because they're like, dude, damn it, man, I've been taught all my life, and these people are saying the Earth is a globe. Now, you're going to have to do a really good job at convincing me that it's not, because from what I hear, everybody's saying that it is. So really, it's your job to convince me. And I think... you're not saying that, but I'm saying this is the kind of conversations we get into because people are trying to get to that psychology part of it. Well, if it's such a grand lie, there must be grand evidence, right? That's going to support the case of it not being what they say it is. So I'm really, I'm getting to the meat and potatoes right now of the conversation, which is if you're going to continue to believe that it is a globe, why do you continue to come in here? See, now that is the question that it's rhetorical. You don't have to answer to me. That's something you got to answer to yourself. Because what we do in here is we provide the evidence. And some of I was saying from the beginning, early on in Flat Earth, we were talking about all kinds of crazy stuff. The Pac-Man model, the azimuthal equidistant.
I've heard the Pac-Man model. Yeah, I love the Pac-Man model. Well, it's also Four Corners thing. That's quite. I do quite like hearing the different cosmologies in Flat Earth.
Well, I know, but there's a lot more, right? And on the globe side, you have as much tomfoolery, right? I mean, you got how many map projections are out there? You got plenty, hundreds probably. I don't know if you know about this or not, but there's so much on the globe earth side that's even more wacky that you think the flat earth, the truth is stranger than fiction, brother. Like there's a perspective that I really don't think of the times you've been in here that you're really grasping. That I'm already at the place where I'm like, dude, it's so easy now. I can just throw a pebble at this glass house and shatter it, and it'll go to a million pieces. I don't have to get in complicated mathematical linguistics with anyone. I can easily destroy the globe with like the greatest of ease. It doesn't even take me like 10 minutes to do it. And you can walk away going like, man, I had nothing to say back to him. So, but I like to hear you kind of come in here, and people in here sometimes get frustrated with you because it's like, dude, I want to prove him wrong. But like, that's not me. I'm more of the side of like, okay, it's either it is or it isn't, right? So, and I mean the globe. So it's a globe or it's not a globe. Because if it is a globe, then, we can all call it a day. We'll all of us go and watch some space movies or forget about this server ever existed. But see, here's the thing, man. Over the time that we've been here, and all of us have been challenging the idea of the globe and the arguments that we've come out with, like the Pac-Man model and a lot of fallacious arguments of like the sun doing things. Like there's a lot of things that are coming at us, and we're just like free thinkers, man. We're thinking of different things. We're speculating. We're talking about stuff. So sometimes when people come in here, they're hearing us speculate. They're like, oh, that sounds really hooey. Like who's gonna believe that? But it's us kind of giving an explanation as to what we think it could be, not what it is. And that's the distinction of like the things that you probably hear coming in here. But I'm clarifying some of the things where flat earthers are saying, no, this is how it is. Look at the AE map. Look at the whatever map, and you have it like, okay, well, this is the Earth as a whole. Let me put this to the test. We'll see flights in the south don't match, and you start getting into your little whatever. But that's not it either, right? And I'm putting the record straight, man, because a lot of people in here do a lot of due diligence, right? And that is what I'm trying to tell you is that because of that, there has been over the time a lot of arguments that you probably heard that don't make any sense. Well, I must agree that is true. But for the majority of the time that we've been in here, we haven't come to any reasonable doubt that the Earth is a globe. Any whatsoever. It seems to be on the contrary for the globe. So, I mean, it's really challenging to not find anything that we're gonna say, well, okay, the Earth is a globe, so now we're gonna, make it so. But it's not that way, Eggshells. Like you're never gonna reach a point in your time looking for things. Like I know that you're challenging flat Earth, but bro, you really gotta take some time and challenge the globe like we all have been doing. And if you do that, you're gonna come over to this side. You're gonna be like, okay, it ain't a globe, so now let's get these guys who think that it is, right? But until that point, you're just going to come in here with this bias, like you said, and you're going to keep wanting us to convince you that it is, that it's not a globe, that it's flat. But like I can tell you real easily, man, there's no way that you can tell me that you know that how they measured the curvature of the Earth, or how, when, and where that they measured that thing. There's no place in time you're going to tell me how they measured the spin of the Earth, axial rotation. There's no place in time where you're going to tell me that. There's no place in time where you're going to tell me how you know that the ever-expanding universe that you think that it is a vacuum, bro. At no point in time are you going to be able to substantiate any of those claims. And there's only 3. These are the major pillars.
I certainly agree with that. I'm not able to prove them.
Well,
I do think sextants, which is where this whole discussion started.
Well,
I do think sextants do a bit of that because I don't actually know when they first came up with a nautical mile, but I'm sure you've all heard the arguments about the importance of a nautical mile to a sphere, right?
All right. So did you hear what I just eggshells? All right, yeah. I know you want to ask about the sextant.
But you're saying that nobody's measured curvature. Nobody's measured the spin of the Earth.
Yeah,
and I think a sextant has done both of those things.
You can't listen, man. For the life of you, you're trying to paint a globe. You're superimposing the globe over everything that has been taught to you, which is fine. I don't care. You can keep thinking that because they use a specific device, they could tell that the Earth is a globe. But brother, let me tell you, nothing is conclusively going to tell you that the Earth is a globe. I don't care what device you use. It doesn't matter what you use. There isn't any device that's going to get, because let me tell you, if it was the fact that the Earth is a globe because of a device, bro, it would have been already solved. This server would have dissolved easy. But because of the fact that
you know the argument about how many 360 degrees is in nautical miles, right?
Yes, all these arguments they equal the same, man. The value of each argument is the same each time. It equals non-conclusive, brother.
The simple thing is, if you think an arc minute equals a nautical mile, what you're saying is you accept that there is 360 degrees. If there's 360 degrees, you can calculate that. If you calculate that, it gives you pretty much bang on the radius. So
but you're
3
basing
minutes. That's a great circle route. So that's north, south, or east.
You're basing everything. You're basing
quite work.
Eggshells. You're basing everything on a presupposition, bro. Everything is built on, like, the foundation of your understanding is built on the presupposition that the Earth is a globe. If I
presuppose my car is a manual and I'm really good at driving it, would you use that to conclude that I'm probably presupposing the correct thing in my car is a manual?
What I'm saying is that
okay. So what I'm getting at is, would a presupposition that works be a good indication that presupposition was accurate?
No, I don't use. Listen, a presupposition is what fundamentally is incorrect in this whole globe argument, because people come in here with the bias thinking, okay, so we got this ball, right? So on this ball, we're going to look at how we can measure. You can't do that. You don't even know if it's a ball or not. So here's my thing to you. Prove to me, like I said before, that it is a ball, and because the burden of proof lies on those who propose the claim, and that's not you. It's not you, Eggshells. I'm saying the argument is
that was also a false equivalence, by the way.
You're somebody's coming in.
Mike.
I muted him.
All right, so you're presupposing that the Earth is a globe. So you're coming into this conversation locked and loaded, talking about sextants already on top of a ball, and you're saying, "Well, I have to, right? Because that's the only way that we can get the idea or the evidence that the Earth is a globe." But no, you don't. So
then help me out. If we start with a presupposition, we throw out the presupposition, but we stay with the observation. So a presupposition, I think, could lead you to an observation, even if that observation was wrong. Like a person could presuppose a globe, then go test it and find they live on a flat Earth.
Riding on eggshells, incorrect. No, because I could tell you the same thing for a cube, and you wouldn't be able to tell me the difference if you're measuring a cube or a globe.
I think you've missed my question. I probably didn't state it well. I mean, somebody could start with a presupposition and then still make an observation that might be accurate, even if it was based on a faulty.
It doesn't matter. It doesn't matter, because you're taking something and you're adding to something that you don't need. In other words, I'm telling you, okay, so if you're going to start here, you're telling me, well, first we have to come with a claim. The claim would be the first thing we have to do.
So let me try then a thought experiment of if you can indulge it for a moment, a group of people who haven't heard anything about a globe, but they make the same observation that mariners have since time immemorial, that the Polaris changes 1 degree linearly if they sail north south.
Okay,
that's an elevation angle.
But that's a problem for the globe.
Yeah, but
that's an elevation angle.
So what are you saying next?
And we're talking about because that's actually not true. But that's not true statement. That's not a true statement.
So you're saying
Polaris does not change linearly with distance. That is not a true statement, and it's not even in the globe model that it does that.
Yeah, you're talking about because stars move, right? Stars are doing something, and I'm saying it in a more general way so you can actually see the point. If stars move, then Earth globe.
No, right? No, I'm just saying. No, I'm just saying it doesn't matter who first came up with it or what their presuppositions were. If you have a measurement that says degrees per distance, then to me, you can straight away just test that and propagate it out and go, what about 360 degrees?
But you don't have that observation. Hold on, but you don't have that observation. Let's fuck this hypothetical shit. That's not what's actually measured in reality.
Okay, give me a reason for that.
From 40 degrees down. No astronomical observations are done from 40 degrees down.
I'm not talking about.
So within this very small window of the sky, that's true.
Yeah.
But for this other part of the sky, that's not true. Right? For the vast majority of the sky, that's not true.
Well, I mean,
and also, they don't assume the Earth's a globe in celestial navigation. They assume that the Earth is a point in space.
Well,
hey, Indio.
In a way of speaking, I could agree with that.
About this point.
So I've got a few things to say on that. If it's working in a window in the sky and you trilaterate your position off 3 stars, isn't it actually working for 3 stars in the sky at the same time? And aren't you always working out your distance to those GPs, which is i.e. the radius of that line of equal altitude? The radius of that line of equal altitude equals 60 degrees, 60 nautical miles per degree.
Yeah, but that's just a convention. It doesn't mean anything.
What do you mean it doesn't mean anything? You can accurately find your longitude and latitude with numbers that don't mean anything.
You're lying.
Hang on.
Accurately. You can accurately find your latitude and longitude. Confirmed how? Confirmed by driving around, right? And then when you do another measurement, I find out I'm a degree off. I got to make a correction.
No. The question is, how did ancient mariners use sextants?
I got to make a correction to my course again.
No. It's not about driving around. How did ancient mariners, how did Captain James Cook get to Australia? Why did he put the Southern Cross on the flag? Because they navigated by the stars. Come on. We all know they navigated
by the stars. The Carolingian Islanders navigated by the stars, and they could hit frickin' rock islands that were like a kilometer across from 600 kilometers away, and they thought the Earth was flat. How did they do that?
And they've had the convent because they've got a linear relationship. Because they've got the relevance here is that they've got a linear relationship between lengths and degrees. Here's a simpler way to put it. You know a protractor? Everybody knows the thing you would have had in a school kit as a kid, a protractor.
Yeah, for sure.
But you don't have
it is a specific shape. What shape is the protractor?
Dude. You just keep saying shit that's not true. I'm not letting you get away with it. You're saying shit that's not true.
All right, but here's the error.
If you take a protractor and you cut it in half at the top, that's what you got.
Yeah, Indio, he already. That's an error, though. If you're using a protractor or a T-square, whatever you're using, it doesn't matter because you have a curved surface. The bottom of the protractor is straight; it's flat. So if you're putting it along a curved surface, you're not going to get the same values, man. Think about this.
I'm asking you.
I'm telling you where you're wrong.
I asked a question and neither of you have answered it.
This is where you're wrong. You're wrong. Okay. You can't use a protractor because if you lay it against
the question, we haven't answered it because it's based upon a false premise, and this is why you have a presupposition that's wrong in the first place.
It's a false premise.
It's not even a presupposition. I want to leave it open for you guys to answer the next question.
Yeah.
I just have this question and another question, and you'll be free to answer them the way you want.
Yeah, but we're answering this one right now, and I've told you you don't want to address the point, and this is very specific to you, right? Because you're using a protractor. You brought it up. Well, have you seen a protractor? We know what it is. If you lie a protractor straight down on a flat table, it's level to the table, right? Because you can see the bottom of the protractor. But if you do it to a curved surface, are you going to allow the same kind of measurements that you're getting from a protractor on a flat surface versus curved? Absolutely not. So what you're saying is using that same kind of idea, putting it on the Earth that's curved, and it's got a flat bottom, the protractor does. How are you going to get the same measurement every single time? It's going to be completely off. You can't use that formula and those types of mathematics, apply it to the curved Earth, which you think we live on. Exactly. And so my point to you is that you couldn't use triangles, you couldn't use protractors, you couldn't use anything that's flat to the surface because you would not be able to get a value that's satisfactory to something you could apply to real mathematics, man. It would not turn out.
I agree. And that's why nobody sensible would use a protractor that way. I absolutely agree. That would be a bad way of measuring it. The question about protractor, the reason I wanted to ask it is, what I am invoking is not the flat bottom of it, but the curved top. It is always curved in a circular fashion. It is never flat. It is never straight. It is never like one angle and another angle. It is always in a circle. And that is because that is the only orientation, that is the only shape where you can get a linear relationship between degrees and distance. For every tick along that curve, you get another degree of angle, right? It starts at 0, goes up to 90, all the way around to 180, and evenly spaced dots. And it's the only shape you can make that because an angle is a measurement of a circle. So if you've got a linear relationship between degrees and angles, what the protractor, the shape of the protractor tells you is that can only fit on one thing. So what you need to disagree with, in my view, is that sextants give you a linear relationship between degrees and nautical miles.
Yeah, I see what
you're saying. A flat circle.
They do.
A two-dimensional circle.
But they do. But this is the thing. They do. There is not a linear relationship. There is only a linear relationship if you cherry pick a small portion of the sky and ignore the rest of the sky, which is the vast majority.
I mean, that's that. I can rebut that if you want. I'm not sure if you're saying that on
say
purpose.
Whatever. In this linear relationship, it's been tried anyway because you actually have no measured distance to correlate the distance you moved, right, in the stars. How do you measure how far you went on a boat?
With difficulty, but dead reckoning will get you some of the way there. GPS, I guess you can do it with nowadays.
So basically, you can't.
No, I think you can get a pretty good job of estimating.
So there's ocean current.
Yeah, there's ocean currents and things. But like Shackleton's navigator, he was pretty good at dead reckoning. He managed to only take 4 sites. Yeah,
and they dead reckoning
like 18 days.
What did Captain Cook dead reckon? That Antarctica 60,000 miles around?
Oh, could well have done. I'm sure some people sucked at it. This guy was Wigby or something. I forget his name. Was really good at it. He's the reason all of Shackleton's men survived. Apparently. This guy wanted to go and see Antarctica.
Cool There's a lot of bullshit in the Antarctica narrative, but I'm not going to get into.
Well, he didn't even get there, so he could have been on
totally about it. That all the shit that they say is a bunch of lies.
Well, the top of the
listen, I want to go to this. Okay, this linear relationship between distance traveled and the movement of stars across the sky.
Mm-hmm.
This is circular logic. Okay. Because
tell me why.
Because the distance moved is assumed to correlate to that, but you don't actually have the measured distance to actually verify that I went 60 miles, right? And then the star moved that amount, right?
Well,
that's not actually being done. What's being done
I think that was done a lot. I think that, you know what latitudes are, right? Latitudes are basically the number to your celestial pole. That's the elevation you will see it. If you're standing on the North Pole at 90 degrees north, it will be at 90 degrees above you. At 80 degrees north, it'll be at 80 degrees elevation. And then you can test this yourself.
You got a picture of the North Pole of somebody pointing their camera straight up of Polaris.
Test it yourself. Test this yourself.
I got a question. Do you have that picture? Has anybody ever produced that picture of being at the North Pole, pointing their camera straight up and taking a picture of the North Star?
Sorry, at the North Pole. No idea.
Yeah, North Pole. Has anybody ever taken that picture?
No idea.
Yeah, they haven't.
It's irrelevant for what I'm saying. What I'm saying is you can find your lat long.
You just use that as your evidence. That if I do this, I'll get this result. You have no evidence for that. You're just saying.
Okay, that's fair enough. That is true. I don't know what happens at the North Pole. I presume that's what happens. That's fair. You can, but if you just find your latitude, you can go out and to within half a degree or something, because Polaris isn't on bang on the North Celestial Pole. You can tell your latitude by looking at Polaris. That's why North.
You can tell your latitude.
Sorry,
by
latitude is. Yeah,
that's bullshit.
That's exactly what latitude is. That's what latitude is. If you find the elevation.
No, latitude
what's 0 degrees?
No. You see, you're
0 degrees is the equator, the point at which Polaris is bang on the horizon.
See, you're jumping the shark. The coordinate system, latitude and longitude, don't exist on the ground. It is a celestial coordinate system.
Exactly. That's what I'm telling you.
Not measured on the ground.
That's what I'm telling you. That's the thing I'm trying to currently say.
But you're not at 40 degrees. You're at a place there. If I'm at this place, I will look at Polaris and see it 40 degrees above the horizon.
What I mean is we've got a convention known as latitude.
A convention.
What that latitude means is if you're at, let's go with degrees we might be at. You guys might be somewhere between 50, 40 and 30 north. And if you go outside and use a sextant or something else to shoot Polaris, it will not be more than a degree off that.
Okay, cool, great. What does that mean? Nothing. It means literally nothing.
It means what you can do is test that relationship yourself, but it absolutely means something, because the sextant, the sextant was, and the astrolabe and all of those things that preceded it, was how ancient mariners managed to cross the globe.
Yeah.
And
how many people are at the bottom of the sea?
So if what you're accepting is that 60 degrees, a higher latitude is a smaller circle as it gets in towards the center, that's great. That's a wonderful thing to recognize because it fits with a flat Earth. The challenge is, if you're accepting that this celestial coordinate system works in the north, what you'll find is 60 degrees south is getting smaller. You can test this. You can find this out yourself. You suddenly find that degrees don't equal the same amount of sky declination east and west, while they still do the same amount north and south. You know that you're on a smaller circle.
What the fuck are you talking? What? I didn't get that.
You can test the latitude you're on by how high the light is in the sky.
Okay.
Is this still conceptual?
And then what? Like,
and as you go south, point rises in the sky.
And?
Do you get what I'm saying?
Have you got proof of this?
As you go north, circles of equal altitude, which are known of lines of latitude, will get smaller the higher the number. So the 90 degrees is a point, 80 degrees is a small circle, 20 degrees is a bigger circle, 0 degrees is sort of infinite circle, or you could call it. It doesn't really fit. It's against the horizon. But 10 degrees is like the biggest 10 line of latitude, right? You can tell that as that light dips lower in the sky, you're drawing a bigger circle. When you go south, the light rises in the sky. The central point of rotation, the further south you get, will be above the horizon.
What are you talking about?
This is still conceptual.
Listen, let me ask you a question.
This is why it's on our flags. This is why it's on the Australian flag. This is why they put it on the New Zealand flag, the Cook Islands flag.
If I draw a circle, is that a rotation? Yes or no?
No, if you keep a light at a certain height.
So why are you calling it a circle? It's why you calling it a rotation?
Because you keep a light at a certain height and move in a forwards direction, which pulls you around like a horse being lunged on a rein, pulls you around in a circle. That's the circle you do by keeping a light at a certain altitude.
Is that a rotation?
No, it's not the Earth rotating. No, it's you figuring out how long a line of latitude is. The higher in the sky it is, the smaller the line will be.
But who's ever done any of this stuff? You see,
mariners, Mariners since time immemorial.
They actually
ancient Polynesians use this shit with coconut sextants. They put coconut.
No, they use a sidereal compass. Good try though. Good try.
I'll show you the coconut sextant. It's pretty cool.
Listen,
they could have used that as well.
A sidereal substance, and the way they did it was they assumed that the Earth was flat. They didn't think it was a globe, and they sailed under a sky road. This is how they sailed between places.
That's quite cool.
They call it plain
sailing. And it had nothing to do with being with a globe. Like,
that's the coconut sextant I posted a picture of that they think they use.
The Carolinian Islanders, the Europeans found these people in all these places, and they're like, how the fuck did you get here? Right? Yeah. They're finding them in the Philippines. They're finding them, like, how did you get here? Because they knew they didn't have Polaris. They knew they didn't have any of the tools of celestial navigation that the Europeans had. They didn't believe the Earth was a globe. So how did they do any of this stuff?
I think people could. I wouldn't put it beyond the realm of possibility that people could think they're on a flat plane, and if they stayed near the equator and told themselves stories about the stars, that they could have missed out on this. I'm not.
It gets worse than that, dude. So, like in 1897, there was a dust storm off of Africa, like from the Canary Islands all the way down to Cape Horn. There was a giant dust storm where no one could see the sky or the horizon. There was fine dust everywhere. You know, you heard what I just said. They couldn't see the sky or the horizon. It's like being in a giant fog of red dust. This is what it was described as. This is a report of the Royal Meteorological Society. There's a guy of the HMS Britain. He sailed 2,000 miles using dead reckoning. Dead reckoning uses planar triangles, right? What happens if I sail 2,000 miles on a course of planar triangles on a ball?
I'll be way out.
Yeah, it would be way out. Somehow he got there. How do you do that?
Dead reckoning is also pretty unreliable. I mean, that could just be survivor's bias right there. You've got a bunch of other people at the bottom of the ocean, as you just said, who did it wrong. He got lucky. I mean, I don't know. I'm not saying that's the answer, but am I saying it's possible? Sure.
Because you got to think of how many times he had to correct his course, right? You're acting like that. They take this measurement, assume the Earth's a ball, set a heading, and just sail off in that direction, and they'll get there.
No, I think they take sighting whenever they can. I think they take sidings and trilaterate their position using a linear relationship between degrees and miles.
Yeah, and then there's a margin of error. So they make a measurement, right? And then they sail for a while. Then they make another measurement. They go, oh, we're off a little bit. And then they sail for a while again. And then they're off a little bit. They're taking a small view of the sky. They're off a little bit. And they keep sailing. And they meander back and forth, until eventually they're close enough to the place they want to be. Oh, we're going to this place. Oh, we see seabirds. We must be close. Like, it's like they're not, this isn't like some precise thing that you're trying to make it out to be. It's not that precise.
Well, they teach all
Did he ever answer your question? Did he ever answer your question about, is there any piece of globe evidence that he's ever applied the same scrutiny towards?
Yeah. Well, he thinks that, like, if you intend to build a house of straw, a brick, but there's no bricks available and you build a house of straw, you failed at building a house. It's a bust.
My test was.
I didn't build a house. That building a house was a bust because I didn't have bricks, so I did something else. But my intention was to build a house, but that doesn't matter. It's not actually a house. It's something else.
The reification fallacy is also like a
goal was to set out and build a brick house.
Like transportation.
I would say that's a myth.
Well, dude, they set out.
But it's like transportation.
The WGS 84. They had a plan to do it. They changed it to something else. Boom. They still did what they had to do.
The reification is like saying anything that gets you from point A to point B is a car. And you say, here's my feet that got me from point A to point B. No, but it's fine. We can assume you were in a car. Here's my bicycle that got me from point A to point B. No, we can still assume your bicycle's a car.
Is this you steel manning my position or doing the opposite?
Trying to explain to you the reification fallacy, which you're doing. Certainly not steel manning anything that you've said.
Yeah, it doesn't sound like
I still think it's a valid question. Have you ever scrutinized any of the globe evidence?
Sure. I think since being in this community, I've scrutinized most of it, I think.
I think what's evident from today
Eratosthenes' method was pretty cool, but relied on assumptions, and it was difficult to tell the actual distances. Satellites seem like they're pretty cool, and they do seem to be up there.
They do seem to be up there. Is that your idea of scrutinizing? Is that your mediocre attempt? Whereas today, everything we've said, you've gone down to the nth degree, down to the half millimeter measurement. Yeah. You're saying satellites seems legit. There's my scrutiny of that topic. Well, I think you've answered my question. Thank you.
One of my tests of like satellites that I just did the other day out of interest
seems legit, right? Seems
got
legit.
a GPS app and tested how many satellites it could find based on what.
Okay, so the Flat Earth app. So the Flat Earth app proves that it's flat because it's an app. That's your point.
But based on
your test was to download a satellite app.
I mean, it's a very weak straw man. It's very weak. Oh, he said app, so I'm going to make fun and pretend there's another app. Like these things are equivalent. Like it's not. It's pretty transparent, Solar. Nobody thinks that I was going, because an app exists.
You're not here when I said scrutiny. Do you know what scrutiny
You're not scrutinizing. Means? You're just sort of nitpicking at
He's asking you if you're scrutinizing. That's what he's asking you.
I think
the level of scrutiny that you're applying to flat Earth evidence, are you applying the equal skepticism to the globe evidence? And from where I'm sitting, doesn't even seem like you even come close.
I mean, like there is obviously the difficult challenge that we will all accept is that, like, for us, our favored cosmology will give it a better run. We'll look at the best evidence for it, and we'll struggle to see the strong evidence on the other side. That's true of you. That's true of me. That's true of all human beings. So I do try and scrutinize it, despite being aware that I'm going to have a bias.
Let me ask you a question. What to you is the best form of evidence?
I don't think there is one best form of evidence. I think that things are best.
Yeah, there is. It's super simple, dude. It's like,
well, you might have different views to me.
No, this is objectively true. It's not even personal. This is objectively true. It's not my personal opinion on whether the best type of evidence. It's direct measurements of things. Direct measurements. How do you decide
what's best?
Because some are objective, some are subjective.
Can you measure everything?
Influence? No, you cannot measure everything, but that's irrelevant. We're talking about what the best method is. What is the best form of evidence are direct measurements of things. Is
Okay,
to measure
to
them
you, I will happily
directly.
grant that that's to you. I don't agree. I don't think there's one
So
best
you
form.
think indirect things where you have to assume things, are better than where you have to make no assumptions?
No, that's just denying the antecedent. That's just suggesting that if I don't agree with you, I must therefore take exactly the opposite contrary position. I just think many things can be good evidence. I don't think there is one thing that is the best evidence.
Look, you
That's
just
not what
straw
India
man
was
my
saying.
position, because there is a dichotomy there. Do you have a third
Right.
option? You have a third option, direct versus
I do.
indirect.
To
What's the third
direct
option?
or
Yeah,
indirect.
I do have a
What is
third
it?
option.
Okay, what's the third option?
Multiple forms of evidence. There is not one best one.
Hey,
Depending
he
on
just
the
gave it to you very
circumstances,
simply.
I've got
Direct
obvious
versus
questions, I've got
indirect.
different ones that are
They're
best for
either
different
going to be an
situations.
indirect or direct. They're not going to vary from that. There's not a third one.
Okay. Is there sometimes a time when a direct measurement is not the best?
No,
Never.
never.
Okay. When I went and got new tires and I put them on my truck, I said, "Can you give me some 32s?" He went, "Yeah, sure." I came back and there were some indeed wheels that looked big to me on the truck. Is that not the best form of measurement? Trusting a guy, paying for them, picking them out of a thing, or I had
Not even a measurement.
That's
Bad
not a
example.
So how should I be confident that I've got 32s on
If
my
you
truck?
measured the tire to be 32 inches, would that be a bad way to measure it?
No, absolutely not.
Well, that's India's point.
No, it's not. He said it would be.
Direct
he's demanding that I agree that the
measurement.
best is the only measurement.
He
In
said
any case,
You're literally trying to convince us.
versus indirect.
Okay, fine. Direct measurements.
You're literally trying to convince us. You're literally trying to convince us that it's better not to measure, and you should just trust somebody's word on it.
No, I think when it comes to tires, yes.
Listen,
I don't think every time it's good to trust people. Sometimes I've got different tools for different jobs. What can I say? Anyway, fine. I'll accept that it's the best form of evidence because I don't mean to sort of nitpick and be a dickhead to you.
to admit it, right? So we have a distance across the ocean. Now, if I could theoretically take a tape measure across the entire ocean and read the tape measure result, is that better than sailing across the ocean and like measuring my speed first, my distance times speed, and then getting a distance from that?
Sure, yeah, the better the measurement.
Which would be more accurate?
Measurement, right? Because I'm measuring speed and I'm measuring time. I'm not measuring distance, right?
Mm-hmm.
Where when I take the tape measure, I am measuring distance.
Yeah.
So which one is better? Which one do you think is more accurate? The tape measure,
tape measure would
or
be
measuring the other two quantities and then doing a calculation to get a distance?
So you concede direct measurement. So you concede that direct measurement is the superior form of measurement.
Can I check a third option before I agree with that? Would direct measurement include doing something like averaging? So you're measuring a really long bit of wood.
That's indirect. That's indirect.
Yeah. So yeah,
that falls into the other category.
Sure. So I just want to check with you though. Like it may be indirect. I don't fully understand this, but I remember my granddad used to tell me this because he used to make boats, like with wood by hand, like the old men used to. And he always said, "Oh, you measure it a bunch of times, and you don't actually pick the middle one. You average them out." And I was like, "Oh, okay, right. What an unnecessarily complex way of doing it." Do you think that's a worse method than directly measuring it?
Those are directly measured measurements, and then you're averaging from the direct measurements. So it is still direct. There is no third option. If you can think of a third option from direct and indirect, please provide it.
Averaging was indirect?
If you are generally averaging, like you say, the average temperature of a daytime could be 21 or call it 80 something Fahrenheit. If you're saying that's the average and you're just using it very loosely, then it's not direct. But if you say, I measured these 10 temperatures, they varied between, say, 82 and 87, and therefore the average of these direct measurements is, you are still averaging a direct measurement. If you're saying, I measure my water, my pool, if you measure my tool, listen, if I measure the temperature of the water in my swimming pool, and then assumed what the daytime temperature would be based on the temperature of my swimming pool, and then took
that would be it's not going to be a measurement.
An indirect measurement like that, I could still average indirect measurements.
You can't do
would
one
be
as
your
a
measurements.
But
then you're assuming that because the water temperature is one thing, you
am I getting laggy or is he? I think he is.
I think he's lagging.
Yeah. I mean, I don't. It sounds like averaging them is an indirect measurement. I can absolutely see in some situations that being better.
Look, and you wouldn't take an average; you would take a mean. Averaging is not what people do.
Quite possible, actually.
Sometimes you'll take a weighted mean. It depends. But that you do that because
the air temperature. I think, India. I think this conversation third option to die.
Oh, sorry. Go ahead. What? Solar? Is he still on here?
Yeah, I'm still here.
Oh yeah, you were cutting out. That's why I started talking. You actually went out. Go ahead. Sorry if I was talking.
Sorry, it was a bit of a lag then.
No, you go ahead.
No, nobody's talking. Is it really nobody talking?
Yeah, he must have lagged out or something. I've been disconnected. I thought maybe sometimes Discord screws up and you can't hear somebody, so I disconnected and reconnected, and I still can't hear him. So if he's talking, he probably.
I'm back now.
No, there you go.
Can you hear me?
Yeah, go ahead.
Yeah, I was lagging badly, but I'm not sure what point we were on, because I was just trying to reiterate your point of that you get either direct or indirect. There isn't a third option. It's kind of like you get deductive logic and you get inductive logic. Inductive means you're inducing an answer, means you're saying these birds mated on this day of the year, therefore I can assume X, Y, Z, versus the actual logical following of a measurement. There's two parallels here. You either are assuming things or you're directly measuring them.
Okay, so can I ask you some questions then?
More satisfactory, direct measurements. And what you spoke about, your direct measurements, were elevation angles. And as you and I discussed earlier, every elevation angle is taken off of a flat baseline. So
we can't have two discussions
believing
at once.
Individuals, every time you guys want to assume
Yeah, it's going a bit robot-y. Like, to me, it's pretty simple. If direct measurements are better, then why would anybody ever use indirect methods? Why would you ever average a distance you've measured directly? And are there other times you might want to use an indirect measurement and it might be, quote-unquote, the best?
I think long distances would be more precisely measured using like a radar and assuming using the speed of light than to use a tape measure, because I think any inaccuracy on the how much is a meter on the tape measure is going to accumulate the longer the distance, right? So I think and that wouldn't happen with radar.
Devices, though. They make these devices and they have an inaccuracy, and it depends on the turbulence. So they get wildly inaccurate. They're called scintillometers. So these devices exist, and then if you have things like okay, so we measure the speed of light, but if it's going through a lot of turbulence, right, the beam is slowing down and speeding up, basically. That's what's happening. So it's going through one pocket of a one medium of one density and another pocket of another density, and then but there's millions of these, right? Because they're we can't see them, but think of it as like a beer with a bunch of foam in it. There's a bunch of these bubbles in the air. So as it travels through the air, this speed accumulates, right? So you're gonna get an accurate distance. It's actually not very accurate. It's not pretty much not accurate past like 45 meters.
And that's
so
why
the
I think
idea of like shining it across the Atlantic Ocean is like that'll never happen. And obviously a tape measure is never going to happen either.
Exactly. That's why I think that there are some things, like I was just sitting here thinking, how do we know the heights of a mountain? Surely there's just no direct way to do that. So it seems to me to be reasonable that in many situations, flat Earth or round, an indirect measurement, an averaging or a use of a metric or geometry or something like that, to me seems totally reasonable. I mean, that's all of Black Swan is an indirect measurement, isn't it? It's using a ball and creating an arc of a certain length to figure out what where a sagittal would be and where the horizon would be, right?
No,
so it's got to be acceptable and useful in some.
That's not how you get a horizon.
So how did you measure the distance to the oil rig?
The geodesic surveys that were conducted in the 1800s set elevation points for most countries on the realm. So the heights of mountains were physically measured all the way from sea level. And if you want to understand that more deeply, you can go look up the geodesic surveys that were done to determine the elevations above the sea level. That level line to which we're always measuring our elevation angles. That level line gives us our altitudes. The point about direct versus indirect is that direct is always more accurate. Indirect can be close, but direct is accurate. If I wanted to know
why would you average lengths?
Let me explain. If I wanted to know how big my foot is, I could say, what is the foot size of a 6'1" individual? And you could give me an average.
You keep giving the most ridiculous strongman of what an indirect measurement is. Nobody claims that an indirect measurement is taking an average of the average population. That's silly. Come on.
I know it's upsetting because it's that simple. I know it's upsetting.
No, come on. A better example would be what's its angular size from head height and how tall that might be.
If I place the tape measure against my foot and I see it's 15 inches and 1/8 of an inch and it's a little bit more, I've got a couple of millimeters left over, and I take that measurement, that is the size of my foot. Whereas your indirect measurement would say an individual of this height should have a foot size of, and gives you the indirect measurement.
And how specific do you think that direct measurement would be?
It depends what tape or what measuring device you're using. Because you could go down to nanometers in an actual
down to the
measuring
nanometer.
device.
If I took you out this weekend, if I took you out, let me ask you a question then. If I took you out this weekend and said, Solar, I'm buying you some shoes, but we're figuring out your foot size, and we went into 6 different stores.
I'm 6 foot.
No. Come on, let me talk. Let me talk, Solar. You don't get to both present the straw man and then not let me present my side. Come on. Come on, man. Come on, be reasonable.
I've destroyed the straw man in the first sentence.
Let me ask you the question so you can respond to it.
Would you more successfully buy a pair of shoes if you know the length of my foot, or if you know the height of me?
I'm taking you out to buy shoes, and I take you to 5 different shoe shops. Do all the shoe shops have exactly the same size down to the nanometer? No, they don't. Why don't they? Because direct measurements aren't that specific down to the nanometer. It's going to depend a little bit about how much pressure you have, whether you were standing or sitting. There's going to be so many things. How much you've sweated between one shop to the other might have affected a nanometer. Bullshit! You're going to get a consistent measurement from different feet down to the nanometer with a direct measurement.
Which is more accurate, to directly measure the foot before you purchase the shoe, or to assume you know the size of the foot based on some other information which is not the measurement of the foot?
Like an average of all of the shops, you mean? I think an average of all of the shops would be better. Because that would be the shape of your foot over the course of a day.
And the shoe that you could purchase.
Does your foot change size and shape throughout the day by nanometers?
The most accurate would be to take the foot to the shoe store and put the foot in the shoe and then see which shoe fit best, because that would still be a direct measurement.
You know, the fundamental point you still got dismantled on, which is direct is better, but you accepted that it wouldn't be accurate down to the scales that you're talking about, so direct is therefore not necessarily always better, and averages can work.
Give me one example where an average is better than the actual measured distance.
I already gave one.
Just one.
My granddad used to make boats by hand out of wood, and he accepted 1 millimeter tolerance from stern to bow to stern.
How would he get to 1 millimeter tolerance without using measuring devices to measure the wood?
Measuring devices, and then he would average the results.
So that's direct.
That's what I started.
He's averaging direct measurements. He's not
averaging direct.
Yes, is an average. So let me ask this question to both of you directly.
All right.
Is
you
average
obviously don't understand this.
Is an average of direct measurements? Is an average of direct measurements an indirect or direct measurement?
I would say. Well, I would say it
indirect. Clearly,
measurement. Yeah, that would be indirect.
Yeah, right. Same as like calculating the height of a building based on trig and a known distance.
Averaging isn't a measurement of any type. It is a mathematical calculation done for the purpose of taking into account systemic errors that are done in any type of measurement. Any type of measurement that's done
100% agree.
Has potentials for systemic errors, user errors, all sorts of stuff.
Exactly.
Typically,
and what would be more accurate?
Yeah, exactly. There's always an inherent inaccuracy in every measurement because the world's not perfect.
Yeah, absolutely.
At the point about your dad's boats. So would he successfully make 100 boats if he averaged all 100 boats while doing it? Or would it be more accurate for him to measure this one beam and see, oh wait, I am that 1 millimeter out. So let me include the 1 millimeter extra to make sure that this boat is as accurate as the other ones were. Which one's more accurate? To just assume your average is the number you need?
To be honest.
Or to actually measure the thing you need?
Yeah, he just gave an example where averaging is not the right thing to do. So he could have every boat, right? So say you had one plan and there was
averaging is sometimes going to be a wrong thing to do. Nobody's going to argue with that. But that it's a bad choice in some examples doesn't mean it's always a bad choice. You were just accepting that, right? Sometimes it's a really good thing because there's inherent errors in it, particularly if you've got to relay a measuring tape, right? If you've got to measure something that is longer than a measuring tape and you want to get it quite accurate, you've got two problems there. And one is you don't always know that you've put the start of the tape at the end of the last bit of tape perfectly. And a bigger problem is you don't know that you're going straight. It's really hard to keep going straight. The tape measures help you by guiding you a fair bit, but you can still meander this way and that. So that you would average those measurements and get a more accurate result than picking one of those? Absolutely. We would all agree with that. Exactly as you said, there are systemic and user errors.
And so because averages can fuck things up. You have to use a mean.
Beg your pardon.
A mean is
the calculation.
50% are above and below that. Like if you take 10 measurements, 50%, you find the value which is 50% of the samples are above what you measured and 50% of the samples are below what you measured, which is not the same as an average. An average is you sum them all and then divide by the samples.
Right.
And in woodwork, if your dad really built boats, you would know that he always used a square. Granddad. He would have used a square at the edge of the plank of wood and then measured along the flat side, not simply taken a tape measure out and meander it across the piece of wood at whatever zigzag he feels like at the time.
Exactly.
If you're doing woodwork, you're doing incredibly precise calculations and measurements, and you often measure 2 or 3 times before you set what that distance is going to be. Direct measurements. You would directly measure 3 or 4 times before you even start writing down the numbers that you're actually measuring. You'd measure the left-hand side of the beam versus the right-hand side of the beam. You'd also measure if the top of the beam was level and horizontal or square to the two sides. If it weren't, you would take it off. So it's very precise when it comes to woodwork.
So
and therefore, it was a bad example to bring up woodwork as something being done with indirect measurement.
Okay, so if we were to then loop this conversation back to what we were talking about just a moment ago, I'm going to post an image in the chat, which is their completed results from FE Core. Was that a direct or an indirect measurement, and how precise were the measurements? First of all, did it have a number? Because originally they were going for a number of beam spread. Do they have any numbers in this measurement?
No. Who cares?
Not really. Well, it's not a measurement then, is it?
Listen, the thing
neither
you
direct
just posted,
nor indirect.
Are you seriously asking me, are there any numbers in that? picture.
No, I mean, in there. No, not in the picture. That's
like,
that's
are you high?
shitty question to ask. No. No. I more mean like if we're saying we need to have a measurement, we need direct measurements. We won't trust these other measurements that are averages and things like that. Did FE Core meet this standard for you?
In this picture?
In any of their results,
did
they
the
say
height above,
here's the beam spread?
They measured their elevation above the surface of the water. Right?
Right. But I mean, like they were trying to hit a target and they wanted to know about how brightly the target would be hit. Did they matched up to these standards, do you reckon?
What are you talking about? Like, what are you talking about? Like, I don't have no clue what you're talking about.
So if we're talking about the importance of taking a direct measurement, that taking angles to stars because it's an indirect measurement because it uses trig, or in fact doesn't, uses a linear relationship, it isn't acceptable because it's not a direct measurement and direct measurements are always better. And is FE Core a direct measurement?
Yes. It's measuring the height of a laser above a surface.
How high was it above the surface?
Pardon me?
How high was it above the surface?
I think 12. If I remember right, these were 10 feet on one side and 12 feet on the other.
The targets that they hit.
If I remember right, but like I'd have to go look at it. I don't even know if that's in the PDF. So we're talking about to the lake level. So it's above the lake level, and yet, well, I'm more familiar with the Lake Issel part of it because that's more definitive to me. This is just like, I mean, we could talk about this. I don't care. It doesn't matter to me, but it doesn't do anything.
It just doesn't seem to me like I'm looking
he's
through
just
their
leading
data
us
now.
down the next.
So, like Valentine,
this is where we started. We've been talking about this for hours now. I'm not changing topics. I'm folding this topic back into the old one.
What is the point of this direct measurement? Well, let me put a nice tight bow on this because this is just like a waste. If we're just arguing over arguing. Why do we use indirect? Why do we want indirect measurements versus direct measurements versus indirect measurements? Why? Because looking at the sky is an indirect measurements that come with, as Miggy was saying, presuppositions. In the alternative, the thing we're concerned about is right the fuck under our feet, and we have direct access to it. Instead, you guys go, never mind that. Look up at the sky. We have a whole story about that shit. Forget the thing at your feet. We don't need to measure that. But we're going to make claims about that and teach to everybody in school as with some objective empirical truth, right? And that we're going to design their entire lives around this idea. Then you say, hey, well, let's measure that thing. If you're going to, socially engineer everybody's lives around this concept, maybe you should go out and measure that thing and show it to everybody. But no, that's too difficult. We can make LIGO, we can make fucking CERN, we can make spaceships, we can do all that shit, but we can't measure the curvature of the Earth. Why can't we do that? When we can actually measure that directly and have an exact, definitive measurement with no assumptions about what it is. That's our problem. And if you think that's unreasonable, I don't know what to tell you.
I think it's unreasonable. Like I feel you on the.
Do you think that the idea that the Earth's a globe is used for social engineering?
Wait, before we go there, I just wanted to.
Yeah. Let's not get into that. That's it. Forget that. That's a deep ass rabbit hole. I don't even want to go there myself. Forget that.
I just wanted to go back to your presupposition thing about the assumptions. When you go and actually look into the globe model, you will see that they always place the observer on a plane, meaning you take the orange and you slice the top off the orange, so you back down to a flat surface, and then they call it the celestial. Then they call it the celestial dome, which is apparently domed around us. And then when they do the mathematics, they assume the ground you're standing on is domed. And the sky is actually flat. Now, in the actual real-world observation, you are standing on a horizontal, level ground. Horizontal so much so they call it the horizon. You're standing on this horizontal line. You're measuring the celestial dome ahead of you or above you. So there's an interrelationship between one flat surface and one domed, curved surface. Then they assume the ground you're standing on is domed or curved, and that the sky is actually a flat background to which, so they've just changed what the actual measurements are. We watch the sun rise and set according to the elevation angles that we take off of a horizontal flat surface. And then that distance the sun and moon travel is an arc. It's on the celestial sphere. But yet you guys always claim that somehow taking a measurement of the sky that's spherical proves that the ground you're standing on is spherical. And you cannot take an angle measurement off of a curved baseline. You can only take it off of a flat baseline. So no matter where you place yourself, no matter where you put Dave along that long flat line, it's irrelevant. The fact that you're measuring an angle means you have the flat baseline
what is
to
the
measure
flat
that
baseline?
Angle.
That angle CA that we talked about before. What is A?
We've discussed this already. We've discussed
what is
this
A?
already.
So that's the thing. Like to just reiterate that A is my eyeball. We know this, right? This is how the black swan works. You've just looped the conversation back to 5 hours ago. If C is the horizon and A is my eyeball, then what the black swan is measuring, the red triangle, and a sextant is measuring the green triangle.
So you really want to go back 5 hours and start repeating everything that you said fallaciously from 5 hours ago?
You're repeating yourself.
What's the black swan?
I was not repeating myself. When I'm talking about a single plane Earth and a celestial dome, and that you've juxtaposed that to be a celestial sphere that you're standing on and a flat sky, we haven't discussed that, buddy. So no, I was not repeating myself.
We haven't discussed that.
It's a brand new point.
You're still going to need some, in my opinion.
Sidestepping, as you've done through Indio's conversation and Miggy's conversation and my conversation, you deliberately misunderstand the point so you can answer a different question. And then we try and actually answer your question.
I'll respond to the point about the dome. It's the topic keeps changing.
One surface. Okay, so let me repeat the point. One surface is flat. One surface is curved.
Mm-hmm.
When you're taking angle measurements, can you take angle measurements off a flat line or off a curve?
I mean, yes, you can take it off a curve, but it doesn't matter because you're taking a line from your eye to the horizon. Point A is an eyeball, which is where you put the sextant
you just
to.
Said a curve.
Okay, describe to me then.
Horizon. You
describe to me solar.
If that's meant to be curved.
Solar. I've drawn the image and put it in the chat. AC is the line I'm talking about. Describe to me that line that is AC, how it is curved.
Okay, so AC is an imaginary line floating in the sky. Do you see your picture you drew? Can you see the little blue line at the bottom? That's called sea level. That's where your elevation angles are taken from. And I've explained this to you already.
I didn't ask you about the blue at the bottom. I asked you about a really clear thing. I said, tell me about the shape of the line AC. AC. What is the shape of AC?
Like, I don't understand what you don't understand. Like, what is your issue here?
I'm happy with it being straight. Exactly. It's solar doesn't want to admit that it's straight. It's simple. It's straight. Right?
Yeah, and straight is flat. So, like, what are you talking about? So,
exactly. So where's
they do a measurement to the horizon, and then they correct the elevation, right? And they bring it down to the surface of the Earth, and then they assume that is flat. Like, what exactly?
It's a great description of it.
Demonstrate.
It's a great description of it. That's exactly
an elevation angle of a curved base.
Where's the curve?
Because you've got your picture for you. No, I asked you off a curved baseline. Show me how you're taking your elevation angle and then move the observer further away and tell me how you take that elevation angle again off of the same flat baseline.
Okay.
When you talk about...
Here's a diagram for you. Here's a diagram for you. I'll put it for you in the chat. And it is both a sextant taking a measurement, but it happens to be taking a measurement bang between the oil rigs. For some reason, if I take that measurement between my eyeball downwards, that's acceptable. That indirect measurement of distance is acceptable. But for some reason, that same horizontal that same horizontal
So
line.
you're showing us pictures of flat
Why are you
baselines.
interrupting my answer?
The flat one. The flat horizontal line.
Yeah, the flat
question
horizontal
was
line.
off of a curved line. Off of a curved line, show us how you measure an elevation angle.
Hang
so
on.
you post
Your
a
curve is
flat
going left, right,
blue
or east?
baseline of the
Sure,
ocean,
fine, I'll
and
do
you
it
want to
for you.
continue describing the black swan with a flat baseline, which is not the request. We said
How
show
can it
us because
be?
you said yeah.
So
Yeah,
does
sure.
the black swan has a flat baseline,
And
does
measure
it?
an angle of a curve adjacent.
So
we're not measuring an elevation angle in the black
keep
swan.
trying to use a sextant on
I've
the black
explained
swan.
What the hell is a
this
section? I don't I'm lost. Like, what the hell does a section got to do with a black swan? Like,
so you're missing it out. You're missing it out.
Black swan is supposed to be the horizon. Stay on topic.
Okay, I'm getting solar in
Black
very late.
swan is a test of the globe prediction that the horizon is a certain distance away.
Sure.
How does
And
this
if
text
P then
measure
Q,
that distance in any of the images? Like, how are you
doesn't.
measuring that distance with the sextant?
It doesn't. It doesn't.
Then
I'm not
what the
saying you
hell's
measure
your
it.
point?
Okay,
It
so
has nothing
this
to do
is
with
this is the discussion we had ages ago before you got here,
Precisely the
which
point.
is what
Which you've brought up again. Fallaciously, you've brought it up again.
I'm just trying to tell Indio what the argument is so he can debunk it. Let me finish, please, man.
Like, it debunks itself, because if the sextant can't measure the distance to the horizon, then it's pointless. Like, it has nothing to do with it. It's like bringing a hammer to it. I mean, we could bring any instrument and say, what does that... Like, I had a wrench. Like, what does the wrench have to do with the distance to the horizon? Nothing. That the sextant is just as useful as a wrench is.
Do you want... I'll tell you, though. It'll make it easier. What this has to do is, if P then Q states this: if the Earth is a sphere with a radius 3959, P, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet, Q. Geometric horizon curve calculators. Not Q, therefore not P. Right? So what is Q? Is Q a curved baseline, or is Q a straight line from the eyeball of the observer of their height to the horizon?
Sextant?
It doesn't.
And where does it say a sextant?
It doesn't.
Is used
I'm
in that
constructing
example?
an argument. I'm constructing an argument. If you're right,
With a
you would be able to follow my questions through and then show how they're wrong.
Listen. So you want to know, is the distance to the horizon the distance from the eye to the horizon, or the distance from the ground to the horizon? Why does it matter? The difference in that distance would be something like a half a millimeter.
No. It's no.
Yeah, it would be something like half a millimeter.
What I'm saying is,
you're talking about the difference between the straight line distance, the tangent distance, versus the what do you call it? The great circle distance. And there's actually a calculator that does that. And I guarantee, I'm going to do it in a second, that the distance, it might not even be measurable. They might not even go to that level of precision, because this is only 10 miles. It doesn't even really matter until you get to like 100 miles.
Is this then a good description of what you're saying about what's being said about the black swan? I'm putting it in the chat now. It's an image of a person standing at Z foot, and there is a terminating point that is where his eye line meets the horizon that should be in front of the oil rig, that is 1.22 times Z foot. Are you happy with that being a presenting the case of the black swan?
That's a shitty sphere, but whatever.
Sure, it's a shitty sphere, but it's a curve, right? You get the point of it.
Yeah.
All I need to do is stick a sextant in that man's hand, and you can see
that's
he's
the
looking
idea
at
behind the black swan. Yes.
Yeah. So if you stick a sextant in that man's hand,
not a sextant, wrong tool. You might as well be talking about the wrench that Indio just explained to you.
If you put a sextant in that man's hand, he could use what you're using for a measurement of the horizon, which is CA, lines CA.
You don't measure horizons with a sextant, eggshell. You don't measure distance to horizon with.
Yeah, you don't measure the distance to the horizon.
Listen, this is part of the indirect.
Don't measure distance to horizon with a wrench.
Yeah, but you're just come on. Nobody's saying you're measuring the distance to the horizon. I'm aware that they're not measuring the distance to the horizon. But what's clear is that you're taking a measurement from the horizon, so it's not a curved baseline. It's a straight line of light.
You're using the wrong tool for the job. What is a sextant measure, and what are the values? See, there's something called absolute values. Angles are actually abstractions. They are not even capable of being directly measured because they're actually abstractions. There's something they're called improper measures. So they're not an actual measurement of something. They're a measurement of like our concept of things. As in an angle, as you wrongly put it, is not a subdivision of a circle. It's the separation between two lines. Now, you can put that inside of a circle if you want. That's fine. But, you can put two lines in.
So why does the height of the observer matter?
Dude, stop. Sextant measures angles. That is all it measures. You cannot get an absolute distance by measuring an angle.
This is why I'm trying to interrupt. You're following Solar's red herring. I'm not talking about measuring distances. Nobody is. What we're asking is whether we can take a straight line from our eyeball to the edge of a curve, which is what P then Q is asking about. Is there a limiting point between line AC, as I've got in my drawing here, where we see the horizon? It doesn't matter how far it is. We're not trying to measure that yet. We're just going, do you see line AC? And then the next line is about calculating it. But for some reason, QE has made people freak out and go, oh, you can't have a curved baseline, when the P then Q is a straight line from the observer's height in feet. It matters what his height is. It's not being taken from the surface. It's going, at what point will my eyeballs hit and go tangent to the globe such that is the vanishing point behind which things should disappear, which the black swan oil derricks haven't disappeared. Listen, the point is, if we're seeing in straight lines, you can take a straight line measurement to the horizon. What you do with that, whether you calculate a distance or use it to measure the elevation of a star, that's totally up to you. But if you can see the horizon in a straight line, which is the P then Q test of black swan, then you can use it to make a sextant measurement. If it's irrelevant and impossible to use it for a sextant measurement, then you can't have the black swan. It cannot test it.
We're going to let you use the sextant.
Okay, so I'm going to tell you why.
And I want you to tell us what you're pointing at in the sky and measuring with that sextant, because that's the only thing you're going to do with the black swan with the sextant. So tell us what you're looking at in the sky.
One of the 56.
You're not on the ball anymore if you're off the ball, right? So there is no ball measurement. You're not even on the ball at all.
I want to stay on this point about this line anymore. CA.
To find the tangent of a ball, you're off the ball. You're outside of the circle. You're not on it anymore. You're outside the circle. You're not in the circle anymore. You're off of it. So the circle that's somewhere, you're finding the line of intersection between a straight line and some other point in space. So this is the way you do it. Got a point somewhere, you got a circle, you draw a line between them that just brushes the circle somewhere. You're not in the circle. Right? So there is no ball. So like when you actually do that what do you call it? That dip angle correction, you just move back down to the surface, right? So you are touching it, and then you make a flat plane. And then you measure from that.
Height of observer correction. And like Indio just said to you, okay, you obviously didn't understand. Imagine you're at the top of the sphere, okay? So every part away from you is falling away from you. Mm-hmm. Now you're talking about height above the surface. So draw a circle on your page and then draw a tangent, a horizontal tangent line above the Earth circle. And show me where that tangent line that's horizontal above the circle intersects with the circle.
I think I've already got one of these for you in my manual. Just let me.
You have a horizontal flat line above another circle that's below it, and you think that horizontal line will intersect with that circle at any point.
Look, in other words, it's a floating tangent. Part of the circle. It's a separate mathematical entity.
Floating tangent.
Yes, it's a separate mathematical entity. It's not the same thing. You're never.
Figure 11 in my manual for my. That's a figure 11 in my manual for the for the sextant.
No, but that's at his toes. That's at his toes or below his feet. And remember, we were saying from an observer height, which means you're above that ball. So draw that circle and then draw the line above the ball, like I just asked you to do. I don't know if that was difficult to understand.
Yeah,
but if you draw a circle and you draw a floating tangent, as in the tangent doesn't actually have an intersection point because it's above the surface. Remember, if you're standing at the top of the ball, every other part is falling away from you, and then you have an observer height placing the tangent off of the other circle. Like that, precisely, but horizontally, like your previous example, a horizontal line off of your sphere, and show me where that line, that tangent, intersects with your horizon.
Hang on, did you just say put a line that doesn't intersect with a circle and then show me where it does intersect with a circle?
Correct. Because you're at an observer height above
do you understand?
a sphere.
Do you do that on purpose? Like, nobody here thought that was a reasonable question. I don't think you just asked me to draw something.
And thank you for
in your definition. In your definition, I drew it wrong.
Providing the picture. Okay, so
and then you went, can you show me how this is different to the thing I just asked you to draw for me?
Okay. This is why
it's a bit weird, man. Come on, that's a bit weird.
This is why I asked you in the beginning. Do you agree that if you're on a sphere,
don't have it touching it? Oh, see how it's not touching it? Like, what?
Because now you've got an observer height. Now you're not on the ball, you're above the ball. Because you've got an observer height.
Right.
Do you understand?
Or an observer standing on that ball.
Do you say right to mean right, or do you just say right to start your sentence?
No,
because
right, I won't agree with you if it's incorrect.
So if you're an observer and you're off the surface of the ground, and in all other directions away from you, it is falling away from you. Then your observer height is placing that line off of the ball. And that at every other point, the ball is now curving away from that line. What do you mean it's not?
Well,
You've agreed with me up until this point.
So it touches the surface.
No. If it's touching the surface, then it's like the eyeball. Then the eyeball has to be on the ground. But then the eyeball has to be on the ground if it's touching the surface.
It clearly doesn't, man. It clearly doesn't. It goes from your eye, out of your eyeball, across to the last bit of the ball it can see. It goes out of your little eyeball and out of, like, have you looked at a ball lately?
Okay, so look at your picture.
Let me finish, man. Let me finish. Look at the picture. If you look at a ball, you can see the edges of the ball. That is your eyesight seeing ball, and the ball curves away from you, and then there is a point, the ball starts curving back in the opposite direction behind you that's hidden from your view.
Eggshells.
The edges of a ball, like a beach ball or something. Why wouldn't the same be the case for a sphere? Why does suddenly now looking at a sphere invoke a bent line? Does your eyes bend when you look at round things?
Look at your first picture. Eggshells, you posted this. Look at your first picture. And tell me, is the tangent coming out of that man's feet or out of that man's eyeballs? Like you've just presupposed that I can look out of his eyeballs and I will still hit a tangent point in the distance. Yes. Whereas that man on the sphere that you posted, he's at the highest point on the sphere that he can be.
Yes.
And if you lifted the tangent line up to his head,
which you don't
where his eyeballs would be. That's where the eyeballs sit.
Which would be the wrong thing to do.
No, it's where the eyeballs sit. So you would draw the tangent from the eyeball. Okay, so shrink the man down a bit. Still the same point.
I'm not drawing it anymore. I feel it was just a silly game last time to be like, make it not intersect and then look at that it doesn't intersect.
Okay, let's go back one step. Your first picture you posted with the little black man on like a gray ball, and there's a dip angle and a height of eye. You see the height of eye piece?
Yes.
The height of eye. Now, why are we not using the tangent at the height of the eye? If you say my eye is looking at a tangent.
Because that's what you're correcting. You may take an indirect measurement. You're doing a calculation of the measurement afterwards in order that you can put it at your feet, because that's what you're trying to figure out where your feet are. It's not going to make much of a difference either way. It's only going to make. It's only like it's
your
what
eyeballs
kind of
are
a
at
difference
ground
is it going to
level.
make? Well, it's just going to be
a black
fail.
swan.
Look,
Black swan
essentially what he's saying, what Solar's basically saying real simply is that line H is that tangent line that you're calling P. So you have P is nothing, okay? You just need to rotate this over a little bit so that line H is level like P, okay? And now that's that tangent line that you're drawing with your eye height to the horizon.
Yeah. That's closer to what I'm saying. What you're trying to do with the dip correction is you're getting the line H, and that will be subtly different, about 1 minute per 5 foot of height or something like that. I forget, some sort of thing like that. That it will
Does
be
the tangent
out by.
come
And so
out of the speed?
exactly as you just said, lunatic. As you just said, what you're trying to do is move that point at which your eyesight meets the ground, i.e. the point on the ground, exactly as you said. Really good description. I don't really need to say it again. You're turning that around till it matches with line P.
Okay, so tangent P should be at the height of I, at the same angle that it was at when it was a tangent.
Not at height of I.
It should be.
I don't know. Lou's got it. Lou's understanding it. Why does it need to be at height of eye? What difference would that make to the final
Because you
calculation?
don't look down. You're not ever looking down below horizontal at the horizon. You are always
That's just
looking
stating your belief.
level
That's not.
out. No.
I'm saying what. I'm saying what.
Real world.
But I'm saying
What we
when you're
observe
using
in
a
the real
sextant,
world-
what does that do to the measurement? Why does that change the measurement? Why does it matter where this tangent point is, unless it matters for how you do a sextant measurement?
Don't use a sextant for a tangent point.
So your complaint about this doesn't actually have to do with how sextants work. It's just a moral belief about where tangents should be.
Of how sextants work continually triggers me to try and elucidate that a sextant isn't used to find a tangent on the horizon. It uses the horizon to measure an elevation angle of something above said horizon.
Could it do that in this
misunderstanding
picture with a curve?
of how the sextant is used is what constantly makes me have to bring up this retarded point. The simple thing is
maybe
that
we're miscommunicating with one another because I feel like I understand you. I feel like what you're saying is if I turn this around, but I'm
man, like he wasn't
your
done.
picture. Your picture shows a height of I that's parallel to the tangent P, that P line tangent that's touching the sphere, where the height of I just has like a little piece of line to kind of show you where the line of eyesight should be. That is where P should be. From the person's eye going horizontally outward, and it, in your imagination, intersects with the sphere at some point. Logically, they could never make the height of I line be horizontal and ever intersect with the ground, so they've dropped it down to his feet or below his feet. But your explanation
so let's accept it then.
I'm taking a line of sight from the observer's eyeball to a horizon, and that line is horizontal, which is the P line at height of I. It is that simple.
Fine. Okay, so fine. I don't agree with you, but I'll happily grant it for the sake of conversation so that we can move on. Let's move it to the height of I. Let's say it's floating off the sphere. It is a tangent. What's wrong with that? It's a straight line from which we can take an angle measurement, correct?
If it's floating off of the sphere, it's never going to be a tangent to your sphere.
Sure. Does it have to be anymore? We've done the correction. We've now got the line we need. Can I do the next step with this thing? Even though you don't seem to like it, what will it do to how we use the sextant?
I don't, like, maybe you just don't get it, dude. If you're off the sphere,
honestly, I think you guys don't get it.
Like, what are you
should be
about?
able to.
Like, what are we talking about? Like,
you should be able to say to me, this is going to make your measurement out because it's going to do X over Y distance. You can't just go, well, I've decided a tangent point. They've drawn it wrong in the book, the manual that comes with the sextant I've gone. The Celestial Navigators have got it wrong. The tangent's up here. And I say, what difference does that make? And you're not able to give me a justification for arguing about this for half an hour?
Fine,
put it there. What difference does it make?
If you're looking at it from a straight mathematical point of view and forget concepts, right? What are they doing in the math? And just look at it that way.
The math's super simple.
They're doing it from a They're doing it from a point in space. You're going to make the argument the Earth is a point in space?
In a way.
Oh boy! And there's
as much as they are. I mean, they're bigger than us. In my model, remember, stars are bigger than Earth. When we're looking at them, they're fucking enormous. Like Polaris is a binary star system.
They're enormous. Whoa! I mean, like I don't know.
Let's go back to the pictures you posted.
So that's my position on it. If we're going to have this long discussion about how terrible it is that the tangent's there, and I need to go to bed soon, like what? Okay, fine. So tangents now at the eye height. It's not intersecting with the sphere. What now?
So you agreed that P line that's presently touching the Earth below my feet should be at height of eye, and it's still horizontal.
This again, I'm happy to grant that for the sake of conversation. If you're asking me what I really think about it, no, I don't think that's the case, but I'm happy to grant it for the sake of conversation so we can move on.
Okay, correct. So then the next pictures that you posted shows a tangent line at a height of eye off the surface of the sphere.
Mm-hmm.
And then you started to laugh because you thought that's quite ludicrous to place this tangent at height of eye, which is how this is always done. It's always done with the height of the observer as a factor. So there's always a height above the sphere because you're the man at the top of the ball. And then there's a height that you are now above the surface of the ball, and every other part of the ball has to be falling away from you. You're now at the height of eye, spheres below. I said, at that point, continue your example of how the tangent intersects with a horizon at a known distance along that tangent line.
I'm just asking you, what difference does this make?
Now,
we've now done all of this effort to correct this. Rather than now asking me questions, I'm trying to ask from you. We've corrected it. I've drawn a little man. I've drawn a little man for you. Right. So what difference does this make? Awesome. Thank you.
This is precisely. This is the crescendo. Like I've just said to you now, where along that line that's floating off of the surface of the sphere does your tangent intersect with the sphere?
No.
Because in the real
world,
it
a tangent anymore.
In the real world, we stand at bodies of water, we look out horizontally, and we can see the flat horizon, the apparent location where the sky meets the ground, and that's at a level observer at height of eye.
You're just stating your conclusion, but you've not led me the premise to get there with you. I don't quite understand it. So we've got this straight line that's at height of eye that isn't tangent to the sphere, but due to the correction we've made, would be parallel to a tangent right where we stood. Let's say it that way. Could I take a measurement from this line now? This correct line.
Okay, so I haven't even got to the height of eye correction yet. I'm just trying to get you to understand the point.
I'm just asking you a direct question, and the direct question is this: could I take an elevation measurement from that line?
So the line that you're talking about has been height of observer corrected back down to the ground.
Mm-hmm. Either way, could I take a measurement from it?
So if you look at the picture that Roger posted, just a little bit above your latest one.
Mm-hmm. Yeah. Going robot-y again, and I need to go to bed.
Yeah, he's roboting. So, dude, listen, you're never taking... you need a 90-degree angle. That's the point. Okay?
Line,
the initial measurement
pointing up toward the sun comes right.
You were roboting for ages, so we lost you.
I don't know if I should interrupt him and continue or wait for him to fix his shit. I don't know what to do.
That sucks. It's really difficult on that end too.
Is it better now?
It sounds actually better now, yeah.
Yeah, it sounds better.
Okay, yeah. So in Roger's picture that was posted at 49 minutes past, the angle, an elevation angle, is always taken from ground level or assumed to be sea level because you adjust for the height of the observer. But when you're the observer taking the angle measurement, you are taking that prior to height of observer adjustment.
Mm-hmm.
So you're taking it from height of eye, which means you are not tangential to the Earth. You are taking a horizontal baseline from height of eye, which is above the sphere. And then you guys believe it still intersects with the sphere. And I simply asked you where. Along your diagram.
I don't think it still intersects with the sphere. You've gone off on a long thing. You're now straw manning me. I asked you a really simple question, man. Maybe it was roboting when you went out to it.
Where was does the simple it line of with your sphere?
This. I've said it doesn't. The question is this. Could I, of that corrected measurement, take an elevation measurement? Could I take an angle from that straight line? Now that it's up above the head at height of eye, why not?
You can never take it off of a curved surface. You can only take it off of a flat baseline with a height of observer correction already done.
Okay,
yes,
so hang
on.
Not taking the elevation. Hold on. Let me just say this real quick. Nobody is taking the elevation angle off of that straight line. Nobody is taking the elevation angle off the line of sight. The elevation angle is always corrected.
Sure, that's what I'm saying.
So
you take the angle,
that correction,
and then you correct it.
It's not corrected.
You don't correct it, then you take it.
It's just a translation of the line in parallel. Like you got the line of sight, you move it parallel, you move it to a lower position. That's all you're doing.
You've got it slightly backwards. It's close, but there's no way to know. Like even if you know I'm going to make a height of eye correction of 2 arc minutes, let's say, you can't make that beforehand because what you're trying to get is the measurement. So the very first thing you do is take the measurement and then you subtract from that height of eye. So it's already in there in the measurement, but the first subtraction you're doing is quite close to what you've been talking about, Solar. The question I'm asking is that line still straight?
So say I take a sextant here at altitude and I take an angle measurement. Then I do the height of observer adjustment and I adjust the angle that I did record from height of eye. The point being, height of eye always places the tangent off the sphere. Then you don't have a horizon. If you have a sphere and you have this tangential line at height of eye, it never intersects with a horizon, is the point.
Yeah, but so, I mean, you've moved the line, but let's be clear how we got there. How we got there was you made me draw it. You changed the maths, which nobody in celestial navigation says. Nobody says you're trying to get this line that's off the thing. We clearly say we're taking it from a measurement to the horizon, and then we're correcting it. You've moved it to a place where it doesn't intersect with the sphere, and now you're going, it doesn't intersect with the sphere. It's not a meaningful debate.
Okay, place it right tangentially on the ground. That's the point that it's now touching the sphere. Where else does it interact with your sphere?
It doesn't. It just hits it at one point.
Okay, and that's the crux of the argument, is that we look out at a horizon, which is said to be the point where it's now intersecting with the sphere. And you've just told me that even if I place the tangent on the sphere, there's no other point that it can interact with the edge of the sphere.
Yeah, sure. Tangent point's only going to be tangent in one point.
It can only be a tangent at one point, and that's where you're standing as the observer. So you don't have a sphere. You don't have a horizon on a sphere. You only have a tangential point wherever you're standing if you're looking out horizontally.
So I know you keep stating the conclusion, and I kind of it's kind of stalled here. I think
not soaking in
because I'm kind of
is it not soaking in yet?
Well, I think what would help it soak in for me. What would help it soak in for me is if you just like when I ask a simple question like is this line straight or can you take a measurement from it, that you gave a clear answer. That would help me figure out where I'm at with this. But if I feel like I often
the answer is always
really direct,
only straight lines.
Simple questions.
The answer is always only a straight line
But that's not always the question, right? That's not always meaningful for the questions I'm asking
to
you.
get an angle. No, you said, can I get an angle measurement off of a straight line? Absolutely. That's what we've been trying to tell you for the last 2 hours, is that the flat baseline, which is the straight line to which we're taking an angle measurement from. That is the point of this argument, is that you need a flat, straight line.
I'm not unaware of it. You don't need to keep repeating it. Honestly, Solar, I've heard you say it 35,000 times.
But it's
I'm very clear on what your position is. I just think it's wrong, and you haven't heard mine. Honestly, I think it is. Let me steelman your position so that you can be confident that I understand it. You feel that what I don't get is that what I need is a curved baseline. I cannot take an angle measurement from a curved line. If what I'm standing on is a curved surface, then what it requires is the angle that I'm measuring, trying to get an elevation from, is from a curved baseline. You cannot do that, so it must be taken from a flat baseline.
No, I don't know whose argument you're reciting. No, that's not my position.
It's not yours? Okay, what's your position?
My position that I just repeated over and over until you told me to stop is effectively that once you're standing at the top of the sphere and you draw a horizontal tangent, there is no other point that sphere interacts with that tangential line. So
that's old. We've both agreed to that. That's not the substance of your argument, right? It's not the disagreement between us. The disagreement is whether you can get
that tangent at the height of the eye or at the observer's height, then you have 0 tangential points.
Yeah, right. But which you don't need anymore because you've taken. Right, but you don't need anymore because you've already taken the tangent to make this weird measurement that you don't really do.
In real life, I can be at the top of a building and I can look out and see a horizon.
What difference does this make to the sextant measurement?
Which means that the sphere is interacting with my tangential line at eye height, which means it can't be the spherical shape you presuppose it is. Is the crux of the argument.
Repeating your conclusion, but you're not really like what you would need to do is go, why is this straight line observation acceptable in one situation? Because I strongly feel you must understand my position by now, which is if you can create a straight line between your eyeball and the horizon in order to do a different measurement to get a distance, then you can use exactly that same measurement and not get a distance, but get an elevation angle from now. If it's not possible to do it... I thought your point was that
curved lines. I thought your point was curved lines, because my point is straight lines. What's your point?
Sure, my point's about straight lines as well. The sextants use straight lines.
Your point's curved lines. That you got a curve.
I'm getting tired of you telling me what my position
you could be up. It's been a bit of a long day. I think. Well, here's the real point. You could be off the surface of anything: a pretzel, a fucking pineapple, whatever you want, right? You can just assume it, like you're looking at the edge of anything and measure an angle between the edge of that and anything else.
Sure,
I mean, this isn't it. Like it isn't rocket science. Like, because the line of sight is a straight line, but you're measuring from the line of sight. You're making no measurements other than where something appears to be in the visual angle between those two things. Doesn't mean anything.
Well, I think it does.
That simple thing, dude. That doesn't mean anything beyond that.
Well,
I see the edge of something. I see a dot in the sky. Here's the angle between them. Boom. That's it. That's the only conclusion you could draw.
Well, it helps people find tiny islands in the middle of vast expanses of ocean.
Yeah, and there's a bunch of methods to do that, as we already went over.
Yeah, so writing, why is the horizon 10 times further in the black swan image?
There could be a bunch of reasons for that. I guess light bending a bit is one of the simplest.
So you don't have straight lines then.
Right? See, that's a good rebuttal. That's a good rebuttal that I think more people should do because I think it's a solid rebuttal.
Yeah. So you don't have straight lines.
You think refraction's a solid rebuttal? Really?
Yeah, because it's using global logic back on you. And it's true. Sextants rely on straight lines, and refractions are a problem for that.
Literally, there's no empirical. I can confidently say that.
There's no empirical.
Don't run this road.
A single drop of empirical evidence that the model of refraction used to make the claim that when we see things picked up is the reason, like light is bending through the air. That model, that physics model, there's not a single piece of evidence to support it. Not a single.
You're talking about the other kind of refraction, though. Like,
I'm talking about.
He was just raising refraction with a sextant. I think it's a good rebuttal.
Terrestrial refraction in the literature. If you look at it, you can pretty much see every single fucking person, scientists, that say we tested this and we can't make this shit work. We have been doing it for 100 years, dude, and you can read all the documents. It's all publicly available. They take the meteorological shit, they measure that, they put it into the model, then they compare it to the survey, the observations, measuring angles, right? They don't match. They don't even remotely match.
Yeah, that's why I think it's a good rebuttal.
And there's other observations. There's other observations which show it's not happening. So because you guys think refraction just does like one thing. Why, I don't know why you guys think this. Some reason that refraction just like picks things up over the horizon and doesn't do anything else. Like we make lenses, right? And how do lenses work?
Yeah, the same principle.
Lenses.
I'm not even invoking anything to do with
principle to work. And there's effects. There's consequences of light when it's refracted, namely dispersion.
I feel like you just ran off on one though. Like if I can just jump back a second. Roger brought up refraction. All I said was that's a good argument. I'm not arguing for or against it.
It's trash. It's a horrible argument. It's actually a horrible argument. It's always been a horrible argument. It's an ad hoc hypothesis without any experimental support. That's all it is. It's just a Hail Mary because you got nothing else.
Roger's using it to rebut my point.
But writing.
The point about the black swan. Okay, let me ask you. I want to ask you a question. So I want to actually get back to the section. What is if I am 1 foot above sea level, what is the dip correction?
I think it's close to negligible. I think at 5 foot, it's 1 arc minute or something like that. And then 2 at 10 foot.
See, this is the funny thing. I looked in so there's a guy on YouTube, one of you guys, right? Glober, says the correction is 1 arc minute per foot of elevation. And that puts the horizon at 0.6 miles away from the observer. And that debunks the black swan, which is odd. He thinks the black swan, the 1.23, is like QE's number or something. That's the globe prediction. So even, I'm assuming what he said is true, that he read it in a nautical manual. That debunks the globe math.
I'll check. It's in my
But then I read the sextant manual, and the manual for the sextant said that amount, it's the horizon's going to be, what would it be?
It's a minute per 5 foot.
And a minute per 5 foot. Well, they had 2 degrees at 5 feet.
Oh, yeah, it's 2 degrees at 5 foot, but nobody's going to take it from below 5 foot, right? Nobody's 5 foot tall and standing directly on the
exact
water.
Document I read of 5 feet. So 2 degrees is 120 arc minutes. So if it's in an nautical manual out there somewhere, like y'all need to get your shit together, man.
Not 2 degrees. It's 2 arc minutes.
Size spheres.
It's 2 arc
y'all
minutes.
need to get your ball down to the right ball. You don't want to have balls of different sizes, man. And you might need to see something about that.
No, it's pretty good. I think the 1 degree per nautical mile, I think, is fairly reliable, fairly robust, and creates a circumference that you can divide by pi. And you get 3956 or something as your radius. If you go nautical miles times 360 and then do the maths to turn that back into a radius, you get something pretty close to the given radius.
Well, have you ever plugged this 5 foot height dip correction into like a curve calculator and see what like it says?
No, haven't actually.
I mean, I can do it real quick, but I don't think any of these numbers match. It's just my opinion from looking at this and looking at the curve calculator gazillions of fucking times. I don't think that they match. And like I've looked at nautical charts with the distance to the horizon, and they don't match like the predictions. They're all different. Yeah. So I don't know like what that is. If you're sailing around the world thinking it's a ball, as you think, but like if you look at the actual geometry and everything's completely different, right? Distances to the horizon, how far things are away, the angles between things, like all this stuff is completely different. Like so, but I don't understand why that is. It's like the size of the Earth changing. And I'm only bringing this up because you brought up the black swan. And the problem with the black swan is the horizon distance. So if you have a globe that you go out and you make observations and they're inconsistent, like, how can you conclude that it's a globe?
Yeah, I think it's like the same thing we were saying before about indirect measurements. If you've got if you've got thousands of different things that are all pointing one way, that's what you do. You don't pick it, you don't sort of rest it on any one particular one.
There's a mismatch in the data. There's a mismatch of the data. They're not pointing one way. They're like, listen, the different, like, what is the, like, so if the Nautical Almanac says the horizon is 0.6 miles away, in the globe math, right, says that the horizon is 1.23 miles away, that's a giant error. That's not a small error. And because it's such a short distance, it's even a worse error because it's such a short distance. The errors accumulate, like, the further away something's supposed to be, that's how errors accumulate, because, like, it's like a lot, like, because you're using units of measure, and as you're using more of those units, any small error in any particular measurement is going to get greater as you accumulate them, right? Errors accumulate. So you're using a small distance, super small distance, I'm 1 foot above the sphere, like, and we have depending on the way you look at it, assume the 0.6 is correct, right? It's 100% error. And if you assume the 1.23 is correct, it's a 50% error. Those are giant errors. They're not small differences. They're giant differences. You'd be really pissed if your bank account had half the money that you thought was in it. You know what I'm saying? Like,
yeah. No,
a couple bucks you might not be too irritated about. But if half your money's gone, you're going to be, this isn't like, if they were like, oh, it's we got a model, it's almost right. You'd be mad. You still wouldn't be happy about that. This is when we talk to you about, have you investigated the globe to sufficient capacity? The globe model is rife with errors such as these. There's so many of them. It's almost boundless. Like, everywhere you look, there's something like this. I don't know if anybody's looked as hard as I have, but everywhere I've ever looked, man, like, I'm like, you ever seen that movie Fracture with Anthony Hopkins?
Which one? Say again?
It's a movie called Fracture with Anthony Hopkins. He tells a story about how, like, this guy's like super anal retentive, where, like, he had to work on examine eggs to see if there was any cracks. And he was such an anal retentive asshole when he was a kid that he, like, discarded every single egg. He was a perfectionist. I find errors like that. Like, I find inconsistencies, discrepancies, like how my mind works. I just find anomalies, like exceptions to the rule, man. I find that shit really quick. And there's so many with the globe. It's boundless. It's just, no matter what direction you look. You think that after all this time is something that they're saying, like, that they claim people are stupid for not believing, that you could at least look in one place where they say it's a globe and find, like, near perfection. And
wouldn't it be
the only thing that's perfect is the propaganda. That is absolutely perfect.
Wouldn't it be a bigger discrepancy, 1 degree for 60 nautical miles on a flat surface? Wouldn't that be a very big discrepancy?
Yeah, but that doesn't actually exist. See, that's an idea that you think exists, but it doesn't actually exist in the real world. You look at how they do measurements and how they're correcting them, and the limitations of the actual observation, of observing in a very small, narrow window of the sky, right? And then I was just telling it to this guy. They make an observation of a very small window of the sky. It's well known that doing astronomical observations in navigation, usually the error is about 15 miles a day. If you just take one sighting and sail, your error is going to be about 15 miles. Obviously, if you sail a long distance, you're really fucked up by the time you get to the other place.
But no, you're not. You assume those. You assume those add together. They don't. So a measurement you take today is unaffected by a measurement you took yesterday. If you take two sites, you can know with a very high probability your position within 1 nautical mile.
Yeah, but the more sight,
no, you can get totally off course.
One sight and sail a heading 50, if you're off 15 miles in one day and you keep sailing on that heading, you're going to be off more on the next day.
You could put untrue. If you put somebody on a boat with a sextant who is a navigator and you put them on the boat in a coma and let them float around for 3 weeks and wake up, they would straight away be able to trilaterate their position. They don't need to rely on previous headings. That's useful. It's helpful. But if they could sight 3 stars or sight the sun 3 times in a day, they can absolutely trilaterate their position. It doesn't rely on yesterday's measurements. These help, but only in making it a bit quicker and knowing where to look.
Yeah, that's a cool story, and that's what you think, dude. That they can wake up
how it's done.
And know their position. How do you verify that you're at the known position?
Because you can test it. We can test it with lat or long.
How do you test it?
Know your lat and long. Test it against your lat and long. Do I hit the island?
Let me give one example. Like if you see a star straight up, like you look up, you see the star. You can just get the GP of that star on the almanac. That's your GP, and you can do that on land. You can do it everywhere. It's like one example that you can verify it, right?
Yeah, you can even do it in Stellarium. Just go to Stellarium, take a rough eyeballing of what is straight up, and then use Bacon's app to just show that star. And what you'll see is it just draws a circle around or near your location. And the closer to 90 degrees it is, the closer the circle will be to you, and the smaller the circle will be.
Look, yeah, that's all cool stories, but too bad none of that shit's true.
That's how people navigate.
That's how
people navigate. But the only way to verify your position on the ocean is to sail somewhere.
Yeah, and what do you think they do when they're aiming for a Polynesian island, like way out in the middle of nowhere?
How do they hit it? Talk over me, but I have the power to mute you, and I will shut you the fuck up if you don't let me talk. Okay. The only way to verify your position to where was I in the ocean? Okay, I'm gonna say I'm here, but I don't see anything. All I see is water in the sky. This nautical almanac says I'm at X amount of degrees. Right? How do I verify that? You can't.
Or you can do the same thing on land.
In some direction and say, well, I'm predicting I'm here. Now I'm going to take another observation. Is my prediction correct? That's not exactly correct, but it's close enough. But it says that I went kind of in the wrong direction. It must have been the currents, must have been the wind, must have been something else. Oh, so I'll sail another direction. I'm not looking at the whole sky. I'm only looking at this small portion. Then I'll sail for a little while more, and I'll do the same thing over and over and over again. Then you guys say, whoa, you can just do this and it's super accurate. It's not how it works in reality. How it works in your mind.
Where do you get
in the physical world?
What makes you so sure it doesn't work?
Nothing but water.
Because you're right. I've got a sextant, but I haven't taken a full sight yet. I just trust that people who work for the Navy or claim to have used a sextant to navigate did that. Why are you saying they didn't? What are you basing that on?
No. Because I've actually looked at shit. People actually test the accuracy of instruments. Do you know this?
Well, yeah, so tell me about a test for the sextant.
Okay, so I know about tests for the actual and tests for sextant. On average, when you take a sighting and you fucking try to go between point A and point B, right, on that sighting, the average that you're off, 15 degrees per day, or 15 miles per day. This has been the same thing since Columbus. Yeah, since Columbus. And Columbus didn't have a sextant. He used an astrolabe.
What, he was off 15 additionally
on the accuracy of Columbus's method of sailing to the Americas. You know, Columbus was lost. He ran into the Americas.
He sounded like he was a pretty poor navigator. In a little bits I know about it.
All I'm saying is they know, like, from what he did, they know because he wrote it all down. So they tried to, take his route, right? They found out that he was off by an average 15 miles a day, and that he probably used other cues to find land. Namely, that's why I mentioned it earlier, seabirds. When you start seeing seabirds, you know you're not in the way deep in the ocean. You know you're closer to land, right? So
because Christopher Columbus was out by 15, which is like slightly out but not terrible for celestial navigation, it therefore doesn't work.
Dude, that's an appeal to pragmatism. Like, no one said it doesn't work. It does work for practical purposes. Whether you think it's measuring a globe or not is another question.
But I just don't think they've looked into it.
Try to conflate things and fucking use the logical fallacy called appeal to utility or appeal to pragmatism. Yeah, lots of things work. Condoms work. They're not great for making a family. Okay?
Yeah, but if it works for practical purposes on assuming a globe, does that work? Does that work assuming different geometries for Earth? And I don't think that's the case. Like if you apply the same thing that is being done onto any other geometry, I think you get less of an accurate position. You'll be more off if you pick a different geometry.
Yeah, but you can think what you want. That doesn't really matter. You can believe.
Yeah, but do you have any points on that? Like, do you think there's any geometry that can work besides the globe?
There's other civilizations other than Westerners that navigated the oceans with incredible accuracy, and they thought the Earth was flat. They used a different technique. They didn't have Polaris. They didn't have magnetic compasses. They didn't have a globe idea in their head. They didn't have sextants. They didn't have any of these tools.
What is the method you said?
I'll post actually a link to it's a fucking paper, dude.
Sure, but I mean, the sextant working on a globe doesn't imply that there's no other accurate way to navigate. The fact that the sextant can be used to give you a position is what it's. I think it's relevant because it's using globe math to do so, right? And it's very hard to.
How is it guys make because it assumes that you're at a point in space. That's what it does. You're at a point making an observation. And the angle between two things is a rotation. Mathematically, I'm talking about. When you do the math, all it is a rotation. You're at a point and you're rotating the lines in space. That's all you're doing. It doesn't assume any surface.
It does when it's using.
Listen, you can project across one of these points when you're assumed radius, right, and say I'm here and there. But that doesn't mean anything. Like.
Yeah, but you need the surface to do the trilateration because if you know the distance you are from two known points and you want to know your position, then sure. But that's what I'm saying. You can say that's wrong or that's assumed, but that's still assuming globe math, which is your contention, like right? Isn't that what you're putting in contention that it's using globe math?
What do you mean? What my point of contention? My point of my contention is at that. The practical uses of this stuff is not measurement of a globe because of you are saying things are more accurate than they actually are. There is lots of fudging. Saying things, there's a linear relationship between the stars and our motion across the surface of the Earth. And no, it's not how it works. It's not how it's actually done. That's not what is actually happening. You're looking at a small portion of the sky. You're assuming, right? You're assuming
a small portion.
Womack tells you, that if you see the Polaris at 45 degrees above the horizon, then you're on 45 latitude. Yeah, that's a cool story, but dude, you haven't done any measurements of the surface of the Earth, okay? You've looked at the sky and says, how does the sky change when I move around? That's all you've done.
Sure.
But you also ignored half the sky and said,
"Sure, but
I'm going to ignore half the sky and pretend that doesn't exist." And I'm going to look at this half. If I assume this half, and I'm on a ball, then yeah, it works. But if I assume the other half, shit, I might be on a flat Earth. So I'm not gonna do that.
But that would not produce the same observation, would it?
Why don't you make observations below 40 degrees?
No, I'm saying.
Why don't you make observations below 40 degrees?
Why do I make celestial navigation? What?
Celestial navigation makes no observations below 40 degrees. Why is that?
Below 40 degrees?
Below 40. I'm talking about elevation angle, right?
Sure. So
you got the horizon up to 40 degrees. Astronomers, nobody. They don't make any observations in there. Only from that point up, right? From 40 degrees. Well, depends on each profession different, right?
Where did you get it from?
And there's the other way. So you can measure up from the horizon or down from zenith, right? So if you go from the horizon and you go up to, I think, was it down from the top? Now I'm confusing myself.
I'm not sure if there's this restriction of 40 degrees. I think I've seen people using 30.
Horizon to 40 degrees up. They don't do any observations there. Why? Because they say, it's inaccurate if you look there.
Where's this information? Where'd you get it from? Because I never heard of it. Like,
the first place I read it was Understanding Astronomical Refraction by Andrew Thomas Young.
Sure. Can you link that?
I mean, you could just Google it, but yeah, I guess I'll link it.
All right.
It's a fairly published paper, and he goes
over what terrestrial refraction say?
What? Say that again.
What's the title? Understanding what?
Understanding Astronomical Refraction.
All right.
He presents a bunch of models.
Sure. Does he claim that
don't have a linear relationship with the sky? So even in your model, when you say that the sky, the elevation of stars have a linear relationship with the movement of you across the surface of the Earth, even that statement's not true. That statement's not true in your model.
Why?
I just told you why. Because you make the observations in that limited part of the sky because you say refraction changes the positions of stars.
Mm-hmm. And why is that not part of the model?
Because if it changes the positions of the stars exponentially, right? It's not a linear, it's exponential. Yeah, so you have from zenith going down to the horizon, that's an exponential function. That's not a linear function.
No, it's not an exponential function.
The math says it is. The refraction model that you guys claim to fucking exist half the time when we see too far, right? Says that refraction is an exponential function.
No. What do you mean? No.
Understanding
the position. Wait. The relation between the angle and the distance, if you take into account refraction, is not going to be exactly linear, but that's not going to be exponential.
According to the mathematics.
Okay, can you get the formula? Let me see if that looks like an exponential formula.
You know that if you see a star on the horizon, that the model says that star is actually under the horizon. You know that, right?
Sure.
Yeah, so you know that. So what do you mean that's not slightly off, dude? It's under the horizon by...
I didn't say it's slightly off. I'm saying that's not exponential.
Diameters, it's under the horizon.
I'm saying that's not an exponential function.
It is exponential, but it's an exponential function. Dude, it is. Dude, don't make me pull it up and show you the fucking graph, dude. Like, seriously.
Exponential sounds like it's bending more and more.
That's right.
Yeah, and it's a specific rate. On like it's
an exponential.
It's a constant
where it just like takes off and does just basically a hockey stick. 88 degrees being zenith distance. So zenith distance is 0 is zenith, right? And it's the angle from zenith. So 88 degrees would be 2 degrees above the horizon.
Mm-hmm.
So they say even at, according to the model of refraction, even at zenith, according to them, there's refraction. Even at zenith. This is according to you guys' model. Like
at zenith, what do you mean? Like
models. Like
at zenith, the refraction. Well, but that just doesn't make sense. At zenith, it would be refracted towards which direction?
Pardon me?
Okay, so if I'm seeing a star at zenith, right, you're saying there's the position is actually changed by refraction. Is that what you're saying?
Yes.
Even if it's at zenith?
By 0.01 degrees. And this is also in the astronomical tables.
Oh, sure. If it's 0.1 degrees. Well, I'm saying if it's exactly zenith, right? If it's exactly zenith, we there's no correction you can make for refraction, right?
There's no correction you can make because it's not measurable with the instrument you're using, right? But it's still there. But the thing is, as you get further and further away from, like, listen, you have
position
and an apparent position. This is how it works: true position, apparent position, right? So you have the true position at zenith. The true position from the apparent position is a difference of 0.01 degrees. As you go from zenith down to the horizon, that difference between the true and apparent increases. And as closer you get to the horizon, that becomes an exponential function. This is why they only make it up between 40 degrees and below. The globe excuse is that, we live on a ball, and that must be an error because of bendy light, right? But then you guys,
wait, one second.
we make the observation of as we move around, it's like a perfect dome over us, and as we move around, it's a perfect linear relationship. That is not.
No one's claiming it's perfectly linear, but it's very close to. And the exponential term of the formula would be a very small constant. So it would be the exponential of the angle times a very small number, because it's mostly still linear. Like if you look at the chart, if you plot the function and look at it, that would still look very much like a line. It would be a little bit curved in the very end, but it would still look like a line. So I mean, that's why would that be a problem for the globe? That needs to be the case for the globe.
Obviously, it's a problem.
I feel like you guys are talking past each other. India, can I clarify for Bacon? I talk to Bacon a lot, and I understand that he's going to be very hard-headed about this. India, are you saying that there are effectively that they approach it in two ways? In that there's a linear function above 40 degrees and then an exponential function below 40 degrees?
Yeah, pretty much, yeah. Yeah.
Okay.
I mean, it's basically flat, like the curve is basically flat till you get to 40 degrees, and then it starts to hockey stick.
Perfect. Okay, so I've understood that. Bacon, when you say that it's a linear relationship at certain points, you're not addressing what India has said. And that's why I think that you guys are like talking past each other.
Okay, what needs to be addressed?
His argument the argument I hear is that it's insignificant. It's so insignificant that
no, it's not insignificant.
It's not. They don't make observations below that.
No, that's not my claim. Well, my claim wasn't that it's insignificant, and I don't think it's true that no one makes observations below 40 degrees.
That is a question. And I can give you a link to somebody that teaches celestial navigation for a living.
Right, sure. So, please do that. Let me take a look.
It's a video. It's like a 2-hour-long video on celestial. It's a whole course on celestial navigation. I mean, it's not like something you're gonna like watch right now.
Yeah, but I'm gonna watch later. That'll be good information, I think. So, if you can link that, I'll watch it at some point.
Okay, hold on. I mean, yeah. The point is this: is that there is no linear relationship. So a linear relationship is if you cherry pick your data. Period.
Yeah, but it's very close to linear.
Who cares?
Well, whoever is navigating.
Think about this. Just think about this, okay? You have a fudge here, a fudge here, a fudge here, a fudge here, a fudge here. Where you're making a measurement, but the measurement is so imprecise, and then you're taking a bunch of very imprecise measurements, and you're using other things other than these imprecise measurements. You use a bunch of accumulated knowledge, not just the sextant, to traverse from point A to point B, right? And you're using mathematics that use a bunch of different methods and don't even presuppose a globe. And
they do.
They don't. They don't, man.
Okay, have you ever done a position fixing?
A point in space, dude. There's no arguing this. It's the same as in astronomy. They say the stars are an infinite distance away, so we assume that the Earth is a point in space. The origin of coordinates is the exact term. They say the Earth is the origin of coordinates. That means Earth is the 0x, 0y.
Yeah, the center of the Earth. And in 0z as well. That's where for example, if you get the raw data of GPS, you can get a XYZ that the 0 would be at the center of the Earth. Sure. But when if you're not just only using points, but you're also using distances between those points, that tells you about the geometry of that surface. And the way we are using it, the way we're calculating it, implies a sphere. You can say that it's not a sphere because we're using imprecise measurements, but the whole position fixing is still sphere based.
What are you talking about? No, it isn't. What are you talking about?
Have you ever done it about position fixing? You know how position fixing is done.
The sphere is not the Earth. The sphere is the celestial sphere, and it's your orientation relative to the celestial sphere. You get that?
No, actually, no. Actually, no. We're not.
What are you talking about?
We're not trying to. One second. We're not trying to find our position in the celestial sphere, because you can use 3 different sites that were took in different times. So in those 3 different times, the celestial sphere would be in a different position. But you're trying to get your Earth coordinates. So that's the sphere you're trying to find your position on Earth, not on the sky. The sky is just the star's coordinates that keep changing. That's not what.
Look, I don't think you understand what's going on. You have the celestial sphere. The celestial sphere is in motion, right? It moves. So we have our time coordinates. Where is my orientation against versus the celestial sphere? Movement, so-called translation across the surface of the sphere, and the motion of the sphere, so-called rotation. It's just 2 rotations, right? From the center, from a point. This is what's happening mathematically, right? So you got 2 lines that go out from the center of a point, and then we push those lines into a direction, right? But that direction is changing, so with time, right? So where something is actually pointing at, you don't even have to assume anything about a sphere. It has nothing to do with the surface of a sphere.
It does when you're doing position fixing.
After the fact, ex post facto, we've said, look, when I see these stars in this position, I'm going to say this spot of ground is 42, 52, whatever latitude, longitude. We've done this by convention. And if you look at the International Terrestrial Reference System, they admit this, that latitude and longitude are determined by convention, and the UK Ordnance Survey says it is a myth that latitude and longitude are points on the ground. Your own shit says this.
Sure, yeah, they're not physical points on the ground, but it's not. Wait.
Precise points.
But when you're trying to
geodetic surveying results don't match astrogeodetic results. They've known this since the 1400s.
Okay, but when you're getting your position using celestial navigation, you're not going to get your coordinates on the celestial sphere, because that coordinate you get is not time dependent. So if I make, if I do celestial navigation right now, I'm going to get my position on Earth. I'm going to get a value. If I do in the next hour, I'm going to get more or less the same value. It doesn't matter when I do it. I'm always going to get more or less the same value if I'm on the same position on Earth. So that's not giving you your celestial position. It's giving you your position on Earth. Whether or not latitude and longitude are actual physical points, which is not the case, I agree with you. They're not physical points. But it's about the position on Earth. It's not about your position on the sky. Like if I ask you what's the coordinate of your house, you don't ask me, well, to what hour.
Am I measuring anything about the Earth when I look at the sky?
Depends on what you're doing.
Okay. So there's a coordinate system in the sky. We make measurements of it. The sky looks a certain way at one time. It looks a certain way at another time. Right?
Mm-hmm.
We know from use, practice, blah, 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 that if I'm standing in one place, New York City, the sky's going to look like this at this time. The sky like this going to look like this at the next time.
Mm-hmm.
Right? So we are making measurements of the sky. The coordinate system is in the sky. Just because we've, right? You could actually do it the other way around. We could have the ground changing in the stars fixed, right? And we could reverse the entire coordinate system, but that would really suck.
Yeah, but your position, the coordinates of the coordinates,
actually reverse the coordinate system. And we could have the ground coordinates changing constantly and the sky coordinates fixed.
Yeah, you can do that.
Yeah, and what good would that
be? Yes, when you're doing, it doesn't matter. You can do both. It would still have to assume a sphere when you're doing celestial navigation, because when you're comparing the distance between the measured and the expected, the correction you use is a correction for spherical distances, right? That will not translate to a flat surface.
Look, you act like you're making. Listen,
let me give you an example.
Like a flat surface, you have no evidence for that.
No, if you have any mapping of points on the surface of a sphere, and you translate them into points on a flat surface, the distance between those positions are no longer the same. They will change. Some of them might get preserved.
Do you think that that's what they're doing with the globe model? Is that what you think? What they're doing with the globe is that?
No. Let me finish the point then. So what they're doing in celestial navigation is that they're using distances over the surface, and they're not doing that in a way that is consistent to any other shape of the Earth that is not a sphere. So how are they not using globe math?
I'm having a problem really understanding what you're saying.
Yeah, I think his whole shtick is that nautical miles only work on a globe. That is what he thinks globe math is.
No.
No.
Well, I'm not sure what you mean by that, but to me,
just made the argument that a globe projection doesn't work when a spherical surface doesn't work when projected onto a flat surface. Yeah, no shit, we know that. Who cares?
But then that's not the point I was making.
It has nothing to do with that. So, like, what the fuck are you talking about?
That wasn't my whole point. That was just my first sentence.
Like, the distances are different. Like, yeah. So what? Like,
that's not my point. I'm not saying distance is different point, and I said nothing else. No, I kept that. That was just my first sentence. That was not the argument. The argument is
connect the first sentence to the second sentence.
Right. I don't see the argument. The argument is when you're doing position fixing, when you're trying to work out your position, you want to correct for those distances. And the way they correct for those distances is using distances on a sphere. Right? They're using globe math. And that's not the distance on the sky, that's distance on Earth that they're using.
Okay.
So those coordinates...
Yeah, but what is globe math? Right?
No,
because you're arguing... he's arguing against...
You're wrong.
So he's arguing against celestial navigation? I don't get it.
No. I'm completely...
What is then the globe math? What is then the globe math to you when using celestial navigation? What is it that you are trying to say? We use globe math. Specify.
When they're getting their distance to start based on the azimuthal angle, and when they are doing the position fixing using the calculated distance of the star, which they use either the Haversine formula or they use tables to make a quick way to get that. It doesn't rely on calculators.
Okay, let me ask you a question. Instead of a radius of 3959, say they just decided tomorrow the radius now is 20,000 miles. How does celestial navigation change?
It wouldn't. But it would still be a sphere.
Thank you very much.
Yeah, but I'm not arguing for the radius. I'm arguing for the shape. Yeah, if you get a cube with the same diameter, that wouldn't work. If you get a pyramid with the same diameter, that wouldn't work. If you get a sphere with a different diameter, that would still work. Because the diameter isn't what makes it work. It's the math.
You don't actually have a measurement of distance. That is
I agree.
The fact that you change to a radius of any size says that you're not measuring the surface of anything.
But the distance doesn't have to be right. It has to be proportionally. It has to be proportional against the other positions you're changing. So, for example, let me give you an example. Let me give you an example.
Proportionality, dude, I understand it. I understand what you're saying. Because of the proportions, the relationship between the sky and how we travel around, that proportionality, that linear relationship is holding. Predetermined.
That's not about that. That's not actually what I'm saying.
Okay, go ahead.
Okay, so if you're taking 3 sides to 3 stars and you're measuring the same elevation angle for the 3 of them, and it doesn't matter the actual distance. It matters that you're measuring the same distance between all of them. So if you try to map those GPs to a different shape that is not a sphere, they're not going to be the same distance to you anymore. So it's not about the scale of how far they are. It's about how those distances compare to each other. And depending on how much they compare to each other, you can get your position on Earth. And if the Earth was a different shape, that method wouldn't work.
So I have an idea. Get 3 boats. Right? Get 3 boats, go out in the middle of the ocean, take sightings of 3 stars at the same elevation angles, and then sail off until you're under all 3 of them, and then figure out how far you went. How about do that?
Well, that sounds like a lot of work.
Yeah. Well, fuck it, dude. We'll just use our imagination instead. Like, you guys say a lot of things exist. Like, I don't get it. Like, you guys say all this stuff exists, but you basically have to ignore every anomaly, You have to cherry pick data. You have to use confirmation bias. You have to do all these things, right? You ignore the errors of the fact you have to do innumerable course corrections. Innumerable. How many, like if I sailed from, say, New York City to Australia, how many course corrections do you think I would have to make in that time? Thousands.
Sure, but every
those course corrections, right? That like I'm actually somehow measuring the surface of the Earth and somehow
they don't add up.
Use this assumption that the Earth is a sphere. I got there, but if I assumed it was something else, I would have sailed into the abyss. That's nonsense, dude. It's just utter nonsense. This celestial navigation is just good enough for practical purposes. It has a small amount of precision. It's precise
how is that?
To get you where you want to go to probably within 1 degree. I mean, like seriously, it's that bad.
No, you can get your position. Okay, well, one second.
It's taken sometimes to cross the Pacific Ocean. Like one time it takes one amount of time, and one time it takes the other some fucking vastly, like 50% longer, even though they supposedly went, according to celestial navigation, the exact same way.
Okay, let me ask you something. Mention about your point of making thousands of course corrections. Yeah. So if I did one position fixing, now I'm doing the next one. How am I using the last one in the current one?
You're not.
Okay, so they're independent, right? Actually, you are, because you usually start with the guess position to save work.
I mean, technically they use rum lines and all that shit. So, like, I mean, it's more complicated than just like even the complications I set out. It's even more complicated than that in actual practice.
Okay, but they use
like they're using a bunch of navigators on a ship. There's only a couple. There's like one guy, and you got to really hope that he's really good. And they call it more of an art than a science. This isn't my words. Like, this is what people that do this shit say. That this is not like this is. It takes skill to do this. It's not like anybody can pick up a sextant, look at an almanac, and sail across the ocean and live. Like, it's not really working that way. It's that they have to use lots of different, like, what would you call it? Lots of different data points, right, through the whole experience of the journey to get to where they want to go. And it's been this way for a long time, even in light of what you think GPS satellites and every other thing.
Okay, let me try to understand your point. Like, what exactly is your
ships on the ocean that should just sail between America and fucking China with with goods on them? Like, why even have fucking people going across the ocean? We could just automate all this shit.
Yeah, like GPS. Is that what you're referring to?
Yeah, like
celestial navigation.
You could actually have a fucking computer look at the sky and figure out where you are on Earth. You wouldn't even need a person.
Actually, that's much more difficult. It's very hard to get the.
And this is one of the
you're both swinging.
Want to hear something funny? One of the first things I looked up when I started investigating this topic was exactly that. A computer system that they were going to put on planes that would tell them where they are on Earth by, like, it would take the sightings of like 7 different stars. And if they assumed the flat Earth, it was the most accurate. Yeah, dude.
Well, can you link me that?
Oh, dude, this is almost like 4 years ago. I'd have to find it. I might be able to find it, and if I do, I'll send it to you.
Because I really doubt that.
They used 3 different methods. They used 3 different methods of calculating the angles between the stars. And the one that was the most accurate with the least error was assuming a flat Earth. I shit you not.
Yeah, I want to see that. I really doubt that that's the case. But I'm still trying to understand. I'm just still trying to understand your point about we having to make.
Very hard to do rotations in computers, as you should see from 3D graphics.
Sorry?
It's hard to do rotations, mathematical rotations.
And
computer graphics, if you want to do
it's hard.
You want to do rotations of objects, right? Well, because you have to model this mathematically, right? So you're modeling rotations. You're modeling the rotation of celestial sphere. You're modeling rotation of the Earth, right?
One second. How is it exactly hard to make rotations on with graphics?
There's several different ways. You can use matrix mathematics. You can use Euler angles, right? You can use quaternions.
Yeah, they use but the quaternions. Wait. The quaternions are used to generate matrices. So even if you're using matrices, you still can use quaternions.
Yeah, but there's like in certain situations there are issues, right? That it doesn't work. Exactly.
Yeah, but having multiple ways of doing something doesn't mean that's hard.
Now,
I mean,
we're talking about now. In the 1970s, right? So this paper is from like the 70s. Sure. At that time, in the 70s, we didn't have the compute power we have now. We could do it now because we have graphics cards that can do these types of operations, parallel operations, like crazy, right? These are matrix mathematics and vectors. This is what they're designed for.
But any other rotation method is going to rely on the same mathematics, not exactly the same formulas, but you're also going to need same trigonometrical functions. And after that, you only need adding and multiplying. There's nothing more complicated than that. Even if you're using, let's say, matrices, because you can get a rotation matrices from Euler's rotation, let's say. That's just some trig functions, and you get a matrix. And multiplying matrices, there's nothing that requires today's technology to do. Okay. It's just multiplying and adding. That's all it is.
Yeah, that's awesome, dude. But if you're on a fucking airplane and that computer's computing it, yeah, theoretically, given enough time, it can actually do that. Yes. And theoretically, the people on the airplane could do it by hand. And theoretically, somebody could use a slide rule, and another person could use a calculator. Yeah, it can be done. It's not. I didn't say it was impossible, but it needs to be done in a timely fashion. So the best way to do it that they found using the system that they wanted to use, the most accurate from what they were observing, because they would use the computer system and test it and say, okay, this is what we fed into the machine. This is what the machine spits out. What's the most accurate? But they're also trying to balance it against what can actually be done. So obviously, because rig functions are actually an infinite series, you have to truncate at some point. That truncation leads to errors, right? Plus small angles lead to errors. Errors are introduced into the system. You have errors in the floating point. So there's errors when you're looking for some level of precision, right?
Sure.
So, okay, so you just brush these off like they don't matter.
No, I'm not. No. I'm never.
Computer.
One second. The error of floating points when applying to coordinates, let's say, it's a centimeter. If you get the smallest difference between two coordinates and translate that into distance, that's like less than a centimeter, and that's a floating point, which is the less precise.
Now, that's
no. Yeah, no. Now we use doubles. Now it's way less. But that's how it used to be. Sorry.
What do you think they were using in 1977?
Floating points.
How many
bits? How many bits of precision wasn't they using? When they were dealing with floats, weren't they using 32 bits of precision?
The 32-bit computer came out like in 1980s.
But it's not about the computer. It's about But the 32-bit processors is not referring to the calculations. It's referring to how memory is addressed and what the size of the instructions. It's not about the size of floating points. You can have 60-bit computers doing 32 bits multiplication between floating points. So it's not about the computers being 32 bits. It's about the operation between floating points.
Listen, they typically would not design the software to use numbers larger than the addressable space. Okay? You're obviously young, so I'm older than you. This is just how it was done back then. You had your addressable memory space, 32-bit. People didn't typically use precisions larger than the addressable memory space because of bugs in the code, basically.
What do you mean?
Okay, so you have to have addressable memory space, right? So you have a number, right? Right? Sure. So you have to put it okay, I can address. Oh God, I can't believe we're going to talk about this. So you have a 32-bit address, right? And any particular operation can address. If I want to do more precision in that 32-bit address, I got to break that up.
No, but that's the memory address. It has nothing to do with the precision of the number. You can use bigger numbers. The addressing isn't tied to the size of the number.
Okay, so data stored in the computer memory has to go into the processor and back into memory, right?
Mm-hmm.
Okay. The addressing of the memory is where the error is stored, right? So that's why they wouldn't, dude. Like seriously.
No, the address of the memory just tells you how many bytes you can address. So if you have a memory of 32 bits that gives you an amount of addresses you can address bytes, it tells you nothing about floating points, because when you're loading things from memory, you're not tied to only 32 bits of memory coming to the CPU. You can get you can get much more than that. It's just gonna come one by one, but you can read more from the memory than just 32 bits. So you can use more than one word of the CPU to store a number. So that what you're saying is that just doesn't follow.
Look, maybe I'm not explaining it right, which I'm probably not.
Oh, I think we were very far from what we were speaking before, which was celestial navigation.
I'm trying to dig up my memory, like. No, never mind. Let's go back to the other thing, because I want to talk about like assembly language shit, and I don't really want to get into that. Anyway, sure. I don't know how much you know about assembly language. So I'm like old school. So like, we're talking about like memories from like 30 years ago. My brain synapses, I don't think are ready for that right now.
All right.
I haven't had to deal with that level of hardware level bullshit in a long time, so it's not fresh in my memory. But there was a reason that we didn't use memory space on the larger than the floating point error. I know that like there's ways around that. We knew that back then, but there's a reason for it, and I just can't remember the reason off the top of my head.
Okay. So going back to previous subject.
The whole point, like, yeah. So let's get back to the subject, because this is all fucking nebulous bullshit. The point is that there's a lot of imprecision in what you're saying. Only works on a sphere. I don't think real world observation says that it's a sphere, because you don't really know what you're doing. Right? You don't really know what you're doing. There's a lot of variables which confounds what is actually happening. And that you can make up a mathematical model that quote unquote works, but we can make lots of mathematicals that quote unquote work and come to any conclusion we want.
Yeah, but I agree that if you have a flat surface that produces the exact same observation of the sky as our model do, then yes, it will work on a flat surface.
Let me give you this idea.
Well, okay. My point.
Well, I'm going to ask you a question. This is related. Now, if I was underwater and I could see the sky, which you can see the sky from underwater. Did you know that? That you can actually see the horizon from underwater. There's something called Snell's window. You can see everything on the surface if you're underwater.
The horizon?
Underwater. Yeah, you can see the horizon from underwater. Yeah, it's amazing.
Well, because usually if you try to look up from the water,
there'll be
it gets pretty reflective. It gets pretty reflective and narrow angles, because the refraction just reflects the light back to water. So
yeah, right.
How exactly can you see the horizon?
Okay, so the point is that if I was under the water and I did celestial navigation, what would the surface of the Earth be?
Well, you would need different correction for the star's position, but then it would be the same.
You think you'd still get a sphere?
Sure.
I think that's hilarious.
Again, if you adjust the correction for refraction, you would get the same thing.
Okay. That's hilarious. I mean, there's no reason to think that.
Okay, so let me give an example. We're below water.
This is what your correction has to be, right? You have a ball on top of a ball, and then the correction's going to be Snell's law. two flat interfaces touching each other.
You don't have to use Snell's law.
This correction, and you think that you're going to come out with the idea that the Earth's a sphere. Like, you're nuts.
No, the thing is, if you have positions below the water, and they're unique, so you don't have ambiguity of positions. Like, so if I give you a latitude and longitude, there's no chance you're going to get to the wrong spot and still read that as a position. So it really makes positions unique. So it identifies all positions. And if you go below the water and you have a correction that will give the same angles as you get above the water, then that would change nothing about the shape of the Earth. You're
not going to have the same
translate exactly. Well, if you're correcting, what I'm saying is, if you can correct for the angles to give the same value you would give outside of the water, that correction is all you have to do. And if you can do that correction precise enough, you can then get exact same results on the surface, right?
No, okay, because I'm going to tell you why not. Because you have like these interfaces, right? So one interface is flat, the interface, but from the flat part to the other part is two curved interfaces, right?
What do you mean?
So you got the surface of the Earth, which is curved, right? But the boundary between the water and underwater is flat.
It's pretty
close to flat. You have the sky, which is curved, right? So you have this change. You can reverse these. I'm talking about the boundaries. Each of these boundaries is where you're making the correction in the angle of the light, right? Because that's what we're measuring, right? We're measuring the angle of the light relative to somebody on the surface of the Earth.
Wait, no, the refraction of
the angle of the light to someone in the Earth and your orientation relative to it. And the light's coming in from
one second.
The way these angles are going to change. And you're going to make all these assumptions about how these lights are changing in your position.
No, it's not assumptions. You can get, because you can go inside the water and see how the angles are changing. It's not an assumption. It's something you can test before you say you have your calculation done. Like, before you have your formula for correcting the angle inside of the water, you have to test it. And when you test it and that's giving you consistent results, then you say, now I have a formula that can correct for stars positions from inside the water. And when you have that formula, that's going to translate to above the water. So that's not going to give you a different position. It would still work the same.
All you have, so what you've made now is you have a mathematical model, right? That says what? That's all you have. You have a mathematical model that makes predictions. Now,
yeah, what you're asking,
model assumes 5-dimensional space, and it makes.
So you're agreeing that I can't have that working, right?
No, I'm not, because you could actually have it reversed. You could have two flat planes, and then like you could be looking out of two adjacent curved surfaces, right, on two flat planes, and it would look the same. That's the thing is, you can't tell the geometry from the light.
Well, we're not. The thing is,
my claim is that the Earth's a ball. That's the point, right? You're trying to infer the geometry from the light. That's what you're trying to do.
My point is just that. The point is just that.
Admit that. You're trying to infer geometry from the lights in the sky, right? Of what you're standing on. Is that not what you're trying to do? You're trying to infer the geometry of the Earth, its shape, from the lights in the sky and how they are observed.
I'm not. I'm explaining to you why that's inferred and why that's used on celestial navigation, and you were objecting to that.
I don't care why it's inferred. Like, listen, all I know is it's an inference in that it doesn't actually prove anything, and whether
but that's not my point.
Mathematically, it's not a sphere, mathematically, and I already demonstrated that because you can just reverse the coordinate system.
What do you mean?
You can have the latitude and longitude on the ground change and everything in the sky being fixed.
Yeah, but it would still require a spherical surface.
You just keep saying that, but that's not true.
What you're saying is moving one and fixing the other isn't about changing the shape. It's about changing the motion. It's about the relative motion. So if the Earth is spinning, the sky is fixed, or the sky is spinning, the Earth is fixed. Of course, that will not change celestial navigation. The math will be the exact same. But that scenario is not proposing any difference in the shape. That scenario is posing a difference in the movement, which is not a claim made by celestial navigation. And when you claimed that it is not globe math, That's what I'm trying to demonstrate. I'm not trying to demonstrate this proves the globe. What I'm trying to demonstrate is that the way you get your position, the way you do trilateration, is globe-based. It assumes a globe to do so. It might be not a globe, but you're right. If light behaves in a very weird way and produces the same observation on a flat surface, it would still work on a flat surface. But that's not what the calculation that is being used is assuming. It's assuming it's here. That's my point.
I just think it's funny, man. You say these things like that they use trilateration and they get these points and that there's some linear relationship between all this stuff. That shit's not true. And you just keep saying it as if it is.
I actually didn't keep saying it. I agreed with you that that's not exactly linear. It's just close to linear, and that's corrected for. So we have the correction.
It's not corrected for. That's a mischaracterization. It's not corrected for. It's ignored.
No, it's not ignored.
It's a partial observation.
It's not
data
ignored
which is inconvenient. No, data which is inconvenient for a non-globe surface is discarded as inaccurate.
No, we can't.
The elevation angles, right? The elevation angles. That data is considered inaccurate. But listen, if there was a difference, okay, flat Earth versus globe Earth, where would the difference in elevation angles of stars be observed? Where, depending on where you look, where would the greatest difference be?
That depends on what map you have of the flat Earth.
Dude, no, seriously, you know this. Where would the greatest difference be?
If you're assuming a map, for example, it will be in the certain
it's a flat surface. I'm looking at the sky. The sky is flat. I'm looking at stars, and I want to determine, like, am I a flat surface or the globe? Where, like, if I compare what it looks like on a globe versus what it looks like on a flat surface, where in the sky do I look to find the greatest difference? The horizon.
That depends.
The horizon, and you know it. The horizon
no, actually,
is where the greatest linear difference would be, right? So Polaris in the sky, the angles stop matching greatly, right, at the horizon from what the globe predicts, because the globe predicts a constant linear relationship all the way to the horizon. And a flat Earth predicts a non-linear relationship all the way to the horizon to change an angle. Where do we actually observe the greatest difference?
So let's talk about that.
From the globe is at the horizon, and you know it.
Let's talk about that. You just claim what's the prediction for a flat surface, and you said it's non-linear. Sure, but the function that it gives you is much more different than what we measure than the difference to a linear one. The one we measure compared to a linear one is way closer than the one that we measure compared to the trigonometrical one on a flat surface. So if you had a flat surface and you try to get a function to describe the angle to the distance, that would be a tangent function, or the inverse of a tangent function, and that's way more discrepant to the measure.
That's dishonest. What you just said is completely dishonest.
That's just what you said.
No. Listen, you just said what we observe, right, would be more. What we observe is closer to what the globe is than what the flat Earth is, and that's just crazy.
No. I'm saying that the function.
The function, the mathematical function.
The globe would predict a linear function if we have no atmosphere. If we have atmosphere, it would not be linear. It would be closer to what we observe. And you're saying that doesn't match. And on a flat surface, you said it would also be nonlinear. Sure, it would also be nonlinear, but the function given by a flat surface would be much more different than a line than the one you get from the Earth with refraction. You get a tangent function. That's just way more different than a line than whatever function we use. That's my point.
Well, listen. Why don't we just say the Earth is flat, and then we'll make up like bending in a certain way that makes it just look that way.
Yeah, good luck.
Well, good luck. I mean, that's pretty much what you did. Not
of course
you,
not.
Not you personally, but you know what I'm saying. That's what the globe has done.
Actually, no.
Ignore it from here to there because that doesn't match the model, right? Ignore this part. And that whatever refraction we need to work is what's happening.
I don't think that's the case.
Hundreds of times a week.
No. It's consistent because the refraction you get on the globe is the same to every direction. So if you look north, if you look west, if you look east, you get the same refraction.
That's not
you get
true.
stars
Listen, stop that. That shit is not being measured, and you know it.
No, I'm talking about the correction. The correction you get is the same for every direction, right? That's no.
They don't do the observation. You stop saying the correction. They don't do the observation. Look, you're very slick.
I'm talking
I'll
about
give you credit.
for
a non-English speaker, you're pretty slick. But they're not doing a correction. You mischaracterize it. They're ignoring it. That's a difference. A correction is when you make the observation, then you add some mathematics to it and to try and fix it. They're not doing that. They're not saying, yes, we have this model that works. Let's fix it. They're not doing that. They're saying, ignore this part because we can't fix it. Because we can't fix it.
Okay, so
right?
Wait. Let me
tell me what I said was wrong.
Yeah, it doesn't seem to be characterizing what I'm trying to say correctly. So let me try to rephrase myself then, not using the word correcting.
Because it isn't a correction. A correction is a fix. They're not fixing anything. They're ignoring it.
Okay, the thing is, if on the globe you have the atmosphere becoming less dense as you go higher. So because with Snell's law you get the light bending towards the denser medium.
That's incorrect.
What's incorrect? What's incorrect?
Snell's law is a special case of Fermat's principle. It's not Snell's law. You guys always say this.
Wait. Doesn't Snell's law tells you that light is going to bend towards the denser medium? Isn't that what it says?
Okay, so no, what it says is that light that crosses from a medium of a lesser refractive index to a greater refractive index will bend towards the normal. That's what it says.
Yes, which is going to increase the angle towards the.
But it's optical density, not matter density. So it is the polar.
Yeah, I agree.
Yeah,
I just
so it has nothing to do with like. So when you guys say density, right?
Yeah, the refractive density. Yeah.
And the idea that density is a gradient, right? A vertical gradient is also a model, right? So the U.S. standard atmosphere is a model that's actually been shown to be wrong by balloon tests, right? So the model, the greatest factor in determining whether light is refracted in the refraction model is the temperature gradient, right? So this temperature gradient is also part of this U.S. standard atmosphere model, right? Which is based completely on assumptions and has been shown to be empirically false, right? So the temperature actually rises with altitude up to 1 kilometer, and then it follows the lapse rate that they say it is. It's been verified by balloon launches. So we have this like infinite stacking of models. And then we have Globers that come in here and says, well, our model predicts refraction is happening. No, it doesn't. You just believe that. Okay? There's no empirical evidence for it. It's just shit y'all say.
Okay, let me try to address
if I
something you
ask
said
you right now to give me data, right? So you just said light is bending. There's model refraction. Light bends toward the denser air. If I asked you for the empirical data to show that is happening, what would you give me?
But that's not my thing. I'm not claiming.
What would you give me? You said light bends towards the denser medium.
I wouldn't give you anything because that's not my claim. I'm not going to find evidence for things I haven't claimed. Let me try to back up what I claim, not what you're trying to strawman me.
I'm not. You said light bends towards the denser medium according to Snell's law. You're correlating that to the air.
No, I'm correlating that. When I said a denser, I mean with the bigger refractive index. That's just a more colloquial way to say that. But what I'm referring to is that it bends towards the medium with the bigger index of refraction. Correct?
Bends towards the normal, but you can call it towards the other medium if you want. It bends towards the normal.
Yeah, that's all I was trying to get a yes for.
Yeah,
I'm not making any claims about the array, right?
In general, that's true.
Sure.
It depends. Yeah, listen, it depends on what. Like, I'm not going to get into like in general cases, if the relative refractive index are great enough, it will deflect. I won't call it bending because that's idiotic. There will be a deflection in its direction of travel. That is the most accurate.
Okay, sure. But you can still just try to apply Snell's law to a gradient if you split the gradient into lots of layers
don't work.
of different
That
medium.
don't work. Yeah, that don't work.
It does. Well, why,
no,
why
it doesn't.
that work?
And I actually have a published paper that shows that it doesn't work.
Oh, can you link me that?
Yeah. So, like, you guys, like, why would you think it would work? I'm going to ask you this. Just why would you think it would work? I know what you're saying. We're going to put the air into infinite freaking layers, and then we're going to, you know.
Okay, so does it work? Does it work if it had?
It doesn't preserve it. It doesn't preserve the angles. So, like, I'll just find it real quick.
Okay.
The point is, why would you think it works?
Why are you asking questions if you're not allowing me to answer? So I'm trying to answer that question.
Because listen, because you're a global propagandist, I can already tell. Because you're trying to set this shit up. But if I ask you if you have any experimental data for the shit you're saying, you don't. So why are you saying it?
But I'm not claiming anything about that would require me to have experimental data.
You just brought up splitting the layer in a bunch of infinite atmospheres. That's a model. If I ask you, do you have any experimental validation for that shit you're saying?
I'm not claiming the model to be true. But I'm not claiming that model.
Then why are we talking about it?
Because you are making the claim that well, maybe not with these words, but you were pointing out inconsistencies from our side. And showing consistency in our side, it's not the same thing as proving it to be the case. And which is not what I'm trying to do. I'm not trying to prove it to be the case. I'm trying to show that the inconsistency you're pointing out isn't there.
Okay, that's awesome. That's awesome. But you've made claims that this works on a globe, right? Right? Is that what you said? They assume sphere, they assume globe, and it works.
The trilateration assumes a globe, and it can give you a spot within about 20 miles.
Yeah, I highly doubt that. I think that's not anything that's ever been measured. I think that's just shit people say. There's a lot of these instances of just things people say that aren't true.
Sure.
That have never been tested. They've never been measured empirically. They're just stuff people say.
You can just get what you can,
between XYZ. Has anybody ever gone out into the world and tested that?
Sure. People when they're when people are navigating and they're trying to find
anecdotal. But that would be anecdotal.
But if you want to pull their card, then what wouldn't be, right?
That's like someone that actually went out for that purpose. That's what wouldn't be anecdotal.
No, it's not
right?
what they. No. People when people are navigating, you can just get from people that did that and ask them how it worked, or you can just actually find.
So how do we determine if it worked or not? Like, did they die or not die?
That's what I'm trying to get to. So when they're approaching the land, if they're within, let's say, 20 miles or 25 miles, they can see the land they're going for if they're within the margin of error, because that's if they're at that distance to their destination, they'll be able to see it. So at that point, it doesn't matter anymore their coordinate latitude and longitude. They're just going to head towards what they see as the destination. But before they get there, when they're correcting for the course, they do that based on the celestial sphere. They do that based on the angles of stars, and they keep doing that to keep on the course. And if they are on the course and they are within 20 miles, they'll be able to see the destination when they're close enough. If they're away from the destination, if they're a different geographical position that they think they are, when they get to land, they're not going to see what they expect to see.
Okay. So, I mean, maybe I'm not making myself clear. So this is how I look at the problem. You have two ideas. You have the idea the Earth is flat. You have the idea that the Earth is a ball. If I make them do celestial navigation based upon the idea that Earth is a ball, I can reach my destination if I do all these little things, make multiple things, like multiple corrections, blah, 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 whatever, right? And I'll get there close enough so that when I get about 80 miles away, I see birds, so I know that I'm close enough. Maybe I'm off by a little bit, but who cares? Doesn't matter. On a flat Earth, what? What happens then? Is it your contention that, like, you sail off, like, fucking you end up dying, sailing up the edge or something? Like, what is your idea that, like, the flat Earth can't use the exact same techniques, arrive at the same places, using the same principles, right? And that somehow that, like, it doesn't work on both. Like, I don't understand.
Yeah,
like,
but I'm not sure. I'm not sure what your question is, because I don't know what you mean when you're saying.
How does one exclude the other? That's my question.
Depends. If you're using when you're saying the same principles, you're referring to every calculation they're doing. Then sure, that would work either way. But that calculation is globe based. Even though you can find a flat Earth model that can make those calculations work, they're still globe based because they're not basing that on the flat surface. And what I really doubt we can have.
Not really globe based though.
You're actually wrong.
Because think about this. Is it really globe based?
Yes.
Think about it. Because
when
what do you have?
position fixing,
Concentric, right? You have 2 concentric spheres, and 2 concentric spheres are the same thing as 2 parallel lines.
Yeah, but you're still using distances on that sphere to get your position.
You're not actually measuring these distances.
You're not. I agree.
And I proved that by asking you about the radius, how you can change the radius. And shit just change. Like, if you use any assumption of distance.
No. If you change the radius, you'd still keep the proportions between distances, which is what gives you your position. So, of course, you can claim that we are not measuring these distances. I'm not saying we are measuring the distance. I'm not saying we know this distance to be the correct ones.
How do you just go from arguing we know it's spheres because of the distance, and then you just back that up to something else?
I didn't say we know it's a sphere. I said it's globe-based. That's what I'm saying. And it's globe-based because if you...
That's a distinction without a difference, man. It's globe-based, but it's not a sphere.
I'm not saying it's not a sphere.
Are you really saying that shit?
Of course not.
So what's a globe? Is a globe a sphere, or is it not a sphere?
Yeah, the globe is a sphere. I'm not saying the Earth is a globe. I'm saying when people navigate, they assume that.
You just committed a category error and demonstrated for everyone what you're actually doing. You're interchanging a model for reality.
No.
Yes, you are.
I'm saying that. No, I'm not making claims about reality. I'm not making claims about reality.
We're not making claims. It seems like you lack conviction.
Claims the whole time. He's literally not claiming. He's trying to convince me that everybody assumes that the Earth is a globe when they use celestial navigation, when the mathematics don't say that.
It does. That's my point. That's exactly my point.
I've been listening to all the morning.
Okay, show us where exactly it says that. Show us where, Bacon.
It's when you're doing position fixing. Miles, position. What?
Tony, chill for a second. All right, check it out. I've been listening all morning.
No, you can go ahead. Yeah, because I'm actually sick of talking. I got shit to do, man.
Basically, what they're doing is they're interchanging models with reality, and they're trying to basically make you doubt that reality can actually be acquired by pushing the concepts into philosophy. So basically, what they're doing is dithering. Bacon, don't overtalk me. They're dithering that they have a model of reality and we have a model of reality, and there's no real way to know. That's why he lacks the confidence to make a claim that the Earth is definitely a globe because of this reasoning. Now, he'll say the globe all the time, but when he says that, he's referring to the globe model. So I'm going to go eat my lunch since I just devoured his soul.
Well, that wasn't my claim at all. My whole claim is they're using globe-based math. That's all my claim.
No, they aren't.
Oh, goodness, dude. Good. I got to go eat my lunch. Don't make me vomit before I go.
Okay, go ahead.
Okay, whoever is saying that they're not using, can you tell me how position fixing is done?
Using a modelic projection, just as I already explained.
Using what?
And you don't have the confidence to make a claim. You keep backing into this "I'm not making a claim" nonsense. So good on you.
I am making a claim. I'm not claim. I am making a claim. I'm just not making the claim you want me to make. I'm just not making the claim you want me to make because you're strawmanning.
No, you are making that claim. No, you are making that claim. You go back and listen to yourself when Indio was telling you. You literally said, "I'm saying they use globe math, but I'm not saying the Earth is a globe." So, Bazinga, you screwed yourself.
Why?
There you go.
Why is that
a problem?
Holy
crap, dude. Oh. Hey, somebody else explain to him how that's a problem of philosophy.
Can't people argue different subjects at a time? A single subject at a time? Why do I have to argue for two things at once?
Dude.
That's what you're doing, Bacon.
Yep. You're using a category error.
The whole subject I try to argue for is that they use globe math. The math is globe-based. And if you want to make claims about what the Earth looks like, that's a different subject.
Show us how, Bacon.
Yeah, when you're doing position fixing, you get...
I want to see a citation in the live stream voice text of what you're saying.
Sure, just any book or any reference on
I don't care what it is. You're making a claim. I want you to put the citation of what you're saying in the live stream from an official navigational reference.
Sure. How do I know if it's official? Just so I don't give you one that you're going to hand wave?
You're making a statement. You're asking me about your claim?
Yeah, because that's your requirement. You want it to be official.
Go figure out what official navigation reference is. You don't know what the hell you're talking about. Have you ever navigated on a ship before?
Of course not.
I have.
Great.
Yeah.
And how do you do? Oh, so you do know how to do a position fixing, right?
You don't know. All I know is you don't know what the hell you're talking about.
Well, don't I? So do you do know how to do position fixing, right? So you do know how to do a position fixing, right?
Yeah.
Okay, so explain me how it's done.
I don't need to explain anything to you.
Yeah, I don't think you know. That's my claim. You don't know.
You don't know.
Prove me wrong.
No, you don't know.
No, I can explain.
Okay, go ahead.
Okay, so now I'm going to teach you a guy who is claiming actually sailed.
Not teaching us anything. What kind of charts do they use in navigation?
Well, there are multiple charts. There are charts to...
Bullshit.
What do you mean?
Navigational charts? There's multiple types? Is that what you just said?
Yeah, there are charts for side reduction, right?
You're out of your mind. I'm talking you're on a ship and navigating. What kind of chart is used?
I don't know.
Yeah, you don't know. I suggest
we can do a position fixing.
I guess you better just sit back because you're out of your mind. You don't know what you're talking about.
Well, I can do a position fixing. If you give me the angles of... Okay, so...
Fixing, yeah, I'll tell you how it's done. Your position fixing you're talking about is done on a flat coordinate chart. The squares on the chart are not...
Sure, but they're local.
The squares on the chart are perfectly square.
Sure, and they're local, right?
That's a flat Earth.
Yeah, and no, that's not a flat Earth because that's local.
Yeah, because when
let me give you an example.
When you find your position on the map and you have something you can triangulate your position with, let's say, shore sightings, lighthouses, radio beacons, you can find out if it's correct or not.
Okay, but
and what happens when you do your navigation with a flat horizontal datum so you can measure elevation angles? That's the only way it can be done. How do you get an elevation angle from a curved surface?
We're not trying to. We're getting from the horizon to the celestial body, and then we correct for deepness. Right?
Yeah. You're just putting your foot in your mouth.
No, that's just how it's done. You correct for dipping, and that's it. There you have an elevation angle.
You said you didn't do it before. Now you're telling us how it's done?
Sure.
Go back to gamma.
So one second. Let me. You're claiming as you really know how to do. So I don't know how to do position fixing, right? As you're claiming, I'm not doing the way it's done on a chip. I've done it myself, not the way it's done on a ship. But apparently you do know, right?
You have a problem because you're doing it how it's not done on a ship.
That's partially.
You're hilarious. You're funny.
Yeah, the only difference is I'm not starting with a guess position. I'm using an algorithm to do so. So I don't need a.
Okay, good. Is that how navigation is done on ships?
No, because they start with a guess position.
Oh, okay. So you don't know.
Okay, so the flats.
You're not even in the same kind of navigation. You're on a theoretical navigation.
What did I say wrong?
You're on a theoretical navigation on your table with a piece of paper that is flat, by the way. I had to mute you because you just can't stop talking over people. Anyway, you don't know what you're talking about. You have no idea. I would never get on a ship with you thinking you could navigate.
Okay, so can you show you actually know how to do that? If I give you the angle to 3 stars, can you give me your position? That's all I want. I want you to prove you actually know how to do that. Sure, I don't know how to do that, how the way it's done on a ship. I do that my own way, which is partially uses the same thing. And the only thing that I'm not doing is I'm not starting with a guess position. So instead of doing side reduction on a chart, I just try to use a error minimizing algorithm. That's the only difference. And I tested it works. So I tested with real data. I tested with Stellarium. I tested with data from books, and it works. I even data from observatory. So what do you have?
What I have is that you don't have any kind of navigation that's done in reality on Earth.
Okay, but can you demonstrate you know how to do that?
Look, I don't have to qualify to you, buddy. You obviously have no idea.
If you don't want to, then say you don't want to.
You never navigated before. You don't know anything about elevation angles. You're in uncharted area here. You're over your head.
The first claim was true. I never navigated before. But you can't just claim that I know anything about it, about any elevation angle. There's nothing special about elevation angles. It's just the angle above the horizontal. It's just 90 degrees minus the zenith angle.
How do you have a horizontal on a curved surface?
You get from zenith. You can get it from zenith.
No, you don't get it from zenith.
You can get it from zenith. That's how bubble section work. Have you never heard of a bubble section?
So look to the sky and not to the earth, huh?
That's one way you can get a horizontal. That's what
you don't set. So you don't know what you're talking about, man. Well, how do you set zero? Listen, how do you set zero on your sextant?
Which one? The nautical sextant?
Oh my God! You don't even know what a sextant is.
I just mentioned two. So which one you're asking for? Like I just mentioned the bubble sextant, which is you can use without even appealing to the horizontal.
We're talking about navigating on a ship on the ocean, okay?
Right. Sure.
Yeah, we're talking about a manual sextant. How do you set zero?
What do you mean?
How do you set it for zero?
What is setting for zero?
Oh my God.
Yeah, that's a way to operate a sextant. I don't have a sextant. I don't know how to operate it. But you're not asking. I didn't make any claims about me knowing how to operate a sextant. I make a claim about what a horizontal angle is. The horizontal angle is elevation angle.
A horizontal angle on a curved surface?
No, I meant vertical elevation angle.
Elevation angle starts from where?
From the horizontal.
How do you have horizontal on a curved surface?
You can correct for dipping. You can get it from zenith.
No, you can't get it from zenith.
That's how auto levels work. That's how theodolites work. What do you mean? The zenith is by definition orthogonal to horizontal, right?
Okay, show me the navigational reference that says that you use zenith first.
No, I'm not saying that's not in navigation. You're asking how to get a horizontal. You can get a horizontal from zenith.
Navigation. I'm talking about navigation.
Right, then you correct for dipping.
Why do you keep switching?
Then you correct for dipping.
Anyone else?
Yeah, if you want to get from the horizontal instead of the horizon, you have to correct for dipping. That's what the dipping is giving you. It's giving you the difference you would get if you could measure directly from horizontal.
Are you adjusting for refraction?
You do that to the angle of the star, yeah.
Really? Too bad that's never done.
Well,
but that's not even.
I'm glad you're doing things I'm glad you're doing things there, Bacon, that no navigator ever does. But
why is that not harmonizing? I mean, you can do it.
What you're saying is not true, because if you establish a horizontal from your zenith, then your horizon mathematically is zero. You have to make no dip correction in that case. What you are doing, because you've already established the horizontal, is doing height of eye correction, which is your height of eye above the horizontal.
You're mixing two responses. You're mixing two responses I give you.
I'm not mixing two responses.
Let me clarify.
No, Bacon, let finish.
I can go ahead and just post and cite where I'm getting my information from. I'm not getting anything mixed up. You said the horizontal from your zenith. That means you're talking about the tangent plane. At that point, you're not making any dip corrections. You already have a tangent plane.
That's why I'm saying you're mixing my responses, because I agree with that. If you're using a horizontal plane established from zenith, there's no dipping correction. And when I said that, he said there's no zenith. We're using we're talking about in the context of celestial navigation, and that's right. In celestial navigation, we're not using global
in the context of celestial navigation. Once you're operating on that plane, you then get a 90 degree to the GP of the star that's along that plane. No sphere involved.
What do you mean? A 90 degree to that GP? The angle we're measuring is between the horizontal and the celestial body. That's the angle, right? Where is the 90 you're referring to?
Hilarious.
Any answer?
Yeah.
The answer.
Hold on when I stop laughing.
Yeah, take your time.
People love their balls so much, they're willing to go in and try to change the way navigation is done. It's astonishing.
One thing I've noticed over the last few weeks of debating ballers in about 3 or 4 different servers is their unwavering commitment to theory without actually having any practical experience. Now, I'm not saying that I've got practical experience in celestial navigation, but that's why, frankly, I don't give my opinion on it. And I think if I were to give my opinion on it, you'd know damn well that I'd actually had some physical experience with it. I do find it interesting how a lot of these guys, they'll quote kind of theory and idea without any practical experience as if it's gospel. And the problem then is that anytime you point out that it doesn't necessarily work out that way in real life, they just don't accept it because they don't have the experience necessary to accept it, right? I just find that very interesting. And I think another way that I like to compare this to is like when you're programming, when you're like writing a program or you're writing a piece of music or you're doing anything practical that kind of exists both digitally and conceptually. The first time you try something, it never works out how you imagined. And then you have to try it again and again and again and again until you hit gold. You get to that point that you're actually looking for. And that's the bit where your brain starts to realize, oh, well, theoretically, I got that program spot on. I think I typed everything correctly. I think I got all my syntax correct. But then when you actually look at it, you've made 55 errors. Right? And so this is the thing. I don't think that they've actually ever had that experience with what they're talking about. So they don't understand that the practical reality isn't the same as the theory they think they know.
Well, I would say I had something very similar as you just described, because that's how my trilateration app went. I didn't get it right at first. I made a number of mistakes, and I adjusted, and it's working now. Like you can just input angles, elevation angle of any 3 stars that are in the almanac, and it's going to output your GP. And you can use any data of anyone who sailed and input there, see if it works.
Okay, good. So good. Bacon. Sorry.
Okay. Thank you. Have you done this yourself? Have you actually gone out and navigated yourself?
No.
So then I don't know why you said any of that, because it doesn't speak to what I said.
Exactly, but you have a good point, Crypto. Though that's true. That's what they do, and usually they'll double down on the fallaciousness.
Yeah, anything that is particular to the practical of doing this, sure, you could ask for an authority to do so, right? But when you're evaluating the math that is being done, that's not dependent on your experience of it. So if you're using the Haversine formula,
it's being done on a plane.
If you're using a Haversine formula to get distance between 2 points, that's not a flat surface, that's a sphere, regardless of your experience.
Too bad physically. It's too bad that physically the surface doesn't apply. It doesn't conform to a ball because it's never been measured. So you have a certain method you're using, right? So you've never done this on board ship. You've never spoken to a ship's captain or a navigator. I'm assuming so. Let's take it from there. So Bacon, how would you validate or verify that your calculations are correct on Earth itself to see if you're in the right location? How did you validate that?
I compared to data of people who actually navigated and recorded their sightings.
No, I want you to put your data on the Earth itself and see if you're in the right location.
Oh, sure. Yeah.
Sure.
You mean if I you mean
sure is not an answer. How did you How did you validate that is correct on Earth after your calculation?
Because it used data from Earth.
Data. No, I want you to use Earth itself with your calculations and go out there and see if you're in the location that you claim to be.
Why my answer doesn't satisfy that? If I get angles that were measured in Y.
Talking about data, not actuality.
Yeah, data that comes from measurement. What the data I'm referring to is angles of elevation.
Fine.
And time.
Take your calculations, go out on Earth, and show us how you're in the right location after you do this in reality compared to your calculations on your table.
Yeah, that's exactly what I'm explaining that I did.
Do that, and then we'll talk.
That's exactly what I'm explaining that I did.
I didn't ask for an explanation. I asked for you to do it in reality to see.
I just said I already did.
So you were out on a ship and you checked your calculations for location?
No.
Out in the ocean?
No.
Then how did you validate that is correct on Earth itself then?
Because I used from people that did.
So you're not on Earth, you're just using numbers that someone else wrote down. Okay, great. So that
were on Earth.
That's not what I'm asking.
So you're rejecting every... Okay, so since...
No, you're just going to something that I'm not asking for.
Okay, so since you are... you're a navigator, right, as you said. And you do know how to do celestial navigation, right?
That's right.
Okay, do you have any recording of any position you have taken?
I haven't navigated since I was 21 years old, so that was 40 years ago.
Right. Do you still remember how to do that?
To do what? I'm not going through exercises
position fixing.
How navigation is done. You're here claiming that you know how to do it a different method. I'm telling you, I want to see how you put that on Earth itself to see if your calculations are correct. It has to be on the surface itself, not from someone else's data.
It gives the same result as the other method.
I don't care. You need to double check yourself to see if it's correct, not using some other data. You can gerrymander data all day long. It doesn't mean it's correct on the surface.
Well, those data are from the surface.
Good. I want to see you do it yourself. I want to see you do it yourself, and then tell us where your location if you don't run into some rocks.
Sure. So if I do that for my location, then are you going to accept that works on the globe?
I want to see your calculations, and I want to see that as a template laid on Earth's surface to double check to see if your location is correct.
I think the point is, Bacon, is that this is a point I've made to Globe. You don't know that what you're saying is correct. So
I do. Just explain why.
No, you don't. To even satisfy the curiosity that you don't have but should have, you should be going out and testing this yourself.
What do you mean I don't have? I'm waiting for my sextant to get to my house so I can do that myself. What do you mean I'm not interested on that? I am very curious of doing that myself. But before I can do that myself...
Why are you talking over me? Why?
Sorry?
Why are you talking over me?
Clearly sorry, I didn't... I think when I...
And now you just carry on. What the fuck?
Yeah, he just keeps on talking.
Just not listening, doesn't care really what we're saying, just wants to reassert the same thing that's in question for the 12th time, and just walk past the point. So when I said earlier that you haven't got practical demonstration, he just goes, "Oh, but I know it's true." Okay, but without the practical demonstration, you can't know it's true, and he just walks past it and reasserts it again and again and again and again.
Yeah, Dunning-Kruger. Yeah, so bacon's cooked to a crisp. Anyway, there's a new person named Doidas, VC verified. Anyone talk with Doidas? Davidus. Davidus, are you there? No. Okay. There's a globe earther named Kessler. Hey, Kessler, how you doing? Are you there? Anything to add about celestial navigation, Kessler? King Mikey is got to listen.
No, I got nothing about.
Pardon me?
I got nothing about.
Okie doke. So I don't know if you guys want to toy with bacon some more. You know, we can unmute him if you want.
Yeah, go on, unmute him. I think my point's been made. If he keeps on reasserting that he's correct, then I can't really be bothered. Because at that point, I know that the point hasn't gone in and it's not going to go in, so I'm not going to.
Right. Should I unmute him, Crypto?
If you want, yeah. I don't.
Okay.
I don't. Because he's being respectful.
Yeah,
I mean, he's messaged me saying he didn't know he was talking over me, which I think is fair. Maybe he didn't, and he's not calling anyone names or anything, so he's not being.
True. That's true. Yeah. It's all right.
Yeah, thank you. Whenever I speak, your volume drops, and then I can't notice you're speaking. So, I think I started to speak at the same time with you, and then I just kept going. So.
I was halfway through a sentence, and that just felt a bit annoying because I hadn't even made my point yet, and then it felt like you started speaking before I made my point. But it doesn't really matter. I was just kind of saying the same thing, so in a different way.
Okay, so you said I should be curious about testing it, and first time I did, I wanted to test with real data. First test I did was with the Stellarium, and there are a number of reasons why people don't accept it, and I understand those reasons. So I went and tried to find actual data because I can't have precise angles to stars. Right now I don't have a sextant or a theodolite. And then I got data from people that have, and it turned out it was giving their correct position. And then
how do you know that though, Bacon? Did you check it yourself?
No, I'm saying that they gave me the position that they were, and the sites that they took, right?
But how did they know where they were?
Well, one of those people is the uncle of my girlfriend. He has a theodolite. He's not very well where he lives. So he used the theodolite to get angles to Betelgeuse, Rigel, and I don't remember what was the third one.
So are you claiming this is how navigation is done?
No. I'm explaining... Okay, this is it has nothing to do with how navigation is done. I'm just explaining why I am curious of testing it, and that's why I'm waiting for my sextant to be delivered so I can do it myself. But until then, I relied on what other people did, and it's not fair to say that I'm not testing it, because even though I'm using other people's data, and you can just say, well, it doesn't count if it's other people, right? If you think that, fine. I'm gonna get my data soon enough.
Okay, so listen. So this data that you're talking about, this is navigational data?
Yes, some of them, yes.
Well, that's what we need. Some of them. We don't need to be mixing. We need navigational data, not mixed with something else. So I don't know what other something else you're using. But anyway, the data that they're using on board ship, is that the data you're using?
It's the elevation angles they got from stars.
On board ship?
Yep.
Good. How did they achieve the elevation angle?
Okay, let me see if I can find the book again here. One sec. But probably
so you're using navigators' data that are all using flat horizontal datum as their starting point for elevation angle. And you're putting that on a ball?
It's not based on flat surface.
Really? You said they're navigating.
Yep.
Yeah, they're navigating using horizontal datum. Who navigates using a ball?
The horizontal can be established over a ball. There's
how?
You aim at the horizon and you correct for dipping.
So where's the curve come in?
I already said that was incorrect.
It is incorrect.
You said that's incorrect if I'm using.
But you agreed. You agreed.
No, that's not what I agreed. I agreed. Okay, let me explain. I agreed that if you're using a horizontal, there's no dipping. I said you aim at the horizon. If you aim at the horizon, that's not a horizontal line.
That is the horizontal.
Oh, that's your claim. Then why?
No, it's not my claim, bro. It's not my claim. It's the way it's done. This is the part you're missing, bro.
What do you mean?
You're missing. Listen, Bacon. You're missing the part of how this is actually. Think of that word, actually done. How it is really done in real life on the surface of Earth. That's what you're missing.
Yeah, but they don't use the angle from the horizon. They
you're
correct for
wrong.
dipping first, right?
You're dead wrong.
Don't they do dipping first?
You're wrong.
They use. So why there's a dipping correction?
It doesn't matter. You set 0 on the horizon. You calculate for your dip angle based on your height. That's it, period.
Yeah, the horizon. I agree.
Where is curvature then?
I'm not disagreeing that is measured from the horizon.
Where's the curvature come in then, please?
In the dipping.
The curvature comes in dipping because the dip angle is only your height above the water. So how is that curvature?
Because the way, I mean, if we had an infinitely big flat surface, it would rise to our level, right?
No, as soon as you say infinite, I'm stopping you. Bullshit. So we're not going to infinite. No, we're not going to infinite. No. Listen, so what you're telling me is the dip angle, which is your height above the water surface, is your curvature. So if I'm going up higher, does that mean the ball gets bigger?
No, but it got slower.
That's what you said. That's what you said.
No, but
yes. Yes.
I'm not saying the value.
You said it. We can rewind it. That's what you said. I asked you this simply, where does the curvature come in? You said from the dip angle. So now I'm asking, what if you're at a higher angle? Does the curvature change?
No.
Well, you're contradicting yourself.
Because I didn't say
the angle was based on your height above the water.
Yeah,
you told me that
it's not only based on that.
You said that's the curvature.
No, you asked it where is the curvature.
Stop saying no. You're lying now because you did say yes that it is the curvature. I asked you directly about. We were talking about dip angle. I said, "Where's the curvature?" You said it's the dip angle.
Not that the dip angle is the same value as the curvature. Like, first of all, I don't understand very well the question. I just give you the answer that I think would be closest to answer that.
Because you don't know, because that's why you have to give these little answers, because you don't know.
Yeah, I don't know what you're asking.
You don't know how this is done, and you're apparently stuck in this globe Earth thing, so you can't get that out of your mind.
Okay, let me give you the same question back to you then. So if I put a camera, right, on a basketball and measure the angle between the basketball...
We're not talking about basketballs.
I am.
And we're not talking about cameras. We're talking about a freaking sextant and the horizon.
Yes, that's why I'm trying to make it.
Bacon, in that instance, you've already set it up so that it's definitely a ball, which is the thing in question. So you can't just assert that the thing is a ball, which is the thing in question, and therefore we're going to look at a ball and therefore assume that the Earth is a ball. This is the thing in question. You can't keep
I can drop that if you want to. Okay, so let's just be completely agnostic on why there's dipping correction. So when he asks where's the curvature, my answer is I don't know. I'm not using any curvature there, right? Because we don't know what's the dipping correcting for.
Well, he just said
can we leave that as a known for a while?
Well, it would be the angle above the surface, regardless of the shape of the Earth.
It's not the angle above the surface, the angle below the horizon. The horizontal, I mean. So if you get a bubble sextant, let's say you're on a beach.
Hold on. There is no angle below the horizon. Continue.
If you're on a beach and you have two sextants, you have a bubble sextant and a nautical sextant, right? So you use the bubble sextant to measure the zenith angle of a star. Let's say that measures 45 degrees. Now you use the nautical sextant, and then you aim. It has two lines of sight instead of one. I mean, the bubble sextant gives you a sight to the bubble, which is just on the instrument, and one side to the celestial body. So you have the angles between those two. The nautical sextant gives you the angle between two sides you're taking. So you can sight at the horizon and you can sight to the celestial body. And that's not going to be exactly 45 degrees. That's going to be a little bit more than 45 degrees, right? Does that agree?
It's going to be about 90.
No, I'm talking about the celestial body in which you measure the zenith angle to be 45 degrees.
Zenith is straight up. We're not talking 45 degrees. The horizon is horizontal.
I'm talking about celestial body. I'm talking about the angle.
Body, if it's at your zenith, it's directly above you at that point.
It's not at my zenith.
The horizon is 90 degrees from you.
I didn't say the celestial body is at my zenith. Just pay attention.
You said it was the zenith.
No, I said I'm measuring from the zenith to be 45 degrees. That's what I said. I said a celestial body that you're measuring the zenith angle to be 45 degrees. That's exactly what I said.
Great. So you're using a zenith. You're not citing anything to calculate your zenith. So what are you using to calculate your zenith without a star there?
I'm not calculating it. I'm referring to a bubble sextant. I'm using a bubble sextant to measure the zenith angle of a celestial body.
Is this how navigation is done?
No.
Oh, so you're not even in the same category.
Oh, so you're going to dismiss the point?
No, you're just not talking about the same topic.
We are.
No, you're not.
But not every sentence I make has to be a description.
You're claiming that you know how navigation is done. You're using the wrong step first. You got that part?
But I'm not claiming that's used, bubble sextant used in navigation. I think you're just deflecting from the point I'm trying to make.
No, you just don't know what you're talking about, and I don't suffer idiocy very well, that's all.
Actually, the point is about horizontal planes. The point now is horizontal planes. So regardless of celestial navigation, I'm explaining how a bubble sextant...
We're talking about celestial navigation is what we're talking about.
Yes, and then we branched it.
Stop changing to different types of sextants in the same sentence is not talking about the same subject.
Yeah, but we branch to horizontals, right? We want to establish premises. We want to agree with premises. We need to have common ground to be able to talk about something.
No, listen. You are the one that needs to agree with premises, not I.
Sure. So then I'm trying to bring see if we can agree. Where we agree and where we disagree about what horizontal plane is.
We're not going to agree because you think the surface is curved, which has never been verified.
That's not what I'm talking about. I'm asking.
That is what we're talking about.
All I'm asking is if I measure the zenith angle of an object with a bubble sextant and compare that to a nautical sextant, are they going to add up to 90 degrees?
Who cares? Who cares?
Maybe if you answer, you know.
Who cares?
That's an important point.
No, it isn't. You're sitting there talking about checking the zenith on two different sextants. That's not what we're talking about.
Why do you think I'm saying that?
I don't know, because I think you're saying
I know you don't know.
You don't have any idea of what this topic is. You don't know what you're talking about.
So why are you trying to prevent the point?
Sorry, hold on a second, bro. It's okay. Like, if he wants to use this example, it's not good for him. I mean, he's being a dick, but Go ahead. I mean, we can use two different sextants. At the end of the day, if your zenith angle is going to be 45 degrees, because it has to be, because the baseline is flat for 1,000 miles, yeah, it's the same. You have to correct that. That's what the dip correction is, to make the baseline flat. It's like another death blow to the globe. I mean, how many different kind of sextants you want to use, Bacon? What's your next one? Yeah, we'll correct it. We'll correct the dip. Okay, fine. We're going to correct the dip. We're going to go from the top of the bird's nest or the owl's nest on the ship or whatever, and get down to the level of the water. That's the dip correction for the horizon. It gives you a flat level plane for thousands of miles, and you got the right distance because of the angle. Fine. Thank you. Welcome to Flat Earth.
Why is that a welcome to Flat Earth?
Because it is.
Because
that is compatible with the globe. That will happen the same with the globe. If you have your eyes.
So you're telling me for thousands of miles to have a flat plane is compatible with the globe? Is that what you're telling me?
No, I'm talking about the angle. We don't use the distance to the horizon. We don't use the distance to. When you're using a sextant, you don't get the distance to the horizon. You just get the angle from the horizon.
No one said you were finding the distance.
Okay, so what is it? Is bullshit or no one said? Because you guys seem to be going against each other.
No, we're not. Every time I want you to know that every time you say angle, I'm going to welcome you to Flat Earth. Every time you say it, just say angle again. Do it.
Why?
You use a sextant to get a what? To get an angle?
Sure.
Is that what a sextant does? Okay, welcome to Flat Earth.
Welcome to Flat Earth.
Why angles can't be measured upon a circle surface?
Really? Do you have a right angle that has a curved adjacent?
I'm not claiming that.
Okay, welcome to Flat Earth. I mean,
it's a pretty simple claim. We have a sextant. A sextant gives you two sides, and it gives you the angle between those two sides. Whatever it is you're pointing to. If you're pointing to your mom and your father using those different sides, it's going to give you the angle between those two.
Now we're talking about navigating between mom and dad. No.
You can point to. You're deflecting the point. The point is
it's okay.
You can point those two sides.
Straight lines. Yep, straight lines to mom and dad. Welcome to Flat Earth.
I'd like to finish my sentence. Yeah, you can point. Then allow me. You can point those two sides to whatever two things you want, and it's going to give you an angle, regardless of the shape of the surface. And what you're doing is one point you're choosing is at the horizon, the other point is at the celestial body. Regardless of the shape of the Earth, you're always going to be able to do that.
Okay, well, you're finding your location on the surface of Earth.
Mm-hmm.
Yeah. So I don't know what you're talking about. So you have to delete that part about it being on the surface of Earth because you think it's curved. It's not curved. Now, in your form of navigation, are you using a right triangle?
No.
Bye-bye.
Why?
Bye-bye ball.
Why?
They have to deny that 90 degree. But he just told us zenith earlier, which is 90. So yes, he is. He's lying again. Why are you lying, dude?
No, zenith is just a point. It is 90 from horizontal. Wait.
What is that point? Is it directly above a geographic location? Okay, so that's your 90 degrees. Thank you. Welcome to Flat Earth.
Welcome to 90. That's 90 to the horizon, right?
Welcome to Flat Earth.
Exactly. Welcome to Flat Earth. Thank you very much.
Why?
Welcome to Flat Earth. Right triangle. Thanks.
That's not a right triangle. You're just right angle.
A right angle based on a right triangle. Yeah. Welcome to Flat Earth.
Not based on a right triangle. There's a line and there's a plane. And the line is orthogonal to the plane, which means there's a 90-degree angle between them.
A 90 degree triangle there. Flat Earth. Welcome to Flat Earth. 90 degrees. Thanks.
That's your argument.
No, it's not my
just repeat that claim.
No, we're just using your statements. It's a right triangle. You're admitting it. Thanks. Welcome to Flat Earth.
How does that imply a flat Earth? Tell me.
You just said you didn't need 90 before, and then you told us you needed 90 because the zenith angle of the star right above the geographical location is a 90-degree angle. So you
it's about 90 degrees angle, a right triangle, and I'm not using a triangle. I'm using a 90-degree angle if I'm referring to horizontal and vertical. But I don't have to. If
you want to argue ticky-tack words like angle, triangle, it doesn't matter. You have a 90-degree in there. You have to get the angle that you're looking for, to get to the location you're trying to get to. You have to. So it doesn't matter what words you use. There's a 90-degree, and then there's an angle to the zenith, and welcome to Flat Earth. Just you can either just stop lying to yourself and the rest of us about this, or we can go to a whole other topic. It's basically Bacon. Why do you need the ball so bad? That's what the next question is. You're just denying the reality of the world that you live in. So why do you need the fairy tale so bad? Can you tell me?
That makes just zero sense to say that if there's a 90-degree angle.
Why can't you just answer the question he asked?
Because he said multiple things. I don't want to just stay with the last one.
No, he didn't. He asked you one thing.
Yeah, but before he asked that, he made a bunch of claims.
Oh my
I'm
God,
responding to the first of them.
Bro, why are you clinging on to this ball, fairy tale? That's the question. Why are you holding on to this ball so hard?
I'm just addressing wrong claims. That's all I'm doing.
So you can't answer the question.
I just did.
You're refusing to answer the question. Everybody's heard it.
You'll come in here, you and many like you will say, I just want to have an honest conversation. But then we'll have an honest conversation to a point, and then because you need the ball so bad, you'll start to lie, right, to yourself. You'll lie to us. You'll say, I don't need a 90, but I need a 90. I don't need a 90, but I need a 90. I need an angle, but we don't need an angle on a ball. We can't make an angle on a ball. We need an angle. It's just this big circular argument. And it's old for us.
90-degree. It's the 90-degree angle of a triangle.
Yeah, it's too simple. So then I have to ask, are you lying to yourself for a reason, or is this this was on Nathan's show earlier today?
Did he say I don't know? I mean, did he say no? No, just now.
He didn't need a try on 90.
He was about to. What did he say? Let him say it.
I'll let him go.
I said, I don't know. Did I say something?
What?
I don't know. Are you asking?
I'm lost now.
It's it's a right angle of a triangle.
No, it's the angle between the horizontal and the vertical is just a right angle. There's no triangle. You can make one.
Well, right here it says the angle measured with the sextant is in reality one corner of a right triangle, formed by you, the celestial body, at its geographical position on Earth. That's what this says right here.
Where? Let me take a look.
Figure 2.
All right, yeah, I think that would be in agreement to what you're saying. I'll disagree with that, but that is also in disagreement to the shape of it, right? Because you can see a curved surface right there.
Oh, duh.
Yeah, so this text that you just sent is basically contradicting itself, right?
No.
What is exactly
Which line is the line of travel?
No, it's not contradicting itself. It's stating how the method is actually used, and then your belief is contradictory to what it's stating.
Okay, let's go on then. Can you give me the full citation so I can see where it goes to?
You never provided a full citation of. He never provided a full citation of anything he said. So you're asking us for a full citation.
No, but he already has a citation.
That's very interesting, Bacon. You said you had citation too. We haven't seen one of them. None.
To what? Citation of what?
Citation for your reference material that you're apparently using. You said you had data. Where's the citation?
For what data?
Exactly. Welcome to Flat Earth. What data? Exactly.
That's your question.
Yeah, my question is what data? I haven't seen it. I don't think you have any.
Okay, sure, I'll give you that if you want to. I just want to see where that comes from.
So you just called yourself out on lying the whole
No,
time.
I am saying I'll give you that if you want to.
You did.
No, I'm just preventing you from deflecting of what I'm asking. I'm asking Elijah.
You said you had data before, and now you're saying no, you don't.
Well, I mean, the bottom line is they're using a horizontal plane, and it has nothing to do with the sphere. Now, when we went through this and I said that the first time, it was because, well, effectively, when you're already at the point where the zenith is the 90, well, the horizontal plane is your reference right there. And mathematically, there is no horizon. You've already established the plane, and you have an angle, and that angle is a part of a right triangle.
This is how navigation. This is how navigation is done, Bacon. Yeah, you talked about you're talking about horizon. Those are all part of a right triangle. When you travel a certain distance, you measure the angle to the star again. You do that several times. You have circles that you use on a flat horizontal datum, like the chart, that are flat, and the Earth's surface that is flat. You have intersecting circles of equal altitude. After doing this several times, you can triangulate exactly within a very close region where you are located physically. This cannot be done on a curved surface.
It does. It can.
Okay, show us how
that's how I do it.
Show us how someone is doing this right now.
Oh, you said it can't be done, right? Of course it can.
No, you said it can be, so where's your citation? I want to see where physically somebody is using this method you're talking about, navigating with only a curved surface. Go.
I never said you can navigate with that. It's not precise enough to navigate, but that can be done, yeah. Like circles of equal altitude can intersect on a sphere. Claiming they can't is just false.
No.
So you have to cut that sphere off like a watermelon to get those circles of equal altitude?
That's ridiculous. So you think that you're going to find your location with a floppy pancake circle of equal altitude? How is it equal? If it's on a curved surface, how is that equal?
Because the angle is equal. Because the angle would be equal.
Equal elevation. You got that
exactly.
part? Elevation. How is the elevation on a circle on a ball equal?
The elevation angle is equal.
Equal to what?
To the one you measured. Everywhere on the circle we measure the same elevation angle. That's why it's called the circle equal elevation.
You don't even get basic 5th grade geometry, bro.
That's exactly what it means.
You're trying to tell us how navigation works.
That's exactly what it means. Okay, if I don't get basic geometry, then how can I get that work? Can you get that working? If I give you, say you
no, I want you to show me how you get an elevation angle from a circle that's on a sphere.
Because all of them have the same angle to the celestial body.
How is that equal elevation on at a floppy? You take a ball and put a pancake on a ball. Tell me how you get equal elevation or equal altitude.
It's not equal elevation. It's equal elevation angle. It's not the elevation that is equal.
No, it's called a circle of equal altitude.
Yes, because the altitude, that altitude is referring to is the elevation angle.
From your location on a ball, you're in the center of a circle. How do you get equal altitude on a circle on the surface of a spherical ball?
It's every point that measures that same altitude. Or
is that radius curved on a circle of equal altitude? Is that radius curved?
The surface radius, yes, it is.
Yes, so not a straight line then.
No one's using that as a straight line.
So
no.
So the flat bottom, right, of the baseline is a curved line then. Is that what you're saying?
Circle?
No, I'm saying, right, Elijah posted this image, right, where it shows 90 degrees, but with a flat baseline underneath it, right? So in your head, the circle of equal altitude has a curved radius, right? That wouldn't be that. How would you get an angle measurement from a curved surface? That wouldn't be possible, right?
Picture. As you can see on the picture, he has an angle measured between that curved surface and the side of a star. Like if you look at the picture, you can see there's.
So this line goes through Earth. Then is that it?
No, as you can. Okay. Oh, the baseline of the triangle. Yes, that would be the chord line that goes through Earth. Yeah, we're not using
not a straight line then, not a straight baseline then, right? How would you get a 90 underneath? How would you get a 90 underneath the GP if it's a curved line?
We're not using the 90 below the GP.
So what do you subtract from when you used your sextant and sighted a star? What number?
The 90 isn't about the GP. The
90, right? Then, okay.
Yeah, which is the sum of your elevation angle and your zenith angle, right? Because if you want to get the distance to the star, you don't use the elevation angle. Use the zenith
angle. What angle is underneath the star then?
In that example?
In all examples.
What do you mean, what angle? The name
so
of the
underneath the GP, right? Underneath the GP of the star, what angle do you have there?
To the horizontal of that position would be a 90.
Oh,
which is different from your...
It doesn't. So it is a 90 then.
Yeah.
How would you get a 90 degrees from a curved surface then?
Because it's a 90 to the tangent of the surface.
Yeah, but you don't have a geometric horizon, right? All lines are bent in your model. So
sure, yeah. Okay. But I agree.
So there's no straight line then. Again,
there is,
right?
It's less accurate, yeah.
So again, no straight line which you can get a 90 degrees from, right? Or even an elevation angle.
What do you mean you can't? Of course you can. It's it was to add inaccuracy to that, right?
So getting an elevation angle from a curved surface, how would that be possible then?
Come again? What's the question?
How can you have an elevation angle, right, sighting the star from a curved surface? You need that straight baseline, right?
Yeah, the angle doesn't come from the surface.
Okay, so I'm having my sextant in my hand and I'm aligning it with the horizon. Is that a straight line?
The direction of the horizon is straight, yeah.
Okay, but it's not, right, in your model because all lines are bent. Black
Swan. The path of line. Yeah, the path of light won't
so it's not a straight line then. So how would you get an elevation angle from a curved surface?
Well, let's do one at a time. So there's two things there. One is straight, the other isn't. The path of light from the horizon to your eye.
No, in your model.
Yeah,
in your model, there are no straight lines, right? So the horizon can be 10 times further, and it's bent over the hump of water. So it's not a straight line, right?
There are straight lines. That's not one.
No.
Yeah, there are straight lines.
No. What do you mean? When we look at the black swan, you see the horizon 10 times further. In your mind, that horizon has moved up. Right, it's moved further and further, right? So it's not a straight line anymore. It's a line that was bent to your eye. So it's not a straight line.
Yeah, but we're not using the line.
Now you're not using the line.
Okay, let me clarify. If you allow me to clarify, I think you might understand my point.
Yeah, but you're double speaking. Yeah,
I'm not. Let me clarify.
And
let me clarify.
I'm going to hop off. So one last thing. So. I will vote for stop wasting time and tell us why, because I know where this is going to end, right? So your only shtick will be that nautical miles only work on a globe. That is the only thing you will have at this moment, right?
Roger.
Yeah.
He almost told you that there's a straight line from the horizon to your eye, but you stopped him.
But it's not in his mind because that is a bent line.
Okay, let me clarify all that. I think, if I'm wrong, it's even better for you to prove me wrong if you allow me to clarify my position. So the light that reaches your eye comes from the horizon and reaches your eye. That point isn't that the path of the light isn't straight, but the direction that the light enters your eye is a straight line, and that's the direction of your sight. So when you're sighting to the horizon, the direction you're pointing to is a straight line. It's not exactly the same as the path of light. The light wouldn't have done a straight trajectory. So if you try to make a straight line to what you're seeing, you're not going to actually.
Nonsense.
How's that nonsense?
Because you're talking about looking at something that's physically there, but mathematically, physically there isn't a physical position. But when we're physically looking at the position of the horizon be 10 miles in the distance, you say, well, it's because it's not coming in at a straight line. You're not looking directly at the geometric horizon. Because the geometric horizon, if you were directly looking at it, theoretically speaking, you'd be looking in front of the oil rigs where 1.2 miles are at. But that's not what you're doing. You're looking beyond at a different angle.
Sure.
So, no.
Isn't that agreeing with what I said?
No, I'm saying what you're saying is contradictory to itself.
No, what I said exactly explain that. So if there's two things. The line of the direction of what you're saying. So if you're pointing to where you see a star, for example, you're just pointing with your finger to that star. The direction you're pointing to is a straight line. Every direction is a straight line. But the light that is coming from the star is going through the atmosphere and refracting. So the star isn't at the direction you're pointing to. It will be lower if you take into account refraction. So you have two lines. One is the path of light, that's a curved one. And you have the direction you see the star, that's a straight one. And we don't require the straight one and the curved one to be the same. So they're different things. And when you're talking about the refracted horizon or all those things, of course those lines are going to be curved because light is curving. But the direction of that, the direction is a straight line. You don't have curved directions. So for example, if a car is making curves,
yeah, I get it. And for example, if you had a straight line to the geometric horizon, then you'd be looking straight at in front of the oil rigs where the horizon is not. So no, you can't be saying that there's two things, but it explains the same thing. You can't say you're agreeing because you're trying to say, well, you're looking directly at the horizon. Well, if you're looking directly at the horizon, then it's not geometrically or angularly where the geometric one would be.
Exactly. And the line I'm saying straight isn't the line to the geometrical. It's the line that points to the apparent.
Because there's no such thing. Because what you're actually doing when you're using the sextant is just establishing a level horizontal. Because it's parallel. Because it's parallel with the horizontal ground.
Yeah, but if it was parallel, you wouldn't be dipping. Then if it was parallel,
no, it is parallel. No, it is parallel.
Then why the dipping then? Then you actually be reading a lower angle than the actual angle, right?
No, because you have an acute angle, theoretically, right? So what you want to do is get your eye mathematically to the ground instead of where your height of eye is actually at. So you're not doing a dip correction, you're doing a height of eye correction. As not yet, but I was almost done. Exactly what I'm saying, which is refuting your point, so there is no yeah, but I can post a citation for that.
It's not refuting the point because if the horizon
your point is you said that you had to take a dip, and I'm saying you're incorrect. And there is no yeah, but you're incorrect. So either you're telling me that I'm incorrect, which means you're going to provide something that backs up what you're saying, or I'm going to prove that you're incorrect by providing what I have. That's the only way that we fix this.
Sure. Let me see if I understand your point then, so I don't strawman you. So you
said this dip. This is my point. You said that's when you correct for dip. No, that's incorrect verbiage. Actually, you're correcting for your height of eye above the horizontal plane. The one you're saying it's not.
Okay, so let me see if we agree on something about what you just said. So you're saying it's a correction for the height of your eye, right? That's what the dipping is, correct?
No, that's not what I'm saying. That's what I'm saying you're incorrect for saying.
So you're not saying that dipping is a correction about the height of the eye?
That's what you're saying, and I'm saying that's incorrect. But you were about to say how that's incorrect, but it's actually your position.
How is that my position?
Because you just said, so I'm saying. But it's really what you're saying.
How am I saying that?
Because that is what you're saying. You're saying that you're correcting for the dip. And I'm saying, no, that's incorrect.
Well, what? You said that what I said is that when I said that dipping is the height of the eye, you said that I said that.
I don't know.
And then when we rephrased me, you didn't say it. You said something else. Like, I'm not getting what you're...
I know. It's all right. I don't really have time. You don't know what you're talking about, clearly. And I'm eating and I gotta go. This isn't fun for me anymore. Have a good one.
Well, I just feel like if the...
Yeah. Again, right? So you will concede that you need a straight baseline for an elevation angle, right?
In the sense that the elevation angle is yeah.
Yeah, so that's why you want to go to the horizon and...
Let me be more precise on my answer. So the elevation angle is an angle from the horizontal, which is a straight line.
Yeah.
And the celestial body, right? But that's not the angle we measure. We only get that angle after we correct it for dipping, right?
Yeah. So that dip will bring...
Incorrect.
Yeah, it's a height of eye correction because you need that straight baseline. You need it straight, right? Not in an angle to the GP. So when you're standing on a boat 20 feet up, I don't know, on the bridge 30 feet up, then you need to subtract that to get your sighting to the floor, to the ocean, the sea level, right? To get that straight baseline. And at the GP of the star will be at 90 degrees, right? So you will concede that is necessary because you will say, well, yeah, that's why we aim at the tangent, right? Correct?
What do you mean? We aim at the
you only get that straight line if you side your sextant to the horizon, right?
Yeah.
Okay. So we will say there are no straight lines on the ball, and you will say, well, we're sighting the tangent point, right? That's the straight line, right?
Okay, yeah.
And then comes out the almanac, and then you will say, well, nautical miles only work on a globe, so and you will need a Mercator map. That's a globe projection, right? So it's all a waste of time, right? This whole argument.
No, I wouldn't make that argument.
No.
So I mean, if you respond to what I'm saying, I think that they'll be more productive. So, when I said that if you measure the angle from the horizon and celestial body, I said that that's not the elevation angle. You have to correct for dipping. You said incorrect, and then you said that the dipping is just a correction for the height of the eye, right?
Mm-hmm.
Right. So if you don't correct for the height of the eye, that angle is going to be different than if you have corrected, right?
Yeah, it's not a 90 anymore at the GP, right? You need a straight baseline.
No, we're not talking about the GP. Just the angle you're measuring with the sextant. So if you were able to go put your eye at the ground and measure the celestial body, you wouldn't need dipping correction, right? The dipping would be 0.
Or a bubble sextant, right?
Right. So if you go above, let's say you go some feet above the ground, and you do that again, that's not going to give you the same angle, right? It's going to give you a bigger angle, correct?
Mm-hmm.
So you have to make that correction for dipping, which makes the angle a little bit smaller, and that smaller angle is actually what the elevation angle is, right?
Yes, because you need a straight baseline for the 90 under the GP, right?
Okay.
Of the star.
So that's what I was saying when you said incorrect. I was saying that you don't get elevation angle before you make the deep correction, regardless of what that is. You only get the elevation angle after you do the deep correction, right?
Because you need a straight baseline. If it's not straight, then you. Sorry.
Incorrect. What he's saying is incorrect. It's not what we're saying.
Well, but when I said it before, he agreed that if you measure from the ground, you get an angle. If you measure above the ground, you get a bigger angle. And the deeping correction, or what we call deep correction, is the correction that corrects for that. He agreed to that. I don't understand. And when I just said, well, so you have to make the correction to get the elevation angle, I don't get how is that incorrect if that's just a restatement of what I just said that he agrees with. Like, I don't understand how you can agree with one and disagree with the other.
The contention is about the word dip.
Because it's a height of eye. It's a height of eye correction, not a dip correction.
Yeah, so I think there's
on the name.
So I think there's a bit of, because dip correction implies that the horizon is falling down, right? It's not when you're looking at the horizon, the globe Earth say, well, it's falling down, right? It's moving down to where you're standing, right? Because a ball, if you
right,
go higher up,
in that case, they would be correcting to make that into the plane that they need. That would be a parallel to the surface. They need to make it actually flat in that scenario. But what he's talking about is the height of eye, which is not dip correction. It's height of eye above a horizontal plane. The end.
Okay, so let's call that the eye correction then. I get that you're objecting to how I'm calling it, but I'm just referring to that heading that we make. So I'm not going to call that dip because, of course, calling dipping assume is something you guys disagree with. But we both agree that that's what you have to do to get the elevation angle. You have to make that
off of a horizontal plane.
Okay.
An established horizontal plane.
Okay.
But you've already taken the angle elevation measurement. Obviously, there's no way you're going to tell me that the elevation angle measurement is taken second. The first thing you do is take the measurement and record the time that you took the measurement.
Yeah, I'm gonna hop off now. Thank you, Bacon.
Later, Roger.
Oh, yeah, anytime.
Bacon, are you under the assumption that the dip has anything to do with curvature?
It can, yeah. I mean, we both agree that
We both agree nothing. I haven't spoken to you yet. So I asked you, are you under the impression that the dip correction has anything to do with curvature?
Yes.
How so?
Because if you're sighting the horizon on a spherical surface, the higher you get, the lower that the line will be. So that would increase your angle. And because you want the elevation angle, which you wouldn't change, you have to make that subtraction.
So the difference between the surface of the water and the bridge of a ship, how much is the surface or the horizon, which changes based on atmospheric conditions, how much is that changing?
It doesn't. The horizon doesn't play a role in this at all. That's the point that I'm trying to make.
Exactly.
So what was the question?
My question is how...
The horizon doesn't even play a role in this.
But you measured using the horizon, don't you?
No, not when you're measuring the angle. When you're subtracting for the height of eye, it has nothing to do with the horizon at that point.
But you're measuring from the celestial body to the horizon, that gives you an angle, and then you make a correction.
No, no, from the celestial to the horizontal plane.
Yeah, and you set you set at horizontal first. You don't cite the star first.
Sure. Actually, you can do both ways. It doesn't matter.
Yeah, you don't.
Cite first.
It's never done though. So okay, I don't know where you're getting your information.
Why would that be different?
I'm going to look at the star first and then do everything else in reverse. You have to set 0 at the horizon first.
Yeah, but what difference does that make? If I start with
that it makes is because your dip angle is only using the height of the eye to flatten it down so that you're actually related to the flat horizontal datum or surface that you're traveling on to get a correct elevation angle.
That's not what I'm asking. If I aim at A and then at B,
you never stop to listen. You start talking before anyone's finished. I see you doing this all the time.
Well, actually, I was in the middle of the question when you.
I wasn't even done talking. How could you be in the middle of a question when I was the one talking?
Because you started talking when I was in the middle of the question.
Holy shit!
I was about to ask you something.
You're really fucking aggravating, man.
Oh, I was asking you something, and then when I was in the middle, you started answering.
How could you be asking me something when I was in the middle of my sentence when you started talking?
No, I wasn't. When I started talking, I started to ask you a question, and then you started speaking over me. Then I waited, and then I started answering you. And that time, I might be speaking over you, but the first time I started answering, it wasn't speaking over you.
Oh my God.
So the question was, if I aim... I have two sides of the section. If I aim one at A and the other at B and read an angle, and if I start by aiming one at B and the other at A and read an angle, why would the angle be different, given which one I'm aiming first?
It's just not the way it's done, that's all.
Actually, boats are usually swinging, and when they're singing...
Wait a minute. Did you say boats are doing something? What did you say?
Yes, boats are swinging with the water, right? We have waves.
Boats are doing what?
Swinging. I mean, not
swinging.
That's all right. Okay, maybe I'm misphrasing it. Let me.
Listing, whatever.
Floating.
No,
they're listing. They're moving around, right, left to right.
Not just moving. I'm referring to.
Okay, gotcha.
I'm not referring to them moving. I'm referring to them like a. Maybe I'm picking the wrong word here. 1 second.
Hey, what's up, guys?
Yeah, they swing back and forth, right? Like, as waves.
Yeah, boats are rocking, yes.
Right, yeah. Thank you. So,
hey, Miggy.
Rock, baby.
Yeah, so boats are rocking. And when that's the case, you have to keep moving what's aiming at the horizon while you try to fix the arm to the star.
Wrong.
No.
Once again, wrong. That's not the sequence. Listen, that's not the sequence that's used in reality, Bacon.
I'm not talking about the sequence.
You set the horizon first. That's your 0 point. Your dip angle is only to make your position to calculate so it's a flat horizontal datum, so you have a horizontal datum of the right triangle to go by first. That's established first.
Hey,
sure. I'm not disagreeing with that necessarily right now.
With the sextant questions, we had Walking Eggshells or whatever his name was. I don't know if Indio's here or not, but he was dealing with a chap earlier, and they were on about the sextant. It was about the same kind of rhetoric that this guy Bacon is talking about. So I haven't really talked to you, Bacon, but you guys coming in here with the sextant questions, do you realize that you're using right angles to actually, when you're speaking of what you're thinking is supporting the point for the globe, it's actually not? I don't know.
I don't see how it's not. Like
saying going into this, I'm not sure if you're contemplating that or not. And how are you going to make right angles on a curved surface, sir?
The angle is between the horizontal and the vertical.
Well, you can't have horizontal curve. Once again, horizontal you can't have on a curved surface, can you?
You can. They're just not going to be the surface.
No, when you draw a line, does it have a curve? Does the line curve?
If it's a curved line, yes. If it's a straight line, no.
There's no such thing as a curved line, sir. It's only a curve or a line. Yeah, so when you draw a circle, it's a circle. It's not a curve. I mean, it's not a line. So, like, if you're looking at a horizontal,
okay, so I don't know who's teaching you this, but like when you're applying the geometry that you're actually talking about, right angles, right? So if you're using that right angle, you can't use it on a curved surface. You can't do it. So like your argument is self-defeating.
But I'm trying to.
Your premise is faulty, basically. So when you're coming,
that's not my premise.
Well, you're talking about. Well, I know, but you're talking about a sextant, like you're applying it to something that's going to back the understanding the Earth is a globe. You're the second guy that's come in here with this today, and it doesn't seem like this argument. It's already your DOA, bro. Like right out the beginning, you can't use geometry like on a curved surface. You're gonna those right angles that you're trying to make. You can't do it on a curved surface. How are you gonna make a right angle on something that's a curve? That doesn't apply. The math
it's right faulty. Angle to the vertical because it's a right angle to the vertical.
The vertical what? Like what are you making a right angle to?
Vertical axis.
Okay, so everything that you're applying right now, this math formula that you might have in your head, it's on the presupposition that the Earth is a globe, correct?
Sure.
Okay, so if it's a presupposition that the Earth is a globe, you've already started with a faulty premise. I just finished telling you that. Now, if you're going to start with something that's already founded in true knowledge, like you already understand the Earth is a globe, then you have to tell us how you got to that point and then apply the formula. Otherwise, you're not working off of something you understand. You're basically working off something you think you know by, secondhand information. You don't know if the Earth is a globe or not, and that's not what you're trying to figure out. It seems like you're working on top of the idea, the presupposition that it is a globe. Do you see where you're starting?
My whole claim is not that this proves a globe.
Why would you even start in on a conversation between the flat Earth and the globe Earth, thinking that there's any kind of weight that you're going to bring towards the conversation? I mean, what is it you're trying to talk about? Because if it's not that the Earth is a globe, or it's already a globe in your mind, you're not even arguing that. You're just talking about what flat Earth is saying, or what is your point here? Is what I'm trying to get to. Because I'm listening to you talk about something.
I can answer if you stop at some point.
Go ahead.
Right. My point is that celestial navigation assumes it's here. That's my point. Regardless of that proving the globe or not.
Don't slow down because you don't fast talk. Just explain it so everybody can understand. Go ahead.
Yeah, celestial navigation assumes the Earth to be spherical.
Okay, assumes, right? And that implies that it's an assumption. Now, we don't like working on assumptions, right? How can we make sure that what you're saying, that statement that you just made, is true? We can't verify it. The assumption is what you're basing your worldview on is completely faulty because you can't verify it. So you're trying to get in a conversation right here with the gentleman, about something you're assuming to know. Do you understand what I'm talking? Psychologically, you're already defeated. You can't come. You can't come back.
Let me answer you.
Go ahead. I don't understand how you're going to come back from what I just said.
So let me speak. You might not understand. So there's the argument. There was the argument that the way celestial navigation works proves a flat surface. It only works on a flat surface. And when I took a look at it, it doesn't seem to be the case.
It's a flat surface.
It seems to assume.
Listen to the slip of the.
I was in the middle of my answer. You have
listen to the slip of the verbiage. It utilizes a flat plane.
Let me answer him. I was in the middle of my answer. So.
Well, I mean, your premise is false again. I mean, that's basically what he told you.
Let me finish speaking, please. So there was the argument that it only works on a flat surface, right? And when I looked at the whole concept, when I looked to the oh my fucking god, let me finish a sentence. When I looked to the concept of what celestial navigation, how it works, what are the concepts behind it? It assumes the Earth to be spherical, and the way I did to test that, if it actually assumes the Earth to be spherical, I did my spherical model of the Earth and my calculations. I didn't look to the calculations. I just started doing mine, just assuming the Earth to be spherical, and then I checked that against what they actually do in navigation, and they matched. That's what I'm arguing for. That they actually do.
But here's the thing, man. It doesn't matter if it's a red lobster that you're assuming the Earth is. I don't care what you assume that it is. You need to provide the evidence, sir, of what it is before you actually start to go in on a claim. Because if
that is not my claim.
You just finished saying it's all an assumption, and you made your own model based upon what the celestial navigation is all about, and then you made your own spherical model, and then you drew up a conclusion of like, well, since they assumed it and I can assume it, and my model proves that what they're assuming is correct, then we're correct. No, incorrect.
That's not my argument.
It doesn't work.
That's not my argument. That's just a straw man.
All right, Bacon. Look, you just finished saying that you made a model, right? I have to walk you through this because you're not understanding your own statement. You made a model, correct? Yes or no? Okay. So that model to you specifically details how you figured out what their assumptions are correct because you made a model. So your model of the Earth being a sphere is correct with the celestial navigation that you're talking about. Yes or no?
It matches it, yes.
Okay. We're at the point where I'm telling you that you did all of that for nothing because I can assume, and I'm going to use something really ridiculous, that the Earth is a red lobster. Right? Now, my red lobster model of the Earth can actually predict the celestial navigation is correct just like you can. What does that actually tell us about the Earth? That it's a red lobster?
Yeah, I don't think that's the case. I don't think you can model.
Okay.
Wait.
You want us to
let me
believe
just answer you.
Just because their assumptions match your model of assumptions, that we can now assume that everything we can model as an assumption is a correct thing that we can just base our reality on.
Two things. I'm not claiming that because I can model it, then it's right. But I don't think you can model the Earth to be a lobster and have that working for selection.
Well, how do you know? Have you done it? Have you done it?
No, but the geometry just changes. So if the geometry changes, wait. Okay,
you don't know.
One second. No, I do know that the distance between points. Let me finish. I know that the distance between points on the surface of a lobster are not going to match the distance between points on the surface of a sphere because they're different geometries, right? So the distances are not going to match.
I made a ridiculous claim because yours is very ridiculous, Bacon. I made a ridiculous
claim. But the point is actually very...
That's providing you a bit of insight as to how you're providing us this statement that you just made. It sounds ridiculous because we're coming back and then telling you, okay, your model says whatever, right? Your assumption, because these guys are saying they assume the Earth is a sphere and their celestial navigations provided more evidence that it is. So then you made the conclusion that you did your own model and it came out with the same thing. So obviously the Earth is a sphere. Now I'm telling you
that's not my claim.
Okay, so you didn't say that the Earth was a sphere because you modeled it like they were assuming and it matched celestial navigation. Now you're not saying that. Is that what do you do? You're going back?
I'm not. No. I did the model to test if the concepts that I understood to be used in celestial navigation actually match the sphere, and they do match a sphere. And now you're saying that it can match. Wait. Now you're saying that it can match any other model. It could even match a shape of a lobster. And wait. Let me just finish. I don't think it will be a problem just for a lobster. I think you have the same problems trying to use a lobster than trying to use a flat Earth. Because the same way you would have the distance between points on the surface being changed relatively in relation to each other.
Okay.
And that would break the formula.
Listen, and you don't have to go into it. I understand what you mean. But what I'm telling you is because the ridiculousness of your claim. The ridiculousness of your claim is that you're working on an assumption. That is what I'm pointing out to you. You somehow are bypassing this and then going into how I just provided, it couldn't be a red lobster. And I'm not even talking about that, right? I just use that as a ridiculous claim that I made so that you can see how ridiculous it is for you to propose that because an assumption was made, that your assumption is also made, and then therefore you concluded that of course it must be because it matches the assumption that they made. That's not, you can't go based upon that. You have to actually go and verify the thing in reality. You have to go out into the world and go verify
That's not the discussion we're having. The discussion we're having is if people actually assume it. It's not whether or not this assumption proves. We're not.
Who cares, Bacon? Like,
if you don't care about this discussion, fine.
No, I care. Listen, I care about the truth. But when you're coming in here saying that we need to care about assumptions, then you are
say that.
Yeah, you're making it sound like, well, if you don't care about people making this conversation about assumptions, nobody. Listen, when you come into this server, people here want to know truth. Then they want you to demonstrate and verify the thing you're talking about. Now you're going on and on about having a conversation in here about assumptions. That is not what you need to come in here for. You need to test and verify. Okay, and the thing that you're talking about hasn't done any of that. You just made some model of what you think the Earth is. Whoop-de-doo. Great for you, whatever. I mean, you want a star, a cookie, what? You need to go into what we're telling you, right? And verify the thing that you're proposing the Earth to be. Now, once you've done that, you can come
Let's
back.
have a conversation, not into monologues.
The reason I'm monologuing is because you're filling it with nonsense. You're coming in here and showing everybody that you don't have nothing to provide. Okay, what do you have to provide? But you're
disagreeing. If you're accepting that they're assuming a sphere, you're in disagreement with the people from your side, because that's exactly what's the point of the debate here. We were discussing if they actually assume the Earth to be a sphere, and you're saying that it's an assumption. It doesn't matter. Okay, so you tell them that. You don't tell me that.
What do you mean tell who that? I'm telling you that you're the one coming in here making models and assuming that the guy who assumed that the Earth was a globe because of celestial navigation is correct because you made a model. I don't care. So what?
People from your side.
Look, no, you're interrupting me now, Bacon. The people in here, they're not assuming anything. I'm like, know that 100%. Nobody in here is assuming anything. So you're projecting that on all the people in here, the truthers in here.
I'm not saying you're assuming anything.
You just finished saying that you're disagreeing with people in here. I'm disagreeing with you because you're coming in here stating that assumptions are the way we need to.
No, I never said that. You're completely strawmanning me. That's not at all what I'm arguing for.
You just declared it, Bacon.
No, I declared that to be an assumption. I didn't declare the assumption to prove the Earth is a sphere.
Where am I wrong?
If you allow me to answer, you might know that. So I'm not. Okay, there's the claim that people assume the Earth to be flat when they're doing celestial navigation, and I'm claiming the opposite. They assume the Earth to be spherical when they're doing celestial navigation. And now you come here and say there's no assumption. Okay, so why are we debating this here? I mean, there are people here who make the claim that celestial navigation assumes the Earth to be a sphere, and I'm claiming the opposite.
No. That's where you're. See, here's where you're misunderstanding. You're talking about the Earth as a whole. The people that are talking about the Earth are working as in their area, what they see the Earth to be as per what they are experiencing. Now you're telling us that the Earth as a whole, because of celestial navigations, is a sphere. And what they're saying is that they're working on celestial navigation on a plane surface. They're not talking about what the Earth is entirely, okay? That's different of what you're saying. So now you need to make the clear distinction of what you're talking about, because we're not talking about assumptions of what the Earth is entirely. You are. Do you see the difference?
Yeah, when you're dealing... I understand that, but when you're dealing with celestial navigation and you take a side of 45 degrees, you know how far that is from the GP of the star? There's no local map. There's no local map that are going to allow you to draw circles of... Let me finish what I'm saying. There are no local maps that are going to allow you to draw circles of equal altitude with that distance as a radius.
Why are you avoiding Miggy's question?
I answered the question, and then I'm clarifying it.
Yeah, I made it. No, I clarify. I made it very clear. Okay, that with the thing that you're making it. Here's where you were misguided on. You were thinking that the people in here that are talking about the Earth being flat is saying that we're working on an entire model like you are. No, that's not what any celestial navigation is. Not taking into consideration what the entire Earth is. The way you pointed it out on your side, which is the globe, is saying that yes, you can. And what we're saying is we're not assuming the entire Earth to be anything. We're just saying what we're working on. It's what it is. It's a plane surface. Okay.
I disagree with that because no, I don't think that's the case. That if you're saying that that's just working locally, if you just get one example of distances, they're just too far. If there's no way you can work with that locally with distances of that magnitude.
What are you talking about?
Listen, Bacon here, dude. How else can you work if it's not locally, man? Do you think the people are like the people from long ago were working with celestial navigation with distances of like somebody from far away, and he got him on a phone or a radio and said, "Hey, man, I'm over here. You're over there. We got two different." There, of course, it's local, man. What are you talking about? It's not local.
What are you talking about? That's not a depiction of how celestial navigation is done. People don't call people to ask where they are.
Okay, so I'm giving that example because you're making it sound like
that's not analogous. That's simply not an analogous example.
How else is navigation done if not locally? If the person that's navigating is doing based upon what their perspective of the Earth is at their current location.
Because they use the GPS of the stars, and the GPS of the stars aren't close. No, not at their current location. GPS is not. The GPS of the stars are not at their location. It's very far from them.
Okay, you're talking about distances now. Distances to the stars and what?
No, to the star, to the GP.
Which is at a right angle to you, the observer, which couldn't be.
That's your claim.
Let me finish. If the surface of the Earth was curved from the GP of the star to you, the observer, you for damn sure wouldn't have a 90-degree angle to it. That's my claim. I read that to you, and you asked me to provide where I was getting that from. Well, it's in every manual, pretty much.
The thing you sent just shows the straight line going through the Earth, through a curved surface.
Yeah, too bad the curved surface doesn't exist.
Yeah, exactly. That's
well, it's in his citation.
No, listen.
And I asked for the link of it so I can read.
We came back full circle.
He won't provide it.
It doesn't matter. Okay, so like to you, it should matter, right? Because we're talking about that what the Earth is not, and you should be coming in here like, well, no, the Earth absolutely is a globe, and you need to provide evidence for that claim. But it seems like every time you want to go around that and be like, I'm not talking about if the Earth is a globe or not. Well, it's already set in your mind that it is.
Yeah, so I know you want me to make the claim that the Earth is spherical, so you can shift the burden. So you can let me finish. So you can shift the burden of proof and then keep asking me for evidence.
Out. No, it's never been shifted. It always rested upon the one who makes the claim. Now the claim,
yes, exactly.
The claim is Bacon that the Earth is a globe.
That's
the burden of proof. The burden. Yes, it is. The burden of proof is the one who makes the claim. So, do you think that people are born in this world and they automatically think the Earth is a globe? No. The claim is that it is a globe, and it was taught to everyone that it is. So the burden of proof is to those. And did I ever say it was your claim? No. I said the Earth is claimed to be a globe, and whoever that is being taught, the burden of proof lies on the one who's claiming it. So if I said the Earth is a globe, it is my job to inform you how it's a globe. Now, whoever informed you that it's a globe, it was their job to provide the evidence to you that it actually is a globe. Now, this is the problem.
But that's not the subject. Okay, can you stop for a second?
Hang on, Bacon, because you're
just monologuing. I want to respond. You're just monologuing.
I'm not monologuing. This information right here is the basis of your argument coming in. It should be anyway. It should be about the Earth being a globe or not. So it shouldn't be about little ideas that you think what the Earth is. You need to come in here with some hard evidence, right? The claim is that the Earth is a globe. Now, if you start there and say, I got this information, you can verify it, go and check it out for yourself. But you don't have any of that, right? Am I not correct? Because if you do, please bring some evidence.
Yeah, I'm willing to give evidence to whatever I'm claiming, right? So if you want me to claim something else, if you want me to claim something else, you can ask for evidence for something else.
No, I want you to
I'm not interested on that. Okay, you speak for almost half an... Dude, just let me answer you. You're just speaking for too long and you're not letting me to finish on any answer. So...
Yeah?
Yeah, well, we can fix that. I got a little button over here. So now maybe you can finish there, Miggy.
I just feel like, okay, he's coming in here saying that he doesn't want to talk about the Earth being a globe because it's damning to him. because he started making models and whatnot about people's assumptions and celestial navigation. Well, he made a model of the Earth being a sphere. Now, to him, it's a reality. I guess it checks out, right? Mind. So what he's saying, and when I kind of shift the burden to the one who makes the claim that the Earth is a globe, I'm like, okay, well, if somebody taught you the Earth is a globe, now it's your time to provide the evidence. And he's like, well, I don't want to do that. He's basically saying, I don't want to do that because I can't. That's what he's telling me. And I know because I've been around these conversations. So, and Bacon, is he still in here? If he's still in here, then that's exactly what I'm...
yeah, he's still here. I'll unmute him. No, he went on deafen.
That's basically... See, here's Bacon and the other chap that was in here, Eggshells or whatever, they were going on about this, providing evidence of the celestial navigation through a sextant. And, they don't ever want to get back to the idea that they have verified information the Earth is a globe. They don't want to come to... You kind of corner them and say, okay, so what you're saying is the Earth is a globe, right? With this argument that you brought in, they don't ever want to pinpoint and say that. They want to dance around the topic and say, oh, I'm not saying that. That's not what I'm saying. Oh, that's
because
what
we can try to one subject at a time. So this can be... Celestial navigation can be a premise that leads to the conclusion of the Earth being spherical, right? So we have to first to settle this out. This is an argument for the shape of the Earth. Celestial navigation is being brought up as an argument for the shape of the Earth, and the premise is celestial navigation.
Who brought it up? Who brought it up?
A lot of people bring it up to argue for the shape of the Earth. What do you mean? In this conversation?
Okay. Well,
no. When I got here, people were already talking about this, and I just started to address things that I knew.
That's incorrect.
What's incorrect? What's incorrect?
What you just said.
Which is?
Nobody uses this argument to prove the shape of the Earth.
No one uses celestial navigation to argue that the Earth is flat.
Flat and the shape.
Come on. I mean, there are hours and hours of videos from Kiwi doing that. Nathan Oakley doing that.
I have to make the distinction because you're bringing up something you don't understand. Flat is not a shape. It's a description. It's not the shape of something. It's just showing you that if the tabletop is flat, it's not telling you the shape of the table.
Yeah, but then it's not a ball, right?
Listen,
if the surface if I have a flat surface, that cannot be a sphere, can it?
Well, of course not. So what I'm saying, though,
there you go.
Yeah, but it could be a cube, right?
Sure.
So
exactly.
All right. So the point is, we're not talking about the shape of anything, and that's what Elijah was saying. We're not talking about. You're saying that flat earthers are coming back and saying it's the shape of something. It's not. We're not talking about a shape. A globe, on the other hand, is claiming shape because of celestial navigation.
Okay, so when you say it's flat because celestial navigation, I say it's a sphere because celestial navigation. I'm claiming sphere, you're not. I'm claiming shape and you're not because flat is not a shape. Is that your argument?
No, that's not the idea that we're talking about two different things, and you're actually saying that because we're arguing the fact that it's flat, and then you're saying it's a sphere, that we're talking about two ideas of shapes, and it's not. That's what I'm telling you.
Okay,
so we don't.
Yeah. Wait, how's that relevant? It's not a discussion about shape.
You're saying that we're arguing like two sides of the same thing. Like we're saying that it's a shape over here, and you're saying it's a shape over here, and we're arguing two shapes, so we're not.
Okay. So, okay, you can say that, but at the same time, you have people saying that the Earth is flat because of that. You can say, well, that's not a shape, but who cares? Yeah. I mean, that's the thing.
Everybody cares.
But I'm not saying. Okay. It's just semantics. If you consider that to be a claim of shape or not.
Listen, because you think that because you're going to be able to say that the Earth is entirely a sphere because of celestial navigations, and we're going to tell you, okay, now provide the evidence. I keep telling you that at the same time, you want to come in here and say that you don't want to talk about the shape of the Earth, but yet you want to provide evidence that it is a globe or a sphere. I don't understand. Do you want to talk about the shape of the Earth and support the claim that it is a sphere or not? Or you just want to be in here, having conversations about how your day is? I need to know what your purpose of the conversation you're trying to have it. If it's not fruitful for the discussion, then why do you want to have it in here? Because people in here want to know truth. They don't want to sit around these assumptions or ideas of what you follow me? You know what I'm saying?
Can I answer you? Yeah. So when people make the claim that celestial navigation proves the Earth to be flat, right? And I say, well, actually, if you take a look at it, they're assuming the Earth to be spherical. Isn't that a valid argument to make, if that's the case?
No, that's not a valid argument because you would just be factually incorrect. A flat plane is actually assumed because they use a baseline, which is a zero angle, which is a line, to the GP, which is where the star is, and then a vertical to the zenith.
Yeah, but that line isn't the surface of the Earth.
Which forms a right angle.
Yeah, but that line isn't the surface of the Earth. Is it?
So when you said that they assume that the Earth's a sphere, no, they do not. They assume it's a plane.
The baseline of the triangle isn't assumed to be the surface of the Earth.
Yes, it is.
It's not assumed to be the surface of the Earth.
Okay, right here. In simplified terms, when we take a sextant altitude of the sun, we're creating a right angle triangle between it, the Earth's surface at the GP, and ourselves. Grade school geometry tells us that the two angles and a right angle triangle must equal 90.
That's not disagreeing with what I said. The point is on the surface.
It is disagreeing with what you said.
Let me clarify that. It's saying that the point is on the surface of the Earth. It doesn't say that the line is the surface of the Earth. And if you look at your own citation, the line goes through the surface of the Earth. It's not the surface of the Earth.
No, dum-dum. If you were standing, taking a measurement with the sextant, then listen, if you have a tangent plane from that position alone, if there were a point that somebody could hypothetically take along that chord to the GP, it wouldn't be at the same angle you were at.
That's why we made a subtraction.
That's because you can't get a right angle off of a curved surface. That's the point.
Yeah.
But we don't use that angle. We make a subtraction before, so that basically solves the problem.
No. The subtraction is your height above the plane.
But that's not an angle.
The subtraction is the angle is acute. The angle is acute until you subtract and make it right. But the bottom line is, you're not arguing with me. This right here says, in simplified terms, when we take a sextant altitude of the sun, we're creating a right angle triangle between it, the Earth's surface, and ourselves. Between these 3 points. And obviously, an angle is two lines. You can't have a line going through. Matter of fact, you saying that the line goes straight through the surface means that you're already conceding that they're using a flat plane, disregarding the surface.
No, because if you look at the citation, the drawing.
You know what? Angle, I'm sorry. Before you continue, I don't want to mute you, so I'm dead serious. No, what? When you say no, what exactly about what I said are you saying no to? So that I know what you're responding to.
The assumption that you just said about the line going through implies that we're not caring about the surface. We are, because if you look at your own citation and you see the angle right below the side of the section, it doesn't go to the line; it goes to the surface. So the angle isn't the angle of the triangle; the angle to the surface, which is different from the angle to the triangle. So you need to take into account of the surface because the angle you're taking. Yeah, so the angle
you don't even hear what you're saying. You're saying the angle to the surface, if it were curved, if you were taking into account the curved Earth, would be a different angle than from the plane. Exactly, because you can't get the 90 off of the curved surface.
That's why
you
it's
make a
wrong.
subtraction.
That's why the diagram is
But
wrong.
we are not using
That's why
that.
that's why the little hump. That's why the little hump there is not really real, and that's why every other depiction just shows a plane because that's what they use. You know, that's what they use. That's why there's a straight line to the vertical forming a 90-degree angle between you because there's nothing in between because you're not on a curved surface because then you wouldn't have a 90-degree angle to that thing if it were technically on the surface like you just said. The angles wouldn't be the same like you just said.
Like I told you, Bacon, at the very beginning, there's nothing here for you to look at when it concerns to the discussion that you're trying to bring up, that you can provide evidence for the Earth being a globe. It's really not going to help your case any to continue forward with it, man. So I would say, you got anything else?
He's still trying to address it.
What do you? He just
why are you? Your friend is trying to address my point. You're saying I shouldn't be having this conversation.
He laid it out for you. It was very simple, very basic for you to understand. So I don't see why you can't comprehend what he just told you. It was very easy to understand. So now I'm telling you, because of in light of what he just said, why can't you just say, okay, well, maybe I'm incorrect with what I just finished saying. I can come back with a different argument because this one, it doesn't seem to support the case that the Earth is a globe.
Well, don't agree with that.
Well, then you haven't provided the evidence that because you are using whatever navigation, you can provide evidence that the Earth is a globe because we're already telling you it's not going to be able to be done because you're building your whole argument on a presupposition. And you cannot assume you have to. Huh?
That presupposition is not my argument.
It's the premise in which you're building your argument.
Nope.
My whole argument is that because of celestial navigation, Earth globe.
Nope.
Then what is it telling us? What is celestial navigation telling us then, Bacon, if not a globe? What are you talking about? What is your driving point here? If not to provide evidence that the Earth is a globe? Are you just want to
I already answered that multiple times.
Want to do on the Earth? Like what is
I already answered that multiple times.
Well, tell me what the point is. Because if it's not about that the Earth is a globe because of it, then why are you bringing it up? Because even though it's not about that, what I'm making the claim about is still being denied. So there's still discussion to be made. No. Exactly say what I told you, Bacon. Is it providing evidence that the Earth is a globe? Yes or no? I'll make it more simple for you. Yes or no?
Yes.
Okay, so now let's get to it. Because now you're saying that it's providing evidence that the Earth is a globe. The man just told you that it is not. And he laid it out for you. And it was very clear. Why don't you realize that you can't work on a curved surface? Because you have to have, at first, a curved surface. You haven't provided evidence for that curved surface. You're only telling us that you're assuming that it's curved. Therefore, it works.
You let me know when I have a question. I can answer.
Do you hear what I just said?
I'm hearing everything you're saying. I'm waiting until you can ask me something so I can answer you because you're just monologuing.
Curved surface, provide evidence, go.
Yeah, first, so premise 1. Celestial navigation assumes the Earth to be a sphere. We agree with premise 1 so I can continue.
Incorrect.
Yeah, there we go. Now we have to discuss premise 1. That's what we're doing right now.
I already told you it was incorrect.
Yeah, that's what the discussion lies about. So we are discussing this premise, which is very important, and our friend.
Yeah, but I already cited sources already. There's no debate.
Yeah, but I don't think. I don't think your sources are actually depicting how it's being conducted. There's no use of that
It doesn't matter what you think.
So why are you talking to me if you don't care about what I think?
No, what you think has nothing to do with information.
Sure. Yeah, I've seen a number of.
If I'm providing you information and you're talking about something that's not related to it, then it doesn't matter.
Yeah, I saw a number of manuals of celestial navigation, and most of them, almost all of them. Okay, well, I can just send like the first 10 I found on Google Images or Google search.
Is it a page from a navigational manual?
Or you want something printed and then scanned?
I don't know. I'm asking you what you already said you had. I'm asking you what it is.
I said I can send you the first 10 Google results of Celestial Navigation manuals.
I don't need that. I just need you to provide how a sphere is assumed. That's all I need. With the method, the actual method that they utilize. Talking about math, the coordinate system, all of this.
Yeah, the position.
I just need you to show me. All right, I need you to show me. To get it's triangulation, not trilateration.
How is that triangulation? Okay, so show me one being done.
Well, I already read it. I already read it out to you.
That's not showing triangulation of your position. Do you have any example of celestial navigation being done to triangulate a position? Do you have a single example of that?
Yeah, is it a trigonometric function that you're utilizing? Okay.
That's what I'm asking.
Okay, so remember when you said it had nothing to do with triangles? And then I read out that, and then I read out, and then, yes, you did. And then I read out that the star in the GP, is creating the right angle of a triangle.
Well,
remember that? All right.
We need some confirmation there, Bacon.
Sorry, could you say that again?
Yeah, that's what I thought. You're not listening, are you? You're basically hearing white noise when he's speaking. That is why we have.
No. Sorry, one second. I mean, I'm here for more than an hour. There are things going on in my house. Sometimes I get distracted. I'm sorry for that. Can you repeat the question, Elijah? Can you repeat the question?
It's probably working.
No, I just told you you were incorrect. I didn't ask you a question.
So why were you expecting an answer?
To see if
you said you made the claim that they assume that the Earth is a sphere for navigation. I said that's incorrect. Then I said, well, I already cited how you're incorrect, and you didn't provide anything.
Yeah, but your citation doesn't assume the Earth to be flat. Someone's breaking up.
Yeah, someone's hot micing.
That's AI. That's AI.
Yes, I just.
So encyclopedia right here. In an encyclopedia, not even an in-depth search. A sextant is a navigational instrument that uses a telescope and an angular scale to calculate latitude and longitude. The observer can thereby calculate his or her position of latitude by using a trigonometric operation known as triangulation.
Can you link that?
So you just said that was incorrect.
Yeah, I am saying that's incorrect. I'm asking you to an example of that being done.
How is that incorrect?
Because that's not. I mean,
What about it is incorrect? You measure the angle between your horizontal plane and the object in the sky, right? And then you refer to a navigational chart after you've taken your time and your degree measurement, and then you do the math and you figure out a point on a line of position, the circle of equal altitude. And if you have a second star, well, then you're going to have another chord that's going to have to be parallel with the first chord from the other star, which obviously, if the surface was curving, would be doubly impossible. It's kind of redundant at this point.
No, it's not impossible. It can work very well on the sphere.
But you're not providing anything. Like, I'm refuting you with what I'm saying. You're not saying anything to tell me how I'm incorrect.
I mean, you claim there's triangulation is being done, right? Triangulation is used to get a position. Do you know the difference between triangulation and trilateration?
One second. AI, I think you're hot micing AI. Or wanted to interject, but you're roboting and hot micing, I guess. AI.
Sounds like we hear the same thing, Roger. I think he's trying to get in here.
I don't know.
Yeah, but I heard Bacon kind of shift the argument a little bit to now telling the difference between those two, where he was actually pointed out how was Elijah's point wrong, and he skipped over that. He didn't address it, and he went straight into something else.
What do you mean? I was in the middle of addressing
Well,
that.
what he said was, do you know the difference between triangulation and trilateration? Because about 10 minutes ago, he said that it was trilateration, and I said, no, it's triangulation, and he said, who uses that? And then, well, I just read from the encyclopedia, well, there you go, that it's triangulation. And then he said, do you know the difference between triangulation and trilateration? Trilateration, well, this here from Siler.net is saying traditionally, triangulation is the process of determining the location of a point by measuring angles to it from known points at either end of a fixed baseline, rather than measuring distances to the point directly.
Exactly, and
which would probably be the method for trilateration. The thing that you're saying is the case, but it's not.
What people do with the angle to the celestial bodies? What do they do with the angle in celestial navigation? This is something we all should know about, because that's the first thing you do, and it's something very basic and requires no complicated math. You measure the angle. What do you do with that angle?
Yeah, who cares, man? How is it providing?
Well, that's the whole point, because he's saying it's not trilateration, it's triangulation. And according to his own source, if he does what people do when they get the angle, he'll realize that he's wrong.
That's great. That's great, man. I'm surprised you can look on Google and find some information in 2022. That's great. Listen, but you haven't provided evidence that the Earth is curved. Now, going back to that point, because you're on and on about this, as you got to be in your bonnet about.
I'm trying to get there.
Who cares? Did you tell everybody here how you verified that the Earth is a curved surface, and that's how you're working out the celestial navigation? Or are you just talking about celestial navigation because it's a cool topic? I once again want to point out to you and the audience listening that you're not getting to the crux of the argument, because you're talking about this whole argument that you've been here for an hour and a half now, that the Earth has to be a ball because of what you're talking about of triangulation, and you're on and on about nonsense. Really, I want you to point to the Earth and then say, look, it's curving, and I know how. This is how you can verify the Earth is curving, and then I can work my celestial navigation based upon that information. But you're not doing that, are you? Now let's get back to that point.
I can get there.
Round and round we go with your idea of thinking that, no, I want to talk about my topic. But the idea is you're coming into a flat Earth server. You need to provide evidence that you think the Earth.
Except for you, everyone that was responding to me was within that topic. You're the only one that is objecting to that topic.
Because I'm not going to be sitting here for another hour and a half talking about what your definitions are of something. If you're not providing evidence that the Earth is a globe, sir, you are wasting everyone's time. Because that is what we want, the truth about what the Earth is. And by God, at some point, you're going to realize that that's what the conversation should be, and not talk about what?
It fundamentally will be about it, because what we're discussing is the premise of the argument. Well, let me finish. Let me finish my answer.
Let's skip all the bull. Right? Let's cut through the crap cake that we got in front of us, and let's talk about the elephant in the room, which is that the Earth is a globe according to you, but you're not telling us how it is a globe. You're dancing around the topic. You're doing the cha-cha, the mamba.
Yeah, that's a premise of an argument. Can you wait?
That's the only thing we want.
20 seconds. Give me 20 seconds to
20 seconds to tell me that the Earth is a globe. Go.
The argument is about the shape of the Earth, but the premise is stop. Speaking over me. Let me answer you. Tell
me how
go. Celestial navigation is the premise of the argument. It's the premise of the argument. If you want to skip premise,
and you know what? It's annoying. It's annoying. I know. It's annoying, and I know. But listen, you know what's more annoying? How you're dancing around the topic. Now the Earth is curving.
We're debating a premise.
The Earth is curving according to you. Let's bring it back. Earth is curving according to you. Now, inquiring minds want to know how it's curving, Bacon. And by God, you got some information right now that's going to tell us how it's curving. Now, I don't want to hear any more of this thing that you're pointing to the stars and you're looking up and telling us how the celestial bodies look and how measurements to them are. I don't care. I'm looking at the ground in which we all stand upon, which you think it's a ball, a sphere, a spheroid, no blades, whatever. I don't care. Now, we're getting to the point that you're dancing around and you're going to tell us exactly how it's curving. Where is the measurement of that curve? Now, that is what I'm interested in, and I'm pretty sure everybody else is here too, because you got to be in your bonnet about the celestial navigation that really nobody cares about. We want to know how you know.
It doesn't sound like nobody cares about, since they're talking about that to me for the past 2 hours.
Yeah, because the point is, it doesn't provide evidence of it being a globe.
It does.
That is the point everybody was engaging you on.
It does.
But so we let you go for a while, and your conversation keeps coming back to, well, I was just assuming at the very beginning. Who cares, right? Because that was your assumption. That celestial navigation is worked out as, the Earth being a globe. No, I don't care. I want to talk about how you found out that Earth is curving. That's what I want to know.
Sure, premise one. Sure, premise one is celestial navigation assumes a sphere. That's the premise one of the argument, right? And people are disagreeing with premise one, so I can't get to the conclusion of the argument, which is the Earth is spherical, if you can't get past the premise.
You're not going to provide evidence that the Earth is a globe.
Yeah, it was.
Just like
there was
everyone
evidence.
else, right? You fall to the wayside. You fall to the wayside like everybody else because you and every Joe Schmo out there comes into this server thinking, well, I got the evidence. This is how I'm going to provide evidence. No, it's not, because you're working on a faulty premise. And that's been pointed out to you many, many times. We just want to hear.
Yeah, prove the premise is faulty. That's
the truth, right? The lovely sound of truth is, I have the evidence. You can verify.
My God, you have to pause for a second. Otherwise, it's just you talking for hours.
Well,
so
ramble on about how you think celestial navigation and triangulation. Who cares, dude? Go back to the Earth being a globe. Now go ahead. Provide evidence the Earth is a globe. Go.
Yeah, you're saying my premise is faulty, right?
No, I'm saying your argument.
No, you said that. You said multiple times that the premise is faulty.
Your argument is DOA, is dead on arrival. That's what the acronym for DOA.
But you don't know the argument. Yeah, I didn't give you the whole argument. I just give you a premise, and you don't want to talk about. Okay, wait. That's the premise of the argument, and you don't want to talk about the premise of the argument. You just want the conclusion. But the conclusion starts with premises, and you want to skip that. I'm not going to do that.
Why don't we just give him 1 minute to state his case so we can then just move on from this then? How about that?
He had
completely over him
to state his case. And he was shown about 3 or 4 times by people in here that he's incorrect, yet he still wants to state his case. So I'm going to stop him short. I'm going to stop him short, and he's going to have to provide. Now it's time for evidence. Evidence now, please.
Yep. So again, premise one is that the celestial navigation assumes the Earth to be a sphere. That's premise one.
Incorrect.
I can get how. Yeah. So that's her goal. He's disagreeing with my premise, and we can debate it. That's it.
No, not debate it. It's your premise. So instead of the premise being assumed, why don't you just justify your premise by providing some evidence or some information?
Yeah, when I looked up celestial navigation, it all looks.
Did you provide it?
Based.
Did you provide it?
Yeah, I can provide you. 1 second.
That's what I asked.
Dude, that was asked over an hour ago.
And I keep it.
Yeah, what we're really on now is what Miggy asked was we need verification of how he found it's a globe in the first place to verify or justify your premise.
The premise. No. The premise is not assuming the Earth to be a globe.
You said it's assumed. You've said it numerous times.
My argument of the Earth being spherical isn't assuming Earth to be sphere.
Your premise one was that celestial navigation assumes spherical.
Exactly.
Earth. So
exactly.
That is your premise.
No.
Your premise is the assumption.
Yeah. That is
no,
your
no,
premise.
no. My premise is not that the Earth is spherical. My premise is that celestial navigation assumes the Earth to be spherical.
Okay, show us where, and show us the calculations where someone's assuming a spherical Earth when they're doing navigation. Please, show us a citation. When was this actually done?
What do you mean? It's done.
When was it actually done the way you are claiming? When was it actually done the way you're claiming? That's it.
You still haven't posted
every
any
time.
citation.
Every time people do celestial navigation.
Okay, so you can't answer the question. I guess.
Just
so let's go back to what
every
Mickey
time
asked.
it's done.
Can you show us proof that the globe is a curved surface on Earth? Where's your proof?
Yeah, just bring us proof. That's it. That's all you got to do.
When was Earth's curvature measured ever in history? When was it measured, Bacon?
Directly, the curvature. You mean like the water?
Measurement is directly.
That's
There's
what
no other way. There's no other way to measure something other than directly.
Can you measure speed?
All right, we're talking
Don't
about the
change the subject. I'm not letting you change.
I'm not changing the
Where's your
subject. I'm not
verification
changing
of curvature? When was it
Can-
measured?
No, you're just making a claim.
When was
I think I
curvature
have
of
an
Earth
example.
measured ever in history? Go.
Make one claim at a time, so I can respond to the thing.
Okay,
thing
the
you're
claim
saying.
is, you made the claim that Earth is a ball. So we need to know how you verified this with an actual curvature measurement.
I didn't do it with curvature measurement. There are other ways to know the
We
shape of
need
the
a
Earth.
measurement.
Measure curve.
We need no, there isn't. We need a measurement. It has to be direct.
there
It
is.
has to be
If-
physical.
Sure, it has to be physical.
Yeah.
But it doesn't have to be direct. Not.
Yes,
most
it
of
does.
Measurements aren't
That's the
direct.
very definition of measurement is direct, physical, energy exchange. It has to be direct. How do you have an energy exchange and a measurement if you're not doing it directly or physically?
Wow.
There are other forms of measurement.
Right, but they're not direct measurements having to do with geometry, though, are they?
Yeah, but when we talk about the black swan, that's not direct in the way you're defining it either.
It is actually.
No, it's not.
Well, I don't know how it's not, but we could discuss.
Well, you said physical energy. You're not. That's not what you're doing. You're not physically taking a unit of measure and doing anything. It's just a little different.
Well, maybe I have a slight disagreement with that, but okay. But we can move on. We're still looking for.
Disagree where?
Because when the gentleman puts his camera at a known location, he points it at another object at a known location with his observation height. These distances and height is a direct measurement.
Not in the way that you defined it. I'm not saying it's not a measurement. I'm saying the way you define direct measurement wouldn't be that.
Well, okay. I can recede on that point.
Thank you.
Yep. Because he didn't take an actual physical, let's say, measuring device and went from point to point. So yeah, I got your point.
But I mean, nobody's done what we're doing, and they're not talking about doing what we're doing to measure the Earth anyway.
Yeah.
So
yeah,
they don't have any kind of form of measurement.
Right. So Bacon, why don't you go out and try to find out or try to verify that the surface of Earth is curved in the first place? That way you wouldn't have to make a premise. You would know for sure.
How
Wouldn't
could I
you know
measure
for
it?
sure? If you
How could I
measured
measure
Earth's surface, if you measured Earth's surface to be curving, you wouldn't have to use that as supposition anymore, right? Because you had measured.
Sure. How can I measure
it.
that?
For sure.
How can I measure that?
I don't know. That's your problem, not ours.
That's not my claim. Well, that's what you're saying. I should do that.
Well,
And
how else are you?
I actually looked to how to do that, and it seems to be very, very complicated to get an accurate measurement of that. So there are other ways that are more approachable to measure how the shape of the Earth looks like. And you're specifically asking me to prove of curvature, which I would say is one of the hardest way to prove the shape of the Earth. And then
No, he said, "Do you know how it was measured?" That's all he asked.
No,
If you don't, then
he
you
didn't
don't.
say that. He saying asking if I did that, and I'm asking, well, how can I do that? So if it's as easy as
what was your question, Sonny?
No, that's not what I asked, Bacon. Stop changing people's words. I asked
What
you
was your question?
when in history was Earth's curvature physically measured?
That wasn't the question I was answering to.
That is the question. Yes, it is.
That's the question now. That's not what you're
No, that
asking
was the
for.
question. Rewind the tape.
You just okay? Yeah. How can I do that?
Go to YouTube. Go to YouTube Live and rewind the tape. I asked the same question I just asked.
Sure. 1 second. Let me do
like when, where, and how was Earth's curvature measured physically?
That seems like some shit he would say too.
Crickets, please.
Nah, he muted himself to watch the live stream. So loading screen, not cricket.
What up?
Apparently, he's more interested in arguing everything than just.
Okay, I rewinded the tape.
And whatsoever.
The question was, the question was, Bacon, why don't you go and verify that the Earth is curved? That was the question. And I'm asking, how can I do that? So it's not the question that Elijah said. It's a different question. It has a different answer.
We've asked you both, and you haven't answered either.
Yeah, in the first one, I'm trying to ask you to be more specific on how do you suggest I can do that? Because it's extremely hard to measure curvature.
It's your claim that it's curved. Wouldn't you know how to measure curvature?
Yeah,
no, my claim isn't that it's curved. That is implied by my claim. No, I can claim. Wait. I can claim.
What are we talking about then?
I can claim it's a sphere if you want to. I can claim the Earth is spherical if you want to. And that would imply
you've already done
that would imply a curve. But that's not the same thing as just claiming the curve. If I claim the curve, it makes sense to ask me. Sure. So if they're the same thing, instead of
therefore curve. So where's the curve?
I can show you where's the sphere.
Really? Show us where it was measured. Where, when, and how was it measured?
Well, there's plenty.
Well, you said. Well, Bacon. Hold on. You said it's extremely difficult to measure the curvature on Earth.
Yeah, the curvature of Earth. Yeah.
You must be basing that on some information where someone tried. So, how do you know it's difficult unless you're basing it on someone? So, when did they try that you're basing this knowledge of it being hard?
No, I was just trying to find experiments that could be able to measure it, and they're extremely hard to do.
So you're making shit up. I'm not making shit up about it being hard.
No, I'm not making shit up. No, I'm not making shit up.
You said it's very difficult to measure the curvature of Earth. What are you basing that on?
I said when I looked it up, it seems a very, very difficult way to measure it. So if there's a easy way to do it, please tell me how. I'll do it right now for you.
No, I want to know how it was done in the past because obviously you're using 3,959 in any of your globe calculations. We want to know how they validated or measured that in order for it to be a thing.
Sure, one way is with...
No, not one way. I asked how they actually did it. Not how you
they did it many times. No, that's what I'm answering you. That's what I'm answering.
Not how you could do it. I want to know how they actually did it in reality.
Which is what I'm saying. If you allow me to finish a sentence. I said one way they did it is with spherical axis. That's one way. You can use the fact that the angle drops from zenith of a celestial body a degree every 16 nautical miles. That's also a way you can get...
Bacon, your accent is kind of a bit tough to hear. Did he say spherical axis?
Axis.
Yeah, spherical axis.
Okay, so you're implying fear, right?
No, that results. No, that concludes the sphere. That doesn't assume a sphere.
Implied it. It sounded like what you just said implied sphere. Using spherical axis. That's how you started your statement. Using spherical axis.
Mm-hmm.
Well, no, he says spherical excess.
Well, it's a sphere according to you, and that's how you're using that measurement that you're talking about.
Yeah, if it's not a sphere, you have no access. I mean, excess. I think excess would be the way to pronounce it.
That's the thing, though. If you're not using it, but how are you using it?
I'm saying if it's not a sphere, and you try to measure spherical excess, you're not going to get excess. You're going to get triangles forming 180 degrees. If it is a sphere, vertical lines are going to diverge. That's going to increase the angles, and you can get a radius out of that.
It depends on your assumption, doesn't it?
No.
Yep, sure does.
How does that? It depends on.
You're assuming it's a ball. Otherwise, your numbers wouldn't fit on a ball if you weren't assuming.
Right.
Actually, no.
Right. Well, Mickey asked you.
Nope. Because if it's not a ball.
Assuming, well, right here, spherical excess. The amount by which the sum of three angles of a triangle on a sphere exceeds 180.
Mm-hmm. Yep. And on a flat surface, they don't. So that measurement can be used to distinguish between a spherical surface and a flat surface.
I don't get what you mean by that. What does that have to do with celestial navigation? I don't even know. What does this have to do with? What does this have to do with anything? As a matter of fact,
that's my point.
Because that's what it was asking me. They asked me. It doesn't make sense to ask me things, and then I answer. You ask what does that have to do with anything?
That's not a measurement of anything.
It is. It measures the radius of the Earth.
No, it's not.
Yes, it measures how much degrees excess 180 degrees when you make a triangle on the surface.
A surface? On the surface? You can make a triangle on a curved surface? Really? Show me how I can do that. Because that'd be
just get a pen and draw it. You can't. You can't draw.
I can draw a triangle on a curved surface. Is that what you're saying?
Yeah, it's spherical one. Yeah.
One has a straight line and the other one doesn't.
It's a spherical triangle, not just a Euclidean triangle.
A triangle?
No,
sir.
It's based on a theoretical ellipsoid. Like it has, again, it's not a measurement of anything.
It is, because if it wasn't an ellipsoid, yeah, but if it wasn't an ellipsoid, if it was a flat surface, they would not measure axis. They would all sum up to 180 degrees.
You're not. That's the problem. You're not measuring anything. That's the point.
You are. You're measuring plumb divergency.
It's a calculation. You're not measuring anything.
You are. You're measuring how bigger the angle are from 180 degrees. That's what you're measuring.
No, you're not.
How am I not?
No, you're not.
That's exactly what they measure. They measure how plums diverge.
But no, that's assuming that plums diverge. Because after you diverge it,
you're measuring.
After you have to put the plots on a sphere, you have to calculate the divergence. Liar.
No, you measure the angle. You don't calculate the angle. You measure it.
Well, plumb is always perpendicular to the horizontal. So what are you talking about? So what are you talking about?
They diverge. And they measurably diverge.
The only way you can think they diverge, because if you're taking a measurement, which is a vertical measurement, and someone else has a vertical measurement, right? The only way to say how much they diverge is to assume how much curvature there is between point A and point B, which you will be assuming the Earth is curved.
No, I can just
how much.
I can just measure azimuth.
Bro, you've been busted about 7, 8, 9, 10 times, like
on your mind, sure. But can you
take a break?
Can you address what I'm saying? Can I?
Spherical triangles. I mean, come on. Let's get real here. Spherical triangles.
It's pretty simple. You don't have to rely on that. It's pretty simple. You have 3 poles on Earth, and they are vertical. And you go to
I said it before, Bacon. I'll say it again. You got to come up with something better than this, man. This is not doing it for you.
This is evidence of Earth curvature. What do you mean?
It's not, sir. It's not evidence of anything, and we've already pointed it out to you. But you keep thinking
you're doing just a semantical argument.
No, you're using assumptions of what you think the Earth is. And here I go again with this. I'm pointing this out to you. You can't keep saying no, you're not. When we rewind,
let me explain why you're not. Let me explain.
No, because when you rewind the tape, you're gonna go back. You're gonna go back to where you hear yourself say, it's an assumption. It's an assumption about 30, 40 times back in.
But I didn't say that about a spherical axis. You don't have to assume the Earth to be a sphere. You're just measuring if plums diverge.
Hold on. You think. Well, I know that great circles have to do is in some way linked to celestial navigation, where spherical excess comes in, right? But it's bullshit, because again, no, you're using angles, and you can't get 90 degrees or any elevation angle off of a curved surface. That's just nonsense. You know that. That's why you agreed with me when I was talking about everything that I talked about coming from the manuals. Well, they utilize a plane. They utilize a plane. The only contention you said was, why do you say that this is proof that the Earth is flat shaped? And I said, well, flat isn't a shape.
Yeah, but the plane isn't used as an assumption of what the surface is, so that doesn't.
So what's it? So what's an equatorial plane then? What's an equatorial plane?
It's the plane that cuts the celestial sphere in half.
Oh, okay. So we can go ahead and hypothetically, theoretically disregard the curved bit and use a plane.
That works.
Use a plane for what? Use a plane for what?
Oh my god, dude! Keep up with everything. What do we use?
Because we use planes. I'm not disagreeing that we use planes. We use a horizontal plane to establish the elevation angle, for example. So if you're saying we can use a plane, sure, we already use a plane. Well, what's your point with that?
That the sphere doesn't come into play at all.
And then it invalidates your argument.
It does when you're. It does when you're.
That's what it points out. It invalidates your argument, so it voids it, makes it null. So you can't use.
Comes to play. The sphere comes to play.
Bacon, you can't use it. Once again, you can't use it for your argument. You have to let it go, okay? Because it's not working. It invalidates.
If you listen for a second, you realize that it. I think you realize that it does relate to, because
we think we should realize. It doesn't mean we're going to be like, oh, on second thought, Bacon, you made a good point. No, we invalidated your argument. That should be okay. Time to move on.
No, you didn't.
We did.
No, you think you did. If you allow an answer, why instead of just restating
ridiculous argument?
Stop restating that I'm refuted. That doesn't do anything.
Well,
yeah, but you have to demonstrate that, not just claim it.
Because he told you it can work on a plane, and you're like,
he told, but he's wrong. That plane isn't the surface of the Earth. If you allow me to speak,
it invalidates.
If you stop monologuing over me, I'll be able to answer him.
The only thing that should matter right now is that it invalidated your argument. That's the only thing that should matter right now.
It didn't. Let me explain why it didn't validate my argument. Because when he said the sphere isn't used, we use a plane. When it comes to the part in which you fix your position, you don't use a plane. When you get the difference between the angle you measured and the angle you expect to measure, that comes from spherical geometry. That's when the sphere comes in. Using a surface or using a plane would not give you the same distances. You wouldn't use Haversine formula. You use Pythagorean theorem to get distance to the stars. No, the GP.
No, you don't use. We're not trying to get the distance to the stars in celestial navigation. I don't know whoever told you that.
To the GP, I said. To the GP of the star.
No, you said to the
GP.
distance.
The star doesn't have a GP.
You said yes, it does. Yes, it does. You said the distance to the star.
Yeah, I meant the GP of the star. I misspoke.
Oh, okay, fine. So you weren't talking about the opposite, right? Because that's not what we are looking for.
Sure.
I just said it invalidated your argument because it provided evidence that it doesn't have to be what you say it is, and we already showed you that. But you can validate my argument.
When you're fixing a position, a plane won't do it. You might do the correction on the plane because the correction is smaller than the distance of the star, so it's locally flat. It works well enough. But when you're getting the angle you expect to see compared to the angle you see, that comes from spherical geometry.
You're just gonna hold on to this argument, huh? And think that it provides evidence for the Earth being the sphere, but it's
that's true.
Well, I know it's true because you're in here keeps restating the same old recycled argument that everybody has coming in here and standing on this, really ridiculous argument. But it's I mean, for you to care about engaging in it means that you think that you got a point which I don't know why you want to continue when it doesn't really matter. And you haven't provided evidence that the Earth is actually curving. You're just talking about celestial navigation and wilbity
Which is the premise. Right? Yeah, that's the premise of the argument.
Does not. You're just based upon what everybody else has been taught that the Earth is a globe, and they're working off this idea that it is, and then they're superimposing that idea over the world that they live in, which is what you're doing right now. Exactly what you're doing. You're superimposing the Earth being a sphere and everything that comes along with it because it fits some model that you made. Like I told you before.
Not because of that, but it's not just because of that. It's because people manage to get their position using distance to the GP of a star and comparing that to the elevation angle.
Doesn't mean because they're using an assumption they are correct to say that the Earth is a globe. That is you're basing your whole idea and understanding of the world based upon that. Because somebody figured out that if you use the Earth being a sphere as a way to navigate, then it must be a sphere because it can be used.
It's not just because you're using. It's because you're using and it's working.
Like I said, it works on the plane, but you keep saying that it doesn't. But you haven't provided evidence that it can.
Yo, Miggy.
Okay. So if you give me, if you tell me how it's done on how the position is fixed on a flat surface, I'll give you angles and elevation to 3 stars, just an example, and then show me how you can fix a position.
Elijah already did show you. Apparently, you're not paying attention. It's been put into Live's text probably a dozen times what we're talking about, and you apparently are not paying attention at all.
No, what Elijah sent, maybe he sent more stuff, but the thing I saw him sending, it's not a position fixing. It's just a picture and it's talking about elevation angle.
Using a right triangle. Yeah, you're right.
Sure, there's a right triangle drawn there. Okay, but that's not the point. I'm not talking about
no curved adjacent. So do you have a calculation that takes a right triangle and turns it into a curved adjacent?
Never claimed curved adjacent.
You did claim curved adjacent. You're saying the Earth is a ball.
You're deflecting from
You're saying, no, I'm not. I'm talking about the exact same subject. You're deflecting because you know you're in a corner.
That's not my point. My point was about trilateration. I'm asking how trilateration...
We're not talking about trilateration. You changed the subject.
It's not trilaterization. It's trilateration.
Well, I guess it does. I guess it does. I guess it would be trilateration. But again, the circles, right? Because they're obvious, right? They're circles, right? And you're trying to determine where you are, where these, say, for instance, 2 or 3 circles intersect. Guess what? They have to be parallel to each other.
They don't.
Yeah, they do.
Okay,
I already read to you that they have to.
Oh, where is it written? Let me. Can you show that?
Okay, but wait a minute, Bacon. You said they don't, so provide the citation right now for why they don't. You have another way, apparently, so show us the way where it's not used like that.
Oh, my way I don't use like that. I can...
We're not talking about your way. Actual navigation done that way is what we're talking about.
Yeah, in navigation, the circles of altitude are just circles around the GP. They don't have to be they don't have to be parallel to each other.
Yeah, they do.
Yeah.
Where's the requirement of that?
So how are you going to get an elevation angle?
Right here.
Because on the sphere, everywhere on the circle.
Right here, this is where it says that you asked. This is what you asked for. From this, a navigator knows he is on a specific circle along the plane of the surface of Earth, of radius r, known as the line of position. He does not know his direction from this point. However, by examining a second star, a second radius can be deduced. The navigator now knows he is at one of the points where both the circular functions meet. In the case that there is only one real route, he knows his position, although this is only possible if the radii are parallel.
The radii are parallel?
Yeah, parallel.
What do you mean?
The thing that you said could go through the Earth to make the 90?
No, that's not what I'm thinking is going on. That's what I'm saying. That
No, I'm not asking you. I'm not asking you what you're thinking is going on. I'm telling you that the radii have to be parallel because
can you link that citation?
Trilateration, right?
Can you link that citation so I can read it as well?
Yeah, sure. Are you gonna say, okay, I'm glad for the information, you were right?
Let me see. Where? No, I'm asking you to link the citation. Where does this comes from?
Yeah, I posted it.
Yeah, you send a picture, right? You have a link for it.
You want me to find where this is?
Oh, so you just found this picture somewhere. You don't know the source of it, right?
Wow.
Yeah, I had the source at one point. Why? Because there's someone else doing the research. And they said, hey, look, here's a snapshot of what I found. Now, all I have to do is type in a couple of words into my search engine, and I could find where this came from. Are you that incompetent?
Yeah, because he wants us to provide him all the evidence and citations.
Well,
but when we ask him to provide us the evidence and citations, he doesn't do it. So it's a one-sided thing, isn't it?
No. He's making the claim.
But are you that incompetent that you can't find this? So if I do find it, then you will say that I'm right?
No, depends on that where the source comes from, because anyone can write any bullshit they want.
I'm telling you that this is what they all say. This is obvious.
I disagree with that.
All of the manuals.
No,
you can't disagree because I have about 5 of these.
Okay.
What are you talking? You have given nothing. You haven't given anything yet since we've been talking.
Let him provide some citations. See how he likes it. Go ahead, Bacon. Provide citations and put them in the live stream.
Sure.
Since you want us to provide you with evidence, why don't you provide us?
Okay, one second. First, you're not going to find people saying those circles don't
provide the evidence.
Let me finish.
No, you don't. You want to make it one-sided.
It doesn't make any sense. It doesn't make
citation. Provide your citation, Bacon. Go ahead. I hate it when you dance around the topic and you make it seem like you can ask us all the questions, you can interrogate us. But what about us telling you to provide the evidence? Where's your citations? Put them in the live stream voice text, Bacon. Can you do that? And
yeah, that's okay. He when you started speaking after I muted him because he couldn't stop talking, then he deafened himself. So now he's muted and deafened server because he is refusing to listen. He is just obfuscating every single thing we've talked about. It's unbelievable.
Well, he wants us to provide him all the citations, and then when it is provided, because I know Elijah has at least 5 sources, he's going to be like, those aren't all credible. He's going to do that. He will just dismiss it, hand wave it, and be like, nah, none of these sources, not even if it's coming from his scientific priest, will he agree with that. So, Bacon, once again, you're indefinite, go ahead and provide your citations, please, because it sounds like you want to do all
citation for what exactly? For what claim?
Oh, so now you got memory loss. How convenient, Bacon.
Yeah.
So you can't say... Just answer the question then. If you know what you're asking for, why don't you answer it?
Unbelievable.
Of course you're not going to find... I mean, if you find one citation that says that the circles of equality...
Yeah, provide us a citation where it says specifically that they do not have to be parallel. That's what we want.
If you find a citation that says the circles of equal altitude are green, I'm not going to find one that says that they don't have to be green. No one's going to write that.
No. That's not. That's the difference between 2 different things. Your argument is counter to mine. I'm saying, well, it must be parallel. You're saying, no, it doesn't. So you don't need to provide a different color. You just need to provide a source where it says that the radii don't have to be parallel.
Exactly. That's what I'm saying. No.
Well, you're saying no, they don't. But I need to know where that knowledge came from. You saying they don't. That's all I need to know.
Yeah, because when I used it, they didn't have to be parallel, and it worked. So it doesn't seem that that's a restriction. And when I was reading about it,
you didn't use anything, because the reason that they have to be parallel is, well, you have to subtract 90 from each of those different measurements, genius. So they have to be parallel. Why? Because you need a 90 to all of them.
Yeah, but if the verticals of all of them are different,
not yeah, but what are you talking? What do you mean? Yeah, but
the argument.
You can't say yeah, but to that.
No, the fact that you're subtracting from 90 just means you're using the zenith angle instead of the elevation angle. That tells you nothing about those circles being parallel to each other.
The zenith angle already has you established on a horizontal plane. Then you have the different circles of equal altitude on this established plane.
Yeah, but your argument that because you subtract from 90, then they have to be parallel, is just not. That's just a non sequitur.
Now you keep saying
the three zeniths, right? That line is perpendicular to the horizontal plane.
There's one zenith.
No, there are not. There are three zeniths. If you're using three stars.
GP, you mean? Yeah, we don't measure to the zenith of the star. We measure.
We don't measure to the zenith, but the angle is 90 degrees. From you to the well, not as I claim, as I read from the manual, because it's not my claim, it's how it's done. You're saying it's not how it's done another way. And I said, okay, provide me something, and you haven't provided anything yet.
We're still waiting, Bacon. Go ahead. Provided live stream voice text.
Okay, how the trial is conducted?
No.
Bacon, are you the citation?
No. Here's what we need. We need a citation that states exactly, in actuality or reality, of how you're saying this is done that is opposite to what we're saying. You have another claim. You made a claim that it's not done the way we said. We need your citation.
Well, when I looked it up on how it works, I haven't found any restrictions on the circles being parallel to each other.
Okay, where did you look it up? Can you please put that link of where you looked it up? Thanks.
Sure.
Finally.
So in other words, what you're saying is you can't find any citations for what you've stated here today. Is that what you're trying to say?
Depends on what claim you're referring to.
No.
He's so silly. It's just crazy.
Yeah, it is crazy. That's insanity. So not one thing you said that you said you're sure of have you provided claim for.
What are you
You haven't provided anything at all as far as a citation that validates your claim.
Which claim? You're talking to one claim.
Listen, Bacon, any of your claims.
Dude.
Yeah, so let's pick one at a time.
Yeah, curvature of Earth. Where's the verification for the curvature?
I wasn't making claims about curvature of the Earth.
God.
Yeah, you're lying now.
That's what. Well, you did claim that you did claim that the circles of equal altitude don't have to be parallel, and substantiate that claim.
Well, why would they have to be parallel?
Because it's a trigonometric function. I don't know. I want to be.
What trigonometric function are you referring to?
Here, I'm going to tell you why. Hold on, Eli. Eli,
I want his answer because he
hold on, Bacon. Shut the fuck up for a second, Bacon. See, on if you pay attention to what Eli posted, there's a thing called line of position, LOP. If they're not parallel, the circles of equal altitude, you don't have a connecting line of position. That's why it doesn't work.
Oh, it can. Of course, it can work. You can have two circles that are
And
not
show
parallel
us
that are
how.
intersecting.
Show us your citation of how it can work. You said sure it can. Show us how right now. A citation.
A citation that circles that are not parallel can intersect.
Exactly.
You don't know how two circles that are
No,
not
I
parallel
want
can
you to
intersect?
know that the circles of equal
this is
altitude
just
can be done for navigation on a curved surface. Go citation. Right now.
If you're challenging
right now, the citation right now.
If you're
Citation.
challenging,
Just put the citation up for goodness sakes, man. Stop.
I'm not putting up with it. Every time I mute him, he deafens. So he obviously doesn't care what we're talking about.
Yeah, he doesn't want to provide the evidence, so it's clear.
I think I'm just going to kick him. Any objections?
Hell no.
Still leave him here.
I'm going to kick him.
Nah, just leave him. It's all right.
Cogdis?
Nah, just it don't
All
matter.
right, whatever. I'll just leave it alone.
Yeah, just leave it alone.
I'll leave it alone. No problem. Some other people want to play with the toys, so I'll leave them alone. I don't know how many times somebody can get intellectually just bludgeoned and keep going with their fallacious argument, and then on the next breath saying, "I didn't make that claim."
Yeah.
and then wait, I'm not done. Then the next breath, what claim?
Yeah, I was gonna say the old goldfish line. And
I didn't make the claim.
Like he can't even be here. The attention span is like only 10 seconds.
Mm-hmm.
That's crazy, dude. Like, how can he not? This is what I mean. In the audience, that's listening too. How can you, in the whole argument, right, or the discussion, or whatever you want to call it, come up with like, what were you talking about again? What did we say?
I know.
He sounds legit, like he's for real. It makes it sound so convincing, like he really doesn't know where he's at. And then two or three people are talking about the same subject. It's like, well, guys, ask me. There's too many people talking, like that meme of the cat looking like all around, like he's all confused. Like it's what it's not like, dude. Because really, it's all about like if you got the evidence, provide the citation, put it in the live stream voice text, silence everybody that's give you the question about it, so we can all look at the information. But no, he wants to go on and ramble about what he thinks is a possibility of what's happening, and assumptions are the way to do things. And wow, man, like this is
not about what I think.
All ballers have, dude. All you guys, you're a bunch of hot air, dude. You really got nothing to bring to the table.
It's not about what I think. If you have distances on the flat surface, you don't use spherical.
About what you think. All about what you think. You want to come in here sounding like an intellect, but you sound like a buffoon, dude, without any citations. It's like, well, I've worked it out. Well, how did you work it out? Provide the citation where you got that information. Well, I just did it. Wait, just no winning with you, man. Whatever.
Oh, I tested it.
Look at the yeah. You didn't test anything. Get out of here.
I did.
You didn't test anything. What did you test?
Hold on. No, I'm not. I'm bypassing him. I'm not even. I don't go back on deafen or whatever it is you do.
He
Look at everything that I
state his case.
Look at all of the images that I posted. These pictures encompass everything that he denied for the last hour and a half, while agreeing with me at the same time. Because at some points when I would read something out, he'd say, "Yeah, I agree with that," but then would contradict himself. And basically, everything that I'm showing right here, he said is not the case. Look at where that observer. Look at dude has a dead ass globe around his face. And then you have that line, that circle around him, the observer, labeled horizon, and then you have the celestial sphere, so-called. That's it.
Yeah.
Like this is them utilizing the plane that we live on. Look at this. You got in this depiction here, this really old looking one, with the like fake ass stars in the background. You got this boat, and you got this line that goes out to some other point and then straight up to the star. Like that's a 90-degree angle from the zenith to the GP to you. I mean, he's saying no, that's not the case. Like if there was, if that line right there were curved, right? Like say you had the star, and then you had the ground, and then you had that line. But say that line was curved at the bottom. At any point on that line, you wouldn't have a 90-degree angle to it, the GP. At no point on that curved line. That's just what it is.
Yeah, and also, Elijah, along that curved adjacent that they're claiming, because that's what they are claiming, they don't have a line of position either. That means your line of position is off. You have no circle of equal altitude, so that means your elevation angle is incorrect. So you're starting with, like, this is a big problem. So I want to see, like, anyone out there that thinks that people are navigating, that they're making a first assumption. They may be making an assumption of a ball, but whenever you go down to do it in actuality, you're using real geometric values of a right triangle. Period. So I want to see how the way he's saying it. He already left, but that's okay. He wasn't listening. Anyway, so any of you that are going to uphold Mr. Bacon's method, can you show us where somebody's actually using a curve adjacent?
Yeah, that's the second person that came in here using a sextant argument, actually. Those two people for today, so they're really buzzing about this sextant, aren't they? On the globe community.
Mm-hmm. Yeah.
They got a winner, man. Like, oh, man, we couldn't get him anywhere else but the sextant, man. Here we go. It's funny because every time that you ask them for a citation or for what they just said, you're like, huh? Like they're deer in headlights.
I know. It's actually just like this. It's like if I were to ask you to do a simple math problem, I'm going to say let's just use 3 numbers to make it easy. We're going to add 1 plus 2 plus 3. Okay? Now I'm going to ask you, Mr. Bacon, how do you come up with the... Oh, I forgot what number 2 was.
Yeah.
Oh, now I got 2 and 3. I forgot 1. That's funny as hell. 1 plus 2 plus 3 is 6.
I say we let Morvis handle the next one.
Yeah.
Mic check.
Hey, who's that? Is that Dave Hinkle?
Dave
What's up, Megan? I can tell one thing, and it always amazes me when they ask them for direct measurement of Earth curvature. Oh, that's too complicated to do that. Like, you can't go out to a 10-mile stretch of ocean and demonstrate the 60-something foot drop. I mean, is that really that complicated? You know? They act like it's too complicated. It's bullshit. But y'all go ahead.
Yeah, you got a good point there, Dave. Yep, 66 feet in 10 miles. So should be actually 5 miles, 16 feet, 5 miles. That's easily measurable. You can see that much. I mean, you can see 16 feet of drop in 5 miles. Easy. Simple. All I got to do is stand at a coastline, zoom into a coastline 5 miles away. Should be, you would never see the shore. You would never see where the waves are breaking on the sand if it was a ball of that size.
But they seem they never want to talk about directly doing stuff like that on the surface of the earth, you know.
Mm-hmm.
It's always about spherical access and all kinds of bullshit or whatever.
Yep, it's like this. It's like the old Southern song. Look away, look away, look away from the surface. They got to look away from the surface. They have to.
We got Aurora in here with no rolls on if you want to try to talk to him.
Oh, did you say Aurora? Hold on a second. Let's unmute Aurora. Oh, they're unmuted.
Alice, maybe. Go ahead.
Aurora, are you there? I saw you light up for a second. Can you say hi? Oh, okay, guess not.
So I even got an argument for 5-year-olds.
You got an argument for 5-year-olds, or you got an argument from 5-year-olds?
No, I got an argument that people at the intellectual age of 5 can understand.
Oh, good. That's going to come in handy.
Now you need to go down two more age groups there.
3 to 5.
3 to 5.
Start them at preschool. If we, we'd be safe if we start off at the preschool level, because it'd be hard to mess that up.
Look what I posted in the chat. So I would just say, do you know what a basin is, kids?
Yeah.
What's a basin? Let's look at the definition. A bowl for washing, typically attached to a wall and having faucets, but obviously overall a wide, round, open container, especially one used for holding liquid. Oh. Now let's take a look at the oceans of the earth. Look at that. Oceanic basin.
Wait a minute. There's abyssal plain? Wait a minute. There's abyssal hills too. How did they measure the abyssal hills? From an abyssal plain, possibly? Nice. Basin. So we're on the earthly basin.
If that last guy did nothing else, he just provided another example of how they have nothing, like Miggy was saying. All they had was just bullshit. Come in here and try to muddy the water, right?
I always try to pin them down, with them to realize what they're saying and how it doesn't have any bearing on the conversation. And he was dancing around the whole topic. He's in here talking about, well, I never made the claim that the Earth is a globe. I never said it was a globe. That's not my argument. Well, then what the hell are you here for? That's what we're talking about. Flat or globe, dude. Like, if you're not here talking about that, then what are you talking about? You'd like how sailors go across the sea? Like, that's wonderful. Maybe there's another forum you can get and talk about how, navigating on the sea using the stars is great. Who cares? I want to talk about why you think the Earth is a globe. And I hate that when they come in here, they make this grand case like they're providing all this evidence, and we're like, okay, so it can happen on a flat surface? Oh, yeah. Okay, then it invalidates what you're saying. No, it doesn't. Yeah, it does. Because if it can happen on a flat surface versus a curve, then it does invalidate you. So it makes it null and void. But here we are entertaining you, and then talking about how what you're saying sounds like you're coming up with some really good ideas. Now, the guy just likes to, make it sound like he wants to stand up for the globe, but not stand up for the globe at the same time. So he wants to ride the fence of like, well, I could be wrong, right? Like the guys that come in here and say, well, I'm 99.9% sure that there's a globe. And it's like, that's ridiculous, man. If you don't know 100%, why the hell are you even bringing it up? Well, say you don't know and call it a day, right? I mean, that's what we got to get down to here for. I mean, celestial navigation and using the stars, that's wonderful. I'm glad that you can understand that celestial navigation works. But how does that provide information that the surface is curving? Because you're not talking about that. And then, he's on and on about triangulation, trilateration. Who cares? Like, that's not talking about the Earth being a globe. And I always bring them back to that because I like to hammer them, just hammer until they just realize, okay, I guess I'm not going to be able to talk about celestial navigation. No, you're not. You're going to be able to talk about how you can support your claim that the Earth is a globe.
Right.
And then you can have your celestial navigation.
Yeah, thanks for bringing that back online, because they do just get into all these convoluted stories, and it's really just diverting away from the main premise, which they all are holding, and they will deny it even, like this guy. But yeah, where's the proof of curvature of Earth? We need that.
Exactly.
So anyone out there, man, you know what? I'd love to hear from one glober that says they've gone out to the ocean and measured the Earth itself. I don't care what the results were. I just want to hear that one of them has, well, maybe, I want to hear that someone has done that. Let's hear it. Who has done that? Anybody? Come on into the live chat. Tell us about how you've measured the surface of Earth. Globers, thanks. Because obviously, if you're so sure that it's a globe, then you probably went out there and measured it yourself, right? Unless you're using some kind of fallacious, illogical argument like the authorities are the ones that proved it, which you can't validate yourself. So that's not going to work. One glober. We're asking for one glober that's actually gone out and measured the surface of the Earth. We want to see your data and your actual observations. We need all the data. Yeah, and why is that Athenosphere flat? Oh, that's right, because it's below a basin.
Silly Glover.
Silly globers. Globes are for kids.
Yeah, they are. And he's like, well, it's complicated. It would be complicated to, figure that out. Well, if it's, and I think you asked that question. Well, obviously, if it's complicated, how do you know it's complicated? Did you try dealing with it or figuring it out, or it's weird.
It's even too complicated for me to figure it out, but I know someone did it.
What up, Jimsy?
Hey, brother. You guys.
Yeah, there's 2 ballers today, Jimsy. The sextant argument is coming up twice. Usually they come in 3s, so the next one should be along shortly.
They've been doing some training about the sextant and formulating some arguments and talking confident. He was probably looking at the mirror and repeating this stuff.
Yeah, he's going to be like, yeah, I'm going to go in there, man. I'm going to show them what's what. I'm going to keep them on triangulation and trilateralation, and that's the point I'm going to make. And I'm never going to agree that I'm talking about the shape of the Earth. I'm just going to say I'm talking about the point. Yeah, that'll get them.
And if they ask for citation, I'll just keep repeating myself.
Yeah, divert. Yep. Crazy, man.
It's all good. Some people hold the globe. They have some type of romantic relationship with the globe, but they can do that if they want to.
It doesn't use triangulation. It uses triangulation. It doesn't. The 90 is your zenith. The 90 is the angle of a right triangle formed by you, the GP, and the star. It works on a sphere. Actually, right here, you see, you assume that you're getting the angles off of the plane. Note equatorial plane. Yeah, that's what I'm saying. Aren't you saying something else that's wrong? No, that's what you said. The wrong thing. Prove to me that you need. I don't know, it's super bizarre conversation.
That was strange, wasn't it? One of the stranger ones, but
yeah,
by far the strangest. But it was one of the stranger ones.
He tried. He tried.
He tried to get away from his own claim. That's what he tried to do.
I know Eggshells got Indio all knotted up this morning. It was like that dude. Indio was really trying to get Eggshells, and Eggshells was just like that guy from the Matrix diverting the bullet from Neo.
Did anyone hear Eggshells' argument with me this morning?
Were you arguing with Eggshells, Laddie?
Yeah, he was trying to get me to admit that there's no such thing as flat water. And he was taking it down to the millionth of a micro level kind of examples, and it was the worst.
I like when they do that. I like when they make it fun.
Yeah, it's really about bringing them back down to earth, isn't it, Miggy?
Yeah, there's much more that they're trying to imply when they talk about those things that they obfuscate to or want to make it sound like they have a point when they really don't. It's crazy.
Like if you were in any other topic and you were explaining these conversations to somebody that wasn't involved, and just take the actual subject matter out of it. So let's say that someone was having a conversation. Let's not worry about the content for now, but we're having a conversation with somebody. If somebody in actual real life was using those forms of illogical forms of speech, the person you were describing that to would say, this person's mentally ill, probably.
Yeah.
But in every other case, when they're talking about the globe, between themselves at least, it's accepted. Dude, but it's like literally, objectively, is insane.
Dude, that's some crunchy ass burnt bacon, man.
Burnt to a crisp. Anybody got a picture of some blackened
Shit's on
bacon?
fire, man. That bacon's on fire.
So what you're trying to say is bacon was burned to bits? Bacon bits.
Bacon bits. Bacon bits.
Shake and bake.
Bacon bits on my salad. Yummy.
I'm making bacon. Like for real.
Hey, what's Jenny from the block?
What's happening?
Chilling, man.
What's not happening? That's been.
Yeah. So we didn't catch any globies today then, huh?
Yeah, you just missed it. There was one just skedaddled. It's probably a frequent flyer, bacon. And we had eggshells in the morning. Not literally, but the guy whose name.
Well, it's more a psychological thing. They're globies wannabes because they want to be on the globe, but even if they want to be on it, they're not.
Yeah, that is a little bit
It's just in
strange.
their mind.
Yeah.
You have to act like one of those psychiatrists. So I'm hearing you say things like globe Earth. Do you
oh
feel...
my gosh, Mickey, we need more comedy in Flat Earth, dude. I love it what you got here so far. Keep going, man. Love you.
Yeah. I'm always, because I guess over the years that I've been doing this, and when we hang, it's comical to me because it does, at one point in the conversation, I was just cracking up because he sounds like the attention span of a gnat. Remember that guy that they came in here one time, Jenny, and he's like, wait, what? It was funny because
That's gold. That is gold.
we're asking him right directly, and he's like, what? I'm like, dude, were you not paying? And that happens a lot with these guys. They act like they just lost the whole entire sentence of what you just said.
Well,
so you have to wind up repeating it, or it's common, for us.
We all know why that happens because they learn about Flat Earth from globies who think they debunk Flat Earth. Those are the kind of videos they're watching. You know this already. That's why they get easily confused when they come in here.
Yeah, he sounded like that. That meme of the cat that's looking everywhere, he's all scared about he's hearing 3 conversations happening.
Yeah, that. Okay, no, this one I'll show you my favorite. Hold on, let me see if I can find it real quick. It's the one of Cat Williams looking around confused. That one gets me every time, dude. I giggle every time I see it. Oh, I got it in another spot. Yeah. But yeah, that's what happens when you listen to somebody that doesn't go through all the information. They just have their confirmation bias.
Yep. Sure do. We need more Globers to step in here with some gumption and actually own up to the claim that the Earth is a globe. This last one was I never said the Earth was a globe, and yet he's arguing for an hour and a half about a sextant on the assumption that the Earth is a globe. But, where are the guys that are saying, yeah, it's a globe, and this is how? I don't hear those. We used to have those back in the day. We don't anymore.
Okay, so finally, at long last, I'm sure you guys are waiting on bated breath for this. All right, there it is. And whenever I see this, I always think of Witsit when he gets on a roll and he's just shooting it down one after another. And then the other person, all they can do is listen because they don't know what the fuck to say. And so, yeah, this I would imagine this would be their facial expression.
Yeah, Mickey, back in the day, they used to stand up and say, man, look at that boat going over that curve. It's a globe. You know, they don't say that much anymore.
Nope.
You know, my toilet on this side of the world it turns it goes left, and on the other side goes right.
I miss that, man. Take us back to the simpler days when arguments were so funny, like that.
That means it's a globe.
Yeah. Toilet bowl water.
And if you go to the line of the equator, it goes straight down. It doesn't go in the clock motion. It just goes straight down.
Take me back to the globe that's pretty.
I remember back then seeing a video, people being like supposedly at the equator and moving some type of device with water going on a drain, moving it from the line of the equator. That was funny. Crossing the equator line, the claim equator line.
You guys should go over all the old Golden Globies one night, and I'll just cut up about it. That would be great.
Bye bye, ball.
Bye
bye, happiness.
You remember RC? What was his name? RC Micey? He was talking about magnetic west. We have a magnetic north, and he's on about a magnetic west.
Oh, yeah.
Oh.
And then there was a guy who said that the sun is on fire. Oh,
that's a great one. It's on fire. It's a ball of burning gas.
I was like, really? It's on fire.
Can you show us a ball of burning gas next to a plant? Is a plant growing? I never saw a plant grow next to fire.
Some Glober once told me, yeah, that's actually a thing. You can grow plants with fire. He never showed me any citations, but he said so. So
he probably checked with Zanuck to make sure he got the citation right.
Crazy ballers. Yeah, I popped in here and that guy Eggshells was going on this morning. And I was like, ooh, look at what we have here. And I thought maybe he would have been a challenge, but then I remembered I've heard Eggshells in here before. He's another frequent flyer.
He's running on eggshells, running on eggshells. I think it was something like that.
Oh, and yeah. He's on another server, isn't he?
He's a trigger for me.
Who said that?
Flatty.
Oh, he's your. Does he?
Yeah, I lost my cool a bit this morning. I'm a bit ashamed of myself. I lost my cool.
Yeah, he likes to argue, that guy. So.
Well, he used to be an actor in Bollywood, and
Really?
he's a good actor. Yeah, he's been in Bollywood movies.
We
the
argue
Indian Hollywood.
An actor?
An actual actor for movies.
Well, that's good.
But not Hollywood, Bollywood.
Yeah, they're probably all connected in some way. So of course he has to be on a globe because the Kabbalah, you know, it's part of that religion.
I just want the evidence.
Yeah, if we could get that would be great.
Seems like that's all I need.
He's like the guy earlier. He was just like, oh well, yeah. It was the guy assumed it, and celestial navigation works. So I made this model, of the sphere, and it works. I'm like, great, that's wonderful. I'm glad that it worked out for you. But now how are you going to provide the evidence you're going to verify that it's a globe? Dun, dun, dun. Because assuming ain't squat. I could assume, and that's why I told him, I could assume the Earth's a lobster. He's like, well, it couldn't work as a lobster. I'm like, how do you know? Oh, man, it's fun. It's fun. It really is.
If it was a lobster, you will be on a roll.
On a roll, actually. Actually,
oh, that's a good one.
Listen, you could make a model that it's on a lobster. You could.
Well, lobsters are curved, right?
And you could make locations on that lobster. You could make predictions about what's going to happen as you're traveling across the back of this lobster. If you go left or right or forward too far, certain distances, you can make predictions based on the lobster. So you could do the same thing. You could do the same thing based on a globe or a lobster. You could still come to accurate results based on the model. Has nothing to do with reality. Neither one.
Yeah, exactly. And that's kind of what I was pointing out to him. And he was like, nah, it just can't work on a lobster. I'm like, dude, that's not my point. He was hanging on that whole idea, because I used the lobster. So this is the kind of mindset that these guys have. It's like everything that's presented in front of them, that's what they have to analyze. And it's like, if it has nothing to do with reality, you don't have to analyze it, man. That's what I was showing them, because it's not built on anything you've ever verified. So if you verify the Earth is a globe, and then you can say, yeah, celestial navigation works because the Earth is a globe, here's the verification for that. But you haven't done that, so you need to go back to square one and, do that whole verifying that Earth is a globe like you say. And then on top of that, we got into the whole discussion about, when they use the sextant, how they can use triangles and geometry and all that, but you can't on a curved surface. And then he started talking about curved triangle. I'm like, what? Oh, this is crazy, man. We're getting into some.
You mean the curved adjacent topic?
Yeah, it got into that a little bit, but it's funny because the only argument that they can ever come up with is something worked on an assumption. It always comes back to that. Always. We get into these discussions, and I don't care because, I entertain a discussion. I like to see sometimes if these guys say something new, but he kind of said a bit of new things that I haven't heard before, but he's really trying to hammer a point and not the underlying premise that it's a globe. So the point was talking about what celestial navigation is doing and how it works and all that. And I'm like, I don't give two flips about what you're talking about, how this works. It works. We know celestial navigation works because sailors use it. How does that pertain to the Earth being a sphere in particular to know that it is? Now, that wasn't addressed because he wanted to, that's not my claim. I don't know. Well, dude, that's what we're talking about. That's what the whole conversation is about. When you came into this server and you logged in to Discord, you came to the Flat Earth server, you were thinking, I'm just going to make a point about navigation. Okay, that's great. Sailors navigate every single day. So good on you. Now, how are we going to talk about the Earth as a globe? Because that's what you're defending. And he's like, that's not my claim. That whole thing.
Wow. So cringy.
Yeah, but usually I think, like Gemsy was saying, it's all psychological. And I know that. That's why I always try to make him see the point.
I take it you took a trip down memory lane, and did you go to Gem Panda's server today? Is that what you're referring to, or just recollecting old times?
No, the guy was in here, like maybe.
Mm-hmm.
Oh, okay, got you. Okay.
For about the last 2.5 hours.
Our Meisty was?
No, Bacon. Bacon was.
Oh, Bacon. Okay. All right, gotcha.
Yeah. Bacon. What is it with breakfast this morning? We got bacon. We had eggshells. What are we gonna have next? Biscuits? What's coming? What's the next Glober coming in?
I guess we.
Biscuits. There you go.
Chorizo Earth.
I guess we should, maybe find out, if you guys don't know already, which debunk videos these fools are watching.
It must be about the sextant, and I know that maybe perhaps QE has a hand in that because he's been crushing them with that. He talked to me about it. It was a month ago or something that I popped in here and we was talking about that. But yeah, he's been. That's the one that and he's got these baller communities that actually want to argue the shape of the Earth in a frenzy. So they're trying to devise a way how to talk about the topic while not talking about. They want to destroy the sextant argument for the flat Earth so that they can continue to think that they can use it for the globe. So I understood what Bacon was trying to do. He's trying to destroy the argument, not so much that he's trying to be in here proving the Earth is a globe, just the argument itself he wants to demolish as it being an argument for flat. So he doesn't want it to. So he's trying
that's why I told you they training, because I've been listening to some people and they've been bringing the sextant like today, like you're saying. Yeah.
Is there a lot of I really don't know how a sextant works? Is that going on a lot, or
no? I think it's more to deal with. They're not talking about how it provides evidence for the globe, but they're more talking about how it actually works on a sphere. That's what they're really trying to point on. And I get it. I know they're probably listening to me right now. I understand what you guys are trying to say, but that's still an assumption, you guys, out there in Globerland. You guys are just believing that it is because that's the assumption. But you take assumption out of it, and you're not able to provide evidence. So anybody listening, if you think it's a globe and you were thinking that bacon or eggshells or whatever breakfast food comes in here and tells us that the Earth is a sextant, is going to fall flat on your face. Pun intended, you know?
Yes, that's absolutely. It's like, I totally, Miggy, you said it good. You know, if you think you know better, come on down, because you're the next contestant on The Flat Earth is Right. Think you can beat Mickey? Bring it on, y'all. Come on, get in here.
The eggs and the bacon got scrambled and eaten.
Yep.
I could have just ate that, to be honest.
I'm not.
I'm gonna crack up some that shows up named French toast or something. That'd be hilarious.
Yeah, get it.
Hey, I heard something really interesting on the radio today. If I could pause on your topic for a second. I just won't be in here for very much longer because I'm on my lunch. So it was NPR radio. Some chick named Natalia, allegedly from the Ukraine, was on there. And the interviewer asked her something to the effect of, can you communicate well at this point in time? And I think she made reference to a group of people or something. And she said, well, now that we are going with, I forgot exactly what she was referring to, but it was in reference to Elon Musk providing them internet. And she said, thank God for Elon Musk. That I will quote her on. And I was like, oh. So, you know, is this, okay, this is my wild, wild thoughts, right? This is probably nothing to do with anything. But to me, it seems like they're preparing like Skynet under the guise of war, people. That's just...
Yeah, Starlink is the satellite company that they're doing their internet access to the world. So that's his one of his projects, Starlink. And so he's actually providing that, according to the company, he's providing that service. So for the people in Ukraine, I guess at this point in time, but that's why that lady was probably saying that, because he's giving them the access so they can be on the internet and such using Starlink.
Yeah, they remember that they've been installing towers everywhere on the plane, like, and they've been turning on these towers every year. And I think it was last month that they claimed that there was some event in the sky and there was something falling from the sky, and they claim it was like, I think, like thousands of those satellites that fell, the satellites from Elon Musk. So I don't know. It's kind of weird that they say they have the satellites update, but then they say they fell from the sky. But I'm pretty sure they're just using towers and that's it.
Okay, so Elon Musk is doing this great thing and providing internet for more countries, yada yada yada. Why does it have to be talked about with Ukraine with everything going on right now? That's what I was like, what?
Well, Elon is always in many interviews, and people always giving him props for his inventions and the advancements of humanity. And a lot of people have reference of him, he being a genius and a savior or something like that.
Right.
So yeah.
A little bit sus, y'all. That's all I'm saying.
Yeah.
Anyway.
They're up to no good. They started making trouble in my neighborhood. I got in one fight, and my mom got scared.
Dude, I love you, man. That's great. Dude, make that into a flat earth tune. That'd be awesome.
I don't know. That song right there might be copyrighted by those guys. I don't know.
Well, I mean, people do parodies all the time. I thought that was protected.
Oh, I don't know. Maybe you can do a parody. I know Helio's done a couple of those.
Dude. Write that down. Spread that around. See who picks it up. No, man, that could be a great flat earth parody. All right, so hopefully the next time Bacon comes back, he's a little more prepared. Otherwise, I'm not sure he knows what's going to happen to him. He's probably going to get dogpiled, and then he's going to get triggered, and then he's going to get himself in trouble.
Maybe when you come back, you have sausage, because we already have bacon. We already have eggs and bacon.
Eggs and bacon.
We'll call him bacon, egg, and cheese. How about that?
Yeah, we haven't had a chorizo earther yet, so we're waiting for
Bacon, egg, and cheese biscuit.
Bacon egger.
Bacon, egg, and chorizo.
You can make some chorizo and egg tortillas,
Sí.
you know.
Oh, muy gusto.
Have you ever had that?
Oh yeah, sí. Sí, yes.
Put salsa on it. You know,
oh yes, I like all that. I'm like half Mexican now. I've eaten so much Mexican food.
You live in Cali, though, don't you? You live in Cali?
I live 17 miles from the border.
Oh, well then, you're eating all that food then.
Yeah, most of the time. It's one of my favorite types of food, actually. But I lived down in Mexico for a couple of times when I was younger, and I love all that traditional Mexican food. Now, you know, it's different when you get down south of the border than it is near the border. South of the border, they eat pretty much just like us, but the quality of the food can be different. But generally speaking, very good produce, vegetables, fruits, all that stuff is just abundant down south when I was there. I'm sure it still is. But the meats weren't as, they didn't taste as good. They were a little more...
gamey?
They weren't as tender.
Yeah.
Mm-hmm. I guess it's the way they grow their cattle, but it's probably more natural, so maybe that's what it was. I'm trying to think. One of my favorite ones is Huevos Rancheros. I love Huevos Rancheros. Ah, yes.
Actually, like your name, right? Sunnyside? That's what the eggs are? Sunnyside?
Sunnyside up.
Over easy. Sunnyside.
Over easy.
Go back to Irish, y'all are making me hungry.
Shoot, I can cook like that too now, actually. It's pretty cool.
I got someone at DM me. He would like to speak. King K-My. Sure. Let me see.
Be prepared for more shenanigans.
Yeah, I think he.
Kenny,
Yeah, he
you're
was in
breaking up.
here last night.
You're roboting a little.
Yep.
Is this Sexton argument number 3?
He won't even go there. He's not that advanced.
Oh, okay.
That might be a good thing.
Hey, he's in. What's up, King? Kink me, whatever your name is.
I'll give him perms. 1 second. I think he has no perms. Let's see. No, he's not. Oh, he's here. Okay.
He's still server muted. Let me unmute him.
All right. He has listening pass. I'll give him VC verify so he can see the chat.
There you go, King Kamaya. Hi there.
Yeah, this definitely is.
Is he breaking up, or it sounds like I can't barely hear what he just said?
No, my mic. I have a janky cord.
Oh,
You might be You might be able to go into the settings to turn your volume up. Seems kind of muffled.
Hey, King. Capitalismo es libertad.
Yeah.
Okay. He has that on his, I don't know, secondary image. It means capitalism is liberty. That's what it means.
Okay.
You're aware?
So what's your status on the shape of the Earth, King?
It's a shape.
Okay. We can all go home now, guys. It's a shape.
Bye. Nice meeting everybody.
Bye. Close the server.
Does that mean you're a shape earther?
I guess so.
Okay. What shape?
In shape earther. Are you in shape? Do you eat Hey, King, do you eat a lot of eggs and bacon to be in shape?
I mean, I could go do some push-ups, but I'm really out of shape, so I don't really know what shape I am right now.
Okay, what about the Earth, though? How about Earth, though?
I don't think the Earth can work out, to be fair, so I don't know what shape it's in.
Hey, I got a question for the new guy. So, what flat Earth debunk videos were you watching?
I don't know.
Are they in your? They're not in your YouTube history. You can't share them with us because we'd be interested in knowing.
I could try to find it, but I don't think.
Yeah, would you? Could you? Come on, we want to know what you've been watching. How do you know the Earth? Well, how do you know about the topic? How'd you come across it?
So I had a friend get banned here for implying that people have daddy issues, and so I just came in here because it seemed.
Yeah, we don't play that game stuff here, so sorry that happened.
Yeah.
This isn't a joke. This isn't a joke server, dude. We've been around here together, the same group, for 5 years.
Yeah.
So, not trying to be rude to you or nothing, but more than likely, there's not going to be anything you guys are going to bring up in here that we haven't talked about a lot. So you have to decide whether or not you're willing to accept new information or not. And if you're not, then just proceed at your own peril.
Don't worry. I don't know any information whatsoever.
Well, how do you know it's a globe then?
I don't.
Come on, man. You know it's a globe. You've been raised to know that it's a globe. Let's not be coy. So what tells you it's a globe for real?
I don't know. I don't know what to know.
Oh, well, we're not going to dogpile you or nothing like that. We're just having a conversation. This isn't a debate.
Yeah, I'm not debating. I'm just saying I don't know what to know.
Okay. All right. Tried. Go ahead, Miggy.
Yeah, I don't know what to know about anything. So if you ask me anything, I don't even know what you're asking me. So when you're asking me that thing that I don't know what you're asking me, I might not know what you're asking me even. Like, dude, really?
Megan, we're not worthy. We're not worthy.
You're actually doing the very thing that your friend was probably kicked out of here for. But
I don't think it is. But I am looking into my search history for flat Earth.
all right, besides the point, King. I mean, you sound like a intellectual person. I mean, I don't think you're as dumb as rocks, but if you're able to put two coherent sentences together, then you can be able to tell us why you think it's a globe. And that's really what we're getting to here. Is because we know that people think it's a joke, and they look around and go, "Ooh, Earth server," and that's not the.
They're dumb. Yeah, no. See, I joined on that assumption, right? And then I realized, right, that this is. It's like it's either really hardcore meta humor or it's like something that people actually believe in, and there's nothing wrong with
Meta
that.
humor? I never heard of that.
So
Yeah,
it's
no,
it's like going beyond the next step of it's like
it's not fun, or it's almost crazy or fantastical or whatever you want to call it. Like it's
That's what
beyond.
the kids are into now, Miggy. That's what they do. Because this guy came in kind of sly, and I kind of appreciated him for a minute. Yeah.
No.
Okay.
He's a young guy for sure, but I don't think he's a real threat to anybody in here. Like intellectually, he does. I mean, he could grasp the concept, but I think what's going to get him is that he's not going to be able to provide any evidence. Which at that point he would be like, "Whoa, that's crazy." First I thought the Earth was a globe, but I don't have any evidence. So where does that lead? But if he cares.
Well, nobody likes to be subject to ridicule either. And if you don't know your stuff, then, that's what's probably going to happen when you talk to other people about it.
I looked through and I don't have anything on flat Earth in my search history.
Okay.
That's great.
So why do you think it's some kind of comical thing that people are just talking about, some meme on the internet? What makes it sound that way? Is it because
I don't think it's a meme on the internet. I don't think it's really like a meme per se. It's just that I believe there's a lot of people who believe in it that they don't actually, and it's kind of like it's a step into like mid irony, it's like
because they're not smart enough to figure it all out. Is that you're kind of hinting towards in a nice way?
I guess, yeah.
That's a common thing. So you're not alone with having those thoughts. You know what I'm saying? But the problem is what science has kind of migrated away from its axiom. And, now we're dealing with calculations that are posed as measurements. So that's where we're at. And Miggy could go through some stuff with you. But, hey, you know what, you guys? Thanks for making my lunch great. I got to go. Nice to meet you, new person. Bye, everybody.
Yeah, Jenny. Have a good day.
You too. Bye.
Later, Jenny. All right. So working off of that, I guess it does sound kind of weird when you hear something contrary to what you currently, view the Earth to be, or your worldview, or everything that everybody's ever talked about in school and friends and everybody. How can anybody think the Earth is anything other than what we know? That's the point, though, right? What do you know? Like knowing something is, breaking something down and saying, I know that the Earth is a globe because I can verify the thing. I can go and check to see if it is, and it'll check out. But
how can I verify that it's flat?
Well, no. Here's the thing. Before you start turning the burden of proof onto me or shifting it to me, I like to take a look at one thing. Is that the claim that stands out? The claim is that the Earth is a globe. The claim is not that it's flat. So when you go into school, the claim isn't that, oh, guys, the Earth is flat, so we're going to show you that it's a globe. No. The claim is that it's a globe, and that's what they teach you. That's the claim. I didn't make that claim. That's the claim that you and I both walked into when we came into this Earth and born into it. So now the claim is there, right? The Earth's a globe. That's great. But whoever taught you that it's a globe, what did they say? What was so convincing in what they told you that you now know that it's a globe? That's what I'm getting to.
Well, they didn't say much. They just said it was a globe.
Right. But I could tell you it's a dinosaur, or I could tell you it's a pickle. Whatever I say doesn't mean that it is.
Well, that'd be a little absurd, wouldn't it?
It's absurd, but it's still a claim, right? The claim is that it's a globe. My claim is it's a dinosaur, or whatever. But whatever I claim it is doesn't necessarily mean that it's going to be true. I would have to actually back up the thing that I'm claiming with evidence. What have they provided to you that substantiates that claim? And that's all I'm asking. Have you even looked into? Because a lot of people are like, pish posh, man, it's a globe. I go to school and they tell me it's a globe. What do you mean to say it's not? Like, oh, have you looked into it? Probably not. And that's where we're at here. It's like,
I'm at like a state of ignorance, you know, and I don't think there's anything wrong with that. To be fair,
I don't either. I don't.
No.
Well, I mean, are you currently going to school right now, King? I mean, is that
No, I'm out.
college or high school?
I
Or
joined the military in April.
Okay.
And ship out to die for Israel.
Well, I mean, hopefully nothing happens to you if you go out there. But listen, like all these claims that people make, and what the Earth is and whatnot, they have to be verified, man. If you're to take them on as your worldview, at least for yourself, because to us, all of us in here, it doesn't matter if you leave the server thinking it's a globe or not. There's nothing that we gain because the Earth is not a globe. All it is beneficial to you. So basically, what we do, it's kind of like for the public. It's like, I don't know, you can consider it like a public service, but we're doing it for humanity because we've all been in bondage with this idea. It's like a prison for your mind because you believe so strongly because of all of what's been taught to you, me and everyone else, that it's a globe, that you follow it with all your heart. There's nothing in your mind that contests it.
Well,
so when you're in here, go ahead. Go ahead.
I don't think I ever had a solid belief on anything, you know.
Oh, okay.
I don't know about you, man, but you never know what you don't know, you know.
I can agree with that, but what we do know is that it's not the thing they're claiming it to be. And going back to that, we're talking about the globe.
Make it flat?
Well, listen, there's only two options here, right? It's a dichotomy. If it's not curving, if the Earth is not curving anywhere, what's the opposite of a curve? So you're not left with another couple of options. There's only one. No, but I'm talking about the surface. If the surface isn't curving anywhere,
an angle.
But if it's not curving, then it's flat. I'll finish it out for you. That way you understand where I was going with it. So if it's not curving anywhere, it's flat. So if we're looking at the Earth and locally, right, and you could be doing it too, locally looking at the Earth, make your observations. And if you do make your observations, are you doing it over land or sea? This depends. But what we come to when we're doing these observations is making long distance observations and verifying that what they're telling us, right, 8 inches per mile squared, going at a distance from where you're at to, however long you want to do it, couple, maybe, 20 miles or so. And then see if there's a little divergence or, inclination or something that indicates that the Earth is a globe. There's nothing there. The information that they've given us doesn't support what we can verify. You're never going to take that information and go, okay, let me go to this flattest stretch of land that I can get to, right? Wherever you think you can get a nice flat land or over a body of water, doesn't matter where, and then go test this out because you'll never come up with that conclusive evidence that it's a globe. That's all I'm saying. So when you test out what they're telling you about it being a globe, it don't work, man. So that's where we're at.
Evidence, yeah. There's no solid evidence, or nothing I can directly prove,
For sure.
So it's best to be open-minded. I see.
Right.
Yeah.
Well, I mean, and that too, the people that come in here, dude, and we've heard every argument possibly under the sun so far that I think I've not really taken in surprisingly by anybody that comes in here and tries to argue the point or think that it's a hilarious topic or whatever. To me, every conversation, I take it as a new one, and just address each individual conversation as they are. But I'm all about verification, man. And hopefully that's the kind of thing that you'd want to have for truth, right? If somebody's telling you something and you're like, dude, I don't believe you. Show me. And then they can show you. Once they do show you, then you verify what the thing they're saying is true. But you take the information anybody gives you and then you verify it. So, and that's what we're doing. That's all we want is the truth. We want to know if people are telling us what they're saying is correct or, you know, it's just stories. So it really does sound like when they talk about, you know, planets and life on other planets and like quasars and black holes and, you know, all these kind of weird, fantastic stories, they want us to believe in this paradigm in which we're in, that the Earth is a globe in outer space spinning at absurd speeds. And to that end, you can't verify it because they're going to tell you, well, you don't have the equipment. That's number one. You don't have the knowledge. You don't have the study. So basically, you're just you're a peon in this world who doesn't know anything and should just pay your taxes and live quietly, you know, without asking any questions. Keep your head down, kind of thing.
Yeah.
But that's the thing, though, man. Like, we're inquisitive creatures, man. All of us are. Every single one of us. We're curious. We want to know stuff. And so why can't we ask those questions? Why does it have to be that we're pushed into what do you call it? Like when people ask questions, they're, dude, don't talk to that guy. He's crazy. You know, it's like, why? If you're just asking, well, you know, how did they come up with the idea? Who's the first guy that said, oh, look, there's globe Earth? Because it sure wasn't you or me. You know, we got that information from, you know, school and whatnot.
No, totally.
I don't know, man. Hopefully I'm making some points here that, like, make you think a little bit. Because, you know, I'm not in the business of convincing, but I really do want to make you think about, you know, the topics that have been given to you. And if you do have friends that are worth their salt, you know, as to be called a friend, then they would be like, yeah, man, that's a good point. You know, how do we know the Earth is a globe?
Yeah. I think I was in here last night, right? And they were talking about like the satellites and how it's mostly like CGI and stuff. I don't know. I don't really know. I don't know about that. It seems a little whack ass.
Yeah, I don't listen. Like, there's everybody and a lot of flat earthers in here got different viewpoints on it. What they're saying and where they're saying the satellites are probably something to be contested. But if the technology exists, it does exist. You know, the idea that, you know, satellites are something that you can, like, something that's being built. In other words, they can show you something that's being made. And they can call it a satellite and say that this thing is going to be flying in low Earth orbit above the Earth and such and such and such. But the actual device can show you that, right? But where it's going to be, the actual location of that thing, that's a different story. Because you or me cannot verify that and say, okay, it's actually where they say it was going to be.
Well, there's a lot of things I can't verify.
Mm-hmm.
Like I can't personally verify where the meat I ate came from. I ordered off a South African website.
Okay.
So does that mean I ate dog or?
Well, here's the thing, though. If you really wanted to know, could you?
Do I need to know the edge? You know what I mean? Like, do I
How do you know
everything?
I get what you're saying, King,
Maybe
but
it was so green.
My thing is this: if you really, really wanted to know, right, where that meat came from, could you know, or would it be something that you couldn't know? It's either falls in the realm of you couldn't never know, or you could know.
It would take a lot of effort to know.
Sure, and at some point you'd find out the origin of that meat. But what I'm telling you is, on the other hand, what they're saying, you will never, ever know or be able to verify. That's the different distinction between what you said and what I'm telling you. On the one hand, you can verify the thing that you're talking about. On the other hand, you can't verify that Mars has a terrain of whatever they say it does, or that it rains diamonds on Jupiter, or God knows what else. You know, so there's things that, like you said, what you don't know. But at the same time, what you described it might be difficult and it might be a very lengthy process, but you could find out where that meat came from. That's kind of my point.
Yeah. Nah, man.
But
I totally get what you're saying though.
but it's a challenge, man, because your mind, like when we have these conversations, King, your mind is constantly fighting that side of you that's like, yeah, but everybody else knows about the Earth being a like. What the? Does everybody in on this joke or whatever lie?
Like I'm really self-isolated, so like I don't really I don't know about that.
Yeah.
You know, like I don't really know if it's like a peer pressure thing. I'd hardly say that.
Well, I mean, you could read about it too. Even if you're by yourself, you could look on the internet or just know that what people are saying about it being what it is. And, it just comes down to what you accept in your worldview as what you perceive the earth to be. Not so much what they're telling you, but what you perceive, what I perceive.
Yeah.
And I could only go with what information can be verified. So if the thing that they're telling me was able to be verified, the server wouldn't exist. None of us would be in here because we'd have substantial evidence to support the claim of what they're telling us of it being a globe. It would be an actual globe. None of us would contest it. We'd say, well, there was a guy who did at one point, but it got squashed because we found out that it was a globe. We looked into it. That doesn't happen though.
Well, there's like 7 billion people though.
Okay, and which one of those are actually verifying the Earth being a globe?
So there's like, does that mean there's like how to if say I went through the mental process, right, to say it's flat, right?
Mm-hmm.
Okay, then why do we think it's a globe? Is just kind of the next step in the argument.
Because it's been hammered into you since you were an infant. There was little globe solar system mobiles that are out there in the world, or kindergarten, when the teacher's telling you, "Look, kids, this is where we live," and you're on this big blue ball and whatnot. So it's not given to you as something to think about. It's hammered into your mind as a young, impressionable child, and all of us, right? It includes every single one of us. We don't have time to think or logically debate in our minds if it could be. We're just brought in this knowledge to just believe that it is. This is where you live. This is the ball that you live on. And so the information we take in, it's just taught to us. And so like I was saying, we don't have the option to critically think about whether it's a globe or not. We have to accept that the world around us is all, every tribe, every language has been given this knowledge to pass to their generations of their kids, and that's the world just keeps believing that it's a globe. So it's been taught to us, and we don't, like I was saying, we don't have a choice. And if you do, guess what happens? You're looked on as the odd person because you thought about it. If you were to think about the Earth being a globe, and maybe you don't care, but go out into your family or friends or something, and you're like, "Hey, do you think the Earth's really a globe? What do you think? How do you think they're going to react?" They'll probably be like, "Are you nuts?" They're going to look at you crazy.
I don't know. I think I asked once, and it was really just not a perfect globe,
Right, but then if you were to ask them, there's some follow-up questions, okay? Even if it's not a perfect globe, or let's say it's an oblate sphere, whatever you think it is, how do you know it is? Maybe it sounds like a 3-year-old kid asking the question, why? But it's really what it comes down to is, at the end of that, they're going to tell you how they actually know. Or they're going to be like, dude, just come on, man. Just cut it out. We learned about it in 7th grade or whatever. It's never going to amount to the end where you're going to reach the conclusion where they say, dude, this is how you can verify it, And that's the satisfaction that everybody wants on the side of truth. We just want to know, man. It's plain and simple.
Yeah, no, but you guys seem to have formulated, your own truth.
No, it's not formulated. It's actually extrapolated from the non-truth. So if something is told to you as truth and then it is not, then that's the truth you live by, that it's not. So it's extrapolated from the thing that they said it was, that it's not. So now we're standing on that it's not.
So then that truth, right, is that it's not true. That's that truth.
Absolutely, 100%.
But not like the actual truth, just that it's not true. That's what we know.
It's
what they're saying isn't true, but we
it's
know.
the
we
claim
don't
of
necessarily know, but we know that what they're saying isn't true.
Yeah, because I'm going to tell you one thing. Yeah, here's the thing. No, about the Earth being flat, we understand that it is. What I'm saying is the whole entire Earth. The concept of the entire Earth, that can't be, not one single human that's living on Earth can tell you what it is entirely. The entire thing. No one. I don't care who it is. Flat Earth, globe Earth, concave Earth, whatever the other concepts are. No one will ever tell you what the entire Earth is. And if they are, they're lying to you. Because you can hit them with the same line of questioning that I've just finished telling you. Go ahead, and now how are you going to verify the entire Earth is what you say it is? I need verification, please. And not a single soul will be able to provide that to you.
Like what if it'd take me to space or some shit, and it
Right. So now we got the whole idea that you're actually going to a location where they're telling you that you're going to be going. How do you know it's not just some really high altitude location? Why does it have to be in quote unquote outer space or in space? There's people that have flown on Concorde jets that have flown over 90,000 feet in the air. So the normal cruising altitude of an airline is what, like in the neighborhood of 30,000, I think, 35,000, something like that. Concords used to fly 90, which people were much higher. Which now you take a look at some of these, I don't know, Richard Branson or what his name is. He has that Virgin rocket or airplane or something that they were cruising in space. They were just at a very high altitude, man. And that's what I'm getting to. It's like they can tell you stories, but until things are provided and verified, you're just going to have this idea of the worldview that they've given you. This is the presupposition we're all given, man, and the standing point at which we offend. That's kind of what I'm saying, man. It's like we are. There's already all that against us. So the free thinking mind will never be able to have any room to grow. Even if you were to question, you're going to be like, nah, don't question it, dude. Just believe. That's it. Believe.
I guess kind of like out of left field, right? But like, how do we know it's flat? Like, then if we don't know it's a globe, and the truth is based off of what's not true, right? How do we know it's flat?
Large bodies of water, when not disturbed, are flat and level. The surface of the water is flat and level.
Is there anything else?
Well, you don't need anything else. Over 70% of the Earth allegedly is covered in water, and all this flat water. And I'm using that as a demonstration. Now, I'm saying that to say that even if you start to think that the Earth is a globe, or the water's got waves or whatever to try to throw me off on that point, the simple fact that water at rest lies flat, when it's not moving.
I don't think, but the ocean's never at rest is kind of the issue with that.
No. I'm talking about just the concept of I'm talking about the concept of water in general. So, and it doesn't matter what body of water, how much water we're talking about. Any amount of large, body, a swimming pool, a lake, a pond, or whatever you want to use. If it's at rest, it's going to be flat and level on its surface. It's just, that's the nature of what water would do when it's at rest. So if that's true, right? Because we're basing this on truth. If that's true, then how could that flat water be curving at any amount of distance? And the answer to that is not.
I mean, if it's being pulled to a center.
That is great, but you're going to have to, then I would tell you, okay, well, if that's what you believe, because you've been taught that, then there's going to need to be some evidence to back that claim up. And when I could show you the evidence that the water lies flat when it's not moving, that's my claim verified to you. I could verify my claim. I could actually show you large bodies of water at rest, and they're flat, perfectly smooth and flat. Now, on the other hand, you can't show me that water's curving at large bodies of water. So there's a problem on your side, not mine. Do you see? So if we're to go on that premise that large bodies of water at rest are flat, then we can say with all certainty that it doesn't matter how big you scale up, water will never start bending at some point, pull to the center of anything.
One second, I'm having to call my mom.
All right, man.
She's on a large body of water, and I think it might be curving.
Yeah.
God
You think, but
forbid.
you don't know. Remember that.
Do we really have to ignore today's technology?
Well, it's not even. I'll take it a step further than that. The thing that we can verify that the water, large bodies of water at rest are flat. If we start to ignore that simple truth, we're throwing everything away. I mean, every logical, consistent argument in the garbage. And I don't want to do that because I know that King and I can come to an understanding on truth and agree that large bodies of water at rest are flat on their surface. We can agree on that, hopefully.
And another thing on top of all this, another thing on top of all this, let's say with refraction, it's debatable, this flatness of water, but we have the down vectors, Plumb tools, and we can measure if they are parallel or divergent from the center point of the ball. Because if we are living on a ball, all the down vectors on the surface cannot be parallel. You cannot have two parallel vectors, downwards vector.
Well,
on a ball.
Sorry to interrupt you. Get.
Yeah.
I'm gonna head out, guys. I'll see you guys later. I'm adding like $300 into my balance so I can buy my first gun since I just turned 18, which is really fucking cool.
All right, man. Yeah, have a good one.
Semi-automatic.
Congratulations.
What do you guys think of a semi-automatic shotgun as my first gun?
I need one of those.
I'll blow your balls out.
Home security, great for home security.
You're gonna shoot your eyes out.
I wouldn't carry it around on the street though.
Don't do that.
Might have a problem there. The land pirates don't. The land pirates don't like competition.
The land pirates don't like competition. Depends if they're on a boat. Are they circumnavigating?
Don't shoot your foot off or anything, King, man. Use gun safety, man. That's the top priority when you handle a fire. So.
I'll see.
That's all we need is another Glober shoot his foot off.
So wait. So like, if I never mind. No, that's a real dumb case. I'll go.
You should pay extra attention to this ancient saying: "Who raises the sword dies by the sword." So just be careful.
So yeah, the reason you don't want to, if you're a Glober, you don't want to shoot your foot off because you will have no foot to put in your mouth when you come in here. So.
Face the foot style. Glad you liked it. Oh man.
Man, oh man, oh man.
At your age, I would recommend better a compound bow instead of a rifle, semi-automatic rifle.
Yeah, or maybe buy a P900 camera and go check that horizon out.
Let's be real, a compound bow is not going to get you the chicks.
Handling a weapon is not a toy, and it comes great responsibility with it.
With great power comes great responsibility. Who said that?
Yeah.
Spider-Man.
Spider-Man. No, actually, it was his uncle.
Uncle Ben. Yeah, that's right.
Uncle Ben. So, a weapon. What do you say about a weapon? A weapon is not a toy. Yeah. So I am a weapon. Stop toying with me.
I was doing shooting as a sport, and my coach told me never point a gun towards any human being, regardless it is loaded or not, unless you want to shoot him and wound him or shoot him and kill him.
Tell that to Alec Baldwin.
Yeah. He said, not even as a joke, there is no jokes about this thing. So whenever you point a gun towards someone, that is a very distinct intent. Yeah. So.
Can't be good.
Yeah. Yes, Godric.
You say you can't have parallel lines to a globe or to a sphere.
Not parallel lines, parallel down vector.
Parallel down vector, but
yeah,
if it's a big sphere, the difference is going to be negligible. It's going to be negligible, so you can't
negligible
really tell.
but measurable. Not negligible. It will be measurable. Yes. Godric, in 100 meters, yeah, according to the Earth's ball curvature calculator, you have about 7.8 millimeters arc curvature for each 100 meters.
How much is that in inches?
8 inches per square mile.
Well, you said 100 meters.
Yeah.
Can you tell if you did the experiment? Could you tell that difference?
100 meters is 300 feet approximately.
Yeah.
So what's sorry?
It's almost 1 centimeter. It's quite a lot.
So, yeah, that's like a half an inch, 2.54 millimeters per inch.
Okay, so you're saying a very accurate plumb line. Wait.
It will be
100 meters across.
Godric, in a 100 meter, yeah, that difference, the curvature will be the width of your finger.
Okay, so what you're saying is a plumb line 100 meters across, separate from each other, 2 plumb lines rather.
Yeah.
You'll have the difference of a centimeter.
Yeah.
Is it a centimeter?
And
that's a noticeable difference.
Almost 7.8 millimeters, which is almost 1 centimeter. Yeah. That will be the arc curvature drop. Which will give you the angle, yeah. According to that curvature, you can calculate the angle between those 2 radiuses. Yeah, it's 2 radiuses, 3,959 miles long. Yeah, and you have a distance between them. At that distance, 3,900 miles, you have a distance between them of 100 meters. So that arc curvature there is, you will have a 7.8 millimeter curvature drop.
You mean difference?
You take a tangent line on one radius, you make a tangent line, yeah? to that circle.
Okay, I think I get it, but can you demonstrate
Yeah.
this?
Can I demonstrate? Well, just look
You can
into
explain
the linear encoders from Airbus. Yeah, they use these large 3D printers. Yeah, and they have 200 meters long linear encoders, and they measure the distance between two plumb tools. Yeah, at both ends. They are perfectly parallel because that printing head is about 4 meters tall.
Whoever's talking, we can't hear you. Hold on, I'm log back in. I get it, but you have to. I want to demonstrate this so I can show the Globers. That's what I want to do.
Yeah. I don't have the resources now, a computer to make a diagram and explain this, but it's very simple actually. And I will say that with this grade of precision, like 65 nanometer in 200 meters, is a fantastic high precision measurement.
Could you hang like a fishing line with the weight at the bottom off of the side of a building, and then move away another 100 meters and get another fishing line hanged over the side of a building with a weight? And can you measure it that way?
I recommend cobalt wire, not fishing line.
Cobalt wire is more precise.
Yeah, the cobalt wire is almost non-elastic. It has the lowest elasticity, and it's also strong.
How would you account for the wind?
Wind inside a building with a controlled medium environment, like constant temperature overall. Yeah. So what wind are we talking about?
And then how would you measure the difference between both lines? Exactly. You need like a special tool for that, like a computer.
Yeah. The linear encoder is used on the bottom to measure the distance between the wires. Yeah, you get the length, and then it's being lifted up at the top of the machine. Yeah, and it's measuring the distance between the wires. And they are perfectly parallel. That's how the plumb tools are being taken.
Have you done this experiment?
When that head is moving, across this long track of 200 meters, they don't want to have hills up and downs along these tracks. They want it to be perfectly straight. 65 nanometers tolerance. So it can move sideways or tilt or whatever, only 65 nanometers, not more than that. You get me?
65 nanometers.
Yeah.
I think they designed the globe model just big enough so you can tell.
That means the 65 unit, the 65th millionth of a millimeter. So it's mind-blowing precise. And guess what? This precision grade can be increased also to picometers, but they don't require that kind of precision. And it's only about adding two piezoelectric actuators, and they will be able to position at 1 picometer that machine. But they don't need that kind of precision. I mean, it doesn't make sense, because you are laying carbon fiber, you are laying fibers which are a few microns in diameter. It's 1,000 times, no, probably like 100 times thinner than a human hair. 100 times thinner.
I think we need something we can all do more easily. That we do have the equipment for. So I don't doubt your precise measurement experiment. I just think we need something that we can all do outside and do it without having to have all these technical tools.
Well, I'm saying these linear encoders, they are the most precise positioning measuring instruments. They are used in precision positioning. So if you want something more accurate than that, yes, it is possible. But it will be a lot more expensive. And these encoders, they are pretty simple in design. It's a band strip with lines like a ruler. But those lines are very, very thin. It's nanometer size. You don't see them with the naked eye. They have a laser which reads that band strip. So it's pointed like 1 centimeter away from the band strip, and when it's moving along that line, that band strip, that laser is counting those lines on the band strip. So you know exactly how far your machine traveled. With laser range finders, yeah. when you're doing outside measurements with laser range finders, the refraction index of the air will can affect your measurement. It depends if you're doing a long distance measurement, if it's short, it's not gonna affect you. But when you measure things beyond 20 meters, 30 meters, yeah, you're gonna have to take into consideration the atmospheric refraction index. For that measurement. But with linear encoders, you exclude all the refraction because that's an empirical measurement. It's just like you are taking a ruler, a tape.
Bye bye ball. Bye bye happiness. Hello flatness. I think I'm gonna cry. Bye bye ball. Bye bye ball.
Wave a bye bye to the ball.
Good afternoon. Is anybody hiding around here?
Here, let Doug just talk to him, Doug.
I think my connection may be dropping in and out. Say that again, if you would, my brother.
Is my mic working? It's not. Okay.
Sounds good to me, Dave.
Mic check. Is it working?
Yes.
Who was talking there? J.E., what's up, man?
Oh, not much. Just stop in a couple minutes here about most of the way through the workday. Got about 3 more hours to go and a lunch somewhere in the middle of this yet.
Not much happening around here right now. We don't have anybody defending their globe fantasies or anything, so if you got a topic, maybe somebody will start talking.
Yeah, that riding on eggshells fellow this morning was a right strange one.
He's a unique glove defender, huh?
Yeah, he kept talking over somebody who was talking, and then when the person talked over him, he started saying, "No, don't talk over me." Blah. And so I butted in. I was like, "Hey," I said, "you need to like slow your pace down. Like you keep talking over everybody else, and now you're mad." And I kind of slapped him a little bit. Said, "You need to back up. You need to like count to 10 and slow down and not talk over anybody else yourself."
It's amazing how many people don't have the basic skill of conversating. There's a lot of people like that.
Yeah, I mean, the guy had some interesting points, and he was like, as soon as somebody stopped talking, he'd be just immediately trying to butt into the last syllables of what they were saying, and he would just start rattling off at top speed. And it's just like, well, slow down here. You got some, he had some interesting information, but, and he kept saying, well, you all keep muting me. And I'm like, well, and I told him at one point, like, well, it's no wonder with your behavior. It's, slow down. And let's digest this. And I'd say, and probably, I lost count after about 3 minutes. He'd mentioned like 10 different things in about 3 minutes time, but he was on here for a good, I'd say at least 3 hours.
What do you think that he thinks he accomplished in those 3 hours?
He probably thinks that he made us look stupid, probably. I think that's their common thing they think they do is that they have some kind of superior font of wisdom. So no matter what we say or do, they think that they made us look stupid.
I'm in the middle of a grocery store where I can't talk much. I can't believe my mic's actually working, but somebody else started talking. Flat Earth Dude, are you there? No, he's not. Reaffraction. How about you? Reaffraction. Orion.
Hey, yo, I only know what I see. I seen enough to know what it means to me. Learned from red dirt and I got degrees. Veered off left turns and wild out east. And we're poor and rich and hold all that class. Don't wanna know any signs, don't wanna know where you are. Mind made up already, we're not here to watch. We just don't wanna fall off the edge and into the dark. So we clench our fists, clutch our pearls. To anybody critical about view of the world. Tongue like a slammed door I keep closed. Just to beat those doubters of these blindfolded free throws. And the channels love a G up, shoot the heat up, we'll beat up and eat up, and I don't wanna have to read up. Just drop a grenade and put my feet up. I don't wanna fall off the edge of the earth. Don't wanna hear nothing. How is it real if it's not what I felt? Is it filter it out? Don't tell me what to believe, or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I don't even wanna walk in your shoes, what about me? Flutter, flutter. World gone mad and it's too PC. And they're trying to take away the freedom that I wanna speak. Click, 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 cut them off, run them out of town, shut them off. Shh, I don't wanna hear another beat. But my gut got this in my head, take note. Cause I know in this story's a slippery slope. So stay in your lane, son, stick to your songs. I don't care where you're coming from, just a simple answer to confirm a doubt. And then baseless opinions that come out of my mouth. In a nut, tell me I don't know what I'm talking about. When a so-called experts ever sorted this out. When we're swamped by Muslims, swamped by Asians. Different time, same old station, crowd ovation. Whip up hatred, that old chestnut, that vocation. Do anything to truth, but face it. I don't wanna fall off the edge of the earth. Don't wanna hear nothing. How is it real if it's not what I felt? Is it filter it out? Don't tell me what to believe. Fuck you and your facts, I'm free. Don't tell me what to believe. Fuck you and your facts, I'm free. Don't tell me what to believe, or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I don't even wanna walk in your shoes, what about me? Flutter, flutter. Don't tell me what to believe, or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I don't even wanna walk in your shoes, what about me? Flutter, flutter. Flutter, flutter, flutter.
What is the world that we're living in now that we know we're not spinning? What is the world? What is the world that we're living in now we know courage is missing? What is the world? What is the world that we're living in now we know flat earth is winning? What is the world? What is the world that we're living? It's like a brand new beginning. We know that most of y'all sitting there wishing, probably just itching for us to go away, completely dismissing things that we say like our minds have gone missing. Meanwhile, you're really the only one shifting reality as if it was switching, like it was some type of fantasy pitching. Next up to bat, but you wind up just riffing. Nothing but air, you just can't do no hitting. Running around saying that water's sticking to outside the balls, your logic is slipping. I understand that you might think I'm tripping. Pay attention to the words that I'm spitting. Only thing that really needs any fixing, your view of the world and the way that you're thinking. No need to go always screaming and kicking. No reason to think that Earth might be tricking. If it was spinning, then we would see drifting. If it was curving, the ships would be sinking. Logical fallacy, keep on insisting. Probably just listen. How about you try some form of consistence? Ship disappeared due to angular distance. Makes a lot more sense purpose of the curve's non-existence. Why the persistence? Why the pursuit of unending persistence? Fighting a war like a soldier enlisted. Really seems as though you got it all twisted. Why not just be a bit more optimistic? Lies you've been told, the veil has been lifted. Now you've been gifted, given permission to take a position. Not in opposition to the world that we're living. Create ignition, start up the engine. Choose to accept it now, this is your mission. Tell us why the damn curvature's missing. Maybe just call up a mathematician. Give him a listen. Have him tell you about his presuppositions. Talking about how it's not superstition. A vacuum and air pressure juxtaposition. Make a decision. Tell us how this model came to fruition. You have the right to enact your volition. Right up to the day of mental acquisition. All I could do is provide ammunition. Can't take the heat, stay the fuck out the kitchen. Judgment day or to the last demolition. You can see this is an act of attrition. On the condition that after admission, do you a favor and start the forgiving. Then go out and share your newfound position with everybody who's potentially victim. Falling for the global prisoner system. So many flaws, no woman can list them. Shout to my beautiful parents, I missed them. Taught me to think for myself, I could kiss them. Now to the day that I'm able to whisk them away in my arms, I will reminisce them. Yeah.
I know lots of things.
Consume all the people stuff.
I do not care about your raps, I do not care about this track. I do not care, I guess I am rare. Yes, I hear the trash. Take it out back. Oh, you can't hear it, you must have your ear to the cash. I'm itching a spaz. I do not hack, but yes, I'm still with the mask. Snatch a beat right out the mainstream real quick. Fuck around, yeah, we gon' remix it. We got you spinning and now you dizzy. You looking like Disney, seeing sixes. All these agendas and all these false flags. How many times till it gets familiar? They've multiplied so many times they form in a line to normalize the pedophilia. Half of these rappers, yeah, this shit getting handled. They're gone with one snap of my finger. Yeah, Thanos. Yeah, I see your ice, your shit be shining. But how many of those innocent African children had to die for those diamonds? Huh? Tell me. They wonder why they were living all so divided. With all those rooms in that big ass mansion with the homeless family sitting right outside it. 1,000 bodies died for that outfit, and you ain't cleaning the blood off it. Your favorite celebrities got blood on their hands, Marina Abramovic. Hillary Clinton, she's gonna send out a hit if you leaking those documents. If you a holistic doctor, they gon' pop your toss you secretly off a bridge. Exposing them, smash the internet. Cause we don't fuck with no fake shit. Nah, NASA images. Yeah, thanking your highnesses. Yeah, for paying the scientists. Yeah, you kneel for the anthem, huh? But you still play for the Zionists. Damn. Yeah, they trying us. They splash subliminals. The Super Bowl, the halftime show. No, that's a ritual. Global warming, climate change. Next year will be a new name with a new tax and a new op and a new fear for a flu strain. Oxitex, the new Dr. Moreau, and they teamed up with the synagogue of Satan. Yeah, I see what you be doing, Q, but I still don't trust the administration. Nope. They drinking adrenochrome straight from a child's throat. You sitting down with that vegan meal, but you still drinking a diet woke. Lady Liberty screaming, covered up in that black burqa. They looking at me like I'm the devil, but I don't see him though. Matt Murdock, all these dark occultists and globalists, the ones causing a mass murder. They try to swerve at me, throw the curve at me. So I had to flat earth them. Listen, boy, I don't care what you say and all the bullshit that he said, she said. All I care is about you waking up. If you don't, you gon' get her, him, you need that. Let the 5G spread, and you gon' see there's a bunch of pissed off and stressed Americans. Say hi to my friends, they're all domestic terrorists.
This is Mix Sessions Live. Oh, yeah.
We making moves, man. Y'all waiting on spaceships. Scotty, come beam your boy all the way up. All the way up. All the way up. I run from my problems, they never gon' solve them. Till Scotty come beam your boy all the way up.
I got what you want, I got what you need. They told me spit a verse, I'ma plant a seed. Rappers got beef, I'm trying to say the cows. Spinach leaf salad, no Thousand Isles. Go ahead, do your thing with your grown self. Quit worrying about that other man, worry about your own self. You got a lot of questions that ain't nothing to stress about. I got a YouTube channel, you should check it out. I got what you need, I got what you're craving. Leave your girl around me, she gon' become a vegan. Yeah, doctors want you sick, man, how that sound?
Fuck you, Monsanto, won't stop till bad health rates go all the way down. All the way down. All the way down. Fuck you, Monsanto, and no, I won't stop until these bad health rates go all the way down.
This question made Neil Tyson have a heart attack. If the earth round, how the hell the water flat? Dropping microphones, trying to get his nerve back. But what a curve at, nigga, what a curve at. Now when I hear space, I'm thinking terabytes. Passing cell towers, some call them satellites. Some call them astronauts, I call them parasites. Scientists are just actors who hide paradise. You know I gotta give it to you real. You know they've been lying to us for years, what they faking for. You'll never find the curve.
Even if you get in a spaceship and go all the way up. All the way up. All the way up. I run from my problems, they never gon' solve them. Till Scotty come beam your boy all the way up. Oh, all the way down. Oh, all the way down. Fuck you, Monsanto, and no, I won't stop until these bad health rates go all the way down. Oh, all the way down. Oh, all the way down. Fuck you, Monsanto, and no, I won't stop until these bad health rates go all the way down. Oh, all the way up. Oh, all the way up. I run from my problems, they never gon' solve them. Till Scotty come beam your boy all the way up. Oh.
Nobody claims that what you're observing when you're seeing the horizon is the geometric horizon.
That's fascinating, but to do geometry you must have one.
It is an optic phenomenon.
So to do geometry though, you must have one. A tangent point with a straight line to it. Now you're telling me all about what you haven't got.
So, which one of you guys can fight? Which one of you thinks you're right? Step up to the mic and see what the people them decide. Who will see his demise when the truth finally come to light? I've been on the globe for my whole life. Something in my nose don't smell right. Meditating, feel a slight breeze in the wind, but I know I ain't moving, this is no ride. How you gonna tell me that the air that I'm breathing, that the PSI I'm feeling, it contain, motherfucker? How you have gas pressure next to a place 10 to the negative 17 to a space, motherfucker? What did Nixon say? One small step for man is one giant leap for mankind. And at the same time, a can of tuna landed on the moon while the Vietnamese died at the same time. I ain't got time for the life, MLM. Helios, flame out, breaking down the dam. Crushing off false gods in the program. Believe when he say that I am that I am. I am that I am. So, which one of you guys can fight? Which one of you dies tonight? Step up to the mic and see what the people them decide. Who will see his demise when the truth finally come to light?
You should raise them to be free. If not, they might rebel.
You are not an educated, you bringing me down like an elevator. Better yet, an escalator. You keep gumming my shoes so that I never make it. I'ma put you down like you a tire levitator. Speaking of the elevation, the black swan, why is the horizon 10 times further than the geometry you predicated? Probably cause you never did it. Never did, never will. Now Globe, tell me how you really feel. This is not a globe, this is the appeal. This is not a globe, this is just for real. This is for your soul, something you can feel. Saying you won't change, but I know you will. Here's your Dr. Bill. Which one of you guys can fight? Which one of you thinks you're right? Step up to the mic and see what the people them decide. Who will see his demise when the truth finally come to light?
You're not gonna like this one, nah, not at first. You're gonna learn to though, you're gonna learn a lot, check it. If you believe we put a man on the moon, you probably believe we're gonna go to Mars too. Well, I hate to be the bearer of bad news, but that's just something now we can't do. Try and leave low Earth orbit, see what happens to you as you turned into soup in your spaceman suit. What? Did you forget about the Van Allen bell? And that is filled with radiation. Yo, does that ring a bell? 4,000 degrees, that sounds hotter than hell. Man, you think if people went through there, they just melt, but NASA's already been through it. There's a lot they tell that we believe them for so long, so we might as well keep up the charade instead of breaking these chains, and let the ones on top continue to control our brains. Yo, let them do what they want with the harder money. $19 billion for cartoons, that's kinda funny. Yeah, that's just common sense to me. $19 billion on some cartoons, on some CGI bullshit. That's just me though. Look into it a little bit, you'd be surprised if that's the right word for it. Yeah. If you think the moon can be terraformed, you're wrong, and I'ma have to be the one informing you that the moon isn't exactly as it appears. Like when it's waxing or waning, doesn't it seem clear? In the daylight, supposed craters turn blue, and there are even times you see a star straight through. Like it isn't a solid ball just spinning around, like it isn't a rock that's magically pulled down into our orbit, where gravity so strong doesn't absorb it. Moon affects the tides, but other bodies of water ignore it, and it's reflecting light coming from the sun. But moonlight's colder than moon shade, explain that one. Now feel free to stay locked up inside your bubble and keep believing those lies that don't love you, and they'll tell you that the earth's shaped like a pear. Look up Atlantic conspiracies if you dare. Yeah, I'm not gonna say anything that's gonna change your mind, right? I'm just gonna plant a seed. Yeah, you've been lied to, you've been deceived, just like me.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
1, 2, 3, 4, 5, 6, 7, 8, 9.
It's the 10 Black Commandments. Yeah. This Globe, you can't tell me about this curve. Can't tell me nothing about this curve, this speed. I'm a real truth is. Truth is on the beach. I ain't forget about you, brothers. My Nikon police shooters. Shout out to the lobby. I've been in this game for years. It made me an animal. It's rules to this. I wrote me a manual, a step-by-step booklet for you to get your game on track. Don't let your way get snatched. Rule number uno, speak on what you know. You shouldn't make claims unless you know for sure. Otherwise you're telling lies. And if that man catch on, then your ass is gone. Number 2, never let them think the earth move. Don't you know the pendulum tricks are not science? Yeah, take it from your highness. They need to be set up from high up and kicked or fired up. 3, never trust nobody. Your science guys will set that ass up properly gassed up. Fellas need to tore it up. Shit for the fast buck. They be lying in the comments, just confuse that ass up. Number 4, know you heard this before. Never get high on the CGI. Number 5, never speculate on the unknown. I don't care if they fight with an ounce, tell them bounce. Number 6, that goddamn citation, get it. You think a globe be backing up the claim and forget it. Number 7, this rule is so underrated. Keep Flat Earth Society and the servers separated. Shadows and sticks don't hit this bullshit. 2021, man, that shit's archaic. Number 8, DC checking 1 or 2. Stop typing and get a mic or something to speak through. Number 9, should have been number 1 to me. If you ain't trolling back, get your ass in BC. If the team must got you slipping, they ain't trying to listen. They be pitching your ass out straight out to cog this. Number 10, a strong word called a measurement, strictly for honest men. If not, just watch them spin. If you ain't got the globe proof, say hell no. Flat earthers want that proof, rain, sleet, hail, snow. All these rules, you'll smash globes until they break up. If not, 20 for trolls who won't wake up. Truth hits your mental, watch your mind shake up. You was sleeping now, you about to wake up. Snacks in the back on your way up. Bathrooms on the left, urinal caked up. DJ on the way, about to play something. Chairs good, stogies lit, feet up. 24/7. Discord. CB. Yeah. Shout out to the mods, golds, silvers, values. Lobby gang. Yeah. It's your boy CB. In the lobby. Catch me in the live stream. 24/7. Shout out to India, CJ, Baba Yaga. Yeah. Nemus. Effie in the house. Tell him bounce.
Yeah, my mic's working. We've got a VC Wi-Fi in here, Mr. Worldwide. Hello, Mr. Worldwide. Is my mic working? Because I acknowledge that I am working. I'm assuming it's not working. Back to the music. If you can hear me.
they lie? Why would they lie? Why would they lie just to a normal guy living just to die? Digesting what he buys, ideas he can't decide. His thoughts aren't his inside, they're put there from up high. Spiritual wickedness, deceptive and perilous. Parasites meticulous, watch your trust with ignorance. Feeding off your solemn bliss, snakes a hiss, NASA's piss. Drunken like a maiden's hiss. Venom, Satan, plague and twist. Digress, regret, withholding evidence. Drowning in incompetence, ever sent. Million billions represent, lacking things we need to test. Never verify, they press. Photographs with leak a mess. I just molded as a stress, a sentence in belligerence. I'm spent, resorting just to less and less. Delving deeper with interest. Yeah. Since a boy, I was told that I'm spinning on the globe. Who we kidding? Now I'm old, and I notice that the whole world folds and can't think freely. What we witness, what we demonstrate clearly. How it's measured flat, imagine that. Water never bending over, and it's facts. Gravity just ain't exact. When two words can replace it simply, so you need to retract. Relative density, perspective and velocity. The sun is closer than it seems. Living in a movie scene, universal pictures gleam. Everything we're fed believed, and I gotta look harder just to find reality. Sitting right in front of me, horizon in the breeze. Atmospheric symphony, melancholic naturally. Globers frolic in the sea. Walls of lies just to please. A narrative just to hide a deep freeze for the mind. Destitution that we're stuck behind. Resolutions that we need to find. Break the barrier just to free the blind. Saturated in a realm of time. Unwind and try to be kind. It's easy to get mean when you're pointing out NASA's crimes, or the cables and the bubbles that we tend to find. Not to mention about this harness star's absence and Don Pettit's inability to speak a proper sentence. Study, look at me, we got sources you can read. You can test it, you can see with the method scientifically. It's all you need, but the knowledge you will grieve. Cause the way the truth hits you hard eventually. Typically, open heart, open doctrines messing with your paradigm. Emotions getting all entwined. Sitting back with truth to grind, and you're losing part your mind. Getting renewed about the cave, cause mentally it's too soon. Stay true, follow through. We all here to help with you, yeah. Big and slow.
Time you word flat, you just scoffed and laughed, thinking that Pythagoras knew better in the past. Yeah, you start to do some research and hit up YouTube, Mark Sargent's clues and Eric's 200 proofs. Where's the edge? Show me. Why would they be lying? Come on, man. Well, why's the horizon always rising to your horizon? Yo, I can't explain it all in the verse you take serious. Cause once you're flat smacked, it'll leave you delirious. You don't want to hear this. Cognitive dissonance settles in your mad. And that's okay, those are the same feelings I had. You're digging deeper and you don't know what to believe. You're getting pissed off that you've been duped and deceived. Yo, who do we blame? NASA, the elite. Both of them. While the darker voices hiding our reality that the Earth's flat, 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 get over it. The Earth's flat, 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 get over it. Earth's flat, 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 get over it. Get over it. Throw on some ODD reality to learn some more. Yeah, got you thinking about things that you never thought before. Gravity pushes, pulls, turns sawdust into balls. What? Then you realize it's a theory and it ain't a proven law. Think density, buoyancy, and electrostatic. It's a complicated concept when you first look at it. Seeing all them pics of Earth through a fisheye lens, cause that's the only way that they can show us that it bends. 70% of Earth's water, which is nothing special. But naturally speaking, water always seeks its level. Then you start to wonder why we can't have world peace when they all play nice with Antarctic treaties. Sure do. You start to seeing celebs coming out as flat earthers. So you double check that you just misheard your TV, your phone, or your radio station. Got you wondering my flat earth's taking over the nation. Even this deep inside the rabbit hole, I have my doubts, but at the end of the day, I wanna stand up and shout that the earth's flat, 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 get over it. The earth's flat, 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 get over it. Earth's flat, 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 get over it. Get over it.
What is gravity?
I have no idea. Okay, next question.
Hey, yo. It's Chocolate saying. It's 2021. Told y'all it's a wrap for this globe. Check it out. Way too many reifications of privations, secular thermodynamics violations, federalist fake as apparent deviations, globals always flapping their guns, no demonstrations, the black swan murdered the ball with simplicity, pretend the clowns aren't they all, no specificity, get with me, get that geometry, your model needs nowadays, mostly I sound like you're on your knees, copperplates, from the wall to ever show for, nevermore, been a rap for your tonight, or scientific, or sick of that they're prolific, crumble like the daughter flat earth, that's just terrific, magical thesis, you know, paleo genius, you thought you had it all sewn up, like a seamstress, you never see this, you ain't chillin' peeping the Gleasons, the globe model so fucking dead, so many reasons mad at me, cause your fairy tale of gravity is rapidly becoming a motherfucking fatality, independent variable, no physicality, factually you're dealing with no type of reality, a tragedy, all of the pseudoscience of fallacy, sad to see that we're surrounded by such banality, cold tards stepping the court for their arraignment, gas rocking off all day, no containment, it's automatic, you sound like a fanatic, your heart's beating out of your chest, no need to panic, problematic, anytime there was Socratic, the final turns for you was like dust to an asthmatic or a crack addict, all tuned up like a mechanic, state you're leaving in when you're done, it's so tragic, you end the sneezing, all snotty nose the wheezing, you globe charts wind up like Sub-Zero freezing, ain't no reason for you not to remain calm, as my nigga make a hit you with 3-point palm, instant exploding paradigm technique, backslapping your beliefs into making it sweet, your brain's obliterated, finished, unable to speak, have you looking like Tom Petty catching a leak, your whole squad left sounding comatose, I hear Michelle Dollar keeps rocks on the head, she keeps her family close, some of y'all think y'all the best team since butter toast, when it comes to FP, prepare to catch an overdose of intellectual honesty, the clear lack of indicative you bros never cease to astonish me, I gotta keep it real and be honest, B, it's quite possibly the dumbest thing I heard since cosmology is often seen as a philosophy, mythology, but actually it's a prophecy of religiosity, get all your skills and your weight up, this crunch time, you whack model getting ate up like lunchtime, how in the hell could we establish a baseline, most of y'all trolls are just here to waste time, I'm not aware of what you're hearing through the grapevine, but you must be out your mind selling space-time, a mathematical construct of imagination, with absolutely no experimental validation, before the story begins you need a foundation, curvature of the earth, that's the conversation, and since the shit up and disappeared without a trace, I'd say it's also time for you to say goodbye to space, tall tales about vacuums and empty place, all the while breathing air, that's just not the case, you best get out my face, cause I can guarantee you that the very air you breathe immediately fuck off the space, we understand no requirement for your compliance, you understand that you are standing in a room with giants, I admire that you're usual in your defiance, but won't you join us in this funeral of pseudoscience, you in the mood to try us, go ahead and test your mic, these motherfuckers think they're moving at the speed of light, how about the speed of sound, 250 miles above the ground, they say the ISS is going round and round, please don't even try son, it's been a rap since you gave up on your geometric horizon, in the trenches hoping and praying we don't get wise, and realize he's smoking more off the grass than Neil Tyson, oh speaking of that clown, I wonder how much longer he can keep it pushing this in the background, never debating, always up to back down, playing in fear of the gravitational smackdown, this little circus won't last long, I'm betting you the type of person that sits at home alone with a mask on, thinking you debunked an argument like the Black Swan, never knowing that your radius could be that wrong, oops I really meant to say dead wrong, implicitly, we've been falsified the globe empirically, need you to listen G, it's not logical to postulate you live in a sphere with no sphericity, it's the epitome, it's not a mystery, the globe model's all wrapped up in stupidity, it's quite simple see, it's probably not the move for you to spew your rhetoric here, or religiously, maybe officially, one day you might find yourself vividly Lyrically in the middle of an epiphany, lyrical symphony. It's been a pleasure, but our times have both come to an end. Synchronicity.
Ready, real.
CIA be lurking, I be in the turban. Little ones stay cursing, older ones out twerking. Talking about lack of education, streets are always dangerous. Bluetooth speakers playing, do you really hear what they saying? Do you know what that mean? Are you down for the teens? They speak through signs and symbols, you can learn about these things. Live by 9/11, Club of 27. Once you think that they in heaven, nah bruh, it's a legend. It's all according to the code. Damn Illuminati with my mind, body, and my soul. That's why they snatching bodies. Everybody in a Holly Grove. Deception is a hobby, switching roles with the auto close. We call that an auto hoax.
Man, what you trying to prove? Don't you know we've been around the globe and been to the moon?
Get it, that's an auto hoax.
You're tripping, times two. What about the shootings that they always cover on the news?
Real, that's an auto hoax.
They don't move, we will make the way. Let it spray, right reality like an AKA. Let them know we don't play. They live like life's a party, but it's really like a breakaway. Let it say, focus your attention on your better days. You know what I'm talking about. Don't let these slimy narcissists, antichrist out there turn your eye. Freedom of speech is actuality. That's why the truth must spread by word of mouth, word of mouth. It's all according to the code. Damn Illuminati with my mind, body, and my soul. That's why they snatching bodies. Everybody in the Holly Grove. Deception is a hobby, switching roles with the auto clone. Let me turn on my auto hoax. Not even a proven fact. The floor curves into a spinning ball, and you can test for that.
Globe is an auto hoax.
Man, you must be trolling me. Scientific theories aren't what they are shown to be.
Yep, that's an auto hoax.
So what you're saying is you don't accept the claim that's missing proof, then you label it.
Exactly, it's an auto hoax.
Wow, sports is scripted by the number code, but do I really don't? Let me turn on my auto hoax.
Squad.
Let me turn on my auto hoax and look this stuff up when I get home, cause boy, I tell you, these kids today is tripping. I ain't tripping, he must be tripping, cause I am not tripping, not one little bit. I know my things, I know my shit.
It's right, yeah. It's right, yeah. It's right, yeah.
We the best music, music.
It's right, yeah.
Another one.
It's right, yeah.
DJ Khaled.
You gotta make your mind up. I gotta ask you, bro, just how'd you find us? I got flattered, but my mind is that a crime, yeah. Don't wanna go back to days when it was a glow. The curve is my priority, and I'll put that over everything. And the globe ain't shit, and there ain't no space. Waiting on gravity, validate Tap, gas, pressure, and less contained. They say gravity, but you can't bend space or time. Sometimes it's sunny, but sometimes it don't shine. Like love don't exist, it's only in your mind. Someone let go of the space glow. Let it go, oh, that glow. Let it go, oh, that glow. Let it go, oh, that glow. Oh, let it go, let go.
I let it go if you say that there's curves in that shit better show. Don't try to play like I'm slow, cause I've been running the block and I know there's no glow. Ask for proof when I give you some low. And I'm proud of myself cause I used to be glow. Now I just hustle and grind and flat smack into all of my muscles. So asking me say it's a ball, he ain't got no proof at all. Keep asking why did it fall? Don't try me, it's gonna end up in a brawl. Brandis clocks like a dog. See tough our lessons from fog. Ask for curvature measurement, making go claims without no evidence. Globe's too big, can't see curve. Hopped in a plane, but you still ain't high up. Red Bull jump, no curve, can't see none. Parallel rays with some shadows in a stick up. Thinking measure shit, no hiccups. You know what some bull that they whipped up. This is flat as little baby, it's CB, I ain't got no choice but to tell ya.
They say gravity, but you can't bend space or time. Sometimes it's sunny, but sometimes it don't shine. Like love don't exist, it's only in your mind. Someone let go of the space glow. Let it go, oh, that glow. Let it go, oh, that glow. Let it go, oh, that glow. Let it go, let go.
girl named Bertha. She said she was a flat earther. On our way to the conference, I said, you know that's nonsense. She said, the shit's not nonsense, you don't even know, have you heard my silence? I said, what about science? And she said, science don't give me no love. I got talking to Linda. She was out on a bender, flicking through Tinder. I said, how's that working for you? She said, it's not working, it's regret and embarrassment lurking. But it's late and I'm lonely and hurting, and where else can I get me some love? Holding on for dear life, always a bridesmaid but never the bride. A billion tiny islands in the ocean, all these characters I dream, variations on a theme. Variations on a theme. Variations on a theme. I met a boy called Casper. He's a worldwide traveller, talking about ayahuasca as he stares into his pasta. He said I probably shouldn't fly so much, probably shouldn't get high so much, but I'm a lonely hedonist and my therapist says I need to find ways to love myself. How could I forget Brian? Open the floodgates without even trying. I missed my stop on that train cause I got a lot of time for a grown man crying. Well, he said she loves me and I love him and he loves she. Still spinning the bottle on the topmost shelf and looking for love like everyone else. Holding on for dear life, always a bridesmaid but never the bride. A billion tiny islands in the ocean, all these characters I dream, variations on a theme. Variations on a theme. Variations on a theme.
If you stay and you go, but if you stay
piss off and leave us while you may. Go on home, Angry Glover, go on home. What the fuck's Van Allen belts if not a dome? For 400 years we'll fight you without fears, and we'll fight you for 400 more. And if you rage, Angry Glover, if you rage, don't you know that most of us have been on planes? So if you think it's funny that Einstein was a dummy, I'll show you the moon landing was staged. Go on home, Angry Glover, go on home. Ain't you got no fucking home of your own? For 400 years we'll fight you without fears, and we'll fight you for 400 more. I'm not spinning, I'm not turning on an axis. I'm centered on everything I see. So fuck your Google Maps, we wanna flood Earth back and live in reality. Go on home, Angry Glover, go on home. Ain't you got no fucking home of your own? For 400 years we'll fight you without fears, and we'll fight you for 400 more. If you stay, Angry Baller, if you stay, you will never be flattered with what you say. So go in your ferry, the curvy has been buried, and piss off and leave us while you may. Go on home, Angry Glover, go on home. What the fuck's Van Allen belt if not a dome? For 400 years we'll fight you without fears, and we'll fight you for 400 more.
and the Globers go insane. I hear their voice on the line as their cocktails causes pain. Even in perfect weather, we cannot see forever. Wherever you go, whatever you do, I will be taking your globe from you. Whatever it takes, or how your heart breaks, I will be taking your globe from you. Globe Earth was planted in your mind, and it must be removed somehow. I hear your laughter and I taste your tears, so let me through right now. Oh, can't you see it, Clover? I will flat smack you sober. Wherever you go, whatever you do, I will be taking your globe from you. Whatever it takes, or how your heart breaks, I will be taking your globe from you. I wonder how you can survive this globe dance. But in the end, if I reach you, I'll take the chance. Even in perfect weather, we cannot see forever. Wherever you go, whatever you do, I will be taking your globe from you. Whatever it takes, or how your heart breaks, I will be taking your globe from you.
All right, what's the big idea? Where is everybody? Y'all hiding or something? Or you just don't want to talk?
It's
What's
early.
Up? Oh, come on. Early, huh? All right. Really?
It's early somewhere.
Nah, he just wants to make an excuse.
I always have an excuse. You want to hear my excuse today?
Everybody's scared to come and talk to us. Us.
Okay, I guess I'm not interesting enough.
Anybody here? There's a couple new people here. Somebody wants to try to talk to them. Well, there was one of them left. Is my mic even working?
Oh, yeah, I can hear you.
I can
Thanks,
hear you
Jeff.
as well. Nice one, Dave Hinkle. I can hear you.
What's up,
What's going
Jen?
on, man?
CBR one.
Nice.
Give us a full report from the island of Japan. Go.
Oh, it's all going well here. You know, no lockdown, nothing to report. Everyone's just getting on with it. I think they were a little bit concerned with the North Korean missile that was fired last Friday. Well, that's all to report, man. Nothing. Boring.
Fair enough. There's a VC verified here named Raul.
What's his name?
Raul. He's got space AIDS, space herpes, but he's got image rolls. He seems sincere.
Okay, so Rahul. Well, nice to meet you, Rahul. Can you hear me? Jin CBR1 here.
Can you speak to us, Raul?
You can open your mic and just have a few words.
So he doesn't wish to speak right at the moment, then.
Yeah, maybe this will help. ¿Cómo está, Raúl? Buenas tardes.
Yeah, what he said.
I said.
He said hello. He said hello, Raul. How are you?
I said good day. Yeah, and how are you? Bien, ça va? No worries. You can speak when you're ready. Might be AFK. I was AFK out in the woods, another world out there. It's amazing.
Well, since you know Spanish, Sonny, I've always been curious that one Santana song. What is he really saying?
Oye, ¿cómo va?
¿Cómo va?
Yeah, that one.
Perito, That's a great song, that one.
You know what? Like it's some kind of a slang, and I don't think I've ever known. That's stupid of me not to know what that song is.
It's from the album Black Magic Woman. It's from the album Black Magic Woman. Okay? That's the album. Great album, that one. By Carlos Santana.
Dude could grind the X pretty well, couldn't he?
Yeah, he was great. Great guitarist, great group, Santana. Great group.
It's from the album Abraxas, which is the same album. I think you might be right. But it's from Abraxas is the name of the album. And originally, Tito Puente is the one who wrote the song.
All right, yeah. In the 70s, we had it on Black Magic Woman. Unless Black Magic Woman's on that album.
I think it might be. I think it is.
Yeah, great album, that one. The cover's the Black Magic Woman's on the cover. There's a black woman
I think
naked
that's
on the
yeah, exactly.
Yeah.
Abraxas. Oops. Apparently, he went to Mission Bay High School, which is right on the corner, for a short while. Right around the block from me. A few miles away.
My dad had some taste. Because my dad bought that. I would have been about 10, 11, 12. When that
Oh my gosh! I found that word in the occult. Hold on, I'll read that later.
Yeah, I think the album cover says a witch's cauldron, like a black pot, and she's over there doing her magic sort of thing over the.
Yeah, the word means some kind of the word means some kind of demigod.
Well, there you go. Yeah, I think the album cover, the black woman's got an afro hairstyle, and she's over the black cooking pot.
Here, I'm gonna drop the album cover.
Yeah, drop the album cover. I had to remember that from my childhood memories.
Me too. And
a little different.
is it spelled the same way though? Hold on a second. Yeah, yes, it's spelled the same way. The album. Songs on the album. Here we go.
Yeah. I'm looking at it. Just a bit different from the one we had.
Here it is. 1, Singing Winds, Crying Beast. 2, Black Magic Woman. Oye Como Vas. 3, 4, Incident at Nashubur. Side 2, Se Acabo. 2, Mother's Daughter. 3, Samba Pati. 4, Hope You're Feeling Better, which I love that song, Hope You're Feeling Better. 5 is El Nicoya.
Is Carlos Santana still alive?
Yes, he is.
Okay, just wondered. Got to be getting up there.
Yeah, he is. Created in 1960, the Santana created in 1966 by Mexican-American guitarist and songwriter Carlos Santana. The band has undergone multiple recordings and performing lineups in its history, with Santana, Carlos being the only consistent one in the group. I heard half of his band that was at Woodstock was from, ended up being part of the band for Journey.
Right.
Yep.
Great performance at Woodstock, by the way, that was.
So some of those, I forget which ones, went on to create Journey. So now you get into the occult part of this word. I don't know if you want to go there. That's kind of scary. Might as well. All right, let's see. Occultworld.com, Abraxas. Spelled either with a A, S, or I-S. Abraxas is a Gnostic name for the demigod who ruled the 365th highest and final aeon or sphere, ascending to the unknowable God, whatever that means. Christian demonologists put Abraxas in the ranks of demons. Abraxas is also the name of a sun mounting an Ouroboros, which is a snake biting its tail. Wow. Held by the highest Egyptian goddess, also in Mesoamerican folklore also. Isis, the creator of the sun and mistress of all gods. Isis mythology found its way into Gnosticism. In addition, Abraxas was associated with the Mithraic mystery religion of Persian origin, the chief rival of Christianity in Rome in its first 400 years. As did Gnosticism, Mithraism featured a complex astrology and numerology. Numerical values of Mithras and Abraxas name each total 365. Wow, this is pretty heavy. I don't mind reading this because if you guys don't mind, I'll read just a few more paragraphs.
Yeah. It's quite interesting.
And then I'll stop maybe just this first page. It's not that long.
Just for context, are you talking about the lyrics of that song, or what is that?
No, I'm talking about what Abraxas is.
Okay, go ahead.
The name of the album is Abraxas. This is in the occult is what this means. So, okay, so Gnostic talismans made of carved opal show Abraxas as a figure with a human body, the head of a rooster, or occasionally a hawk, and serpent legs. His hands hold a shield and a whip. The shield usually inscribed with the name Lao, spelled L-A-O, reminiscent of the Jewish four-letter name of God. He is often mounted on a chariot drawn by 4 white horses, with both the sun and moon overhead. The rooster represents wakefulness and is related to the human heart and universal heart. The sun. The human torso embodies the principles of logos, or articulated thought. The snake legs indicate prudence. The shield is symbolic of wisdom, the great protector of divine warriors. The whip denotes the relentless driving power of life. The 4 horses symbolize 4 ethers by which solar power is circulated throughout the universe. Okay, 7 letters of the name Abraxas represent 7 creative powers and planetary spheres or angels recognized in the ancient world. The letters add up to numerological value of 365, the number of days and powers of the year. Carl G. Jung called Abraxas the truly terrible one, quote unquote, because of his ability to generate truth and falsehood, good and evil, light and darkness, with the same word and in the same deed. In Jungian psychology, there is no easy way out of psychic conflict. One must not only fight on the side of the angels, but occasionally join the host of fallen angels. According to Jung, fear of Abraxas is the beginning of wisdom, and liberation, or gnosis, is achieved by not resisting. Very strange. Here's some further reading. I'll just read this and stop. Stephen Hoeller, Hoeller, Stephen, Gnostic Young and the 7 Sermons to the Dead, Wheaton, Illinois. Victoria Hyatt and Joseph W. Charles, The Book of Demons, New York, Simon & Schuster, 1974. The Old Testament Pseudepigrapha, Volumes 1 and 2, edited by James H. Charlesworth, 1983, reprint, New York, Doubleday, 1985.
So, Sonny, did you say you was at Woodstock?
No, I wasn't at Woodstock. I was only 11 years old.
Oh, that's right.
I lived in St. Louis. Yeah, I lived in Missouri then.
So, how old are you now?
63.
Okay, so if you were 11, then I was 8 years old. So so I was 8 years old. That was 1969 then.
Right.
I was 1970. So the following year, I would have been going to Nigeria.
Wow.
I'd gone to the moon by this time. Yeah. Supposedly.
Yeah.
Supposedly
In
gone to the moon.
July of '69.
Yeah. That's right.
Yep.
July of '69. They would have been going to the moon. So you would have been at Woodstock. I was in London, going to elementary school.
No, in '69 I was playing around in St. Louis, and I remember the day that they said, "Come in, look, they're landing on the moon." I came in. It was a beautiful day. I remember because July, my birthday, 4th of July, are both in that month, and this was a big event too. Everybody was watching their TV. But other than that, I'm like, okay, great. See you later. It's too fun outside. Who cares what's going on?
I was the reverse because I was interested. I was the reverse. I ran home. You see. Yep, I ran home. Stopped the football. Yeah, I'll catch you guys later, man. I got to go and watch these fights. See ya. It was interesting. Very Indeed.
They probably told me go back outside, Sonny, so I wouldn't be bouncing off the walls, which is my normal.
Yeah, great album, that one. I think there are different album covers around the world as well, because we had a different one for that in London, slightly different, which I gave to my friend, who now has it in New Zealand. So that album's still alive that we got in the 70s. We lent it to a friend of ours, and he has it in New Zealand. Lent it to him to record. Make a copy. Where are you going? Now let's check. Come on. Let me down.
See, the thing about that, though, is, Jen, that if I had been old enough to go to Woodstock, I would have also been old enough to be drafted. Thank God that didn't happen.
They probably trash first round here anyway.
That's better.
Yeah, yeah, right, Indio, exactly. Why are people going there? There are no hookers on Mars. No. Oh, also no food and water, so that's not going to make for a pleasant Saturday evening.
Exactly.
What's you going to do with your
right
day?
Place to go for a picnic either.
A picnic on Mars. No plants, no animals.
Matt Damon grew potatoes on Mars. I saw it on the screen.
People probably actually believe that shit is real. Because they saw it in a movie. And I hear someone in the background going, "What do you mean? Movies aren't real? Really?" Blasphemy. What happened to Joshua lately?
I think he's in Battle Mod server lately.
Oh, really? Oh, yeah. I heard them mentioning that. I should have asked him for a link. Anyway, that's all right.
Could be wrong, though. I don't know. I thought I saw him there the other day.
I'll find my way there one of these days. Probably next time I hear from Battlemod here. Well, I could DM him, I guess.
You got Sold My Soul in here with no rolls. Sounds like an interesting name. And they bounced as soon as I said their name. I'll shut up.
Nice to see other people are making all these servers. We're going to have plenty of backup in case, well, maybe. We'll see. Hopefully the, what is it? SHTF? Hopefully that doesn't happen. Thank you, Truth. I joined.
Website. Remember, Gazer. No rolls.
We're just about. All right. Well, one of the biggest tells as we wrap up hour one.
Is my phone messed up or is just no one talking?
You're good.
Your phone's fine. It's quiet.
Okay.
Right? It's just quiet.
Okay, thanks. Well, can I just share a random thought that I had with you guys?
Yeah, go ahead, sir.
Okay, so sorry to bring like a stupid pop culture into this, but you guys know about Kim Kardashian and Pete from Saturday Night Live and Kanye and all that drama that's going on, whatever.
Oh yeah,
And
I did see that one.
did you hear about Jeff Bezos inviting Pete to go on the next Dick Rocket mission?
No, I don't reckon I heard another Dick Rocket mission.
Another Dick Rocket mission?
Yeah, you know Jeff Bezos. He took what's his name from Star Trek or whatever, William Shatner, and went up right on their parabolic mission to space, right? So on the one of their next missions they're going on to, apparently, what I read from the article is Jeff Bezos invited Pete Davidson. That's what it is, Pete Davidson from Saturday Night Live. Onto this next mission. And so when I heard the association with Pete and Jeff Bezos and then his ties to Kanye, because Kanye's hating him right now because he's dating his ex and mother of his children or whatever. And so I was like, what if Kanye says space is fake just because the association with Pete and Jeff Bezos and there, and you know, the exposure that would give, whether you're a fan of Kanye or one of the think he's crazy or think he's a genius, whatever, it doesn't matter. Just the attention that he gets. If Kanye were to come out and say, you know, space is fake, that was inspired by Pete Davidson being invited by Jeff to go to space, and then Kanye comes out and be like, what the fuck are you talking about, bro? Space is fake. Like, I just thought that would be cool. That would be good publicity either way, whether you think Kanye's a genius or insane. His impact on the world, that would be dope if Kanye came out and said space is fake. That was my thought.
That's news to me because just about all news is news to me because I don't watch the news. How many times did I say news there?
Yeah. Yeah, I like the anagram of news is north, east, west, south. So it's kind of like your surroundings. So like the news, it's like what's going on around you, spelling out the word news.
Yeah,
encompass term. But yeah, and I don't watch the news either, but I am on YouTube, so there's stuff that pops up or podcast channels that I listen to that do talk about the news. Or unfortunately, I scroll through Facebook. So most of my news, so to speak, comes from YouTube channels, podcasts, or people that I'm friends with on Facebook or the groups, or specifically the Facebook groups, because I'm in like synchronicity groups and stuff like that where they post some interesting stuff. So
Well, I'm glad you guys are, because then you give me information which I wouldn't have normally because I don't go on any of those channels. So yeah, I appreciate it. Anyway, somebody's got to do that.
yeah, I'm just doing my part. I'm not 100% disconnected. I like to keep my toes in just to know what's going on. I don't get all emotionally involved in it and react and type comments and stuff like that. But yeah, I'm doing my part to let people like you. And congratulations to you that you're able to do that. You're probably way more productive than me because of it.
That may be questionable. I guess it depends on what you mean by productive. But what was I going to say?
Less distraction.
Less distractions. That's true. I don't need any more than I already have. So, what was I going to say? Oh, I was going to say about you looking at things that I was just going to make a statement that there are flat Earth scouts everywhere. We're out there everywhere.
Oh yeah. We are everywhere, and we kind of have some evidence to go on thanks to Dave Weiss's app, which you can, if you have bought the app, and you can know all the flat earthers that are in your immediate area, and message them directly, or put together meetups if you want to meet other. Because generally in our everyday lives we don't bump into other flat earthers. It's only when we go onto the dark web of the internet, the interwebs, that we get to talk to like-minded people, and not so much in our everyday life. So his app basically gives you a way to see how many people, flat earthers, are in your area. I mean, it's not an accurate number because it's only the people that have his app that you can see. There's probably tons that don't, but it's still pretty cool.
I would like to find it, but here's how lame I am. My phone, I can't even load it because it's so old. Apparently, it's too old. And I run a Linux machine, and there's no, unless I can learn, there might be a way I could do it inside of a sandbox type of, for Linux, they have Wine, and you can run Windows apps, but I don't know if it will work. I don't know if I'll be able to get to it. It's kind of amazing this day and age that, like for anyone, that there'd be this block of getting like certain things or apps or whatever you want to call it. I kind of rely on this place to let me know who's close by.
Yep, at least you got this place.
Yeah.
Some of my best friends are people that I've never even met before in quote, real life. Like I talk to more people on here that are like-minded people on here than people that used to be my best friend or that I've known my whole life.
I agree. I concur with that. Likewise here.
I'd like to know a little bit more about that fake space stuff.
Space stuff. We gotta start reading off like odd space stories or stuff from NASA that's just ludicrous like the rest of their stuff, but some of it's like extra ludicrous. Ludicrous, read all about it.
Well, just let me be specific with my words. In colloquial general terms, of course, space is not fake in this 3D whatever realm we live in. So space isn't fake, and outer space isn't necessarily fake either. It just depends on which outer space you're referring to.
Right.
If you're talking about the outer space that that NASA's going to, that's fake. But there could be outer space on this realm we live on.
It's not that it's fake. It's just not real. like see the movies now. See the movies are showing something that is portraying something that's fake because we know it's not real. But the people that are really here on Earth, well, not that the movie people aren't on Earth. Some might challenge that, but the NASA people showing. NASA people saying that they're doing real things up in this place that we know can't exist. That's not fake. It's just not real.
NASA needs to subcontract to Marvel Studios because
they probably already are, man. I'm serious. Do you think these people are like brothers in arms? They're all like in the Kabbalah. They're all in the same religion. Many aspects of the global religion, but they're all in these secret clubs. Like they're all in the Actors Guilds. They're all in these cults, Dionysus, like all of that. So of course, like, hey, bro, I'm John over here at NASA. Oh yeah, cool. Can we borrow some of your Marvel Studios stuff there? We need this equipment. Oh yeah, no problem. We'll loan it to you.
Well, here's the thing. You're praising NASA too much because my point was I think Marvel movies stuff looks better than stuff that NASA shows. That's what I was trying to say.
It does. That's true. That's true also. The movies did it better. Actually, in 1968, Kubrick did it better than the NASA did.
Yeah, then he did it before NASA did, so they brought him in because he was the tip of the spear as far as
So that movie came out like right in the middle of the Apollo programs.
Yeah, like 68, right? Or
68, yeah. Apollo, I think, was going since 66. I think 67 is when they torched Apollo 1.
Speaking of torching Apollo 1, you heard about, since you're not up on all the news, about how they're going to, the ISS is too old, and they're gonna crash into the ocean and not save any of it.
Listen, you know where I heard that from? Whitsitt was on here one day, and he goes, we were talking in depth about how to file a lawsuit against NASA for ISS, the fraud about ISS only that program. 5 hours later, Whitsitt came back on and said they're going to crash the ISS now.
Wow. That's interesting, that correlation. I did hear the thing about Whitsitt saying that about you taking some legal action. And just like, we'll come up with something and then they'll change the definition in Wikipedia like a couple weeks. They're listening, bro.
They can't. They cannot keep up with us is the problem.
Yeah, there's no way.
Because we're not a hive mind. That's why. That's why they can't keep. We're individuals doing our own research, finding different aspects of the same thing, and then we add that knowledge together. We're unstoppable.
Yeah, we're like the ultimate think tank, even though we don't agree on everything, which is great, what makes us a great think tank. But we are the think tank. Like exactly. I'm into synchronicity and all kinds of stuff. I have a room in another server called The Sinkhole, spelled WHOLE, The Sinkhole, and I'm into synchronicity and stuff. And yeah, they can't keep up with this hive mind. There's no bigger hive mind.
Well, see, they are the ones with the hive mind. So they may have a bigger hive. Let's think about this. But they have a bunch of bees that are kind of drones or bzz, 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 bzz. They're bunch of, they can go from flower to flower and back to the home base, but they really don't have much range other than that. They can sit there and pick up flowers here and there, pip, 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 pip. But think about a hive of thinking, sentient individuals
Yeah, we really don't fit the definition of the hive mind, just in the sense that it's a bunch of people's minds all being able to communicate together. Not that we all think the same, like bees, like we make, one opinion, have one goal, we're all work together for this one single thing. No, we all think differently, we all have different opinions, we all bring different things to the table. So yeah, we're not a hive mind, just only in the sense that it's a thing. I will call it think tank. Like, to me, that's better.
Yeah, it is. So you're into synchronicity. So have you heard of the 100th monkey effect?
Absolutely, yep.
Oh, great. Oh, cool, man. Awesome. The first time I read about that was in a book by, the guy passed a few years ago. Let's see if I can, what's his name again? Anyway, it's the name of the title of the book is called Beyond the Quantum. Michael Talbot. That's the author's name.
Yeah.
So, pretty interesting book. That was years ago, 20 years ago I read that book.
Yeah, there's like 3 different synchronicity groups that I'm in on Facebook, and they're constantly posting interesting stuff. They use pop culture a lot as examples and archetypes and all kinds of stuff. It took me a long time to pick up on what